As technology is rapidly evolving and new fields are emerging, the demand for certain programming languages are also changing over the time. And as a software developer, it is important to stay up to date with the latest trends and technologies and to be proficient in a variety of programming languages to stay competitive in the job market. Hello everyone and welcome to this session. You are currently watching an Edureka programming full course video. By the end of this video, you will have a thorough understanding of different programming languages that are currently trending, all the way from their theory to practical applications. Now, if you love watching videos like these, then subscribe to Edureka's YouTube channel and click the bell button to never miss out any updates from us. Also, if you want to learn more about any of the programming languages after watching this session and wish to obtain Edureka's Programming and Framework Certification course, then please see the link in the description below. Now let's begin with our agenda, where we'll have a brief overview of what we will cover in this programming full course video. We'll start with Python, which is a versatile language that is used in a wide variety of applications and is in high demand for data science and machine learning. Then we will move ahead with Java programming language, which is widely used in software industries and are used to develop a variety of applications including video games, mobile apps, and enterprise software. Now it's time to deep dive into some more programming languages. We'll start with C and C++, which are in-demand programming languages as they are versatile and can be used for a wide range of applications and have a large existing code base that needs to be maintained. Once this is done, we will then learn HTML as it is the foundation of most websites and is essential for creating the structure and the layout of the web pages. We will also see CSS, which is in high demand for web development as it is used to create visual presentation of web pages. Now, after all this, we will head over to JavaScript, which is widely used for creating interactive and dynamic web pages, web-based applications, and server-side applications. At last, we will learn about Golang, which is a programming language developed by Google that is designed for building highly concurrent and efficient systems. So stick till the end. Now let's get started with our first programming language, that is Python.
Python has been ranked the #1 programming language in TOB Index and has been used by some of the largest companies in the tech industry like Pinterest, Spotify, YouTube, Instagram, etc. So you looking to learn Python might just be the best decision you've ever made. Since this video caters Python for beginners, I think it is important that we start with what is Python. Python is an easy-to-learn, powerful programming language. It has efficient high-level data structures and a simple but effective approach to object-oriented programming. Python's elegant syntax and dynamic typing, together with its interpreted nature, make it an ideal language for scripting and rapid application development in many areas on most platforms. And with that, we can see why we use Python, right? The #1 point would be the applications. Python is a very versatile programming language ranging from application development to web design, game design, UI/UX development, data science, machine learning, automation, etc. There's also the point of simplified syntax. If you usually work with languages like Java, C++, etc., you'll get me. Python is one of the simplest languages you can learn, and this fact doesn't impact any of the features. It is just as good as all the other options that you have, and the only thing is it's a lot simpler. The third point is well-built packages. Now don't worry if you don't know what packages are. I'll cover that later. The only thing that you need to know right now is that packages have the ability to replace hundreds of lines of code with just a single line of code. I'll show you how to do that later in this video. And the fourth point that I want to stress on is the highly supportive community. Look, I get it. Programming is not always easy and you get stuck sometimes. But with Python's community, you get a lot of support for the issues that you face, and I'm telling you, it's one of the most engaging and interactive communities that I've ever come across. Now, I think it's about time that we get started. I do want you to know that this video will be a hands-on session, and I want you to keep your computer ready and follow along with this tutorial. To get started with Python, you will need two things. The first thing is Python itself, which is an application that you install in your computer so that your computer knows how to interact and understand Python. The second thing you will need is a code editor or an IDE. There are a lot of code editors that you can come across, like Vim, VS Code, Sublime Text, Eclipse, Spyder, PyCharm, etc. In this video, we will be working with the Anaconda distribution. Now, I have chosen this because it's the easiest one with which you can set up your Python ecosystem. To install Anaconda distribution, all you need to do is open up your browser and then type download Anaconda. Now, once you are here, just follow the first link. If you are not able to find this link, then just follow the URL given above, anaconda.com/products/distribution. The installation procedure doesn't really change for any operating system. You can follow the same procedure for Windows, Mac, Linux, etc. So once you're here, just click download and save. Now once downloaded, just click on the file and open it up. Now once you're here, just follow the steps given by the application itself. You don't really need to do any other settings, just follow what's given in the application. I recommend that you install Anaconda to the path provided by the software itself because this makes it easier for the files to interact with each other. You can just follow along the steps and just make sure that this checkbox is always checked. Register Anaconda 3 as my default Python 3.9. What this does is that when you install any other code editors or IDEs, they will be able to recognize the Python that is installed by Anaconda in your system. After all this, you just need to click install and then it will start installing Anaconda to your system. Now the installation might take some time, but once this is done, just finish this up and then open up the start menu and type Anaconda Navigator. Once you have it, open it up and there you have it, Anaconda Navigator for Windows. Over here, you can see the collection of IDEs and code editors that you get with Anaconda Navigator. You also have your environments where you can manage your packages, your educational videos, and also a community to support your growth. In this video, we will be using Jupyter Notebook. And to use that, all you need to do is click Launch over here. Now you can think of this view as a file directory where you can create files, navigate through files, and even delete files. So right now what I'm doing is going to the desktop folder and then I'm clicking on New and Python 3. So what this does is that it creates a new file in my desktop folder to run my Python code. After that, I just want you to do a simple program. It's just one line, alright? Simply type print, all in small letters, and then open brackets, round brackets, and then single or double quotes, and then type some message. I'm typing hello world, and then we can run it by clicking on this button over here, or you can do shift plus enter, and it will show you your message. If you've gotten till here, then congratulations because you just created your first Python project. In this section, we will see what variables and data types are in Python. Variables are nothing but values that are temporarily stored in your computer's memory. Let me show you how to do this. To begin with a variable, you first type the variable's name, like for example, say age. And then what you do is, you assign it a value, like 40. So in the statement, what you're doing is you are assigning the value 40 to a variable name called age. Now, if you run this, again with the run button or shift plus enter, then you can see in the left hand side that this statement has been executed. And now, if you want to access the value of age anywhere in your code in the future, you can just type age and it will give you the result. Now, while you have declared a value for your variable, you should also remember that this value can be updated in the future. For example, say now I say age equals to 50 and I execute the statement. Then if I come back to our second statement, just age, you can see that the execution gives me the result 50. This means that age has been updated. So it's a good idea to always keep track of all the updated variables in your code. Let us continue by declaring a few more variables. Let's say temperature equal to 35.8. In Python, you can declare floating point variables, which is nothing but numbers with a decimal point, and also whole numbers. You can also type something like name equal to Edureka, and you can see over here that I have surrounded it with quotes. The reason why I do this is because whenever you write string values or sequence of characters, Python requires you to surround it with quotes, either double or single. This will help Python recognize the entire sequence of characters as a single entity. You also have some other kinds of data types like Boolean values. Now, Boolean values are nothing but, for example, you can say is offline equal to false. Now, one thing that you should know is that Python is case sensitive. Notice what happens if I replace the capital F with a small. See, it is not being highlighted anymore. This is because Python doesn't recognize this as a keyword anymore. It thinks of this as a name. So always remember to be aware of the case-sensitive keywords while coding in Python. You might also notice that I have used an underscore while declaring the keyword. This is just to make the code more readable. Notice what happens if I take off this underscore. It's not that readable, right? So, whenever you code in Python, always make sure that you enhance readability for anyone else who might access your code. Now, there are three types of values in Python. You have numbers, you have strings, and you have Boolean. Now, there are times where you will need to convert one type of data to another. Let me show you how. So you can see from our previous declarations, we have age equal to 50, which is a whole number. We have temp equal to 35.8, which is a decimal point number. You have a string, which is a collection of characters, and then you have a Boolean value over here. If you want to check the data type of all these variables, what you will need to do is say type, open brackets, and then type the variable name. If you execute this statement, then you will see that age is an integer data type. You can do the same for temp, and you can see that it returns float, which is a floating point variable. This just means that there is a decimal point in that number. You can also type name, which returns string. Now, string is represented as str or str in Python, and then you have your final variable, which is offline, which is a Boolean data type. Let's just get this out of the way now and try a few things. What if I want to convert age into a floating point variable? Doing this is very simple. What you need to do is type the name of the data type you want to convert it into, and then you open brackets, and then you type the variable name. So now you have converted age into a floating point value. You can see the decimal point over here. This concept is helpful in many situations. For example, if I want to say print age of xyz is plus age and execute the statement, you will see a type error. Can only concatenate str, not int to str. What this means is the data type string can be only concatenated or connected to another string. Python doesn't understand how to connect numbers with strings. Solving this is super easy. All you need to do is go over here and then say str of age. This will convert age into string and will allow Python to connect these two strings. Now, if we execute the statement, you can see that it is successfully executed. Now, with this, I have an exercise for you. I want you to collect the birth year of a particular individual, and using that information, I want you to find out his age. You can pause the video over here, take a few minutes, and then come back and see what the solution is. Now, you must have gotten stuck while receiving input, right? Doing this is super easy in Python. What you need to do is type input and then open brackets, and inside those brackets, you can give any message to your user. For example, enter your birth year. Now, obviously, you will need to store this in a variable, right? So let's just save it under birth year. Now, if we run this statement, Python will ask you to enter the input for your birth year variable. Now, I was born in 1998, so let me just type that and then I'll press enter. After this, we will need to subtract the current year with the birth year, right? Now, the current year is 2023 minus the birth year. Now, let's just execute this. And oops, we've got a type error. Unsupported operand types for int and str. Now, let's try to break down this error. Let's check the data type of birth year. Type birth year. You can see over here that birth year has been declared as a string, right? That's what's causing the problem. You're trying to subtract integer with strings. Now we can currently understand that birth year is a number, but Python isn't able to do that. So what you need to do is tell Python that this is an integer. And then if you execute this and type in the same values again, you will be able to get your answer. Now let's try to make this a bit more readable. First thing we need to do is assign this to a variable. So let's just say age equal to this expression, and we'll execute this again. And after that, we can say print age of xyz plus age. Now if we execute this statement, we again get an error. This is again a type error and can concatenate strings with strings, not int with strings, right? So again, we will need to convert this into a string data type so Python is able to correctly read the data. So let's execute this, and then you can see age of xyz is 25. In this tutorial, I will teach you how to do some cool operations using strings in Python. To do this, the first thing we will need to do is declare a string variable called title equal to Python for beginners. Now, after executing this statement, I want you to remember a few things. The first thing is that when you declare a string in Python, it is treated as an object. You can think of objects like real-world objects. Think of a car. A car is an object, and this object has a few functionalities to it, right? It can go forward, it can go backward, it can go sideways, it can honk, it can turn on the lights, etc. Strings are also the same. If you type title dot and press your tab button, you can see a list of functions. These functions are similar to like print, input, etc. The only difference is that print, input, etc. are general purpose functions, meaning that they don't belong to a particular object. And these functions belong to the object called string. Now, calling them functions isn't really the right terminology. When a function belongs to a particular object, you refer to them as methods. So all these methods that are listed over here belong to the object string. Now let us just pick an option called isLower over here. And if you execute this, you can see that it returns false. This means that our string is not completely in the lower case. So you have another method to do that. You can type title dot lower, and if you execute this now, you can see that all the characters, all the individual characters have been converted to the smaller case letters. Now, if you type dot is lower continuing this, then you can see that it returns true. You also have other methods like title dot upper, which returns all of the characters in uppercase letters. You also have other interesting methods for strings in Python like title dot find, which will help you find a particular character or a sequence of characters in your string. Like say if I say y in quotes, then it will return the value 1. You see 1 over here is the index of the first occurrence of this character. Now, the way indexing works in Python is simple. You start from 0 and then you continue with the numbers 1, 2, 3, 4, 5, 6, 7, etc. So when I say find the first occurrence of y, what it means is that the index that is returned is number 1. Now, You can also find the index for a sequence of characters like say for, and you can see that it has returned 7 over here. If you go back over here, you can see the F character starts at 7, and that is where the sequence of characters start from. There's also some other interesting methods that you can use over here. For example, you can try replace to replace one word for another, like say for example for with 4, and then you can see that the string has changed right now. Python for beginners. You should remember that these statements don't really make any changes to your original string. So if you go ahead and type title again, then the result of it would be your original string. If you want to save your modifications, then you will need to save your edits into a new variable. Now for the find expression that we talked about earlier, there is another replacement for it. For example, you can type print for in title, and this will show you the boolean value of your result. Like this sequence of characters does not exist in your variable. But if I change this to the small case, and now if I change it into something that is in the variable, then obviously it will return true. This kind of result is desirable in a lot of cases. Now, in this tutorial, we will be seeing the arithmetic operators in Python. Now, these are the same arithmetic operators that you find in math. For example, you can add numbers, subtract them, multiply them, and so on. So, let's just quickly do 10 plus 3, and you can see that the result is 13. This operator over here is called the addition operator, which adds two numbers. You also have the subtraction, which subtracts 3 from 10. You have the multiply, which is an asterisk, which multiplies 10 by 3, 30. And then you have the division. And technically, there's two types of division. One is a single slash, and the other one is a double slash. Notice what happens. When we did the single slash, we got a floating point value, right? But if you try a double slash, it will give you a whole number. After that, we have the modulus operator, which gives you the remainder of 10 divided by 3, which is 1. So we also have the option to make powers of something. For example, if you want to say 10 to the power 3, then you can put in 2 asterisks, and then if you execute it, you will get the result of 10 to the power 3. Now, for all these operators that you saw, we also have something called as augmented assignment. Let me show you what that means. So up until now, if you had to do something with arithmetic operators, you would have done something like this, right? X equal to 10, x equal to x plus 3, and then you would type print x. Now, there's nothing wrong with you executing your code like this, but you are taking a bit more memory when you do it like this. Because in this statement over here, you are loading x 2 times, right? So a simpler way to do this would be to say x equal to plus equal to 3. Now, this new statement is exactly the same as the old statement. Only difference is it's a lot simpler to write and it's faster. Alright, now let me ask you a question. Suppose I set x equal to 10 plus 5 into 2. What is the answer? Unfortunately, a lot of people get this wrong. The answer to this is 20. The reason for this is because mathematics has something called as operator precedence, where operators like multiplication and division has a higher priority than addition or subtraction. So when you evaluate this statement, you will first evaluate 5 into 2, which is 10, and then you will say 10 plus 10, which is 20. Let's execute to verify this. Now, operator precedence in Python also works the same way as it does in math. The only thing is that you can change this using brackets. So for example, if you want to execute 10 plus 5 first, you can just put this in brackets, and then 10 plus 5 will be executed first, after which it will be multiplied by 2. So let's just verify this again and you can see that it has been done. Now, you've already learned what arithmetic operators are in Python. Up next, we have another set of operators called as comparison operators. Let us see what it does. Suppose I write 3 greater than 2. If I execute this, it will produce a Boolean result, which means it will tell you whether 3 is greater than 2 or not. This operator that we have over here is called the greater than operator, and this belongs to a set of operators called as comparison operators. You also have greater than or equal to, you have less than or equal to, you have equals. Now don't compare this with the assignment operator, alright? This thing is checking for equality. It is checking if 3 is equal to 2 or not. So if I execute this, it will tell you it is false. Now one more operator that we have over here is the not equal to. This will check if something is not equal to something. Now 3 is not equal to 2, and that is why this will return the Boolean value true. So to summarize, we have the greater than, we have greater than or equal to, we have less than or equal to, we have equality, and not equal. These operators combined make up the comparison operators. Now that we are done with comparison operators, we have another set of operators called as logical operators. Now to demonstrate this, let me first declare a variable, age equal to 25. Now let's apply some logical operators to it. We'll first say age greater than 10 and age less than 30. Make note that the AND word over here is the logical operator. So now we have age 25 must be greater than 10 and age must be less than 30. So if you execute this, you will get this as true. The thing with AND operator is that both the left side of the operator and the right side of the operator must be satisfied. Another thing we have is the OR operator. Now for this operator, either the left side of the operator or the right side of the operator or the entire equation must be true. Let us demonstrate this. We can have age equal to 5, and then if we say this, and then if we come to the equation, you have age greater than 10, which is false, or you have age less than 30. Now, age is definitely less than 30, right? So this equation must be true. There we go. The last thing is the NOT operator. Let's just put it like this. If you use the NOT operator, it will give you the inverse of the result that you were going to get. So let's just say this. Age equal to 5 and age is greater than 10. So this is false, right? But if you use the NOT operator over here, the result will still be true. Now, you can obviously inverse this and test the result again. So to summarize this, you first have the AND operator where both sides must be true. Then you have the OR operator where at least one side must be true. And then you have the NOT operator, which will give you the inverse of your result. Now let's look at if statements. We use if statements whenever we want to make a decision in our program. For example, if we have something like, say, temperature, based on the value of that temperature, we can make certain actions. Let me show you. Let us first declare a variable called temperature equal to, say, 40. Now, based on this value, I can take certain actions. For this, I will start with writing if, which is a keyword, and then you write temperature greater than 30, and then a colon, and then you type enter. You see over here, if you observe what you have done, you have first written an if statement and then used a conditional statement to check if the temperature is above 30. Now, a colon in Python is used to segment a block of code. If you see our text cursor over here, you can see that there are a few spaces behind it, right? This is what we call an indentation. In Python, if you indent a particular piece of code, it will belong to the previous statement. This is similar to using curly brackets in languages like C, Java, etc. So be very careful as to not put unnecessary indents in your code. Now, for our condition, let us say if temperature is greater than 30, we'll print, say, it's a hot day. You can see that I have written this string in double quotes. This is because I have a single quote in the word it's. So if I put single quotes over here also, then Python will think that you are just making a mistake while writing. So double quotes over here, and let's continue. As I told you before, since you put a colon over here, everything below that colon is treated as a block of code. So as long as this indent remains, this block of code will be executed only if this condition is true. Let's add another statement over here. Let's say print, it's time for cola. After this, we can come out, and if we execute this statement, you can see that it's hot day and it's time for cola. Now, know that you can add as many conditions as you want to. Now, what if this value was less than 30? Let's say 29. What would happen then? Nothing happened, right? This is because the condition was proved false, and that is why these statements didn't get executed. Remember that you can add as many conditions as you want, and all you have to do that is type elif, and then you can come up with another statement. Say if temperature is less than 30, then print it's nice day. You can also go ahead and write if temperature is less than 10, then print that it's a cold day. You can also add a statement saying print done over here. You should remember that this statement doesn't belong to any condition, so it will be executed no matter what happens. So if you execute it now, you can say it's a nice day and done. Great, right? Now let me ask you a question. What if I asked you to print the numbers 1 to 5? How would you go about by doing that? Obviously, you say print 1, and then print 2, print 3, print 4, and then print 5. But I'm telling you that this approach is wrong. The reason is because I asked you to just print from 1 to 5. But what if I asked you to print from 1 to 100, or 1 to 1000, million, billion perhaps? Would you go about the same way, writing it down individually? Obviously not, right? That's a very time-consuming task. So to handle that, we have something called as loops. And the first kind of loop that I want to talk about is the while loop. Let me show you how you can start using it. The first thing that you do is start with a variable and assign it the initial value of the sequence that you have. For example, I have given I equal to 1. After that, I will type the while keyword, and then I have my conditional statement. While I is less than or equal to 5, and then colon, after which I get a block. Over here, the first thing is I have to print the number, right? So print I, and then we will need to start increasing the value of I by 1. So let's say I plus equal to 1. This will start incrementing the value of I by 1 every iteration. If you don't put the statement, then it will print the initial number until your computer runs out of memory. So now let's just run this, and you can see that your output has been printed over here. Now, you can also change this into, say, 1 to 100 or even 1000. Remember that if you want to increase readability of your numbers, you can always separate it by an underscore. So this is like 1, 000. So now we have the output 1 to 1000. You can also print interesting patterns using this. Let me show you. If you type the same thing and then say I multiplied by a string, you can give it any value that you want. And then if you execute this, you can get patterns. You can see that you've got a triangle over here. What this is a string operation. Basically, you can multiply strings in Python. So if you say I equal to string and then I has the value 1, then this will be printed once. And if I equal to 2, it will be printed twice. I equal to 3, then it will be printed thrice, and so on. Earlier in the video, I introduced you to the data types in Python. This included numbers like integers, floating point variables, strings, and boolean. Now these data types are something that we call as basic data types in Python. There are also some complex data types, and one of them is called lists. A list is nothing but a group of objects. Let me show you how you can do this. First, you will start with the variable name. Let's just say we are doing a collection of names. So our variable name is names, and then equal to, and then we have square brackets. These square brackets represent a list. And now inside this list, you can write down a bunch of names. So let's say Elton, and then you have Sam, Bob, and Emma. You can use either single quotes or double quotes. It doesn't really matter. Now if you execute the statement and then you call out the variable, you can get a list of all those objects. The interesting thing happens from now. While you call out the variable, you can also call out individual variables. Like say you want the name of the second index. So you have 0, 1, and 2, right? So second index, and you can get Bob directly. You can also give a negative value. Now, what do you think happens if I give a negative 1? So this is 0, and then a negative value would be the last element of your list. So if you execute this, you must get Emma. And if you do a negative 2, then it will be the second last element. Now, this is not it. You can also go ahead and get a range of values, say from 0 to 2. What this means is that you will start from 0 and you will print all the elements until you reach 2. Remember that if you execute this, the last value, like the ending parameter, won't be printed. So for example, over here, I have 0, 1, and this 2 won't be printed. See, there you go. Now this is what we mean by list operations. You should also remember that a list doesn't really need to be just a single data type. You can also include numbers, like integers, floating point variables, and even boolean. And if you execute that, you will still get the same result. Early in this video, I told you how to use string methods, right? This was because strings was an object and objects have methods. Well, the thing is, list is also an object, and list also has many methods associated with it. The functionalities of this include adding an element, removing an element, modifying an element, etc. Let us see how to do this. Let me first declare a list of numbers. Say numbers equal to 1, 2, 3, 4, 5, etc. Now we have a list called numbers. Let's see what methods this numbers list has. So we'll type numbers dot and tab, and you can see over here append, clear, copy, count, extend, index, etc. So let us start with, say, append. Now, append is a method that is used to add numbers to the end of the list. So if I say append 6, then my list would be 1, 2, 3, 4, 5, 6. Now, if you type down numbers again and check its values, you can see that you have 6 at the end. See, there you go. We also have another method called as insert. Now, the problem with append is that you can only add numbers at the end, right? But with insert, you can add it anywhere in the list. To use this method, you need to give two values. First thing is the index, second thing is the value of the element itself. So say I want to add a value at index 0 and the value would be 0. Then if I execute the statement and execute it, you can see that 0 has been added. We have 0, 1, 2, 3, 4, 5 and 6. Now sometimes there will be situations where you would like to know whether a certain element exists in a given list or not. So to do that, you can use the in operator. For say, you can write 1 in numbers, and then if you execute the statement, you can see it gives you a boolean value of true. You also have other methods like numbers dot clear, and this will clear the entire numbers list for you. So if you want to know more about list methods or anything in general, then you can head over to the description given below, and I have pasted a blog link over there. This blog lists down all the keywords, methods, syntax errors, etc. And it can give you an approach as to how you can learn Python. Now I want to cover another looping method called as for loops. You see, sometimes in Python, you will come across situations where you would like to iterate over a list of numbers individually. This is where for loops come into picture. Let me show you. Suppose we have a list of numbers 1, 2, 3, 4, 5. Now what if we want to print them out? You would obviously write print and then numbers, right? That will give you the entire result. But now, what if I asked you to print each of these out separately? This is where you can use for loops. What you will do is start by writing the for keyword, and then you will mention the iterator. The iterator is just another variable name. You can keep it anything. I will keep it as items. In, and now the variable name, numbers, and then colon. And after this, you have a separate code block. And over here, you can see print items. Now, if you execute this, you will have 1, 2, 3, 4, 5, all in separate rows. You can also do this with while loops, but it will just be a bit longer. Let me show you. You'll start with I equal to 0 because that's your initial iterator. After which, you'll say while I is less than len of numbers and then colon. Now, if you're wondering what len of numbers is, len is just a method that will give you the length of your list. After this, you can say print numbers and then give the index. You will also need to increase the value of your iterator for every iteration. You can get the same results, but compare and see which one is more simpler. This is why most of us use for loops for iterations. Now, in this section of the video, we will see at a function called range. So, range is a function that will give you a range of values. Let me show you. You type range and then you pass a value to it. Now, if you execute this, you will see range 0, 5, which means that this range function contains the values 0 to 5. You won't get the actual values itself because this is the default representation of the range function, but you can iterate through this function by using a loop. For example, say for number in range 5 print number, and if we execute this, you will get the number 0 to 4. Note that the index starts from 0, so you won't get the written value over here, but the written value minus 1. Now we can also give two values over here, say 5 to 10. This will return a value from 5 to 10, 10 excluded. So it will be 5 to 9. There you go. You have the values 5, 6, 7, 8, and 9. You can also add a third value over here, like say 2. This is the number of steps it will take per iteration. The default over here is 1. That is why you can get a difference of 1 over here, right? But if you say 2, then it will go from 5 to 7 to 9. If I execute this, there you go, 5, 7, and 9. In this section of the video, we will be looking at tuples. Now, tuples are kind of like lists, but tuples are immutable. What this means is that once you declare a tuple, it can't be changed. Let us see how to do that. You'll first start with the variable name as always. Let's say numbers equal to 1, 2, and 3. Now, till now, you've been using lists, right? And when you do lists, you use a square bracket. But with tuples, you will use round brackets. And once you execute this, you can check for the methods. And you won't find anything like append, remove, etc. You have count and you have index. Now, what count does is, suppose you have 2 elements of some sort, and you say numbers.count 3. Now you can see that numbers.count has given you an output of 2. What this means is that 3 occurs twice in your tuple. The other method is the index. The index will just return you the first occurrence of a particular element that you ask for. Now, why do you need tuples? Well, I agree that we will be working with lists most of the time, but there are certain situations where you wouldn't want someone or yourself to accidentally change the data in your list, right? That is where you will use tuples.
Now let's talk about the next one that we have, which is a specialized data structure, obviously, and that is chain map. So chain map is a dictionary-like class which is able to make single view of multiple mappings. So it basically returns a list of several other dictionaries. Suppose you have two dictionaries. Suppose you have two dictionaries with several key value pairs. So in this case, chain map will make a single list of both the dictionaries in it. So as you can see in this example, we have two dictionaries, A and B. And if I use the chain map, it will return me a single view of these two values or multiple mappings. So let's take it up to PyCharm, guys. We'll try to implement this again. So I'll remove this, and instead of deck, we are going to import chain map, guys. So it's very simple. So let me declare two dictionaries, guys. So first of all, I'll give a value, let's say one Edureka. Then the second key value pair is going to be, let's say, Python. Now let's take one more, and inside this I'll give the value, let's say ML, and the fourth one is going to be, let's say, AI. Now using the chain map, I'm going to specify these two dictionaries in this. So let's print A1. Let's see what happens. So as you can see, I have made a chain map which has a single view for multiple mappings, which is A and B, guys. So this is what you can do using the chain map, guys. I hope you understand this. So this is a very basic example, guys, to let you actually understand what is happening over here. So we are using these two dictionaries, and we are able to get it inside a single view, guys. So let's take a look at the next one that we have, which is counter, guys. So counter is also like a dictionary subclass which is used to count hashable objects. Now, what are hashable objects? So let's take a look at this example. So let's say we have a list. Inside this we have different elements. So what counter is going to do is, okay, let's take it to PyCharm to understand this better, guys. So I'll remove this, and instead of chain map, let's say I have counter. So let's take a list, guys. So I'll specify some duplicate values because this is what it is used for, to count the hashable objects, guys. Now what I'll do is I'll make one variable and use the counter and pass A over here. So when I print C now, let's see what happens. So as you can see, I'm getting a dictionary inside which I have these values. So which is saying the number of times 2 has occurred is 5, number of times 4 has occurred is 3, and then again 1, 2, and all. So when I run this again, I'm getting the same value. So this is how you can actually use counter, guys, to count the hashable objects inside any iterable value. So we have a list, we can do it for any other iterable object, guys, like a tuple or set. So this is all about counter. I hope you understand this. Now in addition to the operation you can perform on a dictionary, counter has 3 more operations that we can perform. So which are basically an element function, a most common function, and a subtract function as well. So we'll talk about them in detail now. So talking about the element function, guys, so let's see what elements does. So we'll see elements now. So over here we want the list, so we will put it in the list constructor, guys, and let's print this. Okay, let's see what are we going to get. So it returns a list containing all the elements in the counter, guys. So as you can see, I'm getting all the values that I have inside the counter, and this is the counter that I have. So 2 comes 5 times, 1 comes 2 times, and then we have 3 2 times, 4 3 times, and so on. So this is the function of elements function, which is returning a list containing all the elements inside the counter. And now let's take a look at the next function that we have, which is the most common function. So let's get on to it. So we'll use the C, which is our counter, guys. So I'm going to use the most common here now. So let's see what I will get here. So I'm actually getting a sorted list with the count of each element inside the counter. So we have 2 5 times, 4 3 times, and 1 2 times, 3 2 times, 5 2 times, and 6 1 time. So this is actually how you can use the most common function. And then we have one more function, which is subtract, guys. So for subtract, let me get one more variable. So I want to subtract, let's say, so I'm getting 2 5 times, so I'll just subtract 2 1 time, and I'll subtract 6 1 time. So what I'll do now here is I'll use the counter and let me use the subtract function, guys. Here it is, and I will pass sub over here. Let's see what happens. Okay, so now when I print my counter, okay, I'll get the values, the most common values again. So now as you can see, 2 is coming 4 times here and 6 is coming 0 times because I have subtracted using the subtract function. So this was all about counter, guys. Let's talk about the next data structure, which is ordered dictionary. So ordered dictionary is a dictionary subclass which remembers the order in which the entries were added. Basically, even if you change the value of the key, the position will not be changed because of the order in which it was inserted in the dictionary. So let's take it up to PyCharm, guys. We'll implement the ordered dictionary over there. So I'll remove all this, and instead of counter, we will import ordered dictionary. Now what I'll do is I will implement an ordered dictionary, let's say D, and now I'll add a few values. Let's say, okay, the first one is going to be E, and then the second one is, let's say, D. Now let me print D over here, which is our ordered dictionary. Let's see what the output will be. So we have an ordered dictionary which is saying on the first value we have E, and then so on we have Edureka, all the letters from Edureka, guys. So this is how you can actually implement an ordered dictionary, guys. So let me take a look at what all functions do I have in this. So I have pop, update, pop item, get items, from keys, set default, values, clear, copy, keys. So let me get all the keys from this. So when I run this, okay, let me print this. Now as you can see, I'm getting the ordered dictionary keys, which is 1 2 3 4 5 and 7. And similarly, I can get, instead of keys, let's see what all we can get. We can update pop item. Okay, let's get items. So the functions are actually similar to what we have for dictionary, guys. So this is all about ordered dictionary, guys. It remembers the order in which the elements were put inside the dictionary, guys. Okay, let me do one thing, guys. I'll change the value. Okay, first let's print this so you'll understand it better. So now what I'll do is I will change the value at 1. So instead of E, let's say I want P over there. And now when I print it, let's say what happens. So as you can see, I have replaced the value over there. But since it was inserted in the beginning, like the first one was E, the value is not changing over there. So this is the main reason why we use ordered dictionary, because it remembers the order in which the elements are being added inside the dictionary. So now that we are done with ordered dictionary, let's talk about default dictionary, guys. So what basically default dictionary does is, it is a dictionary subclass which calls a factory function to supply missing values. So in general, it does not throw any errors when a missing key value is called in a dictionary. So you'll understand this better, guys. So let's take a look at this example. We have a default dictionary in which we have to specify our type as well. So let's say we have two values. On the first value, we have Edureka and then we have Python. But instead, we want to print Java over there, which is not actually inside the dictionary because there is no value present over there. But we will not get any key value errors and it will instead give the output as 0. So let's take it up to PyCharm, guys. We'll try to understand over there. So let's remove all this. Now instead of ordered dictionary, we are going to import default dictionary, guys. So let's make a default dictionary. And inside this, let's specify the type as well. Now let's say we have the first value as Python, the second value, let's say Edureka. Now when I print this D over here, I'm getting the value as it's showing me that we have a default dictionary which has a class int that we have specified over here. And then we have a dictionary with the values 1, 2, which has Python and Edureka respectively. Now let's say I want to get the value at the number 3, which is not actually present there. But I'm getting the output as 0. So I'll show you the difference, guys. What actually happens if you do this in a normal ordinary dictionary, guys. So I'll make one more dictionary, let's say A, and I'll give it some value, let's say Python and Edureka. Now when I print this, which is not actually present inside the dictionary, let's see what we are going to get. We are going to get the key error, guys, because 3 is not actually present inside this ordinary dictionary. But if you put it inside a default dictionary, you're not going to get this error, guys. So this is what is the function of default dictionary, guys. It does not show you or throw you any key error, even if the value is missing inside the dictionary, guys. So now that we are done with default dictionary, let's take a look at the next one that we have, which is user dictionary, user list, and user string. So these three data structures are actually same but different. So let's talk about them one by one. So talking about user dictionary, this class acts as a wrapper around dictionary objects. Now the need for this class came from the necessity to subclass directly from the dictionary. It becomes easier to work with this class as the underlying dictionary becomes an attribute. Now talking about the user list, this class acts like a wrapper around the list objects. And it is useful base class for other list-like classes which can inherit from them and override the existing methods or even add a few new ones as well. And the need for this class came from the necessity to subclass directly from list. It becomes easier to work with this class as the underlying list becomes an attribute as well. Now talking about user string, guys, it is also a wrapper around string objects for easier string subclassing. Now the need for this class has been partially supplanted by the ability to subclass directly from string. However, this class can be easier to work with because the underlying string is accessible as an attribute.
What is a set? A set is basically a data structure, guys, which is a collection of unordered elements. All elements in a set are unique, which means every element is present just once. Now these values can be of any data type, but they are not indexed. And because of this, you cannot perform indexing operations such as slicing on sets. So now that you know what are sets, let's move on and see when to use sets in Python. Sets can be used when the order of data actually does not matter, but the only concern is your data elements need to be unique. So now let's move on to see how to create sets in Python. To create sets in Python, you can use two methods. The first method is to use the curly braces and the second is to use the set constructor. I have a small example where I've created a set A using curly braces and a set B using the set constructor. Now let's move on towards our Jupyter notebook and create some sets in Python. The first thing I'm going to do over here is change the name of my notebook. You can give any name of your choice and rename it. Like I've already told you, you can create sets in two ways. The first to use curly braces and the second to use the set constructor. Let's just create some sets using both these methods. I've created a set A using curly braces, and then I've specified some random values to it. You can also notice that all these values are of different data types. After that, I've created a set B using the set constructor. This set constructor has converted a list of values into a set. Hope you're clear with how to create sets. Now let me just show y'all how to create an empty set using the set constructor. All you have to do is give some name to your set, say for example C, and use the set constructor without passing any values to it, and hit run. Now when you print this set, you can see that the set is empty. It has returned an output which is an empty set. So I hope you're clear with how to create sets in Python. Now let me just show y'all what are all the methods you can use along with sets. To do so, you can use the dir method and supply the name of the set as a parameter to it. When I used dir and passed A as a parameter, which is a set that I've already created, it has returned a number of methods as its output. So all these are the methods you can use along with sets. Now let's get back to our presentation and see what are the operations we are going to perform in this session today. First of all, we'll be finding the length of a set and accessing its elements. After that, we'll be adding or updating elements of a set and then removing and deleting elements from it. Following that, we'll perform the mathematical operations that are union, intersection, and difference of sets. Now let's move on towards the first operation of this session, which is finding the length of a set. To find the length of a set, you can use the len method. The length of a set is the number of elements that are actually present in that set. And this len function will return an integer value which is equal to the number of elements present in the set. I have a small example where I've created some random set with the name mySet and I've passed some values to it. After that, I've used the len function and passed the name of the set as a parameter. Now let's go to our Jupyter notebook and see what happens when I do this. I've already created set A, B, and C. I'll just reprint my set A over here so that it's easy for us to refer to it. Now let's find the length of A. When I used len of A, it has returned 7 as the output, which is equal to the number of elements present in my set A. Now let's get back to our presentation and see how to access elements of a set. Since sets contain unordered elements, you cannot use index values to access its elements, but you can loop through it to access the elements of a set. I'll just jump onto my Jupyter notebook and show you all how to access set elements. I'll reprint my sets A and B over here. I've used the for loop to access the elements of set A. All I've done is for every element present in A, print that element. And as you can see in the output, all the elements present in A have been returned one after the other. Now let's get back to our presentation and see how to add elements to a set. To add elements to a set, you can use either the add method or the update method. Now this add method will allow you to add a single element to your set, but the update method will allow you to add a list of values to your set. I'm going to be showing you all how to use both these methods in this session. So here is my Jupyter notebook. When I use the update method, I've passed a list of values to be added to the set C. But here, I've passed 3 again, and 3 has been added just once, and it's not been repeated again. This is because sets contain unique elements, and there is no second copy of one element present in a set. So I hope you've understood how to add elements to a set. Now let's move on to understand how you can remove elements from a set. To remove elements from a set, you can make use of the remove, discard, or the pop methods. The remove method takes one parameter, which is the element to be removed from your set. Now, in case that element is not present in the set, this method is going to throw an error. The question is, what if you're not sure if some element is present in your set or not, but you want to make sure that this element is not present and your program does not throw an error? In this case, you can use the discard method. The discard method takes one parameter, which is the element to be removed, and in case that element is not present in the set, this method will not throw any error. Now moving on towards the pop function. The pop method removes a random element from your set. Now let's get back to our Jupyter notebook and use these methods. I'll reprint all the 3 sets over here. First, I will use the remove method. I've used the remove method and I've specified 2.4 to be removed from the set A. When I print the set A, 2.4 is no more present in my set. Now let me try to pass some value that is not present in the set A. When I use a.remove 6, which is not present in the set A, it has thrown an key error and it specified that 6 is the key which is not present in the set A. So I hope you've understood how to use the remove method. Now let's use the discard method and see what happens. When I used b.discard3, it has removed 3 from the set B. Now let's try to give some parameter to the discard method which is not present in set B. When I used b.discard90, it has executed but it has not thrown any error. So I hope you're clear with both these methods. Now let's try to use the pop method. When I used a.pop, it has popped some random value from the set A and it has returned it as the output over here. 1 is no more present in the set A. So I hope you're clear with how to add and remove elements from a set. Now let's move on to our presentation and see how you can find the union of sets. Union of sets refers to the concatenation of two or more sets into a single set. But in case you have any common values in these sets, the resulting set will contain just one copy of the common element. You can perform the union operation in two ways. One is using the pipeline symbol and the second is using the union method. I have a small example where I've created a set A and B and then I've used the pipeline symbol and the union method to find the union of these two sets. Let's go to our Jupyter notebook and see how this works. I'll reprint my sets A, B, C over here. I've used the pipeline symbol to find the union of A and B. All the elements that are present in A and B has been returned as a new set which is the union of A and B. But the common element are just printed once. Now let's see how to use the union method to perform this operation. I've used the union method to find the union of A and B. Now let's try to find the union of three sets using both these methods. As you can see in the output, I've used the pipeline symbol to find the union of three sets and then I've used the union method to find the union of A, B and C. So I hope you're clear with this. Now let's get back and see what is intersection of sets. The intersection of two or more sets is the formation of a new set consisting only of the common elements that are present in all these sets. You can perform this operation in two ways. One is using the ampersand symbol and the second is to use the intersection function. I'll be showing you all how exactly to do this on our Jupyter notebook. I've used the ampersand symbol to find the union of A and B. And you can see over here the elements that are common between the set A and B are 4 and ABC. Hence the output. Now let's try to use the intersection function. I've determined the intersection of A, B and C using the intersection function. And the resultant is a string which is present in all these sets. So I hope you're clear with both these methods. Now let's get back to our presentation and see what is the difference of sets. The difference of sets produces a new set which contains all the elements that are present in one set except the common elements. To make you all understand this concept clearly, let me jump on to my Jupyter notebook. To find the difference of set, you can use either the minus symbol or the difference method. First over here, I'll be using the minus symbol. When I found the difference of A minus B, I've got all the elements that are present in A, but not the common elements of A and B. When I used B minus A set has been returned which contains all the elements of B except the common elements of B and A. So I hope you're clear with what is the difference of sets. Now let's use the difference method to do the same. I've used the difference method to find A minus C. And as you can see, all the elements present in A but not the common elements of A and C have been returned as my output. You can use the difference method to find the difference of 3 sets as well. When I found the difference of A minus B minus C using the difference method, only one element has been returned which is present in A and not present in B and C. Hope you're clear with this. Now let's move on towards our final topic of this session, which is the concept of a frozen set. A frozen set is a set whose values cannot be modified, which means when you freeze a set, it becomes immutable. To create frozen sets in Python, you can use the frozen set method. As you all know, I've created a set A. Just make a note, guys, that you cannot add or remove values from a frozen set. As you all know, I've created a set A, which is a normal set, and I've been using it to add and remove values from it. Now let's freeze this set. I've created a new set D, which is a frozen set, and I've supplied the values of A as a parameter to this frozen set constructor. Now let's see what happens if I try to add some values to this frozen set. When I used d.add3, it has returned an attribute error, which says frozen set object has no attribute add. Therefore, frozen sets are immutable, and you cannot change the values present in the frozen set. Frozen set helps to serve as a key in a dictionary. What exactly is an array? An array is basically a data structure, guys, with ordered series of elements. Any variable that is declared as an array can hold more than one value at the same time. All values in an array have a particular address which is specified by its index number. Here, as you can see on the screen, I've declared a variable A as an array, and I've stored values from 1 to 100 in my array, which is A. Also make a note of the index values. Indexing always starts from 0 and not from 1. Therefore, A of 0 holds 1, A of 1 holds 2, A of 2 holds 3, and similarly, A of 99 holds 100. When the length of my array is n, the index value will be n minus 1. It is always 1 less than the length of the array. So I hope you're clear with this topic. Now let's move on towards our next topic for this session, which is the difference between Python lists and arrays. Python lists and arrays have the same way of storing data, but there is a key difference that you all have to note. Arrays can store only single data type values, whereas lists can store any data type values. So for example, if I have an array of integer values, all values present in that array will be integers and nothing else. On the other hand, if I have a list, then it can store integers together with float and chars and strings, etc. Now when you try to perform some operations like slicing or looping, it will be similar for both. But when you try to perform different operations, like if you want to multiply your array values by 2 or you want to divide it by 2, you can do so easily when you have an array. But if you try to do the same with a list, it will throw an error because naturally you cannot multiply chars and strings or divide them. So I hope you're clear with the difference between these two. So now let's move on towards the next topic. How to create arrays in Python. Unlike other programming languages, if you want to create arrays in Python, you will have to import the array module. Now this module has all the functions that are necessary for creating and performing various kinds of operations on arrays. To import the array module, you can use 3 ways. First is to import the array module by its original name, which is array. The second method is to use an alias name. This is the most widely and commonly used method as well. In my demonstrations, I'm going to be using this method. The third way is using star. From array import star. What this does is it's going to import all that is present in your array module. Now let's go to our Jupyter notebook and try to do this. Please do it along with me, guys. I'll open a new notebook and I will use the first method to import the array module. As you can see, when I hit run, no error has been returned, which means this is executed. Now let's try to create arrays using this method. As you can see over here, I've created an array A using the first method. So I have used array.array of integer values and I've specified some random integer values. Here, the first array is the name of the module. The second array is the array constructor. And then I've given a type code. This type code specifies what type of elements my array will hold. As you can see, I've created an array. So I hope you're clear with how to create arrays using the first method. Now let me open a new notebook and try the second method. The reason to open a new notebook is because I've already imported array module in this notebook. I'll rename this notebook because I'm going to be using this method in further demonstrations as well. As you can see over here, when I use import array as ARR here is my alias name. When I use this and hit run, it does not throw any error. Now let me try to create arrays using this method. I'm using int as my data type. You can use any data type of your choice. As you can see that an array has been created with some random integer values. In place of the module name array, I've used ARR. Now let's try the third method. I'll open a new notebook again. As you can see over here, when I'm creating arrays using the third method, I've just specified the constructor name and then the type code and the value list. So I hope you're clear with how to create arrays using all three methods. Okay, so now let's get back to our presentation. Our next topic for this session is accessing array elements. To access array elements, you'll have to make use of the index values. Each index value holds a unique element. Like I've told you before, indexing starts from 0 and not from 1. So therefore, A of 0 holds 1, A of 1 holds 2, and so on. This is the normal traversal order which starts from the left-hand side and moves towards the right-hand side. But here, I want you all to note this point as well, that negative indexing also exists. So negative indexing will start from the right-hand side and move towards the left-hand side. Therefore, 100 will be at A of -1, 99 will be at A of -2, and similarly 1 will be at A of -100. So I hope you're clear with negative indexing. Now let's go to our Jupyter notebook and try to access some array elements. As you can see over here, I've created a heading. To create a heading, all you have to do is go to code, select heading, and prefix your text with the number of hashes based on the heading level you want. So if I want h1, I will use 1 hash. If I want h2, I will use 2, and so on. Here I've created a heading of h1, so I prefixed my text with 1 hash. Now let me try to access some array elements. As you can see over here, when I access A of 2, my output is 3. Let's see where 3 is present in my array. 1 is present at A of 0, 2 at A of 1, and 3 at A of 2. So therefore, when I access A of 2, 3 has been returned. Are you guys clear with this? Just give me a quick confirmation before I move on towards the next topic. Shashank says yes. Preeti says, please try to access something using negative index values. Okay, Preeti, let me show you that as well. So here I've tried to access a of -2. A of -2 has returned 5. Let's get back to our array A and see where 5 is present. 6 is at a of -1 and 5 is at a of -2. Therefore, my output is 5. So Preeti, are you clear with this? Okay, Preeti says yes. Now let's move on towards our presentation and see what is the next topic. Our next topic of this session is basic array operations. Here, I just want to tell you all something. Arrays are mutable, which means they are changeable. So in case you want to add or remove elements from it, you can do so easily. Now coming back to our presentation, our first operation under this section will be finding the length of an array. The second is adding or changing elements of an array. And then we will try to remove or delete elements of an array. And then guys, we will try to perform array concatenation, slicing, and finally we will be looping through an array. Now let's move on towards the first operation. To find the length of an array, you will have to make use of the len function. Now this function returns an integer value which is equal to the number of elements that are actually present in your array. The len function takes one parameter which is the name of your array. As you can see in the example over here, I've created some random array A and I've given some random values. As you can see, I have 3 values over here. And when I use the len function and I specify the name of my array, the output is 3, which is equal to the number of elements that are present in my array. Now let's move towards our Jupyter notebook and see how this works. As you can see over here, when I use the len function and I've given the array name which is A, an integer value is returned which is 6. 6 is the number of elements that are actually present in my array which is A. Okay, so I hope you're clear with this. So our next operation is adding elements to an array. In case you want to add elements to an array, you can do so using the append, extend or the insert function. The append function is used when you want to add an element to the end of your array. The extend function is used when you want to add more than one element to the end of your array. The insert function specifically adds a new element to a particular position in the original array. Let's have a look at a small example of these 3. As you can see on the screen, I've created some random array A and then I've used the append function and I've given the value that I want to add to my array. As you can see in the output, 3.4, which is the value I've specified to the append function, has been added to the end of my array which is A. And then I've used the extend function. Please make a note over here that when you use the extend function, you will have to specify the values between square brackets. If you don't use the square brackets, it will throw an error. I've given 3 new values and all 3 values have been added to the end of my array. And then I've tried to use the insert function. Over here, I've specified the index number as 2 and the value to be inserted at that position as 3.4. As you can see in the output, 3.4 has been inserted at C of 2. Now let's go to our Jupyter notebook and we'll do the same. I'll reprint my array which is A so that it's easy for us to refer to it. Since my array A holds integer values, I will give some new integer value to it. As you can see, I've given 8 as the value that I want to insert in my array, and 8 has been added to the end of my array. Now let me try to give some float value to this array and see what happens. As you can see, when I try to append some float value, it gives me a type error. Therefore, I can add only those values which is specific to the type of elements that are present in that array. Now let me try to use the extend function. Like I've told you all, when you're using the extend function, you will have to make use of the square brackets. As you can see in the output, all the values that I've specified within the extend function have been added to the end of my array. Now let me use the insert function. I've used the insert function, and the first parameter I've specified is the index value, and the second is the element to be inserted at this index position. So at index value a of 2, 6 will be inserted. As you can see in the output, 6 has been inserted at a of 2. So I hope you're clear with how to add elements to an array. Now let's move on towards the next operation. Our next operation is removing elements of an array. In case you want to remove elements from an array, you can make use of the pop or the remove function. The pop function removes the element and returns it, whereas the remove function will remove it but it will not return it. The pop function can either take no parameters or one parameter. The parameter it takes is the index value of the element to be removed. If you do not specify any parameter, it will remove the last element from the array. The remove function takes one parameter, which is the element to be removed itself. Now let's have a look at a small example of this. As you can see on the screen, I've created some random array A, and then I've used the pop function without specifying any parameter. As you can see in the output, when I do not specify any parameter, the last value present in my array has been popped and returned as well. Second time, I've used the pop function and I've given some index value. Now this pop function will remove the element that is present at this index position. As you can see, it has removed 3.1 and returned it as well. After that, I've used the remove function. Like I've told you before, the remove function takes one parameter, which is the element to be removed. And you can see in the output that the remove function has not returned any value. After that, I've printed my array. And you can see all the values that are removed using these two functions are no more present in the array A. Now let's go to our Jupyter notebook and do the same. Let me reprint my array, which is A. First, I will use the pop function without specifying any parameter to it. As you can see over here, when I do not give any parameter, it removes the last element that is present in my array. Now let me give some index value to it. I'll reprint my array A because I've removed an element from it. Now let me give some index value to the pop function. As you can see, when I use a.pop of 2, it removes the element which is present at a of 2, which is 6, and it returns it as well. Let me try to use some negative index value for the pop function. A.pop of -1 removes the last element that is present in my array, which is 5. Now I'll use the remove function. Let me reprint my array, guys. As you can see, all the elements that have been removed using the pop function are no more present in my array A. Like I've told you before, when using the remove function, you will have to specify the element that is to be removed. Here, let me remove 8, because there are two occurrences of 8. And let's see what the remove function does. When I hit run, remove function does not return anything. Now let me print my array A and see what is present. As you can see, the first occurrence of 8 has been removed, but the remove function did not return the value. So I hope you're clear with the remove and the pop functions. Now let's get back to our presentation and perform the next operation. Our next operation is array concatenation. Concatenation means joining. So in case you want to join different arrays, you can make use of the plus symbol. As you can see on the screen, I've created some random array A and B, and then I've created some random array C, which is empty. Also make a note that all three arrays have the same type code. And then I've concatenated A and B into my empty array, which is C. As you can see in the output, all the elements present in A and B have been concatenated into my array C. Now let's go to our Jupyter notebook and perform array concatenation. I'm using int as my data type. You can use any data type of your choice. To create an empty array, all you have to do is specify the type code and leave the value list empty. Here I've created an empty array D and I've concatenated B and C into my array which is D. Now let me hit run. When I hit run, all elements present in B and C have been concatenated into my new array which is D. So I hope you're clear with array concatenations. Let me just show you what happens if I try to concatenate arrays of different data types. I'll just change one of my previously created arrays type code and I'll give it as float. Let's see what happens when I change the type code and I try to concatenate these two arrays. You can see that I've encountered an error and it says type error, which means it cannot concatenate two arrays of different data types. So just be careful when you're concatenating arrays. You cannot concatenate arrays which hold different data type elements. Okay, now let's move on towards our presentation and see what is the next operation. Our next operation is slicing an array. Slicing actually means fetching some particular values from your array. To do so, you can make use of the colon symbol. As you can see on the screen, I've created some random array A and I've sliced it from 0 to 3. 0 specifies from where fetching has to start and 3 specifies where it has to stop. So, it will start from 0, it will go on till 3, but it will not include the value which is present at 3. As you can see in the output, I have A of 0, A of 1 and A of 2 that is present in my output. Now let's go to our Jupyter notebook and we will try to slice our arrays. I'll reprint my array D over here and then I will try to slice it. As you can see, I've sliced my array from 0 to 5. So it will start from index number 0, it will go to 5, but it will not include the value which is present at index number 5. You can also see the same in the output over here. Let me try to use some negative index value. My output when I use 0 colon minus 2 contains all the values between 0 and minus 2, but it will not include the value which is present at minus 2. Okay, so I hope you're clear with this topic. Just give me a quick confirmation before I move on. Okay, Anil says yes. Shashank has a question. He asks, what does colon colon minus 1 mean? Shashank, unlike what many of us think, colon colon minus 1 does not reverse my array, but it prints a reversed copy of my array. So let's try to do this over here. As you can see, all the elements present in array D have been reversed. Now let's print our array which is D. The original array D is the same, but colon colon minus 1 has reprinted a reversed copy of my array which is D. This method is actually not preferred because it exhausts the memory. So I hope I've cleared your doubt, Shashank. Just give me a quick confirmation. Okay, Shashank says yes. Now let's get back to our presentation and perform the last operation of this session, which is looping through an array. You all might be familiar with these two loops, which is the for and the while loops. The for loop iterates over the items of an array specified number of times, whereas the while loop iterates until some condition is met or some condition is true. When you're using the while loop, you will have to keep three things in mind. One is initializing your iterator. Second is to specify a condition. Third is to increment your iterator. Remember that if you do not increment your iterator, your while loop will go on forever. Let's see a small example of this. As you can see on the screen, I've created some random array A, and then I've used the for loop to loop through my array A. I've used for x in A print x, which means go to every element that is present in A and print it. Let's try to do the same on our Jupyter notebook. Let me reprint my array D. Now let me use the for loop to loop through this array. For x in A, print x, which means go to every element in D and print it. As you can see, all elements present in D have been returned one after the other. Now let me try to slice this array and print specific elements. As you can see over here, I've sliced my array from index number 0 to -3 and I've printed only those specific values using the for loop. Now let's go to our presentation and have a look at the while loop. Like I've told you before, when you're using the while loop, you will have to do three things. One is initializing your iterator. Second is to specify the condition. And third is to increment your iterator. Let's try to perform looping on our Jupyter notebooks. Please do it along with me, guys. Let me reprint my array D. Here I'm using the iterator as temp. You can use any name of your choice. As you can see over here, I've initialized my iterator to 0 and then I've specified a condition wherein I have told whenever the value of my temporary variable is less than d of 2, then print that value. And then I have iterated the value of temp. I can also use temp plus equal to 1, which is same as temp equal to temp plus 1. Now let's try to use the while loop using the len function. Here I will use my array A. So let me reprint it over here. As you can see over here, when I use the len function, my temporary variable will go to all elements present in my array A and print them one after the other.
Let us talk about scopes and namespaces. So namespace in Python basically makes sure that any name that is used in a program are unique and can be used without any conflict. Namespaces are stored as dictionaries, which is absolutely unnoticeable, yet the namespaces are basically mapping names to objects. It is used so that attributes of an object also form a namespace. And the namespaces having the built-in names are created when the Python interpreter starts up, and these namespaces are never deleted. The global namespaces for a module are created when the module definition is read in and deleted when the interpreter quits. Similarly, local namespaces for a function is created when the function is called and is deleted when the function is executed. And coming on to the Python scope on the other hand can be defined as a region or a block where the namespace is directly accessible. And we have the innermost scope, which is basically the local scope, and then there is non-local and non-global scope mainly enclosed in function scope. And after this we have a global scope, and lastly we have the outermost scope, which basically has built-in names. So let's take a look at an example to understand scope and namespaces. So what we'll do is we'll define a few functions and we'll try to take a look at how namespaces and scopes work. So namespace is nothing but, we use a lot of names inside our program. There'll be names of methods, there'll be name of classes, or any name. For example, we are declaring variables, we are using different modules or importing statements. So those are all names, and namespaces make sure that we are using them without any conflict. So that is one thing that we have to know about namespaces. And scope is basically, the region where we will be able to access them. So now to understand this, let's take a look at a program, guys. So we'll have one function. Let's say the function name is Edureka. So inside this function, we're going to have to implement or declare a few more functions. That is going to be a nested function, guys. So we'll have the definition of another function, which is going to be, let's say, local function, right? And inside this, I'm just going to take a name variable and give it some value. Let's say the value is Python. Then again, we have one more function, which is going to be non-local. So the whole point is to show you what all different type of scopes we have. So guys, there is a local scope, which is basically the local scope which we have. So we have a non-local and non-global scope, guys, mainly enclosed in a function scope. And after this, we have global scope. And lastly, we will have the outermost scope, which basically has built-in names. All right, guys. So this is non-local. So I'll have to use the non-local keyword here. After this, give it some value. Let's say Python programming. And we'll have another function, which is going to be, let's say, global. And we will use the global keyword here. And let's just say this is data science. And we'll have a name in general, which is going to be the local scope. And this will be, let's say, Edureka. Now what we'll do is we'll call all these functions one by one to see what is happening here. All right. So first of all, we have name Edureka. So let's just call our function first of all. Let's see. All right, guys. So let's just print name. So we have this. Now if I call my function local function, let's see what happens. If our scope changes, no, nothing. Right, it's still Edureka only, it is in the local scope. So if I call my function, which is non-local, and after this, if I print the name, it changes to Python programming, guys. And after that, let's just call the other function, which is non. All right, so we have already called non-local. Let's just call global function now. Right now, after this, if I print name, it is still Python programming. Now let's just all right, so we will print name here. So this is our global function, guys. So this is how the scope works, guys. I've shown you how we can work with local, non-local, and global function, which actually shows us how the scope works in Python. So now the next thing that I am going to show is how or what exactly is a class and how we declare a class in Python. Alright, guys, so it's easy. So a class can be seen as a bundle of functionalities, and since everything in Python is treated as an object, a class is also an object, and we can use various methods, functions, data types, etc. in a class and access them using the objects. So let us go ahead and take a look at how we can create a class in Python. So how exactly do we create a class in Python, guys? So it's pretty easy. You just write class, and there's a keyword that we have to use while declaring a class, and after that you just give your name, right? And there you can just give any statements that you want. So let's say this is a very simple class that I'm going to show you guys. So this is how you declare a class. All right, we can just put it inside a function. Now to access anything from my class, what I have to do is I have to make use of objects. Now what exactly are objects, guys? Objects are nothing but, you know, the instances that you create to access the attributes that you have inside your class, guys. As I told you, an object in Python is used to create references to the attributes of a class or to create the instances of a class. So whenever we are actually calling any method or any variable or any attribute from our class, we are actually creating an instance. So that is what object is all about. So how do you create an object, guys? So basically you just write anything. After that you create an instance. So this is how you create an instance. So now X is an instance of my class, guys. So what I'll do now here, I can use X to call any other member function or an attribute from my class. Alright, so if I call this, alright, this is a type error, guys. So let's just write self here. So this is how I can use objects to access values inside my class. So now coming on to the next part, which is the init function. When we create the instance of a class, it actually creates an empty object. So many classes actually create objects with instances that will have specific initial state. So a class defines a special init method. And when we define an init method, the init method will automatically be invoked when we create the instance of a class. We can even pass the arguments in the init function. Let's just try to understand this with an example. So let's just, okay, we'll take it from the beginning. So we'll have class Edureka. After that, we'll have init. We'll have the init function. Let's take a name as well, a variable. I'm passing an argument. All right, so self.name is equal to name. All right, so this is my class. I have no errors. So now to call my attributes from this class, I'll create an instance. All right, wait a second, guys. I'm missing one. All right, so I have to give one variable here. Let's say I'll give it as Python. So I have no errors, guys. So let's see if I can access anything using this. So as you can see, guys, this is quite easy. Or if I create a function now, let's say function, and after that I have print statement, this function is called. All right, so using X, let's see if I can call my function. All right, I forgot to mention. So this is how easily I can use objects, or this is how we use the init method to create instances. So next up, what we have is what exactly are the instance objects. So instance objects are used for attribute references. So I'm just going to show you how we use them using an example, guys. So let's take it up from beginning to explain class instance objects. So I'll take one class, let's say Edureka again. After that, the init function. So I'm sure most of you are clear with this init method that we are using. It is basically a constructor that we use. So whenever we define the init method will automatically invoke when we create the instance of the class. All right, so we can even pass the arguments in that. So that is one advantage that we have with init methods. And I'm just going to show you how we can create instance objects, guys. So let's say self.name is equal to name, or we'll give it some value, let's say, and self.course is equal to let's say data science. So we have one more function, let's say function. Inside this, let's say we have name is equal to Python programming. All right, so now when I create the object, so it is, let's say X is equal to Edureka. So I have no errors. This is my instance. Now instance object would be x.course is equal to, instead of data science, let's say I want to change it to something that I don't have right now, but I can change it. And when I call x.course, now I'll have the value as machine learning. So if I comment this part out, it is data science. So that is how we use the instance objects, guys. And now coming on to the next part that we have, which is method objects, guys. Now let me just tell you how we can use method objects. So inside this only, we have one method which is function. So we can store this value inside, let's say, all right, so we'll have a function is equal to x.function. All right, so this is one method object I have created, and now using this I can just pass any values or call this function. To do that, I'll just have to do this. All right, so I'll have to print it, I guess. Wait a second, there's nothing going on here. So let's just print something. And now when I call my function, this is how I can access the values by using the method objects. So that is all about instance objects and method objects. Next up that I want to talk about is the class and instance variables. So what exactly are class and instance variables? Let's just understand this with an example. So class variable is nothing but the variable that we use to access the attributes. Now let us try to understand this with an example, guys. So we'll take one class, let's say Edureka, and now let me just define one class variable. Let's call it as name and give it a value, let's say Python. Now I'll have one function, let's say init function, and we'll have a few values here as well. Let's say course, and let's take one more value. Let's call it as tech, right? And yes. Now self dot name or self dot course is equal to course, and self dot tech is equal to tech. Now create an instance of a class. So this is going to be first instance. We'll call it as OB, or short for object. Now when I call Edureka, I'll have to pass some values, right? So the course name would be Python programming, and the tech is let's say Python, right? So I can call using OB course name and tech. All right. So if I call name, wait a second, guys. I think I made a mistake here. All right. So this is actually I'm calling the class variable here. Now let's say for each instance I'm going to have different values, guys. So if I call ob.course, okay, we have one error, Python programming, and if I call ob.tech, we're gonna have the value Python. Now to have more instance variables, I'm gonna have to create more instances, guys. So for these values to be different, I'm gonna have to make another instance, guys. So to do that, I'll have ob1 is equal to Edureka. Let's say now this time I'm gonna have to do it as, I'll just take it as Selenium, and this one I'm gonna have, let's say, all right, so let's call it as data science, and this we'll call R programming. And now using OB1, I can access name, tag, and course. So when I call name over here, so I'll just remove all this for once, or just this. All right. When I call ob1.name, still I'm getting Python, guys, because this is a class variable. It's going to be same for each instance. And when I call ob1.course, the value is going to change to data science, because for each instance that we create, instance variable is going to be different. All right. Or we can call it as for each instance variable, we're going to have a different instance. And after that, let's just call ob1.tech as well. So that'll be different as well. So I hope you understand what exactly are class and instance variables, guys. So now next up, I want to talk about inheritance in Python, guys, because inheritance is a very important part when it comes to class and objects, and it's basically prerequisite that you have to learn about while learning about classes and objects. So I'll just quickly tell you what it actually is. So the method of inheriting the properties of a parent class into a child class is known as inheritance. It is an object-oriented programming concept, and since Python is an object-oriented programming language, it is actually quite important. I'll tell you a few benefits of inheritance as well. First one is code reusability. We do not have to write the same code again and again. We can just inherit the properties we need in a child class. And after that, it represents a real world entity or a real world relationship between parent class and the child class. And it is actually transitive in nature. So if a child class inherits properties from a parent, then all other subclasses of the child class will also inherit the properties of the parent class. So these are the advantages of inheritance. Now let's just take a look at a few examples. I'll show you what exactly inheritance is and a few types of inheritance as well. So we'll start with simple inheritance, where we'll have two classes, a class parent, and let's say we'll have some values here. We'll have function 1. All right. So we have created both the parent and the child class. So we have child class here where we have to pass parent as like this. So that is kind of what you have to do while doing the inheritance. Now the fun part is when we create an instance for a child class, guys. So let's just create an instance for a child class. All right. So now is the part where you'll see how we are actually inheriting the properties from the parent, because using the child class, I'm able to call the function one as well. So this is the example of simple inheritance, guys. So this is how we do simple inheritance, guys. Next up I want to show is that is multiple inheritance. So multiple inheritance is nothing but you're going to use two different base classes inside one child class. That is going to be multiple inheritance. So I'll just quickly show you how you do multiple inheritance in Python as well. Alright, so you'll have class parent first of all. So this is going to be your parent 1. Now let's just define a function and we'll just print 1 here, and after that let's just take one more class that is going to be the parent 2. Alright, here we'll just print 2. And now comes the fun part, guys. We'll have the child class here. So inside this we will pass parent 1. Alright, so this is going to be parent 1 and parent 2. And after this let's just create one more function and let's just call it function number 3. And after this we'll just print 3, guys. Now when I create the instance of my child class, alright, so I can actually call all 3 functions, guys. So we'll call function 2. Alright, so child attribute does not have any function 2. Alright, guys, I think I know what I made the mistake about. So this I actually was using a caps letter here, but this was a lowercase letter here, so that's why we were getting the error. So first of all we are getting the instance to get the child class function. Now we'll use it to get the parent class functions and function 1 as well. Alright, so there's no function 1, I guess. Yes. So this is a simple example of multiple inheritance that we can have in Python, guys. And after that we can have multi-level inheritance as well. So there what we can do is, instead of doing this, I can just pass parent 1 here. Now what changes here is I can actually call all these functions using the instance of child class, or I can create the instance of parent 2, but I'll not be able to call the function number 3 over here because it's the instance of the child class. So if we do the multi-level inheritance, we can actually restrict the access. But there's one more way to do that. That is private variables. That I'm just going to tell you how we can work with private variables. Now to understand the private variables, I'm just going to tell you a few things about it. Private variables do not exactly exist in Python, but we can achieve it using the name mangling technique, in which we have a naming convention basically, in which we use underscores and double underscores to declare methods and attributes. So let us just try to understand it with an example, guys. So I'm just going to show you how we make the variables private in Python. And if you have any questions or if you have any queries, guys, I have taken the reference for all of whatever I've taught in this session from the official documentation of Python. So you can just check it out, classes over there, and you can understand it better using the examples. So I have taken the reference from the official documentation. So if you are looking for more information about classes and objects, you can just look it up there. Also, there are a few things that you might want to learn after you complete classes and objects. That's going to be generators and iterators in Python, guys. So guys, we have a tutorial on generators in Python. You can just check it out. and we have made one tutorial for iterators as well. Alright, so now we'll get back to the private variables. What exactly are we going to do here is we'll declare a class first of all. Let's just call it as Edureka. And now we'll have init function. We'll have self, name, and let's say course. Alright, so now self, name, I'm using a single underscore is name, and self course is equal to course. So I'll just show you how it is actually important here, what I have done. Alright, so we'll just print self name. Alright, and self dot course. Seems quite easy, right? Like we will be able to do this. And let's just create an instance of the class Edureka. Yes. Right, we have an invalid syntax. Okay, let's give it as Python programming. I will call it as Python programming here. And data science here. Right, so let's just try to call the show function. We're getting data science and Python programming. So using the name mangling technique, I'm able to access these variables that I've declared over here. So if I remove this, let's see what happens. We're getting an attribute error which says Edureka object has no attribute name, but we do. And if I remove this as well, or just have this, it will show me like data science is equal to Python programming. Right, I forgot to, yes. So we're getting attribute error again, which says Edureka object has no attribute course. But we do have an attribute called course. We are not able to access this because we have used the naming convention. So as long as I've not used the double underscore, I'm not going to be able to access it. So that is how name mangling works. I'll show you one more example, guys. So this is simple, guys. I was just trying to access this method over here. So let's see if I can actually access anything else. I cannot because I'm not even getting any values for it. So I'm not able to access name. I'm not able to access course. So how do I do that? To do that, I'll write Edureka course. So that is how I get Python programming, right? And to get the name, I'll have to write it like this. All right, I'm getting an error, guys. Or I'll just, I think I'll be able to access it using this. Yes. So we'll put it in a print statement so that both of these statements are getting there. All right. So to access these values, I had to use the underscore over here for name. For a single underscore, you can just access it using the single underscore in the instance or when you're calling the attribute. And to call the attribute with a double underscore, you'll have to write it somewhat like this. So if I just try it using like this, will I be able to access it? No, we will get an attribute error which says Edureka object has no attribute course. But Edureka actually has an attribute called Edureka course. So that is how we use name mangling to access private variables in Python.
There are many controversies that say Java is going to die and it has become weak compared to its competitors. So, many beginners and experienced programmers have a doubt if it's really dying. To clear this doubt, let us have a quick look on the major applications and websites once. Airbnb, Uber, Facebook, Instagram, Google, Amazon, Netflix, and lot many. We shall begin with little basic history of Java. Now, why did we recall all these applications and websites? It is because all these tech giants are in the use of none other than Java programming language. It is the base of all data frames, storage, and parts of every single major application. This entirely proves that Java is never going to die. It is getting evolved every single day, and it is one of the major reasons behind the development of much major softwares. Now that we have a good clarification, let us move ahead and learn Java really fast. Java is also used in multiple ways, for example, social media, big data and Hadoop, Android application development, data science and artificial intelligence, data security, software testing, and data analytics. Now that we have a good clarification, let us move ahead and learn Java really fast. We shall begin with a little basic and history of Java. Firstly, history of Java. Java was invented by James Gosling in the year 1995. It was basically invented for interactive television. For God's sake, it was found too advanced and was also able to perform extraordinary and sizable tasks than just a television thing. They found it had some impeccable features as well. Now, let us move ahead and discuss some of those features as well. Some of the major features are as follows. Firstly, open source. Java, since its birth till today, is an open source product. There are many speculations that say Java is not free anymore. But to be sure, Java is still free. And the OpenJDK and Oracle JDK are completely similar to each other. That means you can type your code using Oracle JDK and execute it in OpenJDK. And the JDK versions are also available for all the types of operating systems such as Windows, Linux, Mac, and many other flavors of Linux. Followed by the first feature, the next feature is high performance. Java is an interpreted language, so it will never be as fast as a compiled language like C or C++, but Java enables high performance with the use of just-in-time compiler. So here, Java provides us high performance. Followed by that, the next feature is multithreading. Java multithreading feature makes it possible to write a program that can do many tasks simultaneously. The benefit of multithreading is that it utilizes the same memory and other resources to execute multiple threads at the same time, like while typing, grammatical errors are checked along. Followed by this feature, the fourth feature is secure. When it comes to security, Java is always the first choice. With Java secure features, it enables us to develop virus-free and tamper-free systems. Java program always runs in a Java runtime environment with almost null interaction with host operating system. Hence, it is most secure. Followed by this, the next feature is Java's platform independency. Unlike other programming languages such as C or C++, etc., which are compiled into platform-specific machines, Java is guaranteed to be write once, run anywhere language. On compilation, Java program is compiled into bytecode. This bytecode is platform independent and can be run on any machine. Plus, this bytecode format also provides security. Any machine with Java runtime environment can run Java programs. Followed by this, the next feature is portability. The cross-platform feature enables the Java code to be highly portable. In Java, everything is an object which has some data and behavior. Java can be easily extended as it is based on object-oriented programming model. The last but not the least feature of Java is its robust nature. Java makes an effort to eliminate error-prone codes by emphasizing mainly on compile time error checking and runtime error checking. But the main areas in which Java improvised were memory management and mishandle exceptions by introducing automatic garbage collector and exception handling. Now, let us enter into the installation process. We shall now install Java into the local system. Our local system will be Windows. To download Java, just Google Java download for Windows operating system. You will be redirected to a new web page, and from here, you can select Java SE Downloads Oracle Technology Network Oracle link to download Java for your local system. And now you will be redirected into a new page where you will be shown the Oracle JDK Platform 13. Select the download button, which is shown here in the blue color. Now you will be redirected into the next web page where you can select the version which can match your particular local system. For us, we should be downloading the Oracle JDK version for Windows. Just select Accept License Agreement and click on the version you need to download for your local system, and it's done. You can see that the JDK version for Windows is getting downloaded. Once after the JDK is downloaded into your local system, enter into the system settings and type in Edit Environment Variables. There you can see this particular icon is what we need, which is Edit Environment Variables for your account. Select the environment variables and you can see this dialog box. And in this dialog box, create a new variable, which will be the Java home variable for your JDK. Type in Java home, and inside this second dialog box, you need to add in the location of your Java's bin file. As you can see, the location of my Java JDK is this. So you can just copy this particular path and go back to the Edit Environment Variable dialog box and place in this value. And just select OK to save it. As you can see, I have already set my Java path. So I would prefer to cancel, but you have to select OK. Once after you set the Java home, you need to set the path for your JDK. The path to the JDK can be set using the Path Select option from the Edit Environment Variables. Just select Path and select Edit option and you will be shown with a new dialog box. And in here, you need to select the path to your Java file. You can set the Java path by selecting bin and copying the path. You can see the path to my JDK is C Program Files Java JDK and bin. Copy this path and paste in the Edit Environment Variable path file. As you can see, I have my JDK path already set, which is C Program Files Java JDK bin. After this, just select OK. As I have already set my path, I would prefer to select Cancel, but you have to select OK. Once after your path is set, select OK and close the Edit Environment Variables properties or your system properties. Now that Java JDK has been installed into your local system, let us check the version of Java which is existing in your system. So to check the Java version in your system, just open your command prompt. Once after the command prompt is open, just type in Java C. So if you get this on your command prompt, then it is sure that Java has been successfully installed into your system. Yet, we can also check the version of Java that is installed onto our local system. To do so, we can type in Java space hyphen version and press enter. You can see that the Java version installed into our local system is Java 1.8. Now, we have got Java installed into our system successfully. To run Java, we might need one of the popular IDEs such as Eclipse, IntelliJ, and many more. To execute our programs, we shall select Eclipse IDE. To install Eclipse into a local system, just type in Eclipse download on Google. Once after you type in and enter Eclipse download, you will be redirected to a new web page where you will find many links, and you should select the first link, which will redirect you into the Eclipse Foundation. And in here, you're supposed to download Eclipse IDE 2019-12 installer file. And you can see Your installer file is getting downloaded. You can see that Eclipse installation file has been successfully downloaded into your local system. Now, you just need to open the file. Now you can see multiple options of Eclipse IDE, such as Eclipse IDE for Java developers, IDE for Enterprise Java developers, IDE for C or C++ developers, and many more. Now, we shall prefer IDE for Enterprise Java developers. Now, you have got yourself redirected into a new dialog box, and here you've been asked for install option. Just select install and Eclipse IDE will be installed into your local system. I already have an Eclipse IDE installed in my local system, so I would prefer to go back, but you should select install to install it into your local system. Once after you install the Eclipse IDE into your local system, you shall see something like this. So inside the Eclipse IDE, to create a new file in the Eclipse IDE, you need to select File option, and inside File, you need to select New, and inside New, select New Java project. And there you go. You'll be redirected into a new dialog box where you should enter the name for your project. Let us enter Edureka. Followed by that, Finish. Your project has been successfully created. Now, select your project and right-click on it. Or click the drop-down menu and you can see a source file. Select the source file and right-click the source file, and now create a new package. The name of your package will be set as Edureka by default, which is your project name. Just select Finish to create a new package. Once after you create a new package, just select the package and right-click and select New to create a new class. Now, name your class. The class name can be anything. For now, let us write in hello. And after that, you can also select in public static void main as default. And after that, just finish. And there you go. Your new class has been successfully created. Now, let's go back to our presentation. You can see that we have successfully installed Java. Now let us try to execute a simple hello world program in our Eclipse IDE and see if our Java and Eclipse are working fine together or not. So here you can see that this is our first program, and inside this we are trying to just print hello world message. Now to run the code, you need to select all the code and select the run icon which is placed on your tools bar. So this particular bar is your tools bar, and inside which you can see a green button which says run my first Java program. Just select it and you can see this dialog box, and inside this you need to select OK, which says save and launch. Your application has got successfully launched, and you can see the hello world message has been successfully printed on the console. Now that we have successfully executed our first Java program, let's move ahead and understand the variables in Java. First, let us understand the basic definition of a variable. A variable is a container that holds the value while Java program is being executed. A variable is assigned with a data type. Variable is the name of the memory location, and there are three types of variables in Java, which are local, instance, and static. Let us understand local variable. A variable declared inside the body of a method is called local variable. You can use this variable only within that particular method, and other methods in the class will not be aware of that particular variables which are used in your local class. A local variable cannot be defined with the static keyword. Followed by that, we have instance variable. A variable declared inside the class but outside the body of the method is called instance variable. It is not declared as static. It is called the instant variable because its value is instance specific and not shared among other instances. The last but not the least is the static variable. A variable which can be declared as static is called static variable. It cannot be local. You can create a single copy of static variable and share among all the instances of the class. Memory allocation for static variable happens only once when the class is loaded in the memory. Now, the next part is the data types. The data types supported in Java programming language are int, float, double, long, short, character, byte, and boolean. Now, let us also go through the size of each data type supported by Java. Java supports 2 bytes for integer data type, 4 bytes for float data type, 8 bytes for double, and 8 bytes for long. Followed by that, 2 bytes for character type data type, 1 byte for short, 1 for byte, and 1 byte for boolean. These data types are called as primitive data types. Followed by variables and data types. Now let us enter into the operators that are available in Java. The operators in a programming language are specific or special symbols used along with the variables or numbers so as to carry out some specific operations. The various operators available in Java are as follows. They are unary operator, arithmetic operator, shift operator, relational operator, bitwise operator, logical operator, ternary operator, and finally the assignment operator. We shall discuss about each and every single operator available in Java. Firstly, the unary operator. The Java unary operator requires only one operand. The unary operators are used to perform various operations such as incrementing or decrementing a value by 1, negating an expression, inverting the value of a boolean, and many more. Now, let us execute a simple example of unary operator in Java. As you can see, this particular example is based on unary operators. So here, I have declared a value 10 to the variable x of integer data type. And now, I am trying to increment the value of x by 1 by adding the unary operator increment. This particular incrementation is called post increment. Followed by that, we have a similar increment operator which is placed before x, which says it is a pre-increment operator. Followed by that, we will try to decrement the value of x by 1 by using post decrement operator, where we will provide the decrement operator after x. And similarly, the same decrement operator is used before x, which says that it is a pre-decrement operation. Now, let us try to execute our program and see the output. You can see the output has been successfully generated. Now, followed by this, let us move ahead and understand the arithmetic operator. Java arithmetic operators are used to perform addition, subtraction, multiplication, and division. They act as basic mathematic operations. Now, let us see a basic example for arithmetic operators. You can see I have provided two variables, that is a and b. A has the value 10 and b has the value 5. So, the basic arithmetic operations that I will be performing are addition, subtraction, multiplication, division, and modulus. So the addition symbol is carried out by plus, subtraction is minus, multiplication is star, division is /, and modulus is modulus symbol. These are common. Now, let us execute this and see the output. You can see all the arithmetic operations have been successfully executed and the output is also generated. So you can see the addition is 15, subtraction is 5, multiplication is 50, division is 2, and modulus is 0. Now with this, let us move ahead into the next type of operators, which are none other than the shift operators. The shift operator is used to shift the bits in the value to the left or right side of the specific number of times. We have two types of shift operators, which are left shift operator and the right shift operator. The left shift operator moves the specific number of bits towards the left side and the right shift towards the right side. Now, let us execute a sample program to understand the shift operators in a much better way. You can see I have used shift operator here, which is left shift, and I'm using left shift operator to move 2 bits of 10 towards left side, and 3 bits of 10 towards left side, and 2 bits of 20 towards left side, and 4 bits of 15 towards left side. So basically what happens here is 10 will be converted into binary numbers, and similarly all the other numbers will be converted into binary numbers, and the number of bits which we require, that is 2, will be shifted in that particular converted binary number, and the new number generated will be provided in decimal numbers, and that will be our output. Let us execute this program and see our output. You can see that the program has been getting executed and the new numbers have been generated here as the output. So 10 after shifting 2 bits towards left will be generating 40, and 10 after shifting 3 bits towards left will generate 80, and similarly 15 after shifting 4 bits will generate in 240. Now that we have understood the shift operator, let us move ahead and understand the relational operator. The Java relational operator is used to compare the operands on both the sides of the relational operator. This particular operator judges whether one of the operands is greater or lesser or equal or not equal to the other operator. Now, the basic operation what a relational operator does is, it compares the two numbers. For example, if you have A as 5 and B as 10, and if you compare if A is greater than B, then the result will be false because A is smaller than B. So this is what a relational operator basically does. Now, let us go through a sample program to understand relational operators in a much better way. Here you can see that I have declared 3 variables, that is A, B and C. A has 10, B has 5 and C has 20. Now what we are doing is, we are comparing A is less than B and A is less than C. And followed by that, we are comparing again A is less than B and A is less than C. So this example is both for relational operator as well as logical operator. So the logical operation which we have used is AND. Now let us try to execute this program and see the output. And there you go. The result is false because A is greater than B but not less than B. Similarly, A is less than C, but the result of AND logical operator is false because to become true, both sides of the operand should be true. Now, let us move ahead and understand bitwise operator. Basically, the bitwise operator is applied on the bits. For example, if we provide a number to the variable, that particular number will be converted into binary format, and after that, the operation will be applied on the bits one by one. Let us execute a sample program to understand bitwise operators in a much better way. So this particular example is based on bitwise operators. Here also we have the same 3 values, that is A is equals to 10, B is equals to 5 and C is equals to 20. Now we are performing bitwise operations on the particular variables and comparing them using a logical operator which is AND. Now let us try to execute this program and see the output. You can see that the program has been successfully executed and the output has been printed. But the value of A has been changed here from 10 to 11. This happened because it is based on the bitwise operation which we performed here, that is A++ post increment. Now followed by this, let us move ahead and understand the next type of operators, that are the logical operators. The logical operators are the operators which are applied on both the ends or both the operands. So the basic logical operators supported in Java programming language are AND, OR and NOT. The AND operator is used to perform logical operation on 2 operands and it will result in a Boolean result. So to become a true Boolean result, AND should be having both the operands as true. And in OR, to result a true value, either one of the operands should be true. And when it comes to not, not is just a simple logical operator which negates the existing value. That means if the value is true, then after the not operation, the value will be converted into false. Now, let us see one basic example to understand logical operators in a much better way. You can see the previous example is the best fit to understand logical operators. You can see the value here was false, since A is greater than B. So this value will result in a false, and this value will result in false. So false and false will result in false. Now moving ahead, we shall understand the next type of operators, which are the ternary operators. The ternary operator is simple but highly powerful operator used in Java programming language. This particular ternary operator will reduce the code length to one line. To understand this in a much better way, let us execute a sample program. Here you can see that we have two different values, which are A and B. A has 2 and B has 5. So the ternary operator is this particular statement. Here we have also allocated a new variable which is of integer type, which is minimum. So minimum is equals to A less than B. If A is less than B, then minimum is A, and else B is equals to minimum. So this particular operation is minimum. Here A is compared. If A is truly less than B, then A will be printed into minimum, else B will be printed into minimum. And finally, we shall print the value which is stored into minimum. Now let us execute this and see the output. You can see that the value of A, which is 2, is been printed here after executing the ternary operator present in the line number 7. Now let us move ahead and understand the next type of operators, which are the assignment operators. The assignment operators used in Java programming language are simply used to allocate the resultant memory into the variable which is located in the left side of the operand. The basic assignment operators used in Java programming language are equals to and double equals to. To understand assignment operators in a much better way, let us execute a sample Java program. So this particular program is based on assignment operations. Here we have two different values, which are A and B. A is equals to 10 and B is equals to 20. Now what we are basically doing here is using the assignment operator and adding value 4 to the value 10 and decrementing value 4 to the value 20. This particular operator used here is the assignment operator. Now the result will be A is equals to 14 and B is equals to 16. Now let us execute this program and see if the output will be correct or not. You can see the output is as expected.
Loops in Java are used to run a certain code segment in a project for a finite number of times until a certain condition is satisfied. In this video, we will discuss the different types of loops in Java and their control flow along with their relative examples. If we recall the definition, we find that any particular loop is executed based on the validity of a condition. So, it is important that we also understand the terminology of conditional statements in Java. To understand the conditional statements in Java, let us consider a simple example of a car showroom where Mr. John goes to buy a car. He will be assisted by the sales manager of that particular car showroom. He says that he has a condition to buy a car of either of the three colors, which are black, red, or blue. So he searches the cars which are available in the three colors. First, he'll apply a condition in his mind for searching the car with the color black. If it is not available, then he will go for the car with the color red. If it is not available, then finally he will search for a car which is available in blue. So, if his condition is satisfied, then he'll buy the car. Else, he will not buy the car. That's how the computers also think when a loop is applied onto them. So, according to our example, Mr. John finds a car with blue color and finally buys it. Now, let us dive into the conditional statements which are available in Java. The conditional statements describes the compiler to carry out the execution of a particular code segment in a program until the condition is satisfied. The types of conditional statements available in Java are ternary operator, if operator, else if operator, else if ladder, nested if, break, and switch. Let us execute some examples related to all these conditional operators one by one. Firstly, we shall execute an example based on if loop. As you can see, this particular example is based on if loop. Here, I'm providing a number which is a negative integer number minus 10. And here, I'm providing an if condition which says that if the number is greater than 0, then I should be printing a printf statement which is number is positive. Else, my interpreter will be printing the message the number is negative. Now, let us try to execute this program and see how does it work. As you can see, the output has been generated, which says the number is negative. Since the number which I provided was a negative integer number, the condition here is failed, and the message which was lying outside the if loop, which is the number is negative, is being printed here. Now, let us execute the next control statement, which is the else if statement. As you can see, this particular example is based on else if loop. Here, I'm trying to provide an integer value to the variable a. According to my condition, if the number which I have included results in a modulus is equals to 0, then I should be printing the message as even number. Else, I should be providing the number as odd number. Now, let us try to execute this program and see how does it work. Now, as you can see, the output screen is asking me to enter an integer value. Let us try to input an even number. As you can see, I have inputted an even number and I have received an output as an even number as the condition of the if loop is been satisfied. Now, let us try to input an odd number and see if the else loop is working properly or not. As you can see, it is asking for an input. Now let us try to input an odd number, which is 7, and see the output. As you can see, the output is generated as an odd number, which means the else loop is working fine. Now let us try to execute another example based on else if loop. Here I'm trying to execute an example based on year. I'll be trying to input an year, which the program will find out if it is a leap year or not. The condition I have provided for if statement is if the year modulus is equals to 0 and year modulus 100 is not equals to 0, or year modulus 400 is equals to 0, then I must print the message the year you have entered is a leap year. This means all the conditions which are stated in the if loop must be true. Else, it should print a message which says the year you have entered is not a leap year. Now, let us try to execute this program and see how does it work. As you can see, the output screen is asking me to enter an year. Now, let us try to enter a leap year. As you can see, the conditions which are provided in the if statement are true, and we are printing the message the year you have entered is a leap year. Now let us try to provide an input which is not a leap year. As you can see, now it is asking for an year. Let us input the present year, which is 2019, and see if it is a leap year or not. As you can see, the conditions which were provided in the if loop are not satisfied, and the program is printing the message, which is the year you have entered is not a leap year. Now, let us try to execute some programs based on if-else ladder. In this particular example, we are trying to execute else if ladder condition. As you can see, here I'm trying to provide an integer type input to the variable choice. According to the choices I have provided, the first choice will select a sedan type class car, and the second choice will select SUV type class car. The third choice will provide sports type class car, and the fourth choice will provide crossbreed type class car. If the provided input is neither of all these four, then it will provide the last message, which is invalid choice. As you can see, the first if ladder will compare the choice. If the choice is equals to 1, then it will print the message sedan class. And the next else if ladder will compare the choice if it is equal to 2. If it is equals to 2, then SUV class will be printed. And in the next else if ladder, if the choice is equals to 3, then sports class message will be printed. And followed by that else if ladder, you'll have the next ladder which will compare the choice to be equals to 4. If it is true, then crossbreed segment message will be printed. If neither of all these conditions are true, then finally an else block will print a final message which says it is an invalid choice. Now let us try to execute this program and see how does it work. As you can see, the program has been successfully executed and it is asking for a choice. Now let us try to select SUV type vehicle. For that we need to provide an input as 2. As you can see, the SUV class is successfully selected. Now followed by this program, let us execute nested if condition. This particular example is based on nested if condition. In this particular example, I am going to provide inputs for 3 numbers. N1 is equals to 20, N2 is equals to 30, and N3 is equals to 10. And finally, we have another integer type variable which is greatest. Using the nested if condition, we'll try to find out the greatest number out of all these 3. As you can see, the first if statement has the condition if N1 is greater than equal to N2, then it should enter an inner if loop. Inside the inner if loop, we have a condition which says if N1 is greater than or equal to N3, then it should enter the loop and print greatest is equals to N1. Else, it should print greatest is equals to N3. After the completion of the if condition, if neither of the statements which are provided in the if condition are true, then the control will flow into the else condition. Inside the else condition, we have an if condition which states if N2 is greater than or equal to N3, then it should print N2. Else, it should print N3. Now, the final output will be generated along with a message, the largest number is and the greatest value. Now, let us try to execute this program and see how does it work. As you can see, the output has been successfully generated and it says the largest number is 30. Now let us try to execute an example based on ternary operator. This particular example is based on ternary operator. As you can see, I am trying to provide an input to 2 numbers which are A and B, which will be integer values. This particular statement is our ternary operation. This states that if the provided input A is greater than B, then A should be declared as the greater number. Else, if the condition is false, then B should be declared as the greater number. Now, let us try to execute this program and see how does it work. As you can see, the program has been successfully executed and it is asking for a value for the variable A. Let us enter 10. Now it is asking for a value to the variable B. Let us enter 5. Now let us see the output. As you can see, the output is 10. This states that the number A is greater than number B. Now let us try to execute an example based on switch conditional statements. So this particular example is based on switch conditional statement. Here I'll be asked a question as enter any month. So I'll be entering an integer value to the variable month. If the input value is 1, then the program will execute January. If the input value is 2, the program will execute February. Similarly, if the input value is 12, then it will execute December. and if neither of the cases match to the input which I provide, then it will execute a default message which will be invalid input. Now let us try to execute this program and see how does it work. As you can see, the program has been successfully executed and it is asking me to enter any month. Let us try to input 3. As you can see, March is the message which has been printed by the program. Now let us try to execute an example based on break statement. As you can see in this particular example, I have provided an integer array which has the values 10, 20, 30, 40 and 50. And here I'm trying to print the same array using a print statement with a provided condition. If the number is equals to 40, then the for loop should terminate at that particular instance. Now let us try to execute this program and see how does it work. As you can see, the output has been successfully generated and the values 10, 20 and 30 are printed, but 40 and 50 are not printed because at this particular if statement we have provided a condition that if the number is equals to 40, then the control flow should break. So these were the few examples for conditional statements. Now let us continue with our loops. In Java, we have 3 types of loops. Firstly, the for loop. Next is while loop, and finally we have do while loop. The first type of loop is the for loop. The for loop is a conditional flow statement which allows you to execute a specific code segment for a finite number of iterations. For a for loop, you have 3 arguments, namely initialization variable, the condition variable, and the counter variable, which might be either increment or decrement. Now let us try to execute a program to understand for loop in a better way. Before we execute an example of for loop, let us see the flow diagram of the for loop. Here, we have the initialization step at the first, and later the control flow will enter a conditional statement. If the conditional statement happens to be true, then a particular code segment or a particular set of statements are executed, and after that, the control flow enters into the increment or decrement variable. And the variable will be incremented or decremented according to the condition provided. Once after the increment or decrement process is finished, then the control flow will again enter into the conditional statement and verifies the condition. If the condition is true, then the same loop will be executed. Else, the control will exit from the condition statement. Now, let us try to execute a program to understand this in a better way. This particular example is based on for loop. As you can see, I have a variable by the name arrdata, which is of string type. And this particular variable holds 5 elements which are John, Jerry, Ralph, Jim and Tom, which happen to be the names of the employees of a particular company. Now we will be using a for loop to display the names of these employees. This happens to be the for loop where we have the initialization variable which is I is equals to 0, and followed by that we have a conditional statement which is I is less than arrdata.length. And finally, we have an increment variable which is I++. Now, let us try to execute this for loop and see how does it work. As you can see, the loop has been successfully executed and we have our output here. Let us move on to the next example of for loop, which is either called as enhanced for loop or advanced for loop. In this particular for loop, we will be having a conditional statement at the very beginning of the program. The control flow enters the conditional statement and finds if there are any elements present in the array or not. If the statement is true, then the control flow will enter the initialization statement where a variable will be initialized. Once after the initialization is finished, the control flow will directly enter into the condition statement of the program. If there are any elements present in the program and the condition is true, then it will execute the set of statements and initialize the local variable. And once after the local variable is initialized, then the control flow will continue into the same loop again. If there are no elements present in the array, then the control flow will exit the condition and stop. And here, as you can see, if we come back into the initial conditional statement, If there were no elements present in the array, then the condition will become false and the control flow will directly exit the condition and comes to a stop. Now let us try to execute a program to understand this advanced for loop or enhanced for loop in a much better way. As you can see, I have considered the same example of the list of employee names, and here we are using the advanced for loop, which states that the control flow must enter the array and print all the elements present in the array according to their index. Now let us try to execute this program and see how does it work. Once after the control flow will enter into the array, all the elements present in the array are printed until the last index value. As you can see, the program has been successfully executed and the output is been generated. With this, let us try to execute nested for loop. Before executing an example, let us try to understand the flow diagram of the nested for loop. In a nested for loop, the program will begin at start and the control flow will encounter the first loop statement. After that, the control flow will enter into the condition. If the condition is true, then it will enter into the inner for loop. If the condition is false, then the control flow will directly exit the first outer for loop. Now let us see if the condition is true. Once the condition is true, then the control flow will enter into the inner for loop, and inside the inner for loop it will encounter a condition statement. If the condition is true, then the control flow will start to execute a set of statements which are present inside the inner for loop, and once after the statements are executed, it will enter into the increment or decrement statements. Once after the increment or decrement is done, the control flow will again enter into the condition statement and checks if the condition is true or not. If the condition is true, the same loop will execute again, and if the condition is false, then it will exit the condition statement and it will enter into the increment or decrement variable of the outer for loop. Once after increment or decrement of the outer for loop is done, it will again check the condition in the outer for loop, and if it is false, then it will exit. Now, let us try to execute a program to understand this in a much better way. This particular example is based on nested for loop. As you can see, I have considered an integer type variable which is array, which is going to be a two-dimensional array. And this particular loop is our outer for loop, and this particular loop is our inner for loop. Once after the outer for loop is triggered, it will start the inner for loop. Once after the execution of inner for loop is finished, then the inner for loop will trigger the outer for loop for increment or decrement. Once after the increment or decrement is done, then the condition is verified and the control flow will enter into the inner for loop again. Once after the inner for loop is executed, then it will again trigger the outer for loop and the condition is checked. If the condition is true, the process will continue, else the control flow will exit both the for loops and execute the statements which are present outside the loops. Now let us try to execute this program and see how does it work. As you can see, the program has been successfully executed and the data present in the row 1 and row 2 have been successfully printed here. As you can see, this is the first row, which is row 0, and this is the second row, which is row 1, and the data in the row 0 is 1, 2, and the data in the row 1 is 3 and 4. Now let us learn about while loop. While loop is a control flow statement that executes itself repeatedly until a given Boolean condition is satisfied. While loop can be considered as a repeating if statement. Let us see the flowchart of the while loop to understand this in a much better way. As you can see in this particular example, the control flow will begin at a decision. If the decision is true, then a particular segment of code is executed, and again the control flow will enter into the decision box. If the condition is true, then the loop is repeated, else the condition will exit the decision box. Let us try to execute an example to understand the while loop. This particular example is based on while loop. Here, I'll be providing an input to the integer type variable, which is num. And according to the while condition provided, here we'll find out if the input number is a prime number or not a prime number. For that, we have provided a condition in the while loop which states that if the variable I is less than or equal to the number divided by 2, then it should enter while loop. And inside the while loop, we have again a condition which states that if the number modulus I is equals to 0, then flag will be set to true and the control flow will be broken here. and I will be incremented. And outside the while loop, we have an if statement which states if the flag is not true, then we should print it is a prime number, else we should print it is not a prime number. Now let us try to execute this program and see how does it work. As you can see, the program has been successfully executed and it is asking for an input. Now let us try to input a prime number. As you can see, the output is 3 is a prime number. Similarly, now let us understand do-while loop. Do-while loop is considered to be a conditional statement which is completely similar to the normal while loop. The only difference is that the do-while loop has a boolean or a conditional statement present at the end of the loop. This makes the do-while loop execute at least for once. To understand this in a better way, let us check out a flow diagram. In this particular example, the control flow will first encounter the statement. So this particular statement will be executed at least for once without checking the condition. Once after the statements are executed, the control flow will enter into the conditional statement. Now the condition is checked. If the condition is true, then the same statements will be executed once more. Once after the statements are executed, then the condition is checked again. If the condition is true, then the same loop will be continued, else the control flow will exit the condition. Now, let us try to execute a program to understand this in a much better way. This particular example is based on do-while loop. So in here, I've considered an array into which I'll be entering elements. The process of entering the elements will continue until I provide an input 0. And finally, all the numbers which I have provided into the array will be summed up and the final summation of all the elements present in that particular array will be printed. Now let us try to execute this program and see how does it work. As you can see, the program has been successfully executed and it is asking me to enter the numbers. Let us try to enter a number other than 0. My first number will be 9. And after that, let me enter another number other than 0, which will be 7, followed by that 5. As you can see, it is continuing to accept the numbers which are other than 0. And now let us try to enter 0 and see what happens. As you can see, the loop is been terminated and the summation of all the numbers which were provided into the array are summed up and the summation is provided as 25. So with this, let us execute the next type of loop, which is infinite loop. Before we continue into the infinite loop, let me provide you a simple example to understand while loop and do-while loop in a much better way. You must be familiar with the Roadrunner cartoons. As you can see, the Roadrunner here is running on while loop and the coyote, which always tries to hunt the Roadrunner, is trying to execute itself using a do-while loop. So here, the condition was checked first and the Roadrunner is safe, and in the case of Coyote, it was using a do-while loop and executed itself without checking the condition and it is outside the cliff. So this is the basic difference between the while loop and the do-while loop. Now with this, let us enter into the infinite loop. The infinite loop is not actually a practically designed loop. Instead, it is a situation where a condition of the loop fails and the execution persists until you stop it manually. Let us try to execute a program to understand infinite loop in a much better way. So this particular example is based on infinite loop where I have provided a while loop. So here the condition of the while loop is always true and the control flow will enter into the while loop and will print the message Edureka. Let us try to execute this program and see how does it work. As you can see, the program has been successfully executed and it is continuing to print the Edureka message continuously. Now I have to stop this manually and exit the infinite loop. As you can see, the infinite loop has been successfully terminated now.
Object-oriented programming. So guys, this is one of the software design methodologies that how we're gonna write a software solution in the industry, and it's followed widely. So what is this object-oriented programming? It's a methodology or a paradigm using which we can design our software solutions. Now, there are two major words which you need to focus on. The first one is object and the second one is class. Now, why object comes first and class later? Because of the term itself, object oriented, not class oriented. So we'll discuss on these objects and classes. So guys, object is a real world entity. When I say a real world entity, what does it mean? It means anything which you can see, touch, feel is an object. For example, laptop, mobile phone, chair, table, fan, anything. Even you and me are the objects. So every object will have some state and behavior. What is a class? Class is a blueprint, or I can say it's a drawing of an object. So how an object will look like, how object is going to be represented, that we can do by having this guy called class. So let's say there is a class called dog, which is a representation how a dog will look like. So we will have a representation in two of the ways. The first one is properties and the second one is behavior. Now, properties are also referred to as attributes. For example, what is the weight, what is the age, what is the size, color, breed. So these are the properties. I can even say that they are the attributes which are linked to your object. Behavior goes like eat, sleep, run, bark, etc. and etc. So let's say a nose over here is used for having a process called breathing or respiration. Respiration is a behavior. So we have object with the properties and behavior. So object will have properties, object will have behavior, and these properties and behavior will be written in the class to describe the object. So having object oriented programming approach, we can have different type of objects. So their properties will remain same, but the value for their properties will change. Now the size, age, color and breed for all the different dog objects, it's gonna change, guys, right? So even when I talk about something like employee to a company, let's say plumber, electrician, carpenter, let's say HR, let's say software engineer. Now the different employees, they have the same details. That's like what is their employee ID, what is their name, what is their age, what is their phone, but the data for these properties will be different. Now same way, the sleep pattern would be different for different people, right? So this is what we are going to understand, that different objects, they will have the properties, same properties, but with the different values, right? So I can say an object is a container which is containing properties and behavior both. Now, how we are different from procedural approach, the way we used to write programs in C. So how is it different, right? Let's have some comparisons coming in here. So object-oriented programming is a bottom-to-up approach. What does this mean? This means you think of an object first and then you start coding. You think of data first. Top-down approach is like where you just start writing the program. We modularize our program into objects, whereas in procedural approach, we need to write functions. For security, we have access modifiers. We got default, private, public, protected, but there we have no access modifiers. Objects can move and communicate with each other through member functions, but whereas in functions we don't have objects, so data is just moving freely. So having access modifiers, our software solution can be designed with much more security, right, as compared to procedural approach. And lastly, we have features like overloading, overriding, inheritance, and many other features which object-oriented programming will give us, so that we can very easily design our softwares, which procedural programming will not do that. Now, there are four major fundamentals when it comes to object-oriented programming structure. Guys, we got encapsulation, abstraction, polymorphism, and inheritance. So these are the four major building blocks of any object-oriented programming language, right? So we even call them the pillars for the OOPS. So we'll discuss them one by one. To begin with, what is inheritance? So guys, inheritance is where the property of an object will be acquired by the other object. We'll have a relationship called is a relationship. So it's a parent-child relationship. So having this relationship, let's say animal is the parent, mammals, reptiles, amphibians, and birds, they are the children. So this is a relationship. Bird, reptile, mammal is an animal, right? So that is how we are relating them. We also call this concept as generalization, because here we are generalizing so many different types as one single type, right? So we call animal as super or the parent class, whereas mammals, reptiles, amphibians, birds, they are known as sub or the child classes. So guys, let us have one example on inheritance, and thereafter let's try to code it. So consider that there is an object structure called product. So product is going to have a product ID, product will have a name, product will have a price. So these are few of the attributes associated with the product, right? Now I'm taking this use case. Let's say we are going to develop an e-commerce solution. For an e-commerce solution, now there will be a product which can be an LED TV. So LED TV will extend the product, right? So what is the benefit of extending LED TV from product? So you'll get all these attributes in the LED TV as well, right? So we just need to write additional parameters. So we will come here and say what is the brand, what can be the technology for LED TV, and any other attributes if you want to have. We can have a mobile which can extend the product. So we can have RAM, what is the OS, what is the SD card size, and many more attributes. So extension is what is called inheritance. So if we don't have extension, so how the things will work? Let's see that. With no extension, we need to rewrite a similar code snippet again and again. So you see, PID, name, price, brand, technology is the data associated with LED TV. Same is with the mobile. So PID, name, price, they are the common attributes. So when we know that we have some common attributes or common properties which will be reused again and again, this is like repeating the code again and again. Whereas when we are coming up with this structure here, so we are reusing the similar code again and again. You have product as one guy and you now keep on reusing it again and again. So let's try to come up and write one small program here and understand this example. So I'm going to say a new Java project. So we are using Eclipse as an ID. So you can use IntelliJ, JDeveloper. So whatever you want to use, you can use that. Let's say a new Java project. I'm going to say oops. So in this object-oriented programming structure on the SRC, I'm going to do a right click and say a new class. Now this new class over here, let us name it inheritance app with the main method. So I'm going to write a package. Let's say co.edureka. So this package name co.edureka contains inheritance app with the main method, right? So we know what is main. Main is executed by JVM, right? When my program will run. Now let's come here and write this class as product. And I'm going to write one constructor here which says CISO product object constructed. And thereafter, let's have some attributes. We got product ID, what is the name, and let's say what is the price. So we can even have more attributes, but I got these many details. So I'm going to write methods now. So this is constructor, the default one. So the methods, I'll say void, let's say set product details, where I will say, let's take three inputs, PID, name, and price. So I'm gonna say this dot PID is PID, this dot name is name, and this dot price is price. So we call this guy as a method which is setting the details into the product object. I can even say to write data in product object, we have this method. We also call the methods as behavior, and attributes are also referred to as state. Same way, I'll have show product details, where I will come and say CISO, let's say plus product. Just give me a moment. All right. So I'm gonna say product ID this, and thereafter I'll just have this coming in. Now I will say CISO name a backslash T plus the name. The next way we have price a backslash T and the price. So this is the method which will read the data, right? So to read data from product object. So we call this structure, this class product is textual representation, how an object will look like in the memory, right? You need to understand that this PID name price, they do not belong to the class, they belong to object. So whatever we write in class is in actual property of object as we are describing the object, right? So using class, you are textually describing the object. So PID name price, they do not belong to class. Constructor, the methods, they belong to the object. So if you want something to be property of class, if you want anything which should belong to class, make it static, right? So this is what you need to do. Now coming here, guys, let us create the product object. So create an object. What object? I want product object. Let's say product is a new product. So remember, this statement is an object construction statement, but product is not an object. It's a reference variable which holds the hash code of the object in hexadecimal notation. So what does this mean? This means that if I will say product is plus product, so when you run this code here as Java application, you will get to have a product object constructed. And this guy reference variable is giving you this 7852E922. So we get 7852E922 as a hash code. Now this might vary from system to system, right? So we say product is a reference variable, right? So product is a reference variable, not an object. It is pointing to the object which is created in the memory in the heap. So next is writing data in object. So I will say product dot set the product details. Let's say product ID is 101. Let's say name is iPhone X. Let's say the price is 70,000. So this is the data within the object which we have wrote, and now let's say reading data from object, you will say product dot show the product details. When you run this code here, let me comment out this structure here, and here after writing the data, I'm just gonna put up this CISO statement, data written in product object. So just to show this, so we got product object constructed and then data written in product object, and this is data with respect to your product object. So this is how we get to see data within the object, write and read operations. A very basic structure of an object. Now we can even write the data directly. Coming here, let's write the data directly. So I can say product dot PID. Let me create another object. So I'm gonna say a product. This time let's say this as product 1 is a new product. Or let's say this is a product 2. This guy is product 1. And here I'll say product2 dot PID is 201. Product2 dot name is Nike shoes. Product2 dot price is, let's say, 5,000. So this is writing the data directly. Sorry, my bad. So this is integer. So you'll say product2 dot show the product details. So just gonna do an empty print line here for the correct output. So what you see is product object constructed. We are not writing the data using any method. We are writing the data directly, and you see the data read operation happening again. So if you don't want the data to be written directly, you can make the attributes go as private. So having your attributes as private, so you are limiting the user not to write the data directly. You see, you are now getting an error here. So I'm not gonna make everything private. Let's say the product ID is private. So when you have any attribute marked as private, you will not be able to access it. So this is an error now. Since attribute marked as private cannot be accessed. You cannot access an attribute which is marked as private. So what we will do now? So we can have an indirect way to access PID. We can create a method which says set the PID. You take integer as input and you say this dot PID is PID. So guys, when I'm using this, so this means reference to the current object. So this means reference to current object. So the left hand side PID belongs to object, right hand side PID belongs to the method set PID. Okay, so LHS belongs to the object and RHS belongs to method. So we can similarly say int get PID, which returns back the PID. So when you say set PID and get PID, what does it mean? So these are the special methods. We call them setters and getters. Setter and getter is required when you have your attribute marked as private. So you have some indirect way of capturing these details in your object. So now I can come here and say product2 dot set the PID as 201. Now this is going to work for us. So I think the basic product object structure is clear to everyone. Now moving ahead into our use case where we are going to extend the product, right? So let us take one example of mobile and extend the product. Now I'm gonna say a class called mobile where it extends product. So this is known as a relation where we say mobile is a product and here mobile is child and product is parent. So what I'll do is I'll create a mobile constructor and say a CISO mobile object constructed, right? So this is how we are going to deal with the object. Now let us comment out this code snippet in the main. So instead of having the direct product object, I'm going to write a mobile object now. So I'll say a mobile is a new mobile. Now whenever I am requesting for the mobile object, right? So we are requesting to get mobile object constructed. So this is what we are doing here. Now when you write this instruction, what you see is before your mobile object is constructed, product object is getting constructed. So it's like parent object is constructed before the object of child, right? So what is the behavior here? So product object gets constructed before the mobile object. So as a rule of inheritance, it is like firstly you get the parent object constructed and then the mobile object constructed. So guys, I hope this is clear, right? So what is happening here? We have parent object constructed before the mobile object, as this becomes the rule to inheritance. And we say this is object to object. Now you will be glad to see that everything, whatever product had, will be acquired in mobile, right? So we can come here and we can say mobile dot set the product details. Mention the PID, let's say 301. Mention the name, let's say iPhone X. Mention the price, let's say 70,000. And then you say mobile dot show the product details. When you run this code, you get to see that product object constructed, mobile object constructed, data written in the product object, and you see the details flowing for you. So guys, I hope this is clear, right? So whatever you had in the parent, you got in the child, right? So we have the things coming up for the child, and we can very easily access those things. Now, this product over here, we can have something like, let's say, string. What is the OS? Int. What is the RAM? And int. What is the size of SD card, right? So let's say SD card size. Now, these are additional attributes of mobile other than the product. So these are the additional attributes. Now what I'm gonna do is I'm going to have this guy over here called set product details. Let's do a copy here and let's try to do a paste here. Now I'm going to say string OS, int RAM, and int SD card size. So here I'll say this dot OS is OS, this dot RAM is RAM, and lastly this dot SD card size is SD card size. You see, PID is not accessible. We are getting an error here. It says it's not visible because it's marked as private. So private is not inherited and visible into the child. All right. I'm gonna make this PID as default. So we'll talk about the access modifiers later, but we are focused on understanding the oops here. Now we actually have this same method name set product details, right? So we have redefined the same method from the parent into the child with different inputs. So we got two methods in the child. So we have now two methods in the child, one from parent and one of child, right? So both are different, as in based on inputs, right? Even though name is same. Even though name is same, they are different based on the inputs. So whatsoever belongs to the parent, that is inherited into the child, and now in the child we have the same method coming up again. Why we did this? Because we wanted to set the data for the additional attributes. So this is known as method overloading. Same method name with different inputs. So what I can do now is, why to access the parent's method here, I can have my own method mobile dot set the product details with the PID, let's say 301, name, let's say iPhone X, price, let's say 70,000, OS, let's say iOS, RAM, let's say 4, SD card size, let's say 128. And thereafter I'm gonna say mobile dot show the product details. Now when you run this code, guys, what we see is it says data written in product object. So what I can do is I can just manipulate this and I can say data written in mobile object. When you run this code, you see data written in the mobile object, but whatever you are reading is the one which was inherited from the parent. So this read method show product details is inherited from the parent, and that is being used here. So hence we cannot see more than 3 details. I'll redefine this method as well. So let's redefine show product details as well. But here we have same inputs, two methods, one from parent, one in child, and we have same signatures. When I say same signatures, it means they have same input details. So what I'll do is I'll extend the data here. So we'll have OS, we'll have RAM, and we'll have SD card. So we'll have this OS, RAM, and SD card size. Now what you will observe is that when the show product details will be executed, so we got two show product details method, one in the parent, one in the child. So child method will be executed and not the parent method. So this fundamental over here is referred to as overriding. Very, very beautiful concept, guys. So overriding versus overloading. Method overloading, whereas this is method overriding. So same method name with same inputs in parent-child relationship. So only in a parent-child relationship. Now when you run this code here, what you see is the other details also coming in. Now we know the reason that why we need to overload a method, why we need to override a method. We need to overload a method so that we can write the exact data which we want. So we are customizing this method in the child. We are overriding the method so that we can display more data. So we are customizing the methods in the child, right? So overloading and overriding is what where we are having customizations to predefined methods. We don't want these predefined methods. We want the way we want to present the data, and we have it in front of us. So this is a very quick introduction to object-oriented programming structure, guys. So now let us come here and understand the next part. So inheritance is where one object will acquire the properties of other object. It is a relationship, the parent-child relationship. So syntactically, you need to come up and say extends. So which is extension, right? What are the advantages? Code reusability. So we are reusing the code, having an extensibility. We are using overriding. We are even having the features to hide the data. If you privatize any attribute, you won't be able to inherit it. So we got different types of inheritance. So you got single level, multi-level, and hierarchical, where single level is one parent, one child, multi-level is parent to child to grandchild, and hierarchy is having one parent with more than one children. Multiple inheritance, that's opposite of hierarchy, is not supported in Java. So there is no virtual keyword, there is no pointer technique in Java by which we can solve the problems like dreaded diamond here. So in single level inheritance, we got one parent and we got one child. So arrow is upwards because B is an A, right? So it's extension relationship. Then we have multi-level, parent to child, child to grandchild. And thereafter, guys, we got hierarchy where one parent with the multiple children. So remember, we don't have support for multiple inheritance in Java. That's like the reverse of this hierarchy. Multiple parents having the same object. Next is polymorphism. So guys, it is having the same name with the different definitions. So you can say mothers, they are the best example of polymorphism. They handle kids, they handle office, they handle home. More than one form, right? So here polymorphism can happen in two different ways, compile time and runtime. So what is compile time versus runtime? So compile time means overloading. We call it static polymorphism. So compiler will ensure which method will be executed for which function call. So there are some rules to overload. The method name should be same, and the argument list or the inputs to the method, that should be different and unique. So the other form is runtime polymorphism. That's like dynamic polymorphism, where we got method overriding. All right. So overriding, we got some rules coming in here. So the rules to override is where the method name should be same, input should be same, return type is something which must be same or the subtype of the overridden method. And access level, it must be same or more restrictive. Now what is abstraction, guys? So abstraction is achieved using abstract classes and interfaces. So this is where we achieve a runtime polymorphism in a different approach, right? So here we have an abstract class. So an abstract class is created using an abstract keyword. So here we will have the methods with the abstract keyword. We even have non-abstract methods. This is a class for which you cannot create objects. You can have constructors, you can have static methods, but we cannot create the object, right? So you can even have the final methods. So abstract class acts as a template for the various methods and definitions to be executed. So moving ahead, so the better version of abstract class is an interface. So interface is a blueprint for a class which will contain some constants and abstract methods. So it will enable multiple inheritance and helps in achieving the loose coupling. So a class can extend a class implements an interface. Now this is one of the major differences between classes and interfaces. So we got interface to interface inheritance as well. So guys, abstract class and interfaces, so as in practically we'll see it in our other sessions. So lastly, what is encapsulation? Where we are going to privatize the data. So we can have an attribute, we can mark it as private, and when the attribute is marked as private, it cannot be accessed. So we need setters and getters so as to access this private data. So encapsulation leads to data hiding. So it is focusing on security.
Exception is a problem that arises during the execution of a program. It can occur for many different reasons. Say a user has entered an invalid data, or a file that needs to be opened cannot be found, or you can also say that a network connection that has been lost in the middle of communications, or the JVM has run out of memory, many such cases. But if we do not handle them, it leads to a system failure. So handling an exception is very important. And that's where Java introduced exception handling mechanism to handle the runtime errors so that the normal execution flow will not be disrupted. For example, class not found, IO exception, SQL exception, etc. Now let's move ahead and see the difference between error and exception. First, errors are impossible to recover, but exception can be recovered by handling them. Next, errors are of type unchecked, but exceptions can be either checked or unchecked type. Just wait a little while and you will know what are checked and unchecked type of exceptions. And errors are something that happen at runtime, but exception can happen either at compile time or runtime. Exceptions are caused by application itself, whereas errors are caused by the environment on which the application is running. So these are the key points of difference between errors and exceptions. Now, let's see what is exception hierarchy. All exceptions and errors types are subclasses of class throwable, which is the base class of hierarchy. Here, one branch is headed by exception. That is, this class is used for exceptional conditions that user program should catch. For example, say null pointer exception, runtime exception, etc. And other branch error are used by the Java runtime system to indicate the errors that has to do with the runtime environment itself, that is JRE. For example, virtual machine error or stack overflow error, etc. So how Java virtual machine handles exceptions? Whenever inside a method, if an exception has occurred, then the method creates an object known as exception object and hands it off to the runtime system. And this exception object contains name and description of the exception, and also the current state of the program where exception has occurred. And creating the exception object and handling it to the runtime system is called throwing an exception. Then, using try, catch, finally methods, these exceptions can be handled. So this is how Java Virtual Machine handles exceptions internally. Next, let's see the differences between checked and unchecked exceptions. In simple terms, exceptions that happen at compile time are checked exceptions like IO exceptions, etc. And runtime exceptions are called unchecked exceptions like divide by zero, array out of bound, null pointer exception, etc. Basically, unchecked exceptions are built-in exceptions in Java. So checked exceptions cannot be simply ignored. The programmer should handle these exceptions. And runtime exceptions are ignored at the time of compilation. Now, let's see the basic example of exception. So here, I have defined the class, and inside the main method, I have a try block. So in this try block, the code that we are going to write may raise an exception. That is, it contains the code that raises exception. And then the raised exception will be handled in the catch block. So let's see a small program as how it occurs. First, I will create a new package called exception, Edureka. And now I'll create a new class called sample exception. Finish. So inside the class, the first thing that we are going to do is we are going to write the main method. So here I will create a string str and make it as null. So now after this, I will try to retrieve the length of the string. So when I execute this program, it will throw an exception. Why? Because the string is null and we are trying to retrieve the length of the string. As I said, it throws null pointer exception because the string is null. It does not contain any values. So now let's use try and catch method to handle this exception. So what I'm going to do here, in try block, I'm going to write the code that will raise an exception. Say I have given A as 30 and B as 0. Now I will try to divide a number by 0. Like int C is equal to A by B. So just tell me what happens here. Now say if we try to divide a number by 0, then it says we cannot divide the number by 0 because it raises an arithmetic exception. Correct? So let's see how that occurs. Now, as it throws an exception here, so what I'll do to maintain the normal flow of execution, I will write the catch block to handle this exception. That is, okay, let's run the program and see the output. So as I told, the exception has been catched by catch block. So here first it will throw the exception and then it goes to the catch block. Catch block handles the arithmetic exception E. So it prints cannot divide a number by 0. So this is how exception handling works. Now let's see the various types of exceptions. So in Java, there are two types of exceptions. One, built-in exceptions, and the other one, user-defined exceptions. First, let's see what is built-in exceptions. These are the exceptions which are available in Java libraries, and they are suitable to explain certain error situations, like arithmetic exception, array index out of bound exception, class not found, IO exception, runtime exception, number format, etc. So let's see an example and understand how built-in exception works. So this example is one type of exception, that is arithmetic exception, where we try to divide the number by 0 and it results in arithmetic exception and we have catch the method. So let's see one more example of that kind now. I'll use one more try block. Here what I'm going to do is, I'm going to declare an integer number and try to parse a string variable. So what happens? It's an obvious fact that it throws an exception. So let's see how. So just tell me one thing. I have declared an integer number and trying to parse a string variable. So what happens? It obviously throws an exception. Now, in order to maintain the normal flow, we have to handle this exception. So I'll use the catch block and handle the number format exception. So now let's execute and see. First it said cannot divide by 0 because we handled arithmetic exception. And next we handle number format exception. Next we will see how array index out of bound exception occurs and how it can be handled. So here you can see I have created an array of size 5. And now I'll try to access the 7th element in the array. So what happens after this? It will obviously throw an exception. Why? Because the size of the array is 5 and I'm trying to access the array that is out of bound. So what happens when I catch the exception? It says array index out of bound exception. Sorry, it is array index out of bounds. Now again, let's execute. As I said, again the array index out of bounds exception got handled and it printed the output. So this is how built-in exceptions are present in Java libraries. So now I will jump into the methods of exceptions because you need to know the throw and throws methods to understand user-defined exceptions. After I complete the methods of exceptions, I will explain you the user-defined exceptions. So these are the various methods of exceptions, that is try, catch, finally, throw and throws. Let's see each of them. First, try. Try block is used to enclose the code that may throw exception. The syntax is as follows. As you have already seen, it's very simple. We write a code that throws exception and we can handle it using the catch block. Next, nested try. Nested try block is nothing but a try within a try block. For example, you can see here I have declared one try and inside that I have created one more try catch and there is one more try as well. So let's see a small example as how it works. So I'll do one thing here. I'll give a try block within a try block and then after catch I will end the statement and after that I will print like system.out.println. Let's print some other statement. Just look at the program. First, what I did. So from here I have modified the program. I have given one try block and inside one try block I have given one more try and catch block. Okay. And now I have created one more try catch and handled here. After that, what I'm doing, I'm just giving a statement as print other statement. After that, I'm closing this try block. Then I'm again catching the exception and handling that. Okay. So within this one try block, there are two try blocks. So that's how nested try can be used. So let's see the output. See, first it's saying that cannot divide by 0 because it was the first thing that we have done. And within the try block, it said number format exception because the first try block got executed. And next, for this one more exception that it threw, it said it handled. And again, it's printed other statement. That's all. Because we are not declaring anything in the other try block, that is the main try block. So it is not printing that exception. If this try block has thrown any exception, again that would have been printed. But as there is nothing, it's not printing. So this is a usage of nested try and how it can be declared, and this is how it works. Now, let's see the usage of catch block. As in these previous examples, you have already seen how it can be used. And there's also one more thing, that is multi-catch. That is, if you have to perform various tasks at the occurrence of various exceptions, then you can use Java multi-catch block. So here you can see you have one try block and you have multiple catch blocks. So let's see how that works. I'll modify this program only for you. So here I have one try block and I have two different catch blocks. Let's execute and see. So first it printed number format exception and then it printed other statement. Why this exception did not get handled? Because there was no any exception that was being thrown for this. Okay. If there was any exception that was thrown, then it would have been handled. So this is how you can use multiple catch blocks. Next, we'll see finally. Finally is a block that is used to execute important code such as closing connection, stream, etc. No matter whether exception is handled or not, finally block will always be executed. So in the previous example, you saw that after declaring a try block, you must use catch block to maintain the normal flow. But on using finally block, the catch block is not required. Let's see how. I'll do one thing. I'll remove all the catch blocks here. So I just have a try block. Now I'll give finally and print the statement. Okay. So now let's execute this. As I said, we have not used catch block. It throws the exception. But even on throwing the exception, the flow will not be disrupted there because we have used finally block to execute the code. So you can see the finally block is always executed. So that's how it works. Next, let's see what is throw. Throw is nothing but a keyword which is used to throw an exception. So you can see the syntax here. Inside a method, you are throwing an exception. Let's see how it throws an exception. Let's modify this program. First, I'll define the function here. So inside the throw block, I'm going to throw an arithmetic exception. Okay. Now, let's handle the exception using catch block. I'll close this average function and call this function in the main method. So first I throw the exception in try block and catched it. And now I'm calling the entire function in the main method. So let's see what will be the output. It's just telling the exception is being caught. Correct? Why? Because when we call the average function in the main method, it goes back to the loop. The exception will be thrown, but it has been catched. Correct? So this is how throw is used to throw an exception, and it can be handled in the catch block. Simple? Let's see what is throws. Throws is also a keyword which is used to declare the exceptions. It does not throw any exception, but it specifies that there may occur any exception in the method, and it is always used with the method signature. Let's see how. Again, I'll modify this program itself. As I have told, it is used with method signature. I'm going to use the throws keyword along with the method. And I'm also using a throw keyword to throw the arithmetic exception. Now, inside the main method, I'll use a try block. So this is an example wherein I'm using the throw keywords along with the method signature. And inside this, I'm throwing a new exception. But when I'm calling the method or a function inside the try block in main method, it will throw an exception. So instead of handling it, I'm just printing the finally block. So let's see what happens. So you can see here first the inside average function is printed, and then it says that there is an exception in the main method. That is, we are throwing an exception. As we are not handling that, at the end it's printing the finally block. Simple? So this is how throws is used. Next, let's see the difference between throw and throws. First, throw is explicitly used to throw an exception, but throws is used to declare an exception. We have already seen how it worked. Next, checked exceptions cannot be propagated using only throw, but checked exceptions can be propagated using throws. Throw is followed by an instance and throws is followed by a class. And throw is always used within a method, and throws is used with the method signature. And throw can throw only one exception and not multiple exceptions, and throws can declare multiple exceptions. Just now we saw how it worked. Next, we'll see the difference between final, finally, and finalize. So final is a keyword, finally is a block as we saw, and finalize is a method. Final is used to apply restrictions on class, methods, and variables. But finally is used to place an important code, and finalize is used to perform cleanup processing just before the object is garbage collected. Coming to final, the final class cannot be inherited, and the final method cannot be overridden, and the final variable cannot be changed. Coming to finally, it will be executed whether the exception is handled or not. We already saw how it worked. Now, let's see a user-defined exception. Sometimes the built-in exceptions in Java are not able to describe a certain situation. In such cases, a user can also create exceptions, and that are called as user-defined exceptions. There are two important points. First one, a user-defined exception must extend the exception class. The second one, the exception is thrown using a throw keyword. So let's see how it works. I'll modify the same program. First, inside the try block, I'll throw an exception using throw keyword. I will handle the exception using catch block. I'll close the class. Now I will extend the exception using extends class. So let's pass some argument here and let's try to print the output. So let's pass some argument as we have thrown a new exception, and when I'm extending my exception, then what happens? Let's see. I have saved the program and I'm giving the value of A to B. Okay. Now let's see what will be the output. As expected, it should print the value as 5. Let's see whether it prints the same prescribed value or not. Exactly. We got the output as desired. That is, the throw keyword is used to create a new exception and throw it to the catch block. And then it got handled, and when extending that, we will get the same desired output. So this is how you can create a user-defined exception. Now coming to the end of the discussion, let's see what are custom exceptions and how to parse an exception. I'll modify the same program again. So in this case, if the number that we entered is more than 100, then it should throw an exception. Else, it should print the provided input is valid. Let's see how. After that, I'm reading a number here and then trying to validate the input in try block. If the input is not validated, then it will be handled in the catch block. Again, this is a user-defined exception, so it must extend the exception class. So this is how I have created custom exception. So let's run the program and check what will be the output. So it's asking to enter the number that is less than 100. So I'll enter 99. Says valid input. Again, I'll run the program. Now I'll enter 101. It says input is greater than 100 and it caught the exception. That is, I have mentioned here, if the number is greater than 100, then it should throw an exception. And that exception is caught in the catch block. So this is how custom exception can be used in Java. Now let's also see how to parse an exception. In this case, we are going to parse a simple date format. So for that, I need a java.simpleDateFormat package. I'll import that now. I'll make the class as public and let's write the code. For the simple date format, I'm going to create a reference called SDF. So I'm going to parse the input date that we enter. So this is very simple. I'll tell you how. If we enter the date in this format, then it should print as valid input, or else it should throw an exception. Let's see how to do that. So in the try block, first I have read the input date and then output date and have created a reference for them. And if there is any error in case of changing the date format or while converting the date formats, then that exception will be handled in the catch block. And next, in the main method, I have used a scanner class to read the format. So let's run the program and check the output. So first, let's enter the date format, which is invalid. So I'll give something. So it's telling that some error has occurred while converting the date formats. So it's telling exception is here. That is when we're trying to parse the exception. And the unparsable date will be so and so. Now let's execute it one more time and enter the proper date format. That is 01011996. So it's telling after changing the date format, it will be this. That is the one which I have given in this format. From the input date format, which is in day, month and year, it changed the output date format by parsing the input date to year, month and day. Correct? So this is how we can parse the exception.
Let us quickly dive into the history of C programming. As we all know that Dennis Ritchie is the founder of C programming language. Prior to C programming language, we had many other programming languages such as B, COBOL, ASGOL, and many more, which were usually the machine-level programming languages, and it was very difficult to develop Linux operating system using those machine-level programming languages. This was the reason which Dennis Ritchie founded C programming language in the year 1972 at Bell Laboratories, USA. C was originally implemented on the first machine, which is DEC PDP-11. C is well known to be flexible and versatile, which allows maximum control with minimal number of commands. And it is a very user-friendly programming language, and it is highly readable. Now we shall get into the next stage where we'll discuss the features of C programming language. The first feature of C programming language is it is a high-level programming language. Any programming language is considered as a high-level language if it is written in English or user-readable language. Now we write programs in C language using English or user-readable language, which is user-friendly and easy to understand. Followed by the first feature, the next one is structured language. C language is considered to be a structured programming language as it improves the clarity and quality, and it reduces the development time for designing a programming software. Followed by this, the next feature is rich library. C language has its own library which includes most of the arithmetic and logical operations which are predefined. We just have to include the libraries which we need, and we can execute the functionality of those libraries without having to code them separately. Followed by that, the next feature is its extensibility. The programs which are written in C language are highly extensible. Followed by this, we have the next feature, which is recursion. Recursion is a feature offered by C programming language where we don't have to write the function for multiple times. Instead, wherever we need the function, we just have to call it. This feature reduces the time involved in the development cycle and also improves the code functionality. Followed by this, the next important feature offered by C programming language are the pointers. Using the pointers, we can directly interact with the physical memory of the computer system. The next one is faster execution. Using C programming language, the users can execute programs faster than its predecessors. And the final feature is memory management. The C programming language offers many functions where we can dynamically and directly interact the memory of the computer system. Many functions such as malloc, calloc, realloc, and free are the dynamic memory allocating functions used in C programming language. Followed by this, the next stage is the installation of C in Windows system. Since I'm using Windows system, we can learn the installation of C in Windows. Now, C can be installed in computer system in multiple ways. The most basic way of installing C is installing Turbo C in your system. If you are a fan of Eclipse IDE, then you can directly download GCC compiler and add CNature to the Eclipse IDE and continue to execute your programs. Compared to the previous two methods, the last method is completely simpler and easy to use. You can directly use an online compiler where you can directly write your code and execute it. Now let us try to install Turbo C first. To install Turbo C in your system, you just have to download Turbo C++ for 7, 8, 8.1 and 10. You can either choose a 32-bit version or a 64-bit version. Since my system is a 64-bit version, I have chosen 64-bit version and it is lying in my downloads section. So this is my Turbo C++ executable file. All I need to do is just install it. Select yes. Here you go. You can see the installation wizard here. Just select next and accept the agreements of Turbo C++. Next, next, and you're done. Installation will be completed within a moment, and here you go. You have the finish button and Turbo C is installed in your system. And this is the editor you'll find for Turbo C, and here you can write your programs and execute. So this is how the Turbo C++ editor looks like. Now the next method which I was talking about is Eclipse. To use C programming in Eclipse IDE, you need to download an Eclipse version for C and C++ developers. Now you can see the link for Eclipse IDE installer for C and C++ developers. All you need to do is download this installer and run it, and after running it, you'll find options for various IDEs of Eclipse. All you need to do is just select C or C++ developers version and you'll have the Eclipse. As you can see, I have already downloaded the Eclipse installer. All I need to do is to run this installer now, and I'll be getting a dialog box where I have to choose Eclipse IDE for C, C++ developers. Once after you install the Eclipse IDE, the next step you want to do is to install the GCC compiler. To install the GCC compiler, you need to visit an official website which is MINGW. Here you can either choose the 32-bit version or you can choose a 64-bit version and install it in your PC. This is the download link. I have already installed MingW 64-bit in my system, and once after the installation is finished, you can directly start your Eclipse. Once after the Eclipse IDE is installed, your IDE looks something like this. Once after you start the Eclipse IDE, the first thing you need to do is to set the C++ and C nature. You can select the C++ or C IDE nature by selecting this icon, which is on the right topmost corner of Eclipse IDE. After selecting that, you can see a pop-up where the first option is C or C++. This perspective has been selected here and just select Open. And that's how you start working with Eclipse IDE. And now comes the easiest way to use C programming language in your computer is by choosing an online compiler. This is the official site for using an online compiler where you can write your programs directly onto the text editor. Now with this, we shall move on to our next stage where we shall discuss C tokens. The C tokens available in C programming language are keywords, constants, special symbols, strings, identifiers, and operators. Now we shall discuss about each one of them in detail. Firstly, keywords. Keywords are defined as those variables which have special meaning and are predefined in C libraries. So this was a definition for keywords. Keywords are something which are predefined in C libraries which you cannot rename or you cannot reprogram. For example, if we're using the loops like do-while loop, while loop, for loop, then the methods and the functionality of those particular keywords is predefined. You cannot access them or you cannot redefine them or reprogram them. So this is the meaning of keywords. Some of the basic examples for keywords are for, if, else, main, void, etc. Now let's move on to the next stage of keywords where we'll have the complete description of all the keywords available in C programming language. So these are the complete description of all the keywords which are used in C programming language, which you cannot either access or you cannot change the functionality or you cannot reprogram them. These are all predefined and loaded into C libraries. Followed by this, we shall discuss constants. The definition of constants goes like this. Constants or literals are like variables. But the difference is that the values of constants are fixed. Once declared, they cannot be changed. Now let's understand this in detail. Variables are those, once after you declare them, you can either change their values or you can also perform operations on them. But if you declare the same variables with the keyword const in front of them, then you cannot change them. You cannot change the value which is stored in the variable declared with const keyword. The syntax for declaring constant type variables are const followed by data type and after that the variable name, or you can also declare a pointer type variable name with using const keyword. Followed by this, the next one is the types of constants available in C programming. The first one is the integer constants. Followed by that we have floating point constants. Later we have character constants. Then we have string constants and finally octal or hexadecimal constants. Next are strings. The definition of strings is defined as follows. Strings are defined as a collection of characters defined in form of an array and at the end with a null character which describes the end of the string to the compiler. Strings are nothing but character type arrays. In strings, we have the alphabetical data which is stored in the form of arrays. Alphabetical in the manner A to Z, not the numbers or special symbols. Once after the string is declared in C language, it has to end with a null character which is the only special character used in strings which will indicate the compiler that it is the end of that particular string. Now we shall learn the syntax for declaring a string in C language. The syntax is first you need to begin with the data type which is char, followed by that we have to specify the string name and at the end you have to specify the length you are using for your string. This will be fixed. This will not be varied in the runtime. Followed by strings we have special symbols. Special characters are the symbols or single characters or sequence of characters that have a special built-in meaning in the language and typically cannot be used in identifiers. Let's understand this in a bit detail. Special symbols are characters such as $, ampersand, brackets, etc. are having a special meaning which is predefined in C libraries while designing the C programming language. This is the reason for which they are used in a particular segment of code. For example, if you consider ampersand, The ampersand symbol is used in printf and scanf statements only. This ampersand symbol is dedicated to locate the address of the variable which you have declared in your program. And when you come into modulus symbol, this is especially used along with the data types for specifying the data type. For example, if you are declaring an integer type data type, you'll be using modulus symbol along with D. If you are declaring string type data type, then you'll be using the modulus symbol along with S. So this is about the special symbols, and the basic examples for special symbols used in C programming language are modulus, ampersand, and brackets. The next thing is identifiers. Identifiers are defined as the names that we declare in the program in order to name a value, variable, function, array, and etc. Let us understand identifiers in a little bit detail. Identifiers are nothing but the name you declared for your variables and values, functions, arrays, etc. which you are using in your program. It's like naming a person. For example, if you want to talk to a person, then you call him by his name. So in the same way, if you want to access a particular memory location or value or an array or whatever the function you're using in your program, you call it with a name, which is its identifier. For understanding this, let us consider a simple example, which is int x is equals to 10. Here, int is the data type which you're specifying for your identifier, and x is the variable name which will be storing the value 10. Followed by this, we shall also understand some basic rules for declaring identifiers. Some of the basic and important rules used for declaring identifiers are: first character should always be an alphabet or an underscore. The succeeding characters can either be digits or letters. For example, special characters are not allowed except underscore. And the last rule is that identifiers should not be keywords. Let us see the examples to understand these rules. The first type of examples are valid identifiers which are declared using the rules declared for identifiers in C programming. For example, integer a, which does not have any kind of special symbols or numbers in front of it. And the next one is underscore a b, which is valid because underscore is the only special symbol which is used here. Followed by that, we have alphabet in the starting place, and after alphabets we have numbers. So this is also valid. And the invalid type of identifiers are: you cannot specify the number at the starting position of an identifier. Followed by that, you can also not include space in between the name of an identifier. If you want to include space, or if you want to specify space, then you can use underscore. Followed by that, you cannot specify the keyword as your identifier. Here, long is a keyword which happens to be a data type. Once after you have understood the rules for declaring identifiers in a C program, let us move on to the next concept, which is operators. We have the following operators in C program. We shall understand about each one of them in detail. The first one happens to be arithmetic operators. Followed by that, we have increment or decrement operators. And next, we have assignment operators. Followed by that, we have relational operators. Next, logical operators. And last but not the least, the bitwise operators. Let us understand each one of them in detail. Firstly, arithmetic operators. The arithmetic operators are used to perform mathematical calculations such as addition, subtraction, multiplication, division, and modulus. Let us go through a simple program to understand the functionality of arithmetic operators. This particular program features all the arithmetic type operators that we use in C program. Now let us try to compile this program and see how does it work. As you can see, the code has been successfully compiled and we have the output. Firstly, we have declared three variables here using the integer data type. The first variable is a, which stores the value 9 in it. Followed by that, we have the next variable b, which stores the value 4 in it. And the third variable is an integer type variable, which is empty. Now we'll use the third variable to store the results of the operations performed on a and b. Firstly, we are going to perform addition operation on the first two variables a and b, and the value will be stored inside c. Similarly, the next operation would be subtraction, and the subtraction result will be stored in the value c. Followed by that, we have multiplication, division, and modulus. As you can see, the program has been successfully compiled and the results are shown as below. Firstly, the addition 13, the subtraction 5, multiplication 36, and division is 2. Finally, the modulus operation, which resulted in a remainder which is 1. Now with this, I hope you have understood the basic functionality of arithmetic operators used in C program. Now let us discuss the next type of operators, which are increment operators and decrement operators. Increment operators and decrement operators are basically used when loops are included in program. We shall discuss about loops in a much detailed way in the upcoming concepts. For now, let us understand that the control statement will be executed for multiple times when increment or decrement operators are included in the program. I++ defines that it is incrementing, and I-, defines that it is decrementing. You can either use any of the variables from A to Z along with the increment symbol, which happens to be the plus plus, and decrement symbol, which happens to be minus minus. With this, let us discuss about the next type of operators, which are the assignment operators. Assignment operators are used to assign values to the variables in C programming language. For example, if you are declaring certain value to a variable in C program, then you must use assignment operator. For example, we have int a is equals to 10. Here, int is the data type and a is the variable name. So, to assign the value 10 or to save the value 10 in the variable a, we need to use the assignment operator, which is equals to. And on the same way, if you're using double equals to symbol, it means that you're comparing the values stored on LHS and RHS. For example, if you're using a double equals to b, then the compiler understands that if the value of a is equals to b, then it has to execute certain commands in the upcoming statements. Let's discuss about that in the upcoming concepts. For now, let us move on to the next type of operators, which are relational operators. Relational operator is a programming language construct or operator that tests or defines the relation between two entities or two variables. Examples for relational operators are as follows: greater than, less than, equals to, and not equals to. Let us understand relational operators in a much better way. Relational operators are generally used between two or more variables. If you had to compare the greatest among the two values, for example, consider a is equals to 10 and b is equals to 20. Now the user wants to know which is the greatest variable. Then you will apply an if condition and declare two variables inside it, as shown here. If a is equals to or less than b, then a particular statement or particular code segment will be executed. This condition will be true only if a is less than or equals to b. Followed by the relational operators, we shall discuss about logical operators. The logical operators used in C programming are logical AND, logical OR, and logical NOT. The logical operators are used to perform certain operations on the given expressions. First, we shall discuss logic AND. To execute logic AND, both the sides of the LHS and RHS must be true. Only then it will result in a true value. If any one of the other value is false, then it will result in a false value. Similarly, when we come into logical OR, the logical OR functions with either one of the values of the two comparisons should be true. For example, if you're comparing A or B, then either A should be true or B should be true. Then the resultant will be automatically true. If both the values are false, then the resultant will be false. Similarly, when you come into logical NOT, the major functionality of logical NOT is to convert the true value into false. If you're using the NOT operator in front of a true value, then the value will be converted into false. Followed by the logical operators, we have the bitwise operators. The operators are used to perform bit operations. Decimal values are converted into binary values, which are the sequence of bits, and bitwise operators work on these bits. We have 6 types of bitwise operators. Firstly, bitwise AND, bitwise OR, bitwise NOT, XOR, left shift, and right shift. Followed by this, we shall enter into the most important concept, which is data types and variables used in C language. The data types used in C language are categorized into 4 varieties. Firstly, the basic data types. Next, we have the derived data types. Followed by that, we have enumeration data types. And lastly, we have void data types. We shall discuss about each one of them in detail. Firstly, the basic data types. The basic data types described in C language are int, char, float, and double. And followed by that, the derived data types are the array, pointer, structure, and union. The enumeration data type is none other than the data type which is declared using the keyword enum in front of it. And lastly, we have the data type void. Now we shall discuss the variables used in C programming. Variable is defined as a reserved memory space which stores the value of a definite data type. The value of variable is not constant. Instead, it allows changes. To understand variables in detail, variables are something similar to identifiers. Variables actually store the value which you assign to them. For example, if you declare a variable a with certain data type, say float, and you assign some value into it, say 100, then it will store that particular 100 value in a memory location with float data type. That is, the value of 100 will be stored as 100.00 in a certain memory location in the memory allocated to it. Now let us understand the types of variables available in C programming language. There are mainly 5 types of variables supported in C programming language. They are local variable, global variable, static variable, automatic variable, and external variable. Now let's discuss about local variables first. Any variable that is declared inside a code block or a function that has scope confined to that particular block of code or function is called as a local variable. Let us understand this in a detailed way. For example, you are defining a function inside a main program. So inside the function, you will be declaring some kind of variables like int a or int b. So that particular variable is eligible to be used inside only that particular function, but not inside the entire code. So this is why it is called as a local variable, as its scope is been confined to one particular main program or one particular function, not to the entire program. For example, here I have declared a function by name Edureka, and inside I have declared a local variable by the name local variable, and I have stored certain value that is 10 into it. So I will be able to access this local variable only inside the function Edureka, but not outside the function Edureka. Now let us discuss about global variables. You can see that the global variable is directly the opposite of local variable. The global variables are actually declared outside the main function itself. Before even you start coding, you'll be declaring first the global variables. The speciality of global variables is that you can access the global variables in the main program as well as the function, or in other way, I can say that the global variables can be accessed anywhere in the program. Followed by the global variables, we have the static variables. The static variables are also called as variables, but the only difference is that static variables will never allow you to change the value which they have stored. For example, you can run this code. Here, I have declared a local variable 10, and followed by that I have also declared another static variable with the name static variable, and I have assigned the value 10 into it. Now I can perform some operations such as adding one value to the value stored in local variable. The local variable will accept it and execute the code, and the value of the local variable will turn into 11. But when you come into static variable, and if you want to try this operation on that particular variable, then the compiler will throw an error saying that the value of the static variable cannot be changed. Followed by this, we have the automatic variable. The automatic variables can be declared by using the keyword auto. By default, all the variables which you use in C programming language are automatic variables. For example, you can see this. I have a main function inside which I have declared two different variables. One of them is the integer data type with local variable name which stores the value 10 into it. And the other one is also an integer type variable auto which stores the value 20. I can either use this auto keyword, or I can just simply declare a variable with integer data type and I can type the variable name and declare the value into it. Both are considered to be automatic variables. Followed by this, we have external variable. External variables are declared by using the keyword extern, similar to the other one which is auto variable. Here we'll declare the external variables with the keyword extern. We can share a variable in multiple C source files by using an external variable. For example, I have declared an external variable here of integer data type, and the name of the external variable is external, and it is storing the value 10 inside it. Don't forget to see the keyword which I have used, which is extern, to declare the external type of variable. Now, similar to the rules of declaring identifiers, we have also the same rules for declaring variables. The rules are: a variable can have alphabets, digits and underscore, but not special symbols. Followed by that, we have a variable name can start with alphabet and underscore only. It cannot start with a digit. The next rule is that there should not be white space in between the variable name. As we discussed in the case of identifiers, no variable name or no identifier name should include a space in between them. If you want to specify space, then you must use underscore, but not the actual space. Followed by that, the last rule is that a variable name must not be any reserved word or keyword. Example, integer or float. We shall see some examples for valid type of variables that we can declare in C language. Firstly, int a, where the variable name did not start with any of the special characters or space. It just simply started with an alphabet. Followed by that, we have another way of declaring variables with underscore, which is the only symbol or the special symbol which is eligible to be present in a variable name. Followed by that, we have the last type of valid variables name, which started with an alphabet and it ended with a digit, which is acceptable. Now we shall also discuss some invalid types of variable names, where the first one is int2. Here, the variable name started with an integer value or a number, which is invalid. Followed by that, we have another variable where we have included an actual space between the variable name. That is, we have included an actual space between the variable name a and b, which is invalid. And lastly, we have declared a variable name with a keyword which is long. Long happens to be a data type and it is a keyword, so this is also not acceptable. Followed by this, we shall move into the preprocessor directives, which happens to be the most important concept in C programming language. The preprocessor directives are lines included in a program that begin with a character #, which make them different from the typical source code type. They are invoked by the compiler to process some programs before compilation. It is the macro processor that is used automatically by the C compiler to transform your program before actual compilation. Let us understand preprocessor directives in a much better way. Preprocessor directives are anything which you have written in a C program followed by an # keyword. For example, stdio.h is a preprocessor directive, which means standard input output. This particular preprocessor directives activates the input and output units to perform a C program operation. The code for this preprocessor directives is previously written by the C developers and it is stored in the C library. Now let us understand how the preprocessor directives work. Firstly, the preprocessor directives are declared in a high-level language, which is user's language. For example, #include stdio.h. Before compiling the actual program, the compiler will compile the preprocessor directives. The preprocessor directives will be in a pure high-level language, which will be in a relocatable code. So this relocatable code will be converted by the compiler into assembly-level code and will be passed to the assembler. Now, the job of the assembler is to understand the codes which are sent to it and to perform the operation which is expected from it. That is, to load the particular library. Now, to load the particular library, the command will be sent to the loader and linker in a pure machine level language, and the library which the user is expecting will be loaded to the C program. And that's how the C program will be executed with the libraries which he needs and with the input and output units which he requires. Now let us discuss some of the preprocessor directives. First one is #include. The #include preprocessor directive is used to paste code of given file into the current file. It is used to include system-defined and user-defined header files. There are two variants to use #include directive. The first way is to write #include and the file name between the greater than or lesser than symbols. And the next way is to write #include and include the file name between the double quotes. Followed by that, we have #define. The #define preprocessor directive is used to define constant or micro substitution. It can use any basic data type. The syntax for declaring #define is as follows: #define and the token value. The next type of preprocessor directive is undef. The #undef preprocessor directive is used to undefine the constant or micro defined by the #define. In a simple way, you can undo anything which you have done using the preprocessor directive #define. The syntax for undef is #undef and the token which you have defined using #define. The next preprocessor directive is ifdef. The ifdef preprocessor directive checks if the macro is defined by using the keyword #define. If yes, it executes the code Otherwise, hashtag else code is executed if the else code is present. The syntax is if def macro, a code segment, and if it is not present, then endif, or an else tag will be executed if the code segment inside the else tag is present. The next preprocessor directive is if endif. The if endif preprocessor directive checks if the particular macro is not defined by hashtag define. If yes, it executes the current code. Else, the else code will be executed if it is present in the macro. The syntax for if endif is hashtag if and def macro and the code present inside the macro. If the condition gets failed, then the code inside endif will be executed. Followed by that, we have hashtag if. The hashtag if preprocessor directive evaluates the expression or condition if the condition is true. It executes the code otherwise, else if or else or end if code will be executed. The syntax for hashtag if is hashtag if expression for comparing, and if the comparison is true, then the code inside it will be executed, else the end if code or the else if or else code will be executed. The next one is hashtag else preprocessor directive. The hashtag else preprocessor directive evaluates the expression or condition if the first if condition goes false. If the first if condition goes false, then the control will directly enter into else part and the code which is declared inside the else part will be executed. Followed by this, we have hashtag error. The hashtag error preprocessor directive indicates any error which is present inside the preprocessor directive. The compiler gives fatal error message if the hashtag error directive is found and skips further compilation process. The next one is hash pragma. The hash pragma preprocessor directive is used to provide additional information to the compiler. The hash pragma directive is used by the compiler to offer machine or operating system feature. The syntax for hash pragma is hash pragma followed by the token. With this, let us execute our first C program. As you can see, this particular example is our first program that we are going to execute in C language. Now let us try to run it. As you can see, the code has been getting compiled and the hello world message is printed successfully. With this, let us dive into the control statements that are used in C programming language. Control statements enable us to specify the flow of program control. They specify the order in which the instructions in a program must be executed. They make it possible to make decisions or to perform tasks repeatedly or jump from one code segment to another. Let us understand this in a bit detail. Control statements are actually user-defined conditions for the compiler. The user specifies a particular condition in front of a code segment and asks the compiler to execute that particular code segment if and only if the condition which he specified to the compiler is true or not. If the condition is true, then the code will be executed. If the condition is false, then the code will be skipped and the next code segment will be executed. Sometimes this also enables us to make decisions, and in the other case, we can also perform some particular task for a repeated number of times, such as loops. Now, you can also jump from one code segment to another directly if the condition happens to be false. This can be used in case of switch. Let us execute all the conditional statements present in C program and understand each one of them in a much detailed way. Firstly, we shall understand if condition statement or if control statement. The if statement in C is defined as a programming conditional statement that if proved true, then performs a particular operation and displays the information inside the statement block. For example, if you have a condition in front of a code segment that you want to execute, but you have a condition to execute it. In that particular case, the code segment which you wanted to execute will be executed only if your condition what you specified will be true. Else, that particular code segment will be eliminated or the control will not enter into that block of statements. To understand this, we shall go through a flowchart. Here, this particular flowchart will define the working of if control statement. Firstly, the control will enter start and a particular code segment in the starting point of the program will be executed. Followed by that, the control will directly encounter the if condition. This is the place where you will provide your condition. If that particular condition happens to be true, then the control will pass through the condition and will execute the statements which are provided inside the condition. If the condition is false, then the control will directly jump to the next set of statements which are after the if condition statements. Let us try to execute a program to understand this in a much better way. This particular example is based on if condition. Here I am specifying a variable by the name number which is integer data type. Here I will be asked by the compiler to enter any particular number which is an integer. So the number should not be float or any other. So it should be just an integer. Then the compiler will scan the input whatever I provide to the computer. Then it will run a particular condition specified in the if block, which says if the number provided by the user will result in a remainder is equals to 0, then the code segment which is present inside the if condition block, that is a printf statement, should be executed. Else it should directly run out of the if block and execute the next particular statement which is return 0. Now let us try to execute this program and see how does it work. As you can see, the code has been compiled here. Now the program is asking me for an input. Now let me try to give an even number which is 10. As you can see, the modulus of 10 against 2 will result in a remainder 0. So the condition which I specified here is true and the code segment inside it is been printing here. Now let us try to provide an odd number and see how does it work. As you can see, the code has been compiled now. Now let me specify 7, which happens to be an odd number. Let us see if this works or not. As you can see, the program directly finished and the code block which is present inside the if block did not get executed. Now followed by this, let us understand if-else condition statements. The if-else control statement or conditional statement is similar to if condition, but the only difference is that you will also have an else block here. Let us define it. If-else statement in C language is defined as a programming conditional statement that has two statement blocks over a condition. If proved true, then the block inside the if will be executed, and if false, then the else block will be executed. To understand this in a much better way, let us go through a flowchart. In this particular flowchart, the control is started from executing the start statements. Once after the starting statements are executed, it will encounter a condition. In this particular condition, if the condition is executed and the result is true, then the control flow will enter inside the if block statements, and the if block statements will be executed, and then it will pass into the last set of statements. In case if the condition provided inside the condition block happens to be false, then the condition will be directly entering into the else block of statements, which will be a separate block of statements from the if statements. Then the else block of statements will be executed and the control comes out of the else block of statement into the next set of statements. Now let us see practically and understand how does it work. So this particular example is related to else if statements. Firstly, the compiler will compile the code and the computer will ask me to enter a particular number. So here if the particular number happens to be an even number, then the first set of statements which are present in the if block will be executed. If the condition fails, then the control will directly jump into the else block of statements and will execute the statements present inside the else block, which will say that the number you have inputted is not an even number, instead it is an odd number. Now let us try to execute this statement and see how does it work. Now you can see that the program has been successfully compiled and the computer is asking me for an input. So first let me provide an even number, which is 4. As you can see, the modulus of 4 is resulted in 0 and the if block statements have been successfully executed and it says the number you have inputted is an even number. Now let us try to run this code again and let us provide an odd number this time and let us see if else block is properly working or not. Now let us provide an odd number, which is 9. As you can see, the compiler have understood that the number is 9 and else block of statements have been successfully executed. Let us try to understand the next type of control statements, which is the else if ladder. Else if ladder in C programming language is defined as a programming conditional statement that has multiple else if statement blocks. If any of the condition is true, then the control will exit the else if ladder and execute the next set of statements. As you can see, this is completely similar to the else if control statements. But the only difference is that you have multiple else blocks here. For example, if the first if condition fails, then the control should enter the next else statements. What if the next else statement is also false? Then the control will enter into the next else block. Here you have multiple else blocks. So once the compiler finds the proper and true else block, then that particular else block will be executed. Let us understand this in a much better way using a flowchart. As you can see, the control will start from executing the initial steps, and after that it will encounter the first condition. If the first condition is true, then the statements inside the first condition will be executed. If the first condition is false, then the control will directly enter into the second condition. If the second condition happens to be true, then the set of statements inside the second condition will be executed. Else, the condition will jump into the third condition or the next following condition. And if the condition is true, then the statements inside that particular condition will be executed. If the last condition is also false, then the control will directly exit the else if ladder and execute the next set of statements. Let us understand else if ladder in a much better way by executing a practical example. As you can see, this particular example is based on else if ladder. Here, I'll be asked by the computer for inputting a number. So, if I input the number, and if the particular number which I have inputted by chance equals to 10, then the first set of if block statements will be executed. If the number is not 10, instead if it is equals to 50, then the next else if block will be executed. If the number is not equals to 10 and not equals to 50, then if it is equals to 100, then the third set of statements will be executed. If the number which I have inputted will match none of the above statements, then a final else block will be executed, which will say that your number is not equals to 10 or 50 or 100. Now let us try to execute this program and see how does it work. As you can see, the program has been compiled here and the computer is asking me for an input. So to execute the first set of statements, my number should be 10. To execute the second set of statements, my number should be equals to 50. Or if I choose to execute the last set of statements, then the number which I input should be equals to 100. If I don't want to execute all the above three statements, then I can input any of the random number to execute the last set of statements. Now let me try to input the number 100. As you can see, 100 matched with the third set of statements and the message which is present in the third block is executed. With this, let us move on to the next type of control statements, which is nested if. Nested if statement in C language is defined as a programming conditional statement that comprises of another if statement inside the previous if statement. In a simple way, it's actually an if statement which includes an if statement inside it. To understand this in a much better way, let us consider a flowchart. As you can see, this particular flowchart describes the functionality of nested if. Here, the starting set of statements will be executed and the first condition will be encountered. If the condition happens to be false, then a particular set of statements will be executed and the loop terminates. In case, if the condition provided in the if block happens to be true, then the control will enter inside the if block and it will encounter another condition inside the if block, which happens to be another if statement. So inside another if statement, you have a condition. If true, then a particular set of statements will be executed. If false, another set of statements will be executed. And finally, the control will exit the if condition. Let us execute a practical program to understand this in a much better way. As you can see, this particular example is based on nested if condition. Here, we have two variables of integer data type, which are v1 and v2. Followed by that, we have an if condition. If the entered v1 value is not equals to v2, then it should enter the first block of if statements. If they are equal, then the control will enter into the else block of statements. Now, let us try to execute this program and see how does it work. As you can see, the program has been successfully compiled and the computer is asking me for an input. So let me input two same values. Second value is also same as the first value. And inside the first if condition, we have another if condition which compares both the numbers. If v1 is less than v2, then the first block of statements will be executed, which is this. If it is false, then this particular statement will be executed. Now with this, let us move on to the next type of control statements, which are switch control statements. The switch case in C language is defined as a programming selection statement that checks for a possible match to the provided condition against the available cases. If none of the case matches, then the control will execute the default statement block. This is completely similar to the else if ladder. Here, you'll be having multiple cases. So, the control or the compiler will check for the match between all the available cases. And then, if any case matches, then the code segment inside that particular case will be executed. If the input does not match any of the provided cases, then there will be a default case or default code segment which will be executed by default. Now, let us try to execute a practical example to understand switch control statement in a much better way. But before that, let us check out the flow diagram for switch control statement. In this particular flowchart, you can see that the control entered the switch condition statement, and inside the switch condition statement, it will be received a value which will be compared against the cases provided in the program. As you can see, the value is being compared with the first conditional case here. If the condition matches the value, then this particular statements will be executed which are located inside the first case. Else, the control will enter into the next followed case, and inside that case, if the value is matched, then the statements of that particular case will be executed. Similarly, if that case doesn't match, then the final case will be compared. If it finds a match, then the statements 3 will be executed. If the value does not match any of the provided cases, then the default statement will be executed, which will be provided at the end of the switch control statements. Now, let us try to execute a program to understand switch control statement in a much better way. As you can see, this particular example is based on switch control statement. In this particular program, the compiler will ask me to enter any of the arithmetic operators. For example, I have selected plus, minus, into, and divided by. So once after I enter the operator, the program will ask me to select any two operands. That means I need to provide two different numbers. So once after it gets the operands and operator, it will perform the operation which I requested to it. So first, if I had provided plus operation, then this particular code segment, which happens to be the case plus, will be executed. If I provide the minus operation, then this particular segment of code which works with minus will be executed. Similarly, into and divided by. So if I provide the operation which does not match any of the above cases, then a default case will be executed. Now let us execute this program and see how does it work. As you can see, the program has been successfully executed and the compiler is asking me for an input. Now let me provide minus operator. The program will ask me for two different operands. Let me provide the first operand as 12 and the next operand as 5. Now the case second, which happens to be the minus, is been selected and the code segment inside that will be executed. So according to the result, we have 12 minus 5 is equals to 7. So that's how the switch control statement works. Now let us try to understand the next type of control statement, which is the ternary control statement. Ternary operator in C language is defined as a programming conditional statement that is similar to an if statement, but shorter in code length. The control checks for a condition and executes either of the two statements. So according to the definition, it is actually an if statement, but shorter in code length. In if condition, you actually provide an if condition along with a condition specified inside the if brackets. If the condition happens to be true, then you will have to write another code for the particular statements you want to execute. That's the reason the code length for if block is increased in size. But if you want to code the same thing using a ternary operator, your code length will be decreased to one line, where you will provide the condition along with the possible outcomes. If the condition is true, then the first outcome will be executed, else the second outcome will be executed. To understand ternary control statement in a much better way, let us go through this flowchart. As you can see, the control statement will first encounter the condition. If the condition is true, then a particular code segment will be executed, else the other code segment will be executed. To understand this, let us execute a program. As you can see, this particular example is based on ternary operator. So this particular line is the ternary operator. Here we have max is equals to A is greater than B. If it is true, then A should be greater, else B should be greater. So now let's execute this program and see the result. As you can see, the program has been compiled successfully and it is asking me for two different numbers, one for A and one for B. Now let me enter a smaller value for A, that is 9, and a bigger value for B, which is 10. As you can see, 10 is the largest number and A is not greater than B, so B is being displayed as the greatest number amongst the two. With this, let us move on to the next control statement, which is break control statement. The break control statement in C language is defined as a programming conditional statement that is designed to exit the control from current code segment to the next code segment when a specified condition is satisfied. We have checked the break condition statement in switch control statement. Each and every case in switch control statement will include a break which specifies that if the case is matched, then the control flow should exit the switch case and execute the next particular statements. With this, let us also check the flowchart for break control statement. You can see that the control has entered the condition. If the condition is true, then the control will be break. Else, the condition is repeated and executed. With this, let us move on to our next topic, which is loops. Loop control statements in C are used to perform looping operations until a given condition is true. Control comes out of the loop statements once condition becomes false. There are three different types of loops in C language, which are do while loop, and for loop. And let us understand loops in a much better way. Loops are actually similar to conditional statements. In C programming language, if you had to execute a particular code segment for a repeated number of times, say 5 times, then you can actually specify that to the compiler. You can just write a for loop or a while loop or a do while loop along with a condition stating that you have to execute this particular code segment for 5 times. Then the compiler will automatically understand it and will execute the same code segment for 5 times. Let us understand each one of these loops in a much better way along with flowcharts and examples. Firstly, we shall deal with for loop. For loop can be defined as a precise loop which has initialization, condition, and increment or decrement operators. So firstly, initialization. Initialization process is where you declare an initialization variable and you will assign it to a particular number. Usually the initialization value is 0. Followed by that we have a condition. This is where you specify to the compiler for a particular number of times or iterations. According to the previous example, if you wanted to execute a particular code segment for 5 times, then you have to specify if initialization variable is less than or equal to 5, then execute this particular segment for the next time. Once after that particular code segment is executed, the very next step it takes is increment or decrement. This is where the compiler will check if I have reached the limit or not. If the limit is reached, then the control will exit the loop. If not, then it will execute the loop. Now, let us see a flowchart to understand this in a much better way. As you can see, the control begins at initialization and later the condition is checked. If the condition is true, the statement will be executed. And after that, the increment or decrement process takes place. Once after the increment or decrement process is done, the control will again check the condition. If the condition is true, then the control will enter the loop again. If the condition is false, then it will exit the loop. Now, let us execute a program to understand this in a much better way. As you can see, this particular example is based on for loop. Here, I am trying to print 5 different values, which is 1 to 5. So this particular loop will be executed 5 times. So this particular value is the initialization value and this particular code segment is the condition where I have specified if the initialization value is less than or equal to 5, then the code must be executed. And finally, I have the increment operator which increments once the first loop execution takes place. Once after the first loop execution finishes, the incrementation value will be increased from 1 to 2 and the condition is again checked, and according to the condition, if it is true, the loop will be executed. If false, the condition will be exited. Once after the limit will be crossed to 5, then the loop will exit. Else, it will continue executing the statements present inside that loop. Now let us try to execute this loop and see how does it work. As you can see, the code has been successfully compiled and the result has been provided here. As you can see, the control flow has encountered the for loop first and the initialization value was 1 and the condition was true and the statement has been executed. Once after this loop finishes the first iteration, the initialization value will be incremented to 1 as the increment operator here is been executed now. Once after it changes to 2, the condition is again checked and the condition is true, the loop will be executed. Similarly, it will execute for 3 and 4. And finally, once after the increment value reaches to value 5, the condition is checked again and the condition is true. So the 5 number will be displayed here, and once after the increment goes to 6, then the condition fails. Then the control will exit the loop and the next set of statement will be executed. So that's how the for loop works. Now let us move on to the next type of for loop, which is advanced for loop or nested for loop. As you can see, this is also basically a for loop. But the only difference is that this includes a for loop inside the external for loop. To understand this, let us go through this flow diagram. As you can see, the control flow starts to execute the beginning statements and finally it encounters the first for loop condition. If the condition is true, then it will enter the inner for loop. Once after the control enters the inner for loop, the inner for loop will be executed until the condition of the inner for loop is true. Once the condition inside the inner for loop fails, then the control will be passed to the increment or decrement variable of the external for loop. Here is where the counter variable will be updated and the condition of the outer for loop is again checked. If it is true, then the inner for loop will be executed again. The inner for loop will be executed until the inner condition is true. Once after the inner condition fails, again it reaches the outer increment decrement operators. So the counter variables will be updated. This cycle will be executed until the condition of the external for loop is true. Once after the external for loop fails, then the statements outside the external for loop will be executed, or the control will exit both the for loops. Now let us try to execute a program to understand this in a much better way. So this particular example is based on nested for loop. So you can see that there is an external for loop here. So in this particular for loop, you have a condition, and until this condition is true, the internal for loop will be executed. Now let us try to execute this program and see how does it work. As you can see, the program has been successfully compiled and the data has been displayed here. As long as the first for loop is true, the internal for loop is executed and the data is printed. Now let us try to understand the next type of loop, which is the while loop. The while loop can be defined as a loop which executes itself repeatedly until a given Boolean expression or a condition is true. Now let us understand while loop through a flowchart. As you can see, similar to the previous loop, even the while loop has a decision box. Inside this, the condition will be provided. Once after the control encounters the condition, and if it finds the condition to be true, then the statements inside the while loop will be executed. Else, it will exit the while loop. To understand this, let us execute a program. As you can see, this particular example is based on while loop. We have the counter variable which is declared to the value 1, and followed by that we have a while condition loop here. And inside the while loop we have a condition which states that the counter variable should be less than or equal to 5. Until this condition is true, the loop will be executed. And you can find the increment or decrement variable which is present inside the while loop. So inside the while loop you can see that count plus plus, which means increment operator. Now let us try to execute this program and see the output. As you can see, the program has been successfully executed and the while loop ran until the condition was true, which states that the counter variable should be less than or equals to 5. So when the counter variable reached the maximum limit, the while loop got terminated and the next set of statements were executed. Let us understand the next type of loop, which is do while loop. Do while loop is completely similar to the while loop. The only difference is the condition will be stated at the end of the loop. You can see this when we execute a practical program. But before that, let us check the flow diagram of do while loop. In do while loop, the statements will be executed first. Once the statements are executed, then the condition is checked. If the condition is true, then the same set of statements are executed again. Else, it will exit the loop. Now, let us try to execute a program to understand how does it work. As you can see, this particular example is based on do while loop. You can see that the counter variable j is initialized to 0, and once after the initialization process is done, you can see that we have directly entered into the do while loop. And in this do while loop, we cannot find any condition. Instead, the control is directly entering into the loop and the first set of statements are executed. Once the statements are executed, you can see the increment operator over here, which will increment the value of j from 0 to 1. And once after the increment is done, then the condition is checked. The condition states that the initialization variable should be less than or equals to 5. Until then, this particular code segment can be executed. The only difference between while loop and do while loop is that the while loop will execute once after the condition is checked, but do while loop is executed without checking the condition, which means the do while loop will be executed at least for once. Now let us try to execute this program and see how does it work. As you can see, the program has been successfully executed and the output is also generated. The output was generated until the condition was true. With this, let us move on to the next topic, which is infinite loop. Infinite loop is a situation where the condition of the loop fails and the execution persists until you stop it manually. Infinite loop is not actually a particular type of loop. It is a situation where the condition whatever you have provided to other types of loops like while loop, do while loop, for loop or nested loop, if the condition inside that loop is failed, then the compiler starts to execute the code segment present inside the loop for infinite number of times until you stop it manually. This is a risk which you might face when you fail to provide the proper condition to your loop. With this, let us move on to our next topic, which is based on pointers. The pointer in C language is a variable which stores the address of another variable. This variable can be type of int, char, array, function, or any other type pointer. The size of pointer depends on the architecture. The pointer in C language can be declared using * symbol. So to understand pointer in a much better way, let me give you a small example. Let us assume that you have declared a variable by name n, which is of integer data type, and you have stored some value that is equals to 10. Now, what is happening here is n is pointing to a value which is 10, and it is storing the value in a particular memory location. So n must have a memory location address. Similarly, as you have your house address, in the same way, every variable in C language also has an address. So for example, n might be having some address like 1011. So if you want to access n directly, then you have to access its address. So for that, you have to declare a pointer which can access n directly through its address. So to declare a pointer variable, you have to use an asterisk, which defines that the variable which you have declared is a pointer variable. So here I have declared a pointer variable p with * symbol. That makes it as int star p is equals to address of n. So pointer variable p stores the address of n, which is directly accessing the value present in n. Before we execute a program, let us understand the advantages of pointers. We can return multiple values from a function using pointers. Followed by that, it makes you able to access any memory location in the computer's memory. We can dynamically allocate memory using malloc and calloc functions using pointer variables. Pointers in C language are widely used in arrays, functions, and structures. It reduces the code and improves the performance. Now, let us try to execute a simple program to understand pointers in a much better way. So this particular example is based on pointers. As you can see, I have declared an integer type of array with the name first array, and the first array size is 10. So inside the array, I have stored 10 different values starting from 1 to 10. And after that, I have initialized a pointer variable. So the pointer variable is pointing to the memory address of first array. So what I'm trying to do here is to print the address of each and every element present in the first array. Let us try to execute this program and see what are the addresses of all the elements present in first array. As you can see, the code has been successfully compiled and the addresses of all the values present in first array are being displayed here. For example, the address of value 1 is 0x7FFF056EA460. So this is a hexadecimal value. Once after you convert into a decimal value, then you can have a particular address where the particular value 1 is been stored. Similarly, all the other values have also got a different address through which they can be accessed. Now with this, let us move on to our next topic, which is escape sequence. Escape sequence can be defined as a combination of backward slash and a letter or digit. These sequences are non-printable and are used to communicate with display device or printer by sending non-graphical control statements to specify the actions like new line or tab space. Let us understand this in a much better way. Escape sequence is none other than a combination of backslash and a letter or digit. So we have a particular number of escape sequences in C programming which have different meanings. So basically in a C program, we use new line and tab space to provide new line for the output or to provide a tab space between the obtained output if you are printing an array. So we shall understand what are the meanings of each and every escape sequence which is provided with C programming language. As you can see, these are the few examples of escape sequences designed in C programming language. The first one is alarm, which is provided by \a, and the second one is backspace, and the third one is form feed, and the fourth one, you know this, \n, which means new line, and after that we have carriage return, and followed by that, which is the common one we usually use while printing matrices, so that is tab space, and finally we have vertical tab. Followed by this we have few more escape sequences, which are double backslash and backslash quote, backslash double quote, backslash question mark, and backslash triple n, which describes it as an octal number, and followed by that we also have backslash xhh, which describes it is a hexadecimal number, and the last one is a null character which we use in strings. So the next topic for our discussion will be functions. The most crucial and most important topic in C programming is functions. So what are functions? A function can be defined as a subdivided program of the main program enclosed within flower brackets. Functions can be called by the main program to implement its functionality. This procedure provides code reusability and modularity. Few examples for functions are library functions and user-defined functions. Actually, these are the only two types of functions which are available with C programming. Now let us understand functions in a much better way. For example, you have a program which has to add two numbers for multiple times in your program. For example, consider you had to design a program to add numbers, and inside your program you had to add numbers for 10 times. So to design this program, you had to create an addition operation for 10 times. For the first set of two numbers, for the second set of two numbers, the third set of two numbers, similarly for the 10th set of two numbers. So here you are accessing addition function for 10 different times. So this increases the code length and also increases the compilation time. So the compilation time doesn't matter for this simple operation, but if you're designing a bigger software, then this compilation time will matter a lot and the code length also matters a lot. Instead, you can just write a function where you can define the addition operation and you can just pass the values 10 times to that function and the operation will be executed. So this reduces the code length drastically and also the compilation time will be reduced drastically and the code performance will be improved exponentially. So with this, let us try to understand the advantages of functions in C programming. Advantages of functions are writing the same code repeatedly in program will be avoided, which is the example we discussed about. And after that, functions can be called any number of times in a program. According to the previous example, we had to call 10 times. We can also call multiple times more than 10 also. And after that, tracking a program easily when it is divided into multiple functions. For example, if you divide your main program into multiple functions, then tracking it would be easy. For example, if you have designed a program for Bodemas function, then if you find a problem in multiplication operation, then you can directly enter into multiplication function and check where the error is. But if you did not follow the function type of programming, then it might be a difficult task for you to find where the error is. And coming into the last advantage, reusability is the main achievement of C functions. With this, let us come into the rules for using functions. The rules to be followed to use functions in C programming are as follows. Firstly, function declaration. A function is required to declare as global and the name of the function, parameters of the function, and return type of the function are required to be clearly specified. This says that the function should be globally declared. This means before you start your main program, you need to declare what are the functions you're going to use in your program. Followed by that, you have parameters and name of the functions and the return types, which means whatever the name you specify to your function should be clearly specified and it should be readable. And also, it must include the parameters, the values which you will be passing to the function, and the return type, which means if you are getting some value, for example, as we discussed before, if you're performing an addition operation, then it is sure that you'll be getting a result out of it. So whatever the result or whatever the return type you're getting should be specified. Followed by that, you have the next rule which says function call. While calling the function from anywhere in the program, care should be taken that the data type in the argument list and the number of elements in the argument are matching. For example, you have defined an addition operation. So for a basic addition operation, you might be having two operands. So in the main function, if you're calling the addition operation, then it must be taken care that before calling the function, the operands in the main program are also equals to 2. It is not possible to have 3 variables in calling function and 2 variables in called function. This is an error. So that care should be taken. Followed by that, the next rule is function definition. After the function is declared, it is important that the function includes parameters declared, code segment, and the return type value. Just declaring a function globally doesn't mean that your function should work. To make your function work, you must also define it, which includes the parameters which you are going to use in it, and the code segment and the operation that you want to perform should be included, and also the return type value. Followed by this, we shall understand how to use functions. There are 4 different aspects of using functions in C programming. The first is function without arguments and without return value. In this case, you don't pass any arguments to the called function, and similarly from the called function end, you won't pass any values to the calling function. In the second aspect, function without arguments and with return value. In this particular type, the calling function will not provide any arguments to the called function, but the called function will return a value to the calling function. The third type of aspect is function with argument and without return value. In this case, the calling function will provide some arguments to the called function, but the called function will not return any value to the calling function. The last aspect is function with arguments and with return value. In this particular case, the calling function will provide some arguments to the called function, as well as the called function after executing the operation will provide a result to the calling function. Now, let us try to execute some examples to understand this in a much better way. Functions can be called in 2 ways, either by reference or either by value. Let us execute 2 types to understand this in a much better way. First, let us execute call by value. This particular example is based on call by value. So here, what you're basically doing is you're actually calling a function by passing values. So let us try to execute this program and see how does it work. As you can see, the program has been executed successfully and the output has been displayed here. So the value of x before calling the function is 100, and once after the function has been called through value, some operations have taken place in the function and the result is been given by the called function to the calling function, and the value of num is been changed from 100 to 200. And finally, the value of x is 100 after function has been called. Now, let us try to execute a program based on call by reference. As you can see, this particular example is based on call by reference, where the function will be called according to the addresses of the variables used in the program. As you can see, the outputs have been successfully generated and the values have been changed here since the addresses of the values have been accessed. So if you access the value of a variable through its address, then the values will be changed. And this kind of operations is oftenly risky. So if you're a fresher, then don't prefer to use values and access them through addresses. With this, let us move on to our next topic, which is based on data structures. Data structure can be defined as a collection of data values, the relationships among them, and the functions that can be applied onto the data. They can be classified as follows: primitive data structures or built-in data structures, and the second type is abstract data structures or user-defined data structures. Let us understand the data structures in a much better way, and what are the types of data structures present in C programming language and how are they supported. Let us see them. They can be classified also based on their characteristics. Before this, we classified them according to their nature, but here we can characterize them according to their characteristics. Firstly, the linear ones, and followed by that we have the non-linear data structures. The next are homogeneous, followed by that we have non-homogeneous, and static, and finally the dynamic data structures. Let us understand each one of them in a much better way and understand what exactly they are. Firstly, let us deal with linear data structures. A linear data structure stores its elements in an arranged linear sequence. Non-linear data structures. Non-linear data structures store the elements in a non-linear fashion. For example, tree and graph. Followed by that, we have homogeneous data structures. A homogeneous data structure stores the elements that are made up of same data type. For example, array. The next are non-homogeneous data structures. Non-homogeneous data structures store the elements that are of different data types. For example, structures. Followed by that, we have static data structures. A static data structure are those structures whose size and the allocated memory is fixed and cannot be changed during runtime. For example, array. Followed by that, we have dynamic data structures. And the only difference between static data structures and the dynamic data structures is that you can change the memory size of the data structure in runtime. So the most famous example for dynamic data structures is linked list. Now, let us understand each one of these data structures in a more detailed and better way. As you can see, the data structures, according to the first description, are divided into primitive data structures and abstract data structures. The primitive data structures are character, float, integer, pointer, and the abstract data structures or the user-defined data structures are arrays, lists, files. And inside lists, you can find nonlinear lists and linear lists. If it is a nonlinear list, you can include stacks and queues. And if it is a linear list, then you can include trees and graphs. Now let us understand each one of them in a much better way. Firstly, let us discuss arrays. An array is defined as a collection of similar type of data stored in continuous memory locations. The array is the simplest data structure where each data element can be randomly accessed using its index number. There are three different types of arrays, namely one-dimensional, two-dimensional, and three-dimensional. Now you must be confused about continuous memory and index. I'll explain you each and everything in a more detailed way. Firstly, let us understand one-dimensional array. So, one-dimensional array can be defined as an array with single row and multiple columns. The elements in one-dimensional array can be accessed using index numbers. Now here we'll be understanding what is index number, what is continuous memory, what is one-dimensional memory through this example. So here, this is how a basic one-dimensional array looks like. This is how the memory will be arranged in the physical memory of a computer when you have declared an array. So the array what I have declared is having the size of 5 and the memory addresses or the index of the array is known as the address which is specified for each and every memory location. So the first memory location of the array is 0 and this 0 is called as the index number. So the index number followed by 0 is 1 and similarly 2, 3 and 4. So the fifth element is having the index number as 4. The index numbers for arrays always start from 0. Now let us try to add elements into this system. The first element is 10. So into the array system, the element 10 will be included. Similarly, let us try to add few more numbers into the array system. They are 20, 30, 40 and 50. According to the definition, the elements will be arranged in a continuous order. Followed by index 0, the next index 1 will store the next element which is 20. And similarly 30, 40 and 50. So this is how one-dimensional arrays work. If you want to access any element through this one-dimensional array, index number is used here. Now let us discuss two-dimensional arrays. The two-dimensional array can be defined as the array of arrays. The two-dimensional arrays are organized as matrices which can be represented as the collection of rows and columns. The elements of the array access using intersection of coordinates. Let us understand this in a much better way through the next example. Here we have a two-dimensional array. So this is how a basic two-dimensional array looks like. It has 2 different rows and 5 different columns. So to access any particular array, you need to select the intersection. For example, if you want to access the element which is stored in second row, first column, then you have to access the array index array 1, 1, which is this one. And if you need to access the element stored in second row, fourth column, then you need to provide the address as 1, 4, which is this particular location. Now let us try to add elements into this array. The first element would be 10, which will be stored in the first row, first column. Similarly, let us add few more numbers, which are 20, 30, 40, 50, 60, 70, 80 and 90, and finally 100. Now as you can see, the elements will be stored in a continuous format, and this is how the elements look after when they are stored into the array. Now let us move on to multi-dimensional array. Multi-dimensional array is completely similar to the two-dimensional array. Only thing is another dimension is added to the arrays. That is, it might be 3D or even multiple dimensions. A multi-dimensional array can be defined as an array of arrays. The 3D array is organized as 3D matrix which can be represented as a collection of multiple rows and multiple columns. The elements of the array are accessed using the 3D intersection coordinates. With this, let us move on to our next topic, which is lists. Lists are linear data structures similar to that of arrays, but the only difference is that the elements are not saved in a sequential memory locations. So the types of linked lists are singly linked list, doubly linked list, and circular linked list. To understand linked list, we can assume this. What happens in arrays is the elements are stored in a sequential manner. That is, a particular big block of memory will be reserved for the array. And that block of memory will be divided into the number of indices. For example, if you decide an array of 5 elements of integer data type, then a bigger block of memory will be selected and that will be divided into 5 elements. Each memory block will be having same size, integer size, which is 2 bytes or 4 bytes. But in case of linked list, if you define a linked list of 5 elements, then the memory is not reserved. What happens is you will be having a memory heap, out of which 5 blocks will be randomly selected. So each one of the block will be having its own address. For example, you can see the first block is having the address of 1011, followed by that the next block of memory has 1023, and similarly the last has 7328. So this is how the 5 random integer type of memory blocks are selected. And after that, the elements in your list will be added to each one of them. So the first element will be added to some random block of memory, which is the 10 has been added to the first block. So which is 1011 and 20 to 1023 and 30 to 3026 and 40 to 4537, and last one is added to the 73281. Did you see the change here? The 7328 is changed to null. So this is what describes the end of list. So what exactly happens here is all the elements are given to one or the other memory block, and all the memory blocks are interconnected with each other. As you can see, the first element is 10, the second element is 20, the third element is 30, the fourth element is 40, and the fifth element is 50. So all of those are allocated to one or the other memory, and once after all the numbers are added to all the blocks, then each and every block is connected in a sequential order. In here, the first block is connected to the second block, and second connected to third, and third to fourth, and fourth to fifth. And once after the last block is reached, that block memory address will be changed from the existing memory to null. This indicates the end of linked list. So this is how it behaves like an array. So it has the starting and ending points, and the starting point is called as head, and the ending point is called as tail, and all the elements are called as nodes. So this is how a basic linked list exists. So we have 3 types of linked list in C programming language, which are singly linked list, doubly linked list, and circular linked list. Don't worry, I will explain you each and every type of linked list in a much better way along with practical examples. So firstly, singly linked list, second is doubly linked list, and the third one is circular linked list. Firstly, we have the singly linked list. In singly linked list, we have head and tail. The first block will store the head element, and the next block of the head will store the address of the next connected node. Similarly, the next node will store the element, and the other block will store the address of the upcoming node. This continues until the tail node is reached. Similarly, we have doubly linked list. The only difference between singly linked list and the doubly linked list is, in singly linked list, you can only traverse in one direction, that is from head to tail. But in doubly linked list, you can traverse in both the ways, from head to tail and tail to head. This is possible because the head stores the element, along with it has 2 more blocks where one of the block will store the null element in the head and the other will store the address of the upcoming node. And when you come to the second node, you have 2 address blocks. One address block will store the address of the upcoming node, and the other address block will store the element of the previous node. This happens until the tail node is reached. Similarly, we have circular linked list. Circular linked list is completely similar to the singly linked list. But the only difference is that the tail node will not have null element. Instead, it will store the address of head block or head node. So that's how it will be connected back to the head, and the complete list will become a circular linked list. Now we shall execute the elements based on arrays, single one-dimensional array, two-dimensional array, and coming into list we shall execute singly linked list, doubly linked list, and circular linked list. Firstly, we shall execute one-dimensional array example. As you can see, this particular example is based on one-dimensional array, and I have provided the size of array as 3, which means it can store 4 elements. The index of array starts from 0, As you can see, I have stored the employee IDs of 4 different employees in one single dimensional array. Now we shall try to execute an example for 2-dimensional array. This particular example is based on 2-dimensional array which is having 2 different for loops. One is the external for loop, and inside that external for loop we have the internal for loops. This is repeated for twice here. Now let us try to execute this program and see how does the 2-dimensional array looks like. The 2-dimensional array must look like a matrix. Now you can see the program has been successfully executed and it is asking the values. Now let us include the values. First 1, second we shall include 2. Similarly, let me follow it. As you can see, the 2-dimensional elements have been printed here. There is some problem in print statement. I think I have missed the escape sequence, which is \. Now let us re-execute the program again. You can see the elements printed in matrix format now. This is how the output looks like. Let us execute examples for linked lists. The first example will be based on singly linked list. As you can see, this particular example is based on singly linked list, and we can find the head elements as well as the tail elements, including all the nodes in between. You can see the program has been successfully executed and it is showing the head element as 100 and the tail element as 600, which is described by the null pointer which is located at the tail part. Now let us try to execute an example for doubly linked list. You can see this particular example is based on doubly linked list, and in here I'm defining head and the last tail and the current node, and this is the structure of node what we have defined here, which includes the data and previous and next addresses, which are the pointer variables, and followed by that we have the link definition here, the head link, and after that we have the current link, and lastly we are trying to insert elements 10, 20, 30, 40, 50 and 60 into the linked list. Now let us try to execute this program. You can see the program has been successfully executed and the doubly linked list is being described here. You can see the head node which is 10, and followed by that you have the next node which is 20, 30, 40, 50 and 60. Each of the other nodes are connected to each other, and finally you have the head node which is interconnected to it. Now let us try to execute the third type of linked list, which is circular linked lists. So this particular example is completely similar to the previous one, where we have the elements interconnected with each other and the last element will connect with the head. As you can see, the elements have been successfully displayed here, and it is a singly linked list. As I said before, the only difference is that the last element, which is the tail element, gets connected with the head, which makes it a circular linked list. Let us move on to our next topic, which is stack. So what is stack? Stack is a linear data structure which follows a particular order in which the operations are performed. The order might be either LIFO, which is last in first out, or first in last out, or called as FILO. Stack is completely similar to array, but the only difference is if we want to access stack, then it should be last in first out or first in last out. Let us see this example to understand how does it work. Firstly, let me add the first element, which is 10, into my stack. So 10 will be added to the first location, my stack 0. Followed by that, let us include few more elements, which are 20, 30, 40 and 50. So these are added to the respective locations. So 20 is added to 1, 30 to index 2, 40 to index 3 and 50 to index 4. Now if I want to access the elements in stack, I cannot randomly access it. All I need to do is to access the elements one after the other, which is last in first out or first in last out. According to the first in last out or last in first out, we have 50 as the last in element, and it should be the first out element also. So first 50 is popped out, and after that 40 is popped out, and 30 is popped out, 20 and 10. So this is how the elements are pushed and popped in a stack. So when you're placing an element into the stack, it is called as push, and when you're putting out the elements out of the stack, it is called as pop. The elements 10, 20, 30, 40 and 50 were pushed into the stack, and using the last in first out principle, we have popped out 50, 40, 30, 20 and 10. Now let us try to execute an example to understand this in a much better way. As you can see, this particular example is based on stack, and here we will be pushing few elements into the stack and later we will be popping the elements. As you can see, this particular main program is having a push function where I'll be pushing 11, 12 and 33 elements into the stack, and I'll also be popping out them in the same way using the first in last out principle. Now let us execute this program. As you can see, the program has been successfully executed and the elements 11, 12 and 33 are pushed, and using the last in first out principle, we have popped the element 33 from the stack. Now let us move on to our next topic, which is queue. Queue is completely similar to stack, but the only difference is it follows FIFO, which is first in first out. Now the definition says that a queue is a linear structure which follows a particular order in which operations can be performed. The order is first in, first out. Let us understand the terminology of queue. Similar to stack, the elements are pushed into the queue. First 10, and followed by that we are going to push the elements 20, 30, 40 and 50 into the queue. And unlike the same way which we pop the elements in stack, we are going to dequeue the elements from queue in a reverse order, which is first in, first out. So according to this principle, 10 was the element which was first pushed into the queue. Now 10 must be the element which will be first pushed out or popped out or dequeued from the queue. As you can see, 10 is been dequeued from queue. Followed by that, 20 will be the next element which will be dequeued from queue, and next 30, and similarly 40 and 50. So this is how the queue works. First in, first out. Let us execute a program to understand queues in a much better way. We will be enqueuing the elements 1, 2, 3, 4, 5 and 6, and after that we'll be displaying the queue, and after that we'll be executing a dequeue function to dequeue the elements inside the queue. Now let us run this program and see how does it work. Don't worry about the code, I'll be linking that with the description. As you can see, the elements which are inserted are 1, 2, 3, 4, 5, and once after the queue is full, the elements have been displayed here and one element was deleted. So the first element 1 is deleted, and after that the elements present in the queue are 2, 3 and 4 and 5. Let us move on to our next topic, which is graphs. Graph is defined as a data structure that is represented in a graphical format using nodes and edges. A graph in C language is commonly represented in two formats. Firstly, adjacency matrix and adjacency lists. Now let us discuss the first type of graphs. You can see this is a graph. And here we have the nodes, which are 0, 1, 2, 3 and 4. And the lines which are connecting 0 and 1 are called as edges. So we have edges for 0 to 1, 0 to 4, and similarly we have edges from 1 to 4, 1 to 3 and 1 to 2. And in this way, all the elements are interconnected to each other. Few are connected and few may not. Now let us describe the graphs using adjacency matrix. As you can see, this is adjacency matrix, and the links between the nodes have been described using adjacency matrix. For example, 0 to 0. If there is a link existing between 0 to 0, then it will be specified as 1. If there is no link between 0 to 0, then it should be specified as 0. So 0 to 0 we don't have any edge, so it must be represented as 0. 0 to 1 we do have an edge, so it should be represented as 1. And 0 to 3 you might think there is an edge, but there is no direct edge, so it is 0. And similarly we don't have a direct connection to 2, so it is also 0. Now let us see the adjacency matrix and understand this in a much better way. So to 0 there was no edge, so it is described as 0. And 0 to 1 there was an edge, so it is described as 1. And 0 to 2 we don't have an edge, direct edge, so it is described as 0. Similarly to 3, and to 0 to 4 we do have an edge, so it is described as 1. So this is how adjacency matrix works. And similarly, the adjacency list. Adjacency list is nothing but a linked list which will show the links between the nodes. So 0 to 1 we had a link, and 0 to 4 we also had a link. But once after 0 is connected to 1 and 4, 0 is not connected to any of the other elements. So the end of adjacency list is finished here. And followed by that, the next node is 1. So 1 is connected to 0, 1 is also connected to 4, 1 is connected to 2, 1 is connected to 3, but 1 is not connected to 1. So we have an end of the adjacency list here. And similarly, we have 2, 3 and 4. So this is how adjacency list works. Next, we have directed graphs. The only difference between a normal undirected graph and directed graph is the direction. So here we describe the connection between the nodes based on the direction. So we do have a connection between 3 to 2, but we don't have a connection from 2 to 3 because the direction is outwards from 3 to inward 2. So this is how you need to consider the graph, and you have to design the adjacency matrix and adjacency list. So according to this, we don't have a link between 2 to 3, but we have a link between 3 to 2. 2 is directing to 3, no, we have 0. But 3 is directing to 2, yes, we have 1. Similarly, we have the adjacency list. Here, 0 is connected to 1, 1 is connected to 2, and 2 is connected to 1 and 0, and 3 is connected to 2, 4 to 5, and 5 to 4. Now, let us understand weighted directed graphs. Weighted directed graphs are completely similar to directed graphs. The only difference is that we have certain weights or certain costs for the traversal of the nodes from one to another on their edges. So according to the adjacency matrix, there is no change, but according to the adjacency list, we have a little change which includes the cost or the weight of the traversal of nodes from one to another. Followed by this, we have files. Basic file handling techniques in C programming provide the basic functionalities that user can perform against files in the systems. Now, let us understand this in a much better way. So, the following functionalities are the basic file handling techniques. To create a new file, fopen with attributes A+, W, or W++. We shall understand this in detail in the next upcoming concepts. Opening files, we have to use the fopen function, and reading files, we can use the functions fscanf or fgetc. And to write in a particular file, we can either use fprintf or fputs. And followed by that, to moving to a specific location in a file, we can either use fseek or rewind. And finally, to close a file, we have to use the function fclose. Don't worry, I'll explain each one of these functions using a specific program. In short, fopen is used to open a file, fclose is used to close a file, fgets is used to read a file, and fprint is used to write into a file. Let us execute programs based on all of these three factors. Let us try to create a file and write some text into that file. So here I'm trying to create a file by the name edureka.c, and the message I'll be writing into that file would be Edureka Happy Learning. As you can see, the program has been successfully executed and the file has been created, and the message which I wanted to print has been successfully written into the file, which is Edureka Happy Learning. Let us try to execute a different program where we have to just read the content which is present in the file. As you can see, this particular program has been designed to read the contents present in that particular file. Let us now try to run this program. As you can see, the program has been successfully executed and it is reading the file with some message which says it is missing semicolon. Okay, let me include a semicolon here. Let me try to run this program again. If the error shows again, yeah, there might be some problem with the compiler. The compiler is reading the message. Basically, if you execute this program in an actual C editor, which is Turbo C++ or C, it should not throw an error. Yeah, it is reading the file. So now let us move on to our next section, which defines the functions of R, W, A, and R+, W+, and A+. So R searches a file. If the file is opened successfully using fopen function, then it loads the particular file and sets a pointer to it. And that pointer will be specified to the first character which is starting in the particular file. Followed by that, we have W. W just searches for a file. If the file exists, then the contents will be overwritten. If the file does not exist, then a new file will be created and a null value will be returned if it is unable to open that particular file. Next is A. A searches for the file. If the file is opened successfully, then fopen loads it to the memory and sets up a pointer, and that points to the last character of the file. If the file doesn't exist, then a new file is created, and if a file doesn't open, then it returns a null value. Now, let us go into R+, W+, and A+. R+ searches a file. If it is opened successfully, then fopen loads it up into the memory and sets up a pointer which points to the first character in it. If it is not open, then R+ will return null pointer if it is unable to open it. Followed by that, we have W+. W+ searches for the file if the file is existing. then the contents of that particular file are overwritten, and if the file doesn't exist, then it creates a new file. And in case if it is not able to open it, it will return a null pointer. Similarly, A+. A+ searches a file. If the file is opened successfully, then it loads into the memory and sets the pointer to the last character of the existing file. If it doesn't exist, then a new file is created, and finally, if it is not able to open the file, then it returns a null value. Next, we have strings. The string is defined as a one-dimensional array of characters terminated by a null character. The character array or the string is used to store text such as word or sentences. Each character in the array occupies 1 byte of memory, and the last character must be 0. So as discussed before, strings are completely similar to arrays. The elements are stored in sequential memory, similar to array. But the only difference is that strings include a null character at the end of the array just to convey the compiler that it is the end of the string. So strings are basically two types, which are character arrays or string literals. Now we have some basic operations which will be applied on strings. The most basic operations which we apply on strings are string length, which will return the length of the string. Followed by that, we have string copy, which copies the string from source to destination, and string cat, which is used to join two or more strings. And after that, we have string comparison, which compares the given two strings. After that, we have string reverse, which reverses the given string. Followed by that, we have string lower and string upper, which converts the case of the string. For example, if we use string lower, then the uppercase of the string will be converted into the lowercase, and similarly string upper will convert the lowercase characters into the uppercase characters. Now let us use Eclipse. So this particular example is based on string length operation, where I have provided the string Edureka and I'm trying to find out the length of the string. Now let's run this program. As you can see, the length of the string Edureka is found to be 7. Similarly, let us also execute other programs based on other string functions. The next string function is string copy, where I'll be trying to copy the string Edureka from string 1 to string 2 and see if the data is being printed into the string 2 or not. Let us try to execute this program. As you can see, the data from string 1 is copied into the string 2, and the data inside string 2 is being successfully displayed here. Followed by this, we shall also execute an example for string comparison. In this particular program, I'll be comparing the string 1 with string 2. Let us execute this program. As you can see, the program has been successfully executed. And now let me type in the string 1, which is Edureka. Similarly, let me type in the string 2 in the same way how the string 1 is being declared, which is Edureka. Now let us compare if string 1 is equal to string 2 or not. As you can see, the strings are declared to be equal. Now let us try to execute a program based on string concatenation. In this particular program, I'll be concatenating two different strings. As you can see, I have provided string 1 as hello and string 2 as world. So according to my function, I should be concatenating both the strings, which is hello and world. As you can see, the program is being successfully executed and both the strings are concatenated into one single word, which is string hello world. Followed by this, we shall also execute a program for string reverse function. In this particular example, I'll be writing the text happy learning into the string and I'll be trying to reverse this particular string. Let us execute this program. As you can see, the string before reversing is happy learning and string after reversing is this. Let us try to execute an example based on string lower, where a particular string in uppercase will be converted into lowercase. Now let me write a string in uppercase. I have written Edureka in uppercase. Now let us convert it into lowercase. So as you can see, the data has been displayed as Edureka in lowercase. Similarly, let us try to execute a program based on string uppercase. As you can see, the program has been successfully compiled. Now let me write some text in lowercase. Edureka has been written in lowercase and according to the output, Edureka text has been converted into uppercase. Now with this, let us get into our next topic, which is about structures and unions. Firstly, let us deal with structures. A structure is a user-defined data type available in C language that allows to combine the data items of different data types together. Structures are used to represent a record. Struct is the keyword that is used to declare structures. Basically, structure is a data type. For example, if you consider array or lists, you can only store a specific data type of elements, because array will not allow you to store different elements of different data types. But what if you had to store a database of a school which has different data types? For example, roll number will be integer, marks will be float, and name will be string. In that case, you cannot use arrays, or you cannot even use lists. The only available option is structure or either a union. What structure basically does is, it is capable enough to store the values of different data types. For example, here I'm considering school. I've defined a structure using the keyword struct, and the name of my structure is school, inside which I have declared ID of a student using integer data type, and name of the student using string data type, and percentage of the student using float data type. Now, to understand structures in a much better way, let us execute a practical program. Now let us use an online compiler to compile our code. So in this particular example, I am writing the roll number, name, and marks of a particular student. So let us execute this code. As you can see, the code has been successfully compiled, and it is asking me for input the name, roll number, and percentage of the student. Let me write a random name to the student, Raj, and his roll number will be 123. Followed by that, let us include his percentage, which will be 75.4. As you can see, the data has been successfully inputted for the first student. Now, as we have defined the for loop, which will run for 3 times, so let us also include another student's details here. Name as Ram, and his roll number will be 124, and percentage will be around 60. Now let us enter the value for third student. As you can see, the details of all the 3 students are being displayed here. So with this, let us move into our next topic, which is union. A union is a special data type available in C language that allows storing different data types in same memory location. Union is the keyword used to declare union. So you might be confused about structure and union here. Why are 2 different data structures defined for performing one single operation? Don't worry, there are few differences between union and structure, which we will discuss after this topic. So let us execute an example to understand union in a much better way. We shall consider the example of employees. As you can see, the code has been successfully compiled, and the data of the employee is been displayed here. The ID of employee is 18518774450, and the name is Jhansi. With this, let us move on to the differences between structure and union. The key differences between structure and union are keyword, memory, change of value, access to data, and initialization. The keyword to declare structure is struct, and the keyword to declare union is union. After that, the memory. In structure, each member has unique memory space. For example, ID has a unique memory space, name has its own unique space, and followed by that, even the percentage has its own unique space. When it comes to union, a whole complete block of memory will be declared for union, and all the data members will be sharing that allocated memory. When it comes to the next parameter, it is change of value. Changing the value of one member in structure will not affect the others. But in case of unions, changing the value of one member will definitely affect the others because they are sharing one common memory. After that, access to data. All members can be accessed at one single time if you are using a structure. But when it comes to union, you have to access one member at one single time. You cannot access all the members at one single time. And the last parameter is initialization. All the members of the structure can be initialized at once, but when it comes to union, the only first member of the union can be initialized. So these were the few major differences between structure and union. Let us move into the next topic, which is data segments. So what are data segments? Data segments are divided into 4 different types. They are data area, code area, heap area, and stack area. What are these? Let us discuss each one of them in detail. Firstly, data area. Data area is permanent memory area. All static and external variables are stored in this data area. All variables which are stored in data area exist until the program exists. Followed by that, we have code memory area. Code memory area is only area which can be accessed by function pointers. The size of code area is completely fixed. Followed by that, we have the heap area. The heap area is used to store the data structures which are created by using dynamic memory allocation. We shall discuss about dynamic memory allocation and the functions available in dynamic memory allocation after this concept. So the size of heap area is variable and depends upon the free space in the memory. Followed by that, we have the stack area. Stack area is divided into two parts, namely initialize and non-initialize. Initialized variables are given priority than non-initialized variables. So with this, we shall move on to our next important topic, which is dynamic memory allocation. So what is dynamic memory allocation? Dynamic memory allocation is defined as a procedure in which the size of the data structure is changed during the runtime. There are 4 library functions provided by C in standard library.h header, and this facilitates the dynamic memory allocation. Now let us discuss the dynamic memory allocation functions. Those are malloc, calloc, realloc, and free. Firstly, malloc. Malloc or memory allocation method is used to dynamically allocate a single large block of memory with the specified size. It returns a pointer type void, which can be cast into a pointer of any form. Followed by that, we have calloc. Calloc or continuous memory allocation method is used to dynamically allocate a specific number of blocks of memory of specified types. It includes each block with a default value of 0. The only difference between malloc and calloc is malloc, after allocating a block of memory, will not allocate with a default value of 0. Instead, a junk value is stored there. But in calloc, it will allocate each and every memory block with a default value as 0. Followed by that, we have realloc. Realloc or reallocation is a method used to dynamically change the memory of previously allocated memory. If the memory is previously allocated with help of malloc or calloc, and in case if it is insufficient, then you can reuse realloc and increase the memory size. Realloc is used to dynamically reallocate memory. Followed by that, we have free method. Free method is most important method. Don't ever forget to use free method when you are allocating memory using dynamic memory allocation, because free method deallocates the memory. The memory allocated using the functions malloc and calloc are not deallocated on their own. Hence, free method is used whenever the dynamic memory allocation takes place. It helps to reduce the wastage of memory by freeing it. Now, let us execute programs based on malloc, calloc, realloc, and free. Now, let us execute this program based on malloc. So this particular example is based on malloc. We are using malloc function here, and the data type we have chosen is integer. Now, let us execute this program. As you can see, the number of elements we have chosen are 5, and the memory has been allocated using malloc, and the elements of the array are 1, 2, 3, 4, and 5. Similarly, let us execute a program based on calloc. As you can see, the memory has been successfully allocated using calloc function, and the elements are 1, 2, 3, 4, and 5. Let us execute realloc. Now you can see the memory has been reallocated using realloc. Usually, using malloc and calloc, we have created elements only for 5 elements, which were 1, 2, 3, and 4, and 5. We needed extra space for 6, 7, 8, and 9, and 10. So we have created that extra space using realloc here. Now let us use free method to free all the memory which we have created using calloc, malloc, and realloc functions. Now you can see the memory will be freed using free method. As you can see, the output says that the number of elements were 5, memory successfully allocated using malloc, and malloc memory is been successfully freed. Similarly, calloc is also been freed. Now that we have completed dynamic memory allocation concepts, let us now move on to sorting algorithms. Sorting algorithms are used to arrange the elements of an array in a particular order. The order might be either ascending order or descending order. Now, C programming language has n number of sorting algorithms, out of which we have some primary important basic algorithms which we will be discussing now. Basically, what is a sorting algorithm? A sorting algorithm is used to rearrange a given array or list elements according to the comparison operator on the elements. the comparison operator is used to decide the new order of elements in respect to the data structure. As we have discussed earlier, the sorting algorithms are used to arrange the elements of array or list in a particular order, either ascending or descending. It is based on a condition which you specify. Now, with this, let us move on to the sorting algorithms that we will be discussing today. Firstly, bubble sort, and followed by that, we will discuss about insertion sort, and finally, selection sort. So first, the bubble sort. Bubble sort is the most basic and brute force method of arranging the elements of an array. Now, what happens in bubble sort? In bubble sort, we consider the first element of the array to be the smallest of all the other elements. And this small element will be compared by the next following element. If the following element is smaller than the first element, they will be swapped. Followed by that, the second element of the array will be compared with the third, and third with fourth, and so on. Let us now understand this through this simple example. As you can see in this particular example, we have an array of 5 elements. In the first iteration, the first element, which is -2, will be compared with the second element 45. If the second element is smaller than the first element, then they will be swapped. In this particular algorithm, we are going to arrange the elements in ascending order. So the smaller element will be located in the first place. Firstly, you can see -2 is smaller than 45, so in the comparison, -2 will be left in the first position. And in the second iteration, you can see 45 will be compared with the third element, which is 0. So here, 0 happens to be a smaller element than 45, so they both will be swapped here. Followed by that, in the third iteration, we will be comparing 11 with the element 45. 11 happens to be the smaller element than 45, so they will be swapped again. And in the last iteration, 45 will be compared with -9, and -9 happens to be the smaller element than 45, so they will be swapped. So this was the first cycle. So in this cycle, the elements are arranged to a particular extent, but not completely. So we will follow the next cycle where the elements will be compared again from the starting. In the starting iteration, -2 will be compared with 0. As you can see, -2 happens to be smaller than 0, so no changes in the positions of the elements. Followed by that, 0 will be compared with 11, and 11 happens to be bigger than 0, so no change in that as well. In the next iteration, 11 will be compared with -9, and -9 happens to be a smaller element compared to 11, so they both will be swapped. And in the last iteration, 11 will be compared with 45, where 11 will be the smallest, so no change in their positions. And now we will see the third cycle. In the third cycle, -2 will be compared with 0 in the first iteration, followed by that 0 will be again compared with -9. -9 happens to be smaller than 0, so they both will be swapped. And in the third iteration, 0 will be compared with 11, and the positions will not be changed because 0 is less than 11. And in the fourth iteration, 11 will be compared with 45, where 45 happens to be the biggest number than 11, so no change in the position. So in the last cycle, -2 will be compared with -9, and -9 happens to be a smaller element compared to -2, so they both will be swapped. And in the last iteration, you can see that -9 is in the correct position, that is the smallest position, happening to be the first of the array. And followed by that, we have the second position with -2, and third position we have 0, fourth 11, and finally 45. Hence the array is been sorted here. So this is how bubble sort algorithm works. Now let us see a practical example so that we can understand this algorithm in a much better way. So this particular example is based on bubble sort. We are going to arrange each and every element in a particular position based on ascending order. This is the same array that we have considered in our previous example, which has the elements -2, 45, 0, 11, and -9. Now let us run this program and see the output. As you can see, the program got successfully executed, and the elements of the array are in ascending order. And the ascending order is being achieved through bubble sort algorithm. Followed by this, let us move on to our next sorting algorithm, which happens to be the insertion sort. Insertion sort is also completely similar to bubble sort, but the only difference is that we presume that the first element of the array is already sorted. So in this case, we consider the first element of the array, which is 9, is already sorted. Followed by that, we have 5. So we will take 5 as the key. So here we have considered 5 as the key, and now we compare 5 with 9. So in comparison, if 5 happens to be the smaller number than the presumed arranged element, which is 9, then they both will be swapped. we can see that 5 is already smaller than 9. So what we do is we replace 9 with 5 and 5 with 9. So in the next iteration, we will consider the first two elements to be sorted and we will consider the third element as the key. Now we will take 1 in the position of key and now we'll compare the key with the first two elements which are 5 and 9. So we can see that 1 happens to be smaller than 5 and 9. And inside we can see that 5 happens to be smaller than 9. So we send 9 to the position of 1 and 5 to the position of 9 and 1 to the position of 5. So this is how it happened. Firstly, we compare 1 with 5 and 1 with 9. And we find that 1 is smaller than 5 and 9. And later we compare 9 and 5. So we find that 5 is smaller than 9. The bigger number will be sent to the place of the key and the next following number will be sent to the position of the earlier number and the smallest key will be sent to the first position. Followed by this, we have the next iteration where we'll consider 4 as the key. So 4 will be taken into the position of key. Now 4 will be compared with the previous elements which are 1, 5 and 9. So we can see that 4 is greater than the first position 1. So we will not make any changes to the first position. Followed by that, we will compare 4 with 5. So here we can see that 4 is smaller than 5. Followed by that, we'll compare 4 with 9. We can see that 9 is bigger than 4. What we will do is, now we'll compare the other two elements in the array which are 5 and 9. 5 is smaller than 9. So we will send 9 to the key position which is 4. So followed by that, we will send 5 to 9th position as shown in the next iteration. And now the position where 5 element was removed will be empty and inside that position we will send 4. And that's how the array will be sorted here. You can see 1, 4, 5 and 9. And in the next cycle, we will take the element 3 as the key and we'll compare with the other elements. As you can see, 3 is taken into the key position and now 3 will be compared with all the elements in the array. As you can see, 3 is compared with 1 and you can see 1 is already arranged and 3 is compared with 4 and you can see 4 is bigger than 3. Now we will compare the other elements with 3 and 3 is compared with 5 and it happens to be 3 is smaller than 5, followed by that 3 is also smaller than 9. Now the elements inside the arrays are compared. Now the number 9 happens to be the biggest one, so 9 will be sent to the key position, followed by that 5 will be sent to the 9th position and 4 will be sent to the 5th position. And 3 will be in the position of 4 which will be vacant after 4 is transferred to the 5th position. As you can see, now the array is completely sorted. In the ascending order where 1 is the smallest number, followed by that we have 3, next is 4, next is 5 and lastly we have 9. Now let us see a practical example to understand insertion sort in a much better way. Let us consider the same array what we have discussed here. So this particular example is based on insertion sort and we will be considering the same array what we have discussed in our earlier example, which is 9, 5, 1 and 4 and 3. Let us execute this program and see if the array will be sorted in ascending order according to insertion sort or not. As you can see, the program has been successfully compiled and we obtain the same result what we discussed before, which is 1, 3, 4, 5 and 9. Now with this, let us move on to our last algorithm, which is selection sort algorithm. Selection sort happens to be a little different from the other two algorithms. Here, we actually compare all the elements with each other and we come to an end with the smallest element and we declare that particular smallest element as minimum and we will replace that element to the first position. And after that we come to the next cycle where we swap the second smallest element in the second position of the array. Now let us understand this through this particular example where we have considered an array which has 5 elements, namely 20, 12, 10, 15 and 2. Now we will compare the elements present in the array. As you can see, the first element happens to be 20. We will assign 20 as minimum in the first cycle. Now what we do is we'll compare 20 with 12 and we will find out which is the minimum. 12 happens to be the minimum number when compared with 20. So 12 is now the new minimum element. Now 12 will be compared with the next following element, which is 10. We can see that 10 is the next minimum element found in the array and now 10 is the new minimum element declared. Followed by that, we will compare the next element with the minimum, which is 15. 15 is greater than 10, so there is no change. Next, we will compare 10 with the last element, which is 2. Now we find that 2 is the smallest element compared to 10. So the last minimum element finally obtained is 2. So what we do here is, we will swap 2 with the first position, which is 20. As you can see, now the element 20 is been replaced by 2. So 2 is the first element sorted in selection sort algorithm. Before moving into the second cycle, let us have a small acknowledgement of the first cycle. So this is how the comparison happened. Firstly, we considered 20 was the minimum number, but 12 happened to be the minimum number. Followed by that, we got our next minimum number, which is 10. And lastly, we got 2, our minimum number. And finally, the array got sorted with the first element placing 2 in the first position. Followed by that, now we shall move to the next cycle. In the next cycle, we can see the first position of the array 2 is been successfully sorted. Now we shall consider 12 to be the minimum number. So we consider the minimum number to be 10. Now 10 will be compared with the next following number, which is 15. And we find that 10 is already smaller than 15, so there will be no change in the position. Followed by that, we have 10 and 20. So 10 happens to be the smaller number when we compare with 20. So there is no change in the position. So now what we do is, we shall swap the position of 12 with 10, making that the next smallest element in the array. With this, we finish the second cycle. Now we shall move to the third cycle, where we will consider the following element after 10, which is 12, to be the minimum element, and we will compare with the other following elements, which are 15 and 20. As you can see, we have considered 12 to be the minimum number, and we compare with 15, and we obtain 12 is smaller than 15, so there is no change in the position. In the next iteration, we compare 12 with 20, and we find that 12 is smaller number compared to 20, so there is no change in the position again. So we find that the array has been already sorted for this cycle, and we will move on to the next cycle, where we will make 15 as our minimum element, and we will compare 15 with the following element, which is 20. So here you can see that we have made 15 as our next minimum element, and now we are comparing with the element 20. And we find that 15 is already smaller than 20, so there is no change in the positioning. And finally, we obtain the sorted array. Now let us execute a practical example to understand selection sort algorithm in a much better way. We shall consider the same array in that particular example as well. Now this particular example is based on selection sort algorithm, and we have taken the same elements which we have discussed in the earlier example, which are 20, 12, 10, 15 and 2. If the elements will be arranged in ascending order according to selection sort algorithm or not. As you can see, the program got successfully executed, and the elements of the array have been sorted in ascending order based on selection sort algorithm, and the result what we have obtained is completely similar to the result we have discussed before, which is 2, 10, 12, 15 and 20. The history of C++. The C++ programming language is developed in the year 1980 by Mr. Brane Strausstrup at the well-established Bell Laboratories of American Telephone and Telegraph, popularly known as the AT&T Company, positioned in the United States of America. He developed a C++ programming language in order to integrate the object-oriented style of programming into C language without having to make any significant change to the C fundamentals. Now, with this, we shall move into the important features of the C++ programming language. So firstly, we have rich library. C++ language incorporates multiple built-in arithmetic and logical functions along with many built-in libraries which make development faster and convenient. Next, we have the object-oriented style of programming. C++ programming language is designed to be an object-oriented programming language. Object-oriented programming style makes development and maintenance easier, whereas in case of procedure-oriented programming languages, if the code grows, the complexity grows proportionately. Now, let's move on to the next feature, which is compiler-based. C++ programming language is a compiler-based programming language. It means without compilation, no C++ program can be executed. First, we need to compile our program using the compiler, and then we can execute our program. Followed by this, the next feature is extensible. C++ programming language is highly extensible because of its easy adaptable features. Next feature is recursion. C++ language supports function backtracking, which involves recursion. In the process of recursion, a function is called within another function for multiple number of times. Then we have pointers. C++ enables users to directly interact with memory using the pointers. We use pointers in memory, structure, functions, array, stack, and many more. Then we have structured. C++ programming language supports structured programming, which includes the use of functions. Functions reduce the code complexity and they are totally reusable. And finally, we have memory management. C++ provides the best-in-class memory management. It can both allocate and deallocate memory dynamically at any instance of time. Now, let us move on to the next part of our session where we'll learn to install C++ in Windows. Now, allow me to guide you the step-by-step procedure to install C++. Firstly, we would need an editor. So, to run C++, we have multiple text editors. For example, Dev C++, Turbo C, CodeBlocks, Visual Studio, Eclipse, and many more. So, in this tutorial, I'll be using Dev C++. To install Dev C++, all you need to do is to download Dev C++ into your local system. For that, you need to Google Dev C++ first. Click the first link and you'll be directed to the next home page of Dev C++. And in here, all you need to do is to just select a download button here. So this is the download button. Please click on it and the file will be downloaded into your local system. So once after the Dev C++ installation folder is been downloaded into your local system, it looks something like this. Now all you need to do is install that. Just click on it and you'll be shown up with a dialog box. Select Yes. Then you will find a dialog box saying Unpacking Data. Select OK. Then select I agree. Next. And select the Install button. Once the installation is finished, select the Finish button and you'll be finding the Dev C++ text editor opening. You can choose English original language here. Then you can choose the color and font for your coding and press Next. Select OK and you have your text editor. To start with your text editor, select File and New, and inside New you can either select a project or a source file. Let me select a simple source file here. And that's how you get it. Now let us execute our first C++ program. So this is our first C++ program here. We are trying to print Hello World message using this program. To run the program, you need to select the Execute option from the menu bar. Once you select that, you'll be having three different options here. First one is Compile, then you have Run, and finally you have Compile and Run. So it's better you use Compile and Run while your program will be compiled. Along with that, after the compilation, your program will run automatically. As you can see, my program is getting compiled. And the output is being generated onto the terminal. So this is the message what we wanted to print, Hello World. Now, followed by this, let us understand the structure of a C++ program. So the basic structure of a C++ program involves C++ headers, class definition, member functions, and main function. Now let us understand each one of them in detail. Firstly, the C++ headers. The lines starting with hash symbol are considered to be the header files. So in our program, hash include IOStream is considered to be the header file. So all the header files are used in a program have their own unique meaning. For example, the header file which we have included, which is none other than the IOStream, instructs the preprocessor to perform standard input and output operations, such as writing the output of our first program on the screen. Now followed by that, we have the namespace. A namespace allows grouping of various members like classes, objects, functions, and various C++ tokens under one single name. Various users can create separate namespaces and thus can use similar names for other members. This avoids the compile time error that may exist due to the identical name conflicts. Followed by this, we have the class definition. This is a simple Hello World program, so I did not include a class, but in the future programs, we will be dealing with classes. For now, let us understand class definition. The class is a user-defined data structure declared with the keyword class. It includes data and functions as its members Those access will be governed by three access specifiers, namely private, protected, and public. By default, access members of all C++ classes are private. And finally, we have the member function definition. The member functions are the operators and functions that are declared as members of a particular class. The member functions are also called as friend of the main class. Finally, we deal with the main class or the main function. The main function is also known as the entry point of every C++ program. When a C++ program is executed, the execution control goes directly into the main function. So, this is the basic structure of a C++ program. Followed by this, let us move on to the next topic, which deals with the identifiers used in C++ programs. So what are identifiers? Identifiers in C++ language are none other than the names assigned to the variables and functions used in a C++ program. The valid identifiers in a C++ program are declared using alphabets from capital A to capital Z, or small a to small z, and even you can declare a name using the numbers starting from 0 to 9. The identifiers cannot include special symbols and white spaces, but you can include an underscore. One basic example of a valid identifier is int x is equals to 10. Now let us discuss some rules to declare identifiers in C++ program. So the rules are simple. First character should always be an alphabet or an underscore. Followed by that, succeeding characters can either be digits or letters. The third rule is that special characters are not allowed except the underscore. And fourth and the final rule is identifiers should not be keywords. To understand these rules, let us check out some valid identifier names as well as some invalid identifier names. Firstly, we have int a, which is a valid identifier because it is starting from an alphabet. Followed by that, we have another one which is int underscore ab, which is also valid because it is starting from underscore. Then we have int a30, which is valid because the first letter is starting with an alphabet. Followed by that, we have numbers. Then let's check out the invalid identifier names. We have int2, which is starting with a number, so it is considered to be an invalid identifier. Then we have int a white space b. It is starting with an alphabet, but it includes a white space which is not allowed. Then we have int long. So the fourth rule speaks about this type of identifiers. Identifiers should not be keywords. We have long, which is a keyword that is a data type. So you cannot name your identifier with a data type or a keyword. So these are the few rules for declaring identifiers. And with this, let us move on to the next chapter, that is the keywords. So what are keywords? Similar to identifiers, we do have some special and reserved words in C++ program which have their own special meaning. Such words are called as keywords. Some of the keywords used in C programming language are as follows, and after that we shall deal with some new keywords which are introduced from C++ language. So these are the keywords which are used in C programming language as well as C++ programming language. So they include default, break, case, char, long, and many more like delete, struct, switch. Now let us move to the keywords which were introduced from the C++ programming language. So these are the new keywords which are introduced from C++ programming language. They are ASM, delete, virtual, template, inline, protected, throw, catch, and many more. So with these, let us move on to the next chapter. The next chapter is whitespace. Whitespace can be defined as a term used in C++ programming language to define blank spaces, tab spaces, new line characters, and comments. Whitespace separates one statement from another and enables the compiler to identify where one element in a statement, such as an int, ends and the beginning of the next line. Let us consider a basic syntax to understand whitespace. Here we have char Edureka happy learning. Char is a data type and Edureka happy learning is the name of the variable. So between the both we have a space which is the whitespace. Now we have understood what exactly whitespace is, so with this let's move on to the next chapter called commits. So in C++ program, commits are user written statements that are included in every C++ code for explanation purpose. These commits help anyone reading the source code. All programming languages allow some kind of commits. C++ supports both single line commits and multi-line commits. let us see how does these commits work. So this is our basics first hello world program. Now let us try to add single line commits here. To add single line commits, you need to type in 2 forward slashes. After that, you need to type in your message. So here, let me type in single line commit. So this is how the single line commits work. Now let us try to deal with the multiple line commits. To write in the multiple line commits, you need to replace the forward slash with an asterisk. So here, the lines from hello world written and the closing bracket, everything is commented. In order to close the multiple line commit, you need to end the commit with asterisk and forward slash. This is how the multiple line commits end. So these are the ways to declare multiple line commits and single line commits in your C++ program. Now with this, let us move on to our next chapter, that is about data types used in C++ programming language. So the 3 basic data types used in C++ programming language are derived data types, built-in data types, and finally the user-defined data types. First, let us deal with derived data types. So some of the examples for derived data types are arrays, pointers, function, reference, and many more. Let us deal with each one of them in detail. Firstly, let's deal with arrays. So what is an array? An array is defined as a collection of similar type of data items stored in continuous memory locations. The array is the simplest data structure where each data element can be randomly accessed using the index number or the address number. So in C++ programming language, we have 3 different kinds of arrays. They are one-dimensional array, two-dimensional array, and multi-dimensional array or JART array. So let's see each one of them. Firstly, let us understand one-dimensional array. So one-dimensional array can be defined as an array with single row and multiple number of columns. So the elements in one-dimensional array are accessed using their index numbers. Now let us understand the terminology of one-dimensional array. For example, consider that you have declared an array of size 5. So what the compiler does is, it will select one bigger block of memory, then divide the block of memory into 5 different parts, and those 5 blocks will be allocated to the one variable which is none other than your array variable. So here I have selected my array variable to be my array, and now compiler has given me 5 continuous blocks of memory to store integer type of data because my array is integer type and I have reserved 5 blocks. Now let us try to store some data into my one-dimensional array called my array. So firstly, I'll select 10. So the element 10 will be stored in the first memory location of the array, which is 0. Always remember, the array starts from the memory location 0. Followed by that, we shall add in few more elements, which are 20, 30, 40, and 50. So the data is been allocated into the array in a continuous format. So this is how the one-dimensional array works. Now let us execute a simple example to understand one-dimensional arrays in a much better way. So this particular example is based on one-dimensional array. I have declared my array variable as ARR and I'm trying to store 5 elements into my ARR array. Let us execute this program and see how does it work. You can either choose execute and compile and run option, or you can just press F11 as a shortkey to compile and run your program. You can see my program has been successfully executed and I have the output here. As you can see, I have successfully included all the elements into my array and I tried to print out one particular element from my array which is at the array index number 3. So in the array index number 3, we had 4 and that was the one which was displayed on our terminal. Now with this, let us move on to the next type of arrays, which are the two-dimensional arrays. The two-dimensional array can be defined as an array of arrays. The 2D array is organized as matrices, which can be represented as the collection of rows and columns. The elements of an array are accessed using their intersection coordinates. Now, let us understand how do they work. Here, let us consider our array as ARRAY. So ARRAY or array is my array variable's name here, and I have declared an array with 2 rows and 5 columns. Now, let us try to insert an element into the array. So I'll select first element as 10. You can see the intersection coordinates as 0, 0. So 0, 0 happens to be the first memory location of my array here. So the 10 element will be stored in the first memory location. Followed by that, let us include few more elements into my array now. So we have 20, 30, 40, 50, 60, 70, 80, 90 and 100. So all these elements will be allocated into my array in continuous memory locations based on their coordinate numbers. So let us see how does it happen. You can see they are arranged in a sequential manner. So 20 is at 0, 1, 30 is at 0, 2 and finally 100 is at 1, 4. Now to access these elements, we have to provide their index numbers or the intersection coordinates here. Now let us execute a simple two-dimensional array example to understand them in a much better way. So this is the basic example for two-dimensional array. So here my array name is test and I have provided 3 rows and 3 columns. So the elements that I am going to enter into my three-dimensional array are 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now we have 2 for loops here. So first for loop will be for the rows and the second for loop will be working for the columns. Now let us try to execute this program and see how does it work. You can see that the elements have been successfully included into my array along with their intersection coordinates here. So 0, 0 which happens to be the first memory location saves my first element 1 and 2, 2 happening to be the last memory location saves my last element 9. So now with this, let us move on to the next type of arrays, which are the multi-dimensional arrays or also called as JART arrays in C++. So the multi-dimensional arrays can be defined as an array of arrays. The 3D array is organized in the form of a 3D matrix, which can be represented as the collection of multiple rows and multiple columns. The elements of the array are accessed using their 3D intersection coordinates. So here we have a vertical column, horizontal row, and another row which is in perpendicular with the horizontal row and the vertical column. Now let us execute a simple program to understand its terminology. In this particular program, we are going to enter 12 different values manually, and the name of my array is test, which has 2 rows, 3 columns and 2 rows which are perpendicular with the rows and columns. Now we have 3 different for loops here. First one will be for the rows, second one will be for the columns, and third one will be for the row which is in perpendicular with the row and column. Now let us execute this program and see how does it work. Don't worry about the codes, you can mail us for them at any time and we will reply you as soon as possible with the codes you need. Now let us enter 12 different values. Let me enter 1 to 12. As you can see, all my 12 elements have been included into the array from 1 to 12. 1 being located at the first memory location, which is 0, 0, 0, and 12 is located at the last memory location, which is 1, 2, 2. So this is how the multi-dimensional arrays work. Now with this, let us continue with our next part of the session, which is related to the linked lists. So what are lists? Lists are the linear data structures completely similar to that of arrays, but the only difference is that the elements are not saved in a sequential memory locations as we used to do in arrays. Instead, they are sorted in random addresses and connected using pointers. So we have 3 different kind of linked lists in C++ similar to C, which are singly linked lists, doubly linked lists, and circular linked lists. Firstly, let us understand the working terminology of lists. Here, we will be having a random memory heap in our computer system. So what exactly happens is, if you want to store 5 different elements into your list, then the computer will select 5 random blocks from the memory heap. So here you can see that we have 5 random blocks from the memory heap with different addresses. First one is 1001 and the other one is 1023, then 3026 and 4537 and finally 7328. Remember the last block here? There is something happening here when we store the elements into the linked list. Now let us store the elements. You can see that 10 is allocated to the first one, 20 to the next one, 30 to the next one, 40 and finally 50 to the last one. The change happened here is the last memory location is allocated to null. This means that this is the end of the list. So here, how are they connected now? These are the addresses. So every block has a different address. So what compiler does is, it will connect this block with this block, where this block will be pointing to the address of this block. So actually, this particular address is not the address of this memory block. This particular address is the connecting address of the next memory block. So similarly, you have the address of the next connecting memory block here. This is how the linked list works, and they get interconnected with each other. Once the linked list is complete, then we have the head node and the tail node. Once the linked list is complete, all the blocks are considered as nodes. Firstly, we have the head node, which is the starting part of the linked list, and at last we have the tail node, which is called as the ending part of the linked list. Now let us deal with the types of linked list. We have three different types of linked list in C++. Firstly, we have singly linked list, then we have doubly linked list, followed by that we have circular linked list. Now let us understand the terminology of singly linked list. So this is singly linked list. Singly linked list contains two different fields, namely the address of the next node and the data assigned to the present node. So this particular node is known as the head node, and this is the address block which is pointing to the next upcoming node. So here we have the head node where the memory is being stored, and this is address block where the address of the upcoming node is stored. Now let us execute a simple example to understand the terminology of singly linked lists. So this particular example is based on singly linked list. Now let us try to execute this. Once we execute, we'll be provided with four different options. First one will be for inserting elements into the linked list. Second one will be to delete the elements from the linked list. And third one will be to display the elements in the linked list. And finally, we have the count for counting the number of elements in the linked list. Other than that, we can give a random input to exit the linked list. Firstly, let us insert. Now we have inserted four different elements into our linked list. Let us display the elements. We can select number 3 to display the elements. So you can see that we have four different elements, which are 1, 2, 3, and 4. Now let us try to delete the element number 4. Let us select option 2. Now the compiler is asking for us to give the position of the element. Remember, we had the elements starting from 0 in arrays, but in linked list, the elements start from 1. So to delete the element 4, we need to give the address 4. You can see the fourth element has been successfully deleted. Let us check out the elements remaining in the linked list. You can see that we are remained with 1, 2, and 3. Now let us try to count the number of elements in our linked list by providing option number 4. You can see that the output is 3. Now let us try to exit our linked list. We are done. Let us try to understand the next type of linked list, which are the doubly linked lists. So doubly linked list is completely similar to singly linked list, but the only difference is it is traversable in both directions. When you come back into the singly linked list, you can see that you can traverse from head to tail, but not from tail to head. The singly linked list can travel in only one direction, but not in two directions. But when you come into the doubly linked list, you can travel in both the directions, starting from head to tail, and you can also come from tail to head. So this is the speciality of doubly linked list. The doubly linked list has three particular blocks. One to store the address of the previous block, and the one to store the memory, and the last one to store the address of the upcoming node. So this is how the doubly linked lists work. To understand this in a much better way, let us execute a simple example. So this particular example is based on doubly linked list. Now let us execute this. As you can see, the program has been successfully compiled, and now the system is asking for four different options. One, to insert elements into the linked list. Second, to delete the elements. Third, to reverse the linked list. And finally, the fourth one, to exit. Now let us try to add in some new elements. As you can see, we have inserted 5 different elements into my linked list, which are 10, 20, 30, 40, and 50. Now let us try to delete one element from our linked list by providing option number 2. Enter the element to be deleted. Now let us delete 30 from our linked list. You can see the element 30 has been eliminated from our linked list, and we remain with 10, 20, 40, and 50. Now let us try to reverse the linked list. So let us select option number 3. After reversing, you can find that the elements have been completely reversed from 50, 40, 20, and 10. Now let us try to exit the program. So this is how the doubly linked lists work. So with this, let us move on to the next type of linked list, which are the circular linked lists. There is no much difference between the circular linked list and the singly linked list, but the major and one and only difference is that in singly linked list, the tail node had the address of null, but here the tail node is pointing back to the head. So this is how the list gets connected with each other and it behaves like a circular linked list. Now let us execute a simple example to understand its terminology. So this particular example is based on circular linked list. Now let us execute this program and see how does it work. You can see that the program has been successfully executed and we have the output here, and it says the circular linked list created is as follows, which is 30, 20, 10, 40, 50, and finally the tail is getting back connected to number 30. So this is how the circular linked list works. And after that, we have also tried to eliminate the number 10 from our linked list. So after eliminating, we have 40, 50, 30, 20, and again it is connected back to 40. So this is how the circular linked list works. With this, let us move on to the next concept, that is about stack. So what exactly is stack? Stack is a linear data structure which allows a particular order in which the operations are performed. The order may be LIFO, that is last in first out, or FILO, which is first in last out. Let us understand this practically. So what exactly stack is? Stack is completely similar to that of array, but the only difference is to access the elements, we need to follow the terminology called first in last out or last in first out. So what is this? Let us understand this through this simple example. So here I have this sample stack named as my stack. This stack stores integer type of elements. So let me include my first element, which is 10. So what happens here is, in the same way that we saw in arrays, the element 10 will be stored in the first memory location of the stack, that is 0. Followed by that, let us try to include few more elements in the same way. We have 20, 30, 40, and 50. So these elements will be stored in sequential order in the same way which happened in arrays. Now, if you want to access the elements from the stack, then you need to follow first in last out procedure or last in first out procedure. For example, if you want to access the element number 10, then you need to exit 50, 40, 30, and 20 first from the array. Then you'll get the access to number 10. Let us see how does it work. Let us remove 50 first, then 40, then 30, then 20. And finally, you'll be able to access element 10 from the stack. So to access the element 10 from the stack, you need to eliminate all these elements first. So this is how the stacks work. Now to understand this in a much better way, let us execute a sample code. So this particular example is based on stacks. Let us try to execute this. As you can see, the program has been successfully executed and the elements are same which we chose for our stack, which are 10 to 50. So my stack is having 50, 40, 30, 20, and 10 elements, and size of my stack is 5. And the top element is 50 as we chose in our stack. The first element which is on the top of the stack is 50. So we need to pop all these elements to access the number 10. So this is how the stacks work. Now let us move on to the next concept in our tutorial, which is none other than queues. So what is queue? A queue is a linear data structure which follows the particular order in which the operations are performed. The order is first in, first out. Remember, we had the order first in, last out in stack, and in queue we have first in, first out. Let us understand the terminology how queues work. Queue is also completely similar to that of stack, but the only difference is, in order to access the elements in stack, you need to follow a different order from stacks. In stacks, we used to follow first in, last out, but here you can use first in, first out. So let us see how does it happen. So let me store the element 10 in my queue. So the element 10 will be stored in the first location, which is 0, similar to that of stack. Let us include few more elements, 20, 30, 40, and 50. So my queue is full now. starting from 10, 20, 30, 40, and 50. So in queue, what we used to do is, to access the element 10, we were supposed to pop 50, 40, 30, and 20. But in case of queue, we can directly access 10, which is first in, first out. So to access 10, we can directly pop out the element 10 from the queue. Now, next we can pop 20, then we can pop 30, followed by that we can pop 40 and 50. So this is how queues work. Now to understand this in a much better way, let us execute a small example. So this particular code is based on queues. Now let us try to execute this. You can see that the code has been executed and now it is asking for 3 different options. 1 to insert, 2 to remove, 3 to display, and others to exit. Now let us try to insert elements into our queue. First, let me insert 10. Then 20. Now let us try to eliminate number 10 from my queue. To eliminate, I need to select the option number 2. So the first element which was removed from the queue is 10. Now if I choose 2 again, then the next upcoming element is 20, which will be removed from my queue. You can see 20 has been successfully removed now. So similarly, it removes 30. So this is how the queue works. Now let us try to display the elements present in my queue. So to display the elements, I need to select the option number 3. So you can see that I am remained with 2 elements which are 40 and 50 in my queue. Now let us try to exit our queue by providing option number 4, which is other than 1, 2, 3. This is how you exit. So now with this, let us move to the next part of our tutorial, which is functions. So what are functions? Function is a subdivided program of the main program that performs a specific predefined task. It can be reused, so this reduces code complexity. So the syntax for functions is return type, function name, and parameter list. So to understand functions in a better way, let us execute a sample code. So this particular example is based on functions. So what I'm basically trying to do here is, I've declared a function here by name sum, which will be performing addition operation. And in my main program, I'm trying to call the same function by the name sum. And I'm passing 2 different parameters here, which are 25 and 20. And I'm trying to add them up. Now let us try to execute this program and see how it works. You can see that the program has been successfully executed and we have the output here. So this is how the functions work. Now let us move on to the next part of our tutorial, which happens to be reference. So what is a reference? A reference variable is an alternate name for the original variable. You can see that I have provided a basic example here. I have declared a variable on the name hello, which is of integer type, and it stores number 1. And now here I'm trying to declare another variable by name world, which has an ampersand symbol here, which says that it is a reference variable. Now this particular reference variable is pointing to the variable hello, so it can access the data which is present inside my hello variable, which is 1. So this is how reference variables work. Now after this, we have the applications of reference variables. There are 2 ways in which we can access reference variables, which are call by value and call by reference. Now let's execute a sample program to understand this application. So this particular example is based on reference. This is the first way of applying reference in a C++ program. This is by call by value. So let's execute this program and see the output. You can see the program has been successfully executed now. After this, let's try to execute the same program in call by reference manner. Now we are going to try to execute the same program in call by reference manner. Now let's try to execute this. You can see that the program has been successfully compiled and we got the output. Now after the reference, we shall move on to the next concept, that is about pointers. So pointer in C++ is a variable which stores the address of another variable. This variable can be the type of int, char, array, function, or any other pointer. The size of the pointer totally depends upon the architecture. So the pointer in C++ language can be declared using the asterisk symbol. So here you can find an example, int n is equals to 10. Followed by that, we have the pointer variable of integer type, which is declared using the asterisk symbol, and it stores the address of my first variable n. So this is how the pointers work. Let us execute one simple program to understand pointers. So this particular program is based on pointers. Now let us execute it. You can see that the program has been successfully executed and the address of pointer is shown here and the value stored in the variable is also shown. Now let's move on to the next concept. So the next concept is based on strings. So what are strings? The string is defined as one-dimensional array of characters terminated by a null character. The character array or the string is used to store text such as words or sentences. Each character in the array occupies 1 byte of memory and the last character must always be 0. So we have two types of strings, which are char array and string literal. Now let us execute an example to understand strings. So this here is an example for strings. Here I'm trying to print two different messages, which are hello world, welcome to Edureka, happy learning. Now let us try to execute this program. So here we go. We have hello world and welcome to Edureka, happy learning printed here. Followed by this, we have some important string functions in C++, which are string length, which describes the length of the string. Followed by that, we have string copy, which copies one string from a source to another destination. Then we have a string concatenation, which is used to join two different or more strings. Then we have a string compare, which compares given two strings. Then we have string reverse, which reverses the given string. String lower and string upper. The string lower converts the text from uppercase to lowercase, whereas the string upper is vice versa. Now let us try to execute all these string functions in one single program. So this particular example is dedicated to execute string functions. So we'll consider string copy, string concatenation, and string length. So our strings are Edureka, happy learning, and the last string 3 is completely empty. Now we'll try to execute this and see how does it work. So firstly, what we did is copying the string 1 into string 3. That is, string 1 had Edureka, and now this memory is been copied to string 3. Later, we have string concatenation, where we try to concatenate two strings that are Edureka and happy learning. And finally, the Edureka happy learning result is stored into the first string, that is str1. Now we will find out the length of str1, which happens to be 22. So this is how string functions work. Now followed by that, we shall move on to the next topic, which is the built-in data types. So the built-in data types available in C++ programming language are as follows. They are char, signed char, unsigned char, short int, signed short int, unsigned int, signed int, unsigned int, long int, signed long int, unsigned long int, float, double, long double, and W character T. So they are mentioned along with their bandwidth and typical range. Followed by this, we have the user-defined data structures. The first one amongst the user-defined data structures is the structure. So what is a structure? So structure is defined as a user-defined data type available for C++ that allows to combining data items of different data types together. Structures are used to represent a record. Struct is the keyword which is used to declare structures. So this here is a basic example of structures where I have used struct keyword and my structure name is school. So my structure is saving integer data type, which is ID of a student. Then followed by that, we have a string data type, which happens to be the name of the student. And lastly, I have float data type, which happens to be the percentage of that particular student. Now let us consider executing an example to understand structures in a better way. So this particular program is based on structures where point happens to be my structure. Now let's execute this and see how does it work. You can see that the program has been successfully executed and the output has been printed here. Now let us move to the next part of the user-defined data types, which is enumeration. So what is enumeration? Enumeration in C++ is a user-defined data type. It is designed to assign names to an integral constant The names increase the readability of the program, and also the program becomes very easy to maintain. Enumeration is completely similar to that of structure, but the only difference is whatever the data you save in an enumeration using the keyword enum, then the values stored in that particular enum will be constant. You cannot remove the elements from enum, but you can add in some new elements to the enum. Now let's execute a simple program to understand what exactly enums are. So this particular program is based on enums, where my enum name is week. The days of a week start from Monday to Sunday, and all these values stored are constant. You cannot remove any values from this particular enum, but if you want to try to add in some more, you can add. But in this particular context, you cannot add more days to a week, but in some other context, you can add in some more. Now let's try to execute this program. So this is how the enum works. Now what I've tried to do is to display the location of the day Wednesday. So this starts from 0, 1, and 2. So the location was 2. That's what displayed in the terminal. Now let's move on to the next part where we deal with a class. So a class in C++ is actually a user-defined data type. It's declared with a keyword class at the side of its members with personal, protected, or public access specifiers. By default, all the members of a C++ class are private. Now let's execute a simple program to understand classes. So this particular example is based on classes. So here, student happens to be my class, and inside that I have provided two different data types. One is integer type, which stores the ID of the student, and the other is string type, which stores the name of my student. And inside my main program, I have a constructor named student. Then using this constructor, I'll be trying to input the data into my class. So now let's try to execute this and see the output. You can see that the program has been executed successfully, and the roll number and the name of the student are being successfully printed here. So this is how the classes work in C++. Followed by that, we have a union. So what is a union? Union is completely similar to a structure in terms of declaration and usage, but all the members of a union occupy the same space in memory. That is, the same memory location is shared among all the union members. Now let's try to execute a sample program to understand how unions work. So this particular program is based on unions. Now let's try to execute this and see how does it function. You can see the code has been getting compiled and the output has been successfully generated, and we have the output here where A is 5, A is 10890511034, and B is 7.3. So basically what I have done here is I've declared a union, and inside the union I've declared variable A and variable B, which are of different types, integer and float respectively. And inside my main function, I've tried to do some operations upon these variables, and the results of those operations are being displayed here. So with this, let's move on to the next segment where we'll learn about variables used in C++. So variable is defined as the reserved memory space which stores the value of a definite data type. The value of a variable is not constant. Instead, it allows changes. So in C++, we have different types of variables which are as follows: local variable, global variable, static variable, automatic variable, and external variable. So firstly, let's understand local variable. So any variable that is declared inside the code block or a function and has scope defined to that particular block of code or function is called as a local variable. So for example, here I have void Edureka, which happens to be my function, and inside this function I have declared a variable on the name local variable. So this particular variable is storing the value 10, and now the scope for this particular variable is confined to the function Edureka. This means the local variable is not capable enough to be accessed outside the function Edureka. So this is how the local variables function. Followed by this, we have the global variable. So what is a global variable? Any variable that is declared outside the code block or a function and has scope across the entire program and allows any function to change its value is known as global variable. So basically, the global variables are declared outside all the functions and before even the main function is started. By doing this, the programmer will be capable enough to access the global variable from any function or any method, and even from main. And all the functions, including the main method, can change the values which are present in the global variable. Here, I have declared a global variable of integer data type, and it is saving the value 10 inside it. And you can see that the global variable is declared outside the Edureka function. So now I can access this global variable from my function or my main function and change its value after applying any particular operation on global variable. So this is how the global variables work. Followed by this, we have static variables. Any variable that is declared using the keyword static is known as a static variable. Static variables retain the declared value throughout the entire execution of the program and will not be changed between multiple function calls. Here you can see that I have used the static keyword. Followed by that, I have provided a data type which is integer, and I have declared my static variable which stores the value 10. Now this particular value 10 will not be changed even after you apply any kind of operations onto this particular static variable. So this is the functionality of static variable. Followed by this, we have the automatic variable. So the automatic variables can be declared using the keyword auto. By default, all the variables declared in C++ language are automatic. Followed by that, we have the external variable. External variables are declared by using the keyword extern. We can share a variable in multiple C++ source files by using the external variable. For example, I have declared a variable by the name external, which is of integer data type, and I have stored 10 inside that variable. And we need to concentrate that I have declared this particular variable using the keyword extern, which makes this particularly an external variable. An external variable is also called as a global variable. Now after this, let's check out some rules for declaring variables. The rules for declaring variables are completely similar to that of identifiers, which say a variable can have alphabets, digits, and underscore. A variable can start with an alphabet and underscore only. It can't start with a digit. Followed by that, no white spaces are allowed within the variable name. And the last rule is that a variable name must not be any reserved word or a keyword. Example, integer, float, etc. Now let's see some examples for valid variables names. First one is integer a, which starts from an alphabet, so it's valid. Followed by that, we have another one which is of integer data type, and it's starting with underscore. So this is valid. Followed by that, we have integer a30, which is also valid because it's starting from an alphabet and it is continuing with a number, which is valid. So now let's check out some examples for invalid variables. Firstly, you have integer 2. So this particular variable is starting with a number which happens to be 2. So it's invalid. Followed by that, we have another example where we have declared int a space b. So this particular variable name includes space. So spaces are not allowed to be declared for variables. Followed by that, we have int long. So we cannot use long because long happens to be a data type and a keyword in C++, so it's invalid. Now let's begin with our next topic, modifiers. So what are modifiers? So the modifiers in C++ allow the character, int, and double data types to have modifiers preceding them. A modifier is used to alter the meaning of the base type so that it more precisely fits the needs of various situations. The data type modifiers available in C++ are signed, unsigned, long, short. Now let us execute a simple example to understand how exactly modifiers function. So this particular example is based on type modifiers where I have declared two variables of short int I and short unsigned int I. So j is storing the value of 50,000 and I is declared is equals to j. So when it's modified into unsigned int, the value will be changed. Now let's check out this. You can see that the program is getting compiled and the output has been displayed here. The modified value is minus 15,576 and the actual value which we have given to the unsigned int was 50,000. So the original value was 15,536 with this symbol minus. Let's move on to the next topic, which is based on type qualifiers. So the type qualifiers provide additional information about the variables they precede. There are three different type qualifiers present in C++ language. They are const, volatile, and restrict. Let's understand each one of them in detail. Objects of const type cannot change the program during execution. Next we have volatile. The modifier volatile tells the compiler that a variable's value may be changed in different ways, not explicitly specified by the program. Then finally we have a restrict. A pointer qualified by restrict is initially the only means by which the object it points to can be accessed. Only C99 adds a new type qualifier called restrict. Now with this, let us move on to the next topic, which is about operators in C++. So we have different operators supporting in C++. They are arithmetic operators, increment or decrement operators, assignment operators, relational operators, logical operators, and finally the bitwise operators. Firstly, let us understand about the arithmetic operators in C++. Arithmetic operations are used to perform mathematical calculations such as addition, subtraction, multiplication, division, and modulus. Followed by that, we have the increment or decrement operators. The increment or decrement operators are used to increase the value of a variable by specific number, and similarly, decrement operator is used to decrease the value of a variable by a specific number. Now let's move on to the assignment operators. The assignment operator in C++ is used to assign the values to a particular variable. For example, equals to and double equals to. Int a is equals to 10 is the simple example for assignment operators. Then we shall move on to relational operators. The name itself indicates the operation of this particular operator. The relational operator is a programming language construct or operator that tests or defines the relationship between two entities or variables. So the basic examples for relational operators are greater than, less than, equals to, not equals to, and few more. Then we have logical operators. These operators are used to perform logical operations on given expressions. There are three logical operators supporting in C++ language. They are logical and, logical or, and logical not. Finally, we have the bitwise operators. These operators are used to perform bit operations. Decimal values are converted into binary values, which are a sequence of bits, and bitwise operators work on these bits. So the bitwise operators supporting in C++ language are bitwise and, bitwise or, bitwise not, XOR, left shift, and right shift. So with this, we shall conclude with operators and move on to the next part, which deals with the control statements. So what are control statements? Control statements enable us to specify the flow of program control. They specify the order in which the instructions in a program must be executed. They make it possible to make decisions to perform tasks repeatedly or to jump from one section of the code to another. So the following are the control statements in C++ programming language: if statement, if else ladder, nested if, switch, and break. First, we shall learn about if control statement. If control statement in C++ is defined as a programming conditional statement that, if proved true, performs an operation and displays the information inside that particular statement block. Let us understand the flowchart of if control statement. Basically, the control begins by executing the beginning parts. So after executing the start part, it enters or encounters the first condition. If the condition happens to be true, then the control enters the condition and executes the statements provided in that particular condition block. If false, the control first executes the start blocks, then it encounters the first condition. This condition is none other than the if condition. If the condition is true, then the control enters the condition and executes the statements which are present inside the condition block. In case if the condition fails, then the control flows outside the condition and executes the statements which are present outside the condition block. So this is how if control statement works. Now let us try to execute a sample program to understand the functionality of if control statement. So this particular example is based on if conditional statement. So here I have declared a variable a which stores the value 100. So the if condition is if a is less than 200, then this particular statement should be executed. Else only one particular statement which is outside the if block should be executed. Now let's run this program. You can see that the program has been successfully executed, and since the condition is true, this particular statement, which is a message which says a is less than 200, is been printed in the terminal. So this is how the if statement works. Now let's move on to the next type of conditional statement, which is if-else control statement. So the if-else control statement in C++ is defined as a programming conditional statement that has two statement blocks over one condition. If proved true, then the if block will be executed, and if false, then the else block will be executed. Now let's check out the flow diagram to understand its functionality. So firstly, the start block will be executed as usual. Followed by that, we have an if condition. If the condition is true, then the control enters the if condition and executes them. If false, then the condition enters the else statement and executes the else statements. Once after either of the statements are executed, the control flows outside the if or else block and executes the statements which are present outside those blocks. This is how the if-else conditional statement works. Now we shall execute a sample program to understand it in a much better way. So this particular example is based on else if conditional statement. Now let's execute it. You can see that I have given a is equals to 100 and b is equals to 200. In case if b is greater than a, then if block should be executed. Else, an else block present after the if block should be executed. Since b is less than 200, the first if block is executed here. Now let's move on to the next type of control statement, that is the if-else ladder control statement. The if-else ladder in C++ language is defined as a programming conditional statement that has multiple if-else blocks. If any of the condition is true, then that control will exit the if-else ladder and execute the next set of statement. Now let's see the flowchart to understand if-else ladder in a much better way. So here the control begins at the start statements. After that, it has a set of conditions provided in here, starting from the condition 1, condition 2, condition 3, followed by that we have the last condition, which is the condition n. So what exactly happens here is the control checks for a valid condition. If condition 1 is true, then the statements in the condition block are executed and it leaves the block. If in case the condition 1 fails, then the control will flow to the upcoming condition and the condition is checked. If in case true, the statements are executed and the control leaves the block. In case if all the controls fail, then it reaches the last condition and checks for the valid statement. If the statement is valid, then that particular statement will be executed. Else, the control will skip all the if statements and finally execute the last statements which are followed after the if-else ladder block. So that's how the if-else ladder works. Now let's see a practical example to understand its functionality in a much better way. So this particular example is based on else if ladder. So here I will be entering the score of a student. So in case my score lies between 90 and 50, then my grade will be A. In case my score lies between 50 and 35, then my grade will be B. In case it is less than 35, it's supposed to be C. And if it is invalid score entered by the user, then it is set as failed. Now let's try to execute this program and see how does it work. You can see the program is getting compiled and now I'm supposed to enter my score. Let us enter 90. You can see my grade is A, which is printed here. Now with this, let's move on to the next type of control statement, which is the nested if control statement. So the nested if control statement in C++ is defined as a programming conditional statement that comprises another if statement inside the previous if statement. Now let's see the flowchart to understand its functionality in a better way. So here, the control begins at start block and executes the first outer if statement. If the condition is true, then the control enters inside the if block where it encounters another if statement. In case if the control sees the condition fails, then it will exit as it is. Now we shall assume the condition is true. Once after the control enters the second if block, it checks for the second condition. If it is true, then statements will be executed. Else, the else statements will be executed. So this is how a nested if statement works. Now let's try to execute a simple program to understand nested if statement. So this particular code is based on nested if statement. Let's try to execute it. Before that, you can see that the outer if has a is equals to 100. In case if a is equals to truly 100, then it enters the if block and the next if condition is checked. In case if it is false, then the control will directly exit the outer if block and execute the two out statements which are present outside the if block. Now let's try to execute this. You can see that the outer if block failed, so the statements present outside the conditional block have been executed here. Now with this, let's move on to the next type of control statement, which happens to be the switch control statement. Switch case in C++ is defined as a programming selection statement that checks for a possible match to the provided condition against the available cases. If none of the cases match, then the control will execute the default statement block. This is similar to else if ladder. Now let's check out the flowchart to understand this in a much better way. So here, the control will first enter the switch expression and checks the condition. If the condition matches with case 1, then the statements inside the case 1 will be executed and the control leaves the switch block. Similarly, if the case 1 fails, then it checks for the validity in case 2. If case 2 finds a match, statements 2 will be executed and exits the switch statement. In case if case 2 also fails, then case 3 is checked and statements 3 will be executed. And finally, it will exit the switch statement. In case if all the cases fail, then there is a default statement in switch expression which will be executed, and after that the control leaves the switch case. So this is how the switch case is been designed to work with. Now let's execute a sample program to understand this in a much better way. So this particular program is based on switch control statement. We have 3 cases inside here, and I have provided one particular choice, which is 3. If case 3 is matched, then the message inside the case 3 should be printed. Now let's execute this program and see the output. You can see that case 3 found a match and the message inside the case 3 block has been executed here. Now with this, let's move on to the next part of our tutorial, which happens to be the break statement. The break statement in C++ programming language is defined as a programming conditional statement that is designed to exit the control from the current code segment to the next code segment when a specific condition is satisfied. Now let's check the flowchart. Firstly, the condition is checked. The control checks the condition, and if it finds the condition is valid, then very next the control flow from that particular block of code will be blocked and the control takes an exit. In case if the control finds the condition to be invalid, then the same condition is continued for one more time. So this is how the break control statement works. Followed by this, let us continue with the loops in C++ program. So what are loops? Loop control statements in C++ are used to perform looping operations until the given condition is true. Control statements come out of the loop statements once the provided condition becomes false. So there are 3 different types of loops in C++ programming language. They are do while loop, and for loop. Let us understand each one of them in a much better way. Firstly, we shall deal with the for loop. The for loop can be defined as a precise loop which has initialization, condition, and increment or decrement operator. So the for loop has 3 different parts. Firstly, initialization comes in the first position. Later, we have the condition provided by the user. Then we have a valid increment or decrement operator. Now let us check out the flowchart to understand the functionality of for loop. The control begins at the initialization state, and once after the initialization is done, then the control checks the condition. In case if the condition is true, then the statements inside the for loop will be executed, and once the statements are executed, the control flows into increment or decrement operator and performs the operation of increment or decrement as per the user's request. Once after the process is done, then the control will again enter the condition and checks the condition's validity. If the condition is valid, then it enters the loop again. In case if the condition is false, then it will exit the for loop. This is how the for loop works. Now let's try to execute a program to understand the working condition of for loop. So this particular example is based on for loop. So here I've provided the initialization variable as I is equals to 1. Followed by that we have the condition which says that I should be less than or equal to 10. And lastly, I've provided the increment operator. Now let's try to run this program. You can see that the program has been successfully compiled and the numbers starting from 1 to 10 are being printed here on the terminal. So this is how the for loop works. Followed by this, let's deal with the nested for loop. The nested for loop is completely similar to that of the for loop, but the only difference is the external for loop includes an inner for loop. Let's check the functionality. The control begins at the start statements. Firstly, the outer for loop is executed. In case the condition fails, the control exits. In case the condition is true, then it encounters the inner for loop. If the control finds the condition in the internal for loop is true, then it executes the internal for loop. else it exits. So this is how the nested for loop works. Now let's move on to the while loop. While loop can be defined as a loop which executes itself repeatedly until a given Boolean expression or a condition is true. Now let's check out the flow diagram. The control begins at a decision. In case if the decision is true, the statements inside the while loop will be executed, else the loop will be terminated. Now let's try to execute a simple program to understand the functionality of while loop. So this particular program is based on while loop. Let's try to execute it. The program should be working for generating factorial numbers of the given number. Now I have inputted 10. Let's generate the factorial numbers here. We have the factorial number of 10 as 3628800. Now let's move on to the next type of loop, which happens to be do while loop. The while loop and do while loop are completely similar to each other, but the only difference is the condition block will be placed at the end of the while loop. So here the control begins at the execution of statements first. Once after the statement is executed, then the condition is checked. If the condition is true, then the statements will be executed again. In case if it is false, then the control exits the do while loop. Now let's execute a sample program to understand do while loop in a better way. So this particular example is based on do while loop. Now let's try to execute this. We can see that the program is getting compiled and the output has been generated here. The value of num from 1 to 6 are being generated here as per the condition provided here. Now with this we conclude the basics of C++ tutorial. Now let us move on to the next segment of our today's tutorial, the object-oriented programming. Object-oriented programming system is a programming paradigm based on the concept of objects that contain data members and methods related to them. The primary purpose of object-oriented programming is to increase the flexibility and maintainability of programs. Now let us discuss the important features of object-oriented programming. The object-oriented programming emphasizes more on data rather than procedure. The programs are divided into objects, thus making it easy to work within. Data structures are designed in such a way that they characterize the objects. Functions that work on the data of an object are placed together in the data structure. Data is hidden and cannot be accessed by external functions without permission. This is because of the access modifiers. Communication between objects can take place with the help of functions. Adding new data and functions has become very easy. The object-oriented programming paradigm follows the bottom-up approach in the program design. Now let us discuss the important steps included in object-oriented programming. Firstly, we have encapsulation. Encapsulation can be defined as a process of wrapping up the data and information under a single unit. In object-oriented programming, encapsulation is defined as binding together the data and their related functions. In other words, wrapping the data together with the functions that manipulate them. We can implement encapsulation using the three access modifiers, which are public, private, and protected. Now, we have some types of encapsulation. The types of encapsulation that C++ supports are member variable encapsulation, function encapsulation, and class encapsulation. Let us go through a simple example to understand how encapsulation works in C++. So this particular example is based on encapsulation. Now let us try to execute it. Now we can see that the program has been compiling and the encapsulation has been applied onto all the classes present in the program. Now let us move on to the next topic, that is the abstraction. Data abstraction is a programming technique for separating the interface and implementation details. This provides only the important details and hides the complicated code segments of the program. There are three main access specifiers implementing abstraction, which are public, private, and protected. There are basically three ways to apply abstraction in C++ programming language. That is, abstraction using classes, abstraction using header files, and finally, abstraction using specifiers. Now, let us go through a simple example to understand the terminology of abstraction. So this particular example is based on the terminology of abstraction. Now, let us execute this program and see how does it work. As you can see, the program has been successfully compiled and the abstraction process is being applied upon the classes that are meant to. Now, let us move on to our next topic, that is inheritance. Inheritance is defined as a process of acquiring all the properties and behaviors into the child object from its parent object automatically. There are 5 types of inheritances available in C++ language. They are single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, and finally the hybrid inheritance. C++ uses access specifiers to limit the access of base class attributes to the derived class. There are totally 3 types of access specifiers in C++. They are public, private, and protected. Let us see through some examples to understand inheritance in a much better way. So this is a basic example of inheritance. The class trainInfo happens to be the parent class and the class bulletTrain happens to be the child class. Here we are inheriting the properties of class train into the class bulletTrain. Now let us execute this program and see the output. As you can see, we have successfully inherited the properties of train class into the bulletTrain class. Now let us move a bit further and execute a program based on single inheritance. This particular example is based on single inheritance. Single inheritance is a type of inheritance where the child class inherits the properties of one parent class. Now here, a program has been successfully executed and now it is asking for a name as an input. As you can see, the data has been successfully displayed here. And now let us execute an example based on multiple inheritance. Multiple inheritance is a type of inheritance where one child class inherits the properties of 2 or more different parent classes. This particular example is one of a kind. Let us execute this and see how does it work. As you can see, we have inherited the properties of multiple classes into one child class and the output has been displayed here successfully. Now let us move on and execute another example based on multi-level inheritance. Multi-level inheritance is a type of inheritance where the class inherits the properties from 2 different levels of parent classes. For example, here class base is the topmost class or the first class. Derive1 is the second class which is inheriting the properties of the parent class base. Here we have another child class on the name Derive2. So what happens here is Derive2 inherits the properties of Derive1, which is in turn inheriting the properties of the first parent class, which is base. So this is how multi-level inheritance works. Now let us execute this program and see the output. You can see the program has been successfully compiled and now it is asking me for an input. Similarly for Y, then for Z, and here's the output. So this is how multi-level inheritance works. Let us move on to the next type of inheritance, which is none other than the hierarchical inheritance. Hierarchical inheritance is completely similar to multi-level inheritance. Now let us execute this program and see how does it work. As you can see, the program has been successfully compiled and the output has been generated here based on hierarchical inheritance. Now finally, hybrid inheritance. Hybrid inheritance is a combination of 2 or more previous types of inheritance. That is, hybrid inheritance can include multi-level inheritance and multiple inheritance, or multi-level inheritance and single-level inheritance, or the combination of any other inheritances types. So this is a program based on such a kind. Now let us execute this and see the output. As you can see, the program has been successfully compiled and the output has been generated. Now with this, let us move on to the next concept in our tutorial for today, that is overloading. So what is overloading? Overloading is a process where we create 2 or more members of a class having same name but different number of parameters. We can overload by using methods, constructors, and indexed properties. There are basically 2 types of overloading, which are functional overloading and operator overloading. Now let us execute an example based on overloading. So this particular example is based on function overloading, and here we are having 2 methods on the same name, that are add and add. One method is having 2 parameters and the other one is having 3 parameters. Now let us execute this program and see how does it work. As you can see, both the functions have been executed successfully without any problem, and we have the results of the functions as well. Now, let us move on to the next topic, which is overriding. When a derived class has a function with the same name as a function of the base class, then it is called as function overriding. Both functions must have the same number of parameters in both the classes. Now, let us execute a program based on function overriding to understand the terminology in a better way. So this particular program is based on functional overriding. Here we have a function called desc in the base class. Similarly, we have another function in derived class with the same name called disp. So let us execute this program and see how does it work. You can see that the program has been successfully compiled and the output has been displayed here. So this is how the overriding works in C++. Now let us take a step further and find out the differences between function overloading and function overriding. First difference is that the scope is same in overloading, whereas in overriding the scope is completely different. Then the second difference, signatures must differ when you're overloading, but whereas signatures must remain same when you're overriding. The next difference is multiple overloading is possible, whereas multiple overriding is not possible. And the last difference between the both is overloading can occur without inheritance, while overriding will occur only because of inheritance. Now let us move on further and understand interface. The interface is a solution to implement the behavior and functionalities of the parent class into the child class from its parent class without the actual involvement of the members of the parent class. So this is the syntax for applying interface in C++, which is double underscore with interface, which is the keyword. Followed by that, we have to mention the interface name. And inside the block, you can have your own statements. Now let us execute a program based on interface to understand its terminology. So this particular example is based on interface. Now let us execute this and see how does it work. As you can see, the program has been successfully compiled and the output has been generated here. Now let us move on to the next concept, which is friend. A friend function of a class is outlined outside that particular class's scope. However, it is possible to access all the private and protected members of a class. Basically, this property is a bit insecure when it comes in the real time. However, let us see the syntax to use friend functions in C++ programming. Class is the keyword here, followed by that you have to provide the class name to which you have described your friend function, and inside the block you have to use the keyword friend, followed by that you have to place a data type and the function name inside which you have the arguments. Now let us execute a program based on friend function to understand its terminology in a much better way. So this particular example is based on friend function. Now let us try to execute it. You can see that the program has been successfully compiled and the result is displayed here. Followed by this, let us move on to our next concept, that is constructor. The constructor is considered as a member function of a particular class. It is mainly used to initialize the objects of the class. It is provided with the same name that we have provided for the class. Now there are three types of constructors. They are default constructor, parameterized constructor, and finally the copy constructor. Let us execute a simple program based on constructors to understand their terminology. So this particular program is based on constructors. As you can see, the program has been successfully compiled and we have the results here. Now let us move on to our next topic, which is the destructors. So what is a destructor? Destructor is completely similar to the garbage cleaner in Java. How does destructors in C++ work? Destructors are another type of member functions that are responsible for destroying or deleting the object. It frees up the space occupied by the object after it is no longer needed. It is completely similar to the free method which we use in dynamic memory allocations in C programming. Now the syntax for destructor is destructor name, but care should be taken that the tilde symbol is used in front of destructor name. Now let us execute a simple example based on destructors. So this particular example is based on destructors. Now let us try to execute it. You can see that the destructor has been successfully executed and an output has been generated. Now let us move on to the next topic here. The next topic is the STL, Standard Template Library. The Standard Template Library is a set of C++ template classes to provide common programming data structures and functions such as list, stack, arrays, etc. STL has three components. They are containers, algorithms, and iterators. Now with this, we have concluded with the object-oriented style of programming. Now let us move on to the advanced programming concepts in C++. First one, file handling. Files and streams. Files are used to store data in a storage device permanently. In C++, we have a set of file handling methods. These include ifstream, offstream, and fstream. What is offstream? This stream class signifies the output file stream and is applied to create files for writing information into files. Then we have fstream. This stream class signifies the input file stream and is applied for reading information from files. Finally, we have fstream. This stream class can be used for both read and write from and to files. Now, let us execute basic examples for understanding file handling methods in C++. Now, let us try to create a file. So this particular code segment is used to create a file. Let us name our file as Edureka. Now let's run the code. As you can see, a new file has been successfully created and our file is right here. Now let us try to execute another program which follows the write function into the file. Now this particular code is used to write data into the file that we have created. So the data that we will be writing into our file is Edureka Happy Learning. Now let us try to execute this code. As you can see, the message has been successfully written into the file and the message has been displayed here. Now let us try to execute another program which reads the data present in our file. So this particular code is used to read the data which is present in our file. As you can see, the compiler is reading the message that we have written into our new file, that is edureka.txt. Now we shall execute the last program based on file handling techniques, which is used to close the file that we have opened. So this particular code segment is used to close the file that we have opened, which is edureka.txt. Let us run this code to close the file. As you can see, the code has been successfully executed and the file has been closed. Now with this, let us move on to the next segment, which deals with exception handling. So what is exception handling? Exception handling is a phase which deals with the handling of errors and exceptions that rise in runtime due to the mistakes in code or invalid inputs entered by the user. In C++ programming language, we have two types of exception handling, that are runtime exception handling and compile time exception handling. Let us go through some examples to understand exception handling in a better way. So this particular example is based on exception handling, and we are going to try the try and catch block here. You can see that the code has been successfully compiled and the code was designed to divide 25 by 0, and the exception should be attempted to divide by 0, which is displayed here in the terminal. Now let us try to execute another example based on exception handling where the catch block will be facing a failure. Let us see how does it happen. You can see that the code has been successfully executed. This kind of approach is used when catch block and try block both face failures. So in this situation, we have to specify a default catch block which will execute a default exception. As you can see, we have default exception message printed here in the terminal. Now let us try to execute one last example based on exception handling, which is having multiple catch blocks in a program. So here we have multiple catch blocks included in our program. Now let us try to execute this. You can see that the code has been successfully executed and the output has been printed here. Now with this, let us move on to the next segment where we will learn dynamic memory management in C++. Firstly, we shall deal with dynamic memory allocation. Dynamic memory allocation can be defined as a procedure in which the size of a data structure is changed during the runtime. In C++, the new operator is used to allocate memory at runtime, and the memory is allocated in bytes. So the syntax for dynamic memory allocation using the new keyword in C++ is data type pointer is equals to new keyword and the data type. Now let us execute an example based on dynamic memory allocation. As you can see, the code has been successfully executed, and you can see the memory allocated for the data in our program, which is 1, 2, 3, 4, and 5. Now with this, let us move on to the next concept, that is deallocation. Deallocation acts as the free method in C programming. Once heap memory is allocated to a variable or class object using new keyword, we can deallocate that memory space using delete keyword when the memory is no longer needed. This improves the program efficiency. Let us move on to the next concept, that is signal handling. Signals are the interrupts delivered to a method by software package which may terminate a program untimely. You'll be able to generate interrupts by pressing Ctrl+C on an operating system, Linux or Windows OS. Now we shall execute a simple example based on signal handling, where we'll try to print a message called Welcome to Edureka. Now let us run this program. As you can see, the program has been successfully executed, and the terminal is starting to produce the signal Welcome to Edureka for infinite number of times. Now we have to stop this in order to cancel the signal generation. We have to just press the stop button in order to stop the signal generation. The signal generation has been successfully stopped. Let us move on to the next concept, which is multithreading. Multithreading is a special sort of multitasking, and a multitasking is that feature that enables your PC to run 2 or additional programs at the same time. In general, there are 2 kinds of multitasking. First one, process-based, and the second one is thread-based. Process-based multitasking handles the execution of programs. Thread-based multitasking deals with the execution of items of identical programs. A multi-threaded program contains 2 or additional elements which will run at the same time. Every part of such a program is termed as a thread, and every thread defines a separate path of execution. C++ does not contain any constitutional support for multi-threaded applications. Instead, it depends entirely upon the OS to produce this feature. The C++ programming language has the following stages in multi-threading. First, to create the thread. Next, pass arguments to the thread. Then, join or detach threads, and finally, to terminate the thread. Now, let's execute all these 4 stages to understand the terminology of multithreading, and before that, let us understand the syntax of multithreading. So in the syntax of multithreading, we're supposed to include the library which is pthread.h in the program in which we are processing multithreading. Let us execute the program for creating a thread. So this particular program should successfully create a thread. You can see that there are threads created and the message is being printed along with the threads. Now, followed by this, we shall try to pass some arguments to different threads. So this particular program should be able to pass multiple messages to multiple threads. Let us execute that. You can see that the output is being generated here, and we have created 5 different threads and we have allocated a single message to every single thread. Now with this, let us move on to the next stage where we will try to join and detach threads. So this particular program should join and detach threads. Let us execute this. You can see that we have created 5 different threads and we have attached 1, 2, 3 and 4 threads, and the 0 thread is being detached. Now with this, let us continue with our final process, which is none other than terminating a thread. So the syntax for terminating a thread is include pthread.h library, and you need to write pthread exit status, and that's how you terminate a thread. Let us continue with our next topic, that is containers. Associative containers that store elements in a mapped fashion are called as maps. All the elements in a map are stored in a key value pair, where each key is unique. Sorting is done with the help of keys and the values are associated with each key. Values can be inserted and deleted whenever required. So the syntax for a container is map key type, value type, and map name, followed by a semicolon. Now we shall execute an example based on containers. So this example is based on containers. Now let us try to execute it. As you can see, the program has been successfully executed, and we have the container where we have the roll numbers along with their marks. Let us try to execute another example based on containers. So this is another example based on containers. Now let us try to execute this program and see the output. You can see that the program has been successfully compiled and the output has been successfully generated here. The output is the key value pair, which has been displayed here. Now with this, let us wind up our session with some most important interview questions that are asked based in C++. So we shall deal with 4 important programs. They are Fibonacci numbers in C++, then followed by that we have quicksort in C++. Then we shall understand call by reference in C++, and finally, what is type conversion in C++. These interview questions are answered in detail in the article written based on C++ tutorial. The first one is the Fibonacci series in C++. Now let us try to execute the first program, that is generating Fibonacci series using C++. So now let us enter the numbers. You can see that I have entered the number as 5 and the Fibonacci series for the same has been successfully generated here. Now let us try to execute the second program, which is none other than the quicksort in C++. Don't worry about the code, we will mail you the code whenever you ask it for. So this particular code is designed for running quicksort algorithm using C++. Now let us try to execute this. As you can see, the code has been successfully executed and now it is asking for the number of elements to be sorted. Let me give a random number, that is 10. Now let me provide the elements to be sorted one by one. Firstly, I'll provide 5, then I'll provide 1, next 4. Followed by that, let me enter 6, then 7, then 8, later 2, then 3, then 9, and finally 10. Let us see if the numbers get arranged in a proper way or not. You can see the numbers have been successfully arranged in the proper manner, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now with this, let us move on to our next question, that is call by reference. Let us execute a simple example based on call by reference. So this particular example is based on call by reference. This example has been already executed while we were discussing call by reference in reference variables, though we shall try to execute this one more time. You can see this program has been successfully compiled now and we got the output, and the output has been displayed on the terminal. Finally, we reached to the last question, which is type conversion in C++. So what is type conversion in C++? Type conversion refers to the conversion from one type to another. The main idea behind the type conversion is to make variable of one type compatible with the variable of another type to perform an operation. Now let us try to execute a simple example to understand type conversion. So this particular example is based on type conversion. Now let us try to execute this program and see how does it work. As you can see, the code has been successfully executed and the output has been generated. As we specified in the code, we have 3 different variables of 3 different data types. Firstly, we have int1, which is an integer data type, which is saving 100 as its value. Followed by that, we have a character1 variable, which is of character type, which saves C inside it as its value. And third variable is FLT1, which is a float data type variable, which will be storing the sum of integer 1 plus 2.7. As we specified the operations, firstly, integer 1 will be saving the value of integer 1 plus character 1. We have integer 1, that is 100, and character 1, C. So the value of character C in ASCII is 99. So the summation of 100 and 99 gives us 199. And now finally, we have FLT1, which will be storing the value of int1 plus 2.7, that is 199 plus 2.7. Now what happens is that the data type int will be converted into float, and the final value, which is none other than 201.7, will be stored in FLT1 variable. So this is how type conversion takes place.
So the idea behind HTML was a modest one. When Tim Berners-Lee was putting together his first elementary browsing and authoring system for the web, he created a quick little hypertext language that would serve his purposes. He imagined dozens or even hundreds of hypertext formats in the future, and smart clients that could easily negotiate and translate documents from servers all across the internet. Now HTML stands for Hypertext Markup Language, and it is the standard markup language for creating web pages and web applications. It is used to describe the structure of the web pages using a process called markup. Now HTML mostly constitutes of elements, And these elements are the building blocks of any HTML page and are represented by tags. Now let me just give you a brief introduction to the structure of HTML. Now this is also called an HTML boilerplate. So firstly, an HTML boilerplate begins with the HTML tags, which tells the browser that this is an HTML page and this is where it begins from. Next comes the head tag, which contains most of the meta information about the document. The head tag normally also contains the link to the styling sheets, the fonts that you might be using on your web page, and even the JavaScript that you might be using. Now, the head tag also has the title element, which specifies the title for the document and can be seen as a text on the tab that you open on a browser. Now, next comes the body tag, which mostly contains the content that is visible to the viewer of your page. And these contains elements like h1 tags or paragraph tags, which are known by p tags, and they make up the mass of your content. Now, to create an HTML page, there are a few steps. So firstly, you need to open any sort of text editor. It could be Notepad++, Notepad, Sublime Text, or even Visual Studio Code. You have the freedom to use whatever text editor you want. Next, you have to write up some HTML code that you want to show on your web page, and then you just save your file as a .html. And to open the file, all you have to do is just view it on your browser. Now let me just give you a quick demonstration on how that is actually done if you've still not understood that. So let us create a folder first. So let's call this folder HTML demo, and now we're just going to use Sublime Text because that's my favorite text editor. Out here, all you have to do is create a new file, and I'm going to be saying that it's a HTML type. Then you just fit in your HTML boilerplate. I'm going to tell my title is going to be my first web page, and that is the title of our web page. Now let's put in some content into this. So it's going to have an h1 which says this is just some text. Let's save this. This is going to be saved into our HTML demo. So let's open it. Let's save it as index.html. Now once you've saved it, all you have to do to view it is go into your folder and just open it on your browser. So as you guys can see, the title is written out here on the tab, and this is our h1 that we just created. Okay, so that's how you basically create an HTML page. So let's move on. Now there are some elements that I want to tell you all about, which is very important. So first is the doctype element. So the doctype declaration represents that the file you're working is a document type and helps the browser to display web pages correctly. And it only appears once at the top of the page before any HTML tag, and the doctype declaration is not case sensitive. Okay, so this is what HTML actually looks like. Now before we move further with some HTML coding, I want to make you all aware that a web page is fundamentally made up of three constituents. The first is HTML, the second is CSS or cascading style sheets, and the third is JavaScript. Now HTML will only give the structure of the web page. It has nothing to do with the styling, while CSS is completely responsible for how beautiful your web page looks, what colors you're using as the background, how your images are actually lined up, and all those sorts of things. To learn more about CSS, you can always refer to our CSS tutorial on the same page of Edureka. And thirdly, JavaScript is for making your page much more dynamic. If you're clicking on a button, your posts are being actually submitted. That's all being done by JavaScript. And if you all want to learn about JavaScript, we also have tutorials for that, and you can surely check them out. Okay, so now let's go ahead and create some elements and see how they look like on an HTML page. So let's go back to our HTML page. So this is what an h1 looks like. So let me just copy this down now. And let me show you all the types of headings that HTML provides us. It's actually h1 through h6, so h2, h3, h4, h5, and h6. Let's also change them here. h6, h5, h4, h3, 2. Now let's save it. Let's go ahead and reload our page. So this is how the different types of headings look like. This is h1 being the biggest and h6 being the smallest. Okay, so that was about headings. Now we have some other tags also that I want to make you all aware of. So there's a p tag first. So p normally stands for paragraph. Now paragraph is basically what it looks like, and it normally contains random text or paragraphs of your web page. And this is what they look like. So this is what a paragraph looks like. Okay, so that was all about adding a paragraph. So how do you add images? So you can simply add image with the image tag, and all you have to say is a source. Now I already have a beautiful picture of a Pokemon that I really loved as a kid. So let me just copy that down into the folder. Okay, so now that we've copied down our image into our folder, all you have to do is give the source. Now this can be ninetails.png. That's the name of our image. Let's go back to our page. Let's reload it. Okay. Now you can also put in attributes like height, and you could say the height is going to be 7 or 500 pixels, and then you can also put in an attribute called width and say that's also going to be 500 pixels. Yeah, so that changes the height and width of your image. You can also make it smaller by saying something like 100 pixels. So let me just show you that. Save it, let's reload it, and yeah, now we have a much smaller Ninetales out there. Now, suppose you don't have a picture, you can also put an alt tag. So this will say there was supposed to be an image here. So let's save that. Now you will not be able to see the alt tag because our image is working. But suppose I misspelled the name of my image, and now you'll see something like that out there. So there was supposed to be an image out here. So it's showing the alternate thing. Right, we can also have line breaks in our HTML. So you do that simply by saying /br, and then there will be a line break between this word Alamco and Laborious. So let's save that. Let's cancel this out. Okay, so now Alamco and Laborious are on different lines. We can also make stuff bold. So suppose you want to make this first word bold. So you can go B/B, and that'll make it bold. Yep, now lorem is bold. You can also, for making things bold, you can use the strong tag. And now let's say this is also bold. And now this is also bold, comes up right there. Then you can change the size of text. So let's just create some other text so that it doesn't get cluttered up. So we have tags like big, and we also have tags like small. So let me just show you the difference. This text is big, while this is small. Let's do that. So this text is big while this is small. So let me just put a line break here. Save that. Let's also put a line break here, and now let's put back our image. Yeah, this text is big while this is small. Now you can also put in horizontal lines inside your HTML. All you have to say is HR, and that'll put in horizontal line out there, right like that. You can also put the width and height out here. So width, there's no reason to put a height because it's not there, and width is going to be something like 70%. You could say 70. And you have a line that goes 70% through the screen. Next, we can also put in links into our HTML. So suppose you want to go to a site. So let's say you want to go to Edureka. Now we can put some text like, say, this is a link to a website. Let's save that. Let's put it here. And now this will take us to edureka.co. Yep, so that's how it works. You can also put links on images. So suppose we were to remove this text out here, copy this image from here, and just put it out here. Now if we were to click on the image, it'll take us to edureka.co. Okay. You can also add lists into your HTML page. So there are two types of lists. One is an ordered list. So ordered lists are numbered lists, and you can put in list items like this. So let's put in a bunch of list items. Okay, so let's type in some text. So this is a random list. So list items are actually going to be the things that you're going to list out. So these could be anything that you're listing out. You could list out your favorite dogs. You could list out your favorite chocolates or anything like that. Let me just show you what that looks like. Let's go back to our page. And this is what it looks like. So as you guys can see, we have a list out here which says this is a random list, this is a random list, and just to make it a little more creative, let's go and put in some stuff like that. So firstly, let's put an H2 out here. These are some of my favorite dogs. Let's say I love Samoyeds. I also love Corgis. I love Huskies. And I also love golden retrievers. So now we'll have an actually good list out here. So these are some of my favorite dogs. Now, if I were to just make this an unordered list, so we could also have unordered lists. So this is how you create an unordered list. You just go UL and then you put in your list items. So I'm going to say, so let's put in H2 again, and these are some of my favorite heroes in Dota 2. So list item, this is going to be, let's see, I really love playing Shadow Fiend. Then let's put in some other heroes like Storm Spirit, Invoker, and let's say Templar Assassin. Let's save that and let's see. So these are some of my favorite heroes in Dota 2. Now if you see, our H2 is kind of indented. That is because we have put it inside our list. Now if you were to just cut it out and put it outside, let's reindent my lines and let's see. So now it's properly showing. So these are some of my favorite heroes in Dota 2. You can also put in images in these list items. So suppose we were to put in some images of Shadow Fiend, Storm Spirit, you would just put an image out here and you would put the source. Now I don't really have images, but you can also put in the URL of images. So let me just show you how to do that. So let's see, Shadow Fiend. Let's go into the images. Let's find something small, like let's say 300 x 300. Okay, so this looks like a nice cartoonish figure. So we open this image in the new tab and we copy down this link. So you can see the source is this link. Let's save it. Let's see if it shows up. Yep, and now this thing shows up just outside Shadow Fiend. You can also put in some styling or some attributes, like let's say width is going to be 100 pixels and height is going to be 100 pixels. So let's save that now. And now it's a much smaller image of Shadow Fiend. Now we have other types of tags also. So these are called div tags. So div tag stands for division. So to divide your page into separate parts, you could say this will contain the footer. So footer tags are normally coming in the end. Now you could also have a div tag in the beginning, and this could contain the header. So these tags will contain the header. This is, so let me just put in some header. So this is the header and this is the footer. So this is the header. Headers always come on top, and this is the footer. Now you can also create forms using HTML. So let's go ahead and create one. So our form is going to be called a registration form. Okay, so now let's put our form in a div first of all. So let's give our div an ID. So IDs and classes are actually used to select stuff on an HTML page when you're styling. So to understand more about IDs, check out our CSS tutorial. Let's give this ID form, or registration form rather. Then let's go into our div and create a form. Our form will always stay inside our form tags. Now that we have done that, let's understand the elements of a form. Firstly, we need an input. So first input will be of type text. Let's say its name is going to be first name, and we'll have a placeholder like something like this, say aria, and we will always be requiring it. So if you say required, that means somebody will, if he's actually inputting stuff into the form, this is a mandatory field. Okay, so let's save that and see. So now we have a registration form called aria. Okay, so we also need labels. So let's go ahead and create one. So label, so for first name, and this is going to say first name, and it's going to have a colon. So now there's a label called first name. Now we can do this for last name also. So let's Control C, Control V. So it's going to be last, this is going to be last, and this is also going to be last. And we want to put a placeholder for Paul, and this is also a required field. So now we have a last name with this placeholder. We can submit stuff into that. Now form also takes in two important attributes I forgot to mention. So one is the action and the other is the method. Now action is something that will happen when you submit this form. So you can run a script, something like script.php. But for now, that's for another session. Okay. Now there are other types of inputs. So let's see, let's create another div. Now suppose you want to input the gender also. So let's see, let's first create a label, and let's also create an input type. So input will be type of radio, and this is going to be called gender male, and let's also give us a value of choice 1. Save it. Now you want a label and you want to give it the attribute for, and you want to give it the name out here. So let's put in that. So gender male, save that, and let's write male out here. So let's save that now and let's see what it looks like. So now we have this thing called male. We can check it and we can uncheck it. Now let's create for female also and others. So let's see, let's call this female, and this is going to be of type choice 2. Now we have male, we have female. But if you see, we can actually select both of them or all of them, so that's not something we want, right? So let's make this choice 3. Let's make this other. Okay, now we have a gender submission going on, so male or it's female or it's other. Now we can't really select everything, so how do we actually solve that? So let's give them all the same name. So we can call it gender choice, save it. Now you either go male or you go female or you go other. You can't really select the same thing. So that's how you make that happen. Okay, now let's look into some other types of input types we can take in. So let's create another div. Suppose you want to take in the email address. So let's go ahead and copy that. Let's put it out here. Let's say, so label for, let's see, first of all, we need to change this type to email. And we will also give this a name of email. Let's put in a placeholder instead of a value. And it's going to be something like, let's put xyz@email.com. Okay, now we have this thing going on. So let's change this label to email, and let's change this label to email too. Now we have this thing going, and we can type in our email. And we'll also need to type in a password for registrations. Let's call this password. Let's also make this password. The type is going to be password. And let's remove a placeholder because passwords don't really have placeholders. Save that. And now you see, when you type in a password, you can't really see anything. That's how you make a form that inputs a password. Okay, so that was how you take in emails and passwords in a form. Now there are some other stuff that I want to show you. So let's dive right into that. So let's create another div. Okay, so first of all, we need a select tag. So select tags are used for making selections. So let me show you how that works. So firstly, let's give this a name and let's call this birthday, or let's call this the month. Now we'll also need a label for this. Let's create a label. So our label is for month. Let's call it birthday. Now our select can have various options. So you're basically going to put in a bunch of options out here. Let's see, option. Now we need 12 options actually. That's 3, that's 6, that's 9, that's 12. Delete these out. Just read in my lines. Now our options are going to have values. So our value will be something like, fine, so let's say Jan, Feb, March, April, May, June, July, August, September, October, November, and December. And you could say January out here, February. Let me just create this quickly. March. Let's save this. Now let's see what this looks like. So we have this birthday thing, and it has all the months in there. Okay, now out here, if you see, it already comes with a default value of January. Now you can also mitigate that by putting in another option called default. Let's put another option, so now that we have an option, let's give this a value 0, and let's say selected disabled. Now if you reload this, there's nothing, but you get all these different values. Now instead of just making it blank, you could say that this could say month. So now this says month, and you could create something similar for days also. So for days you need to create 30 of these, and I hope you get the logic of creating this thing. Now our form also needs a button to submit, so let's go and create that. Also, let me show you another type of input. So let's say input, and the type will be check box, and the name will be agree. And let's put a label for this, a for agree, and I agree to all the conditions of the form. Now we will have this thing going, and we have a checkbox. We could check it, we could uncheck it, something like that. Then all we need is an input. Not an input, we rather need a button. Say button, and you say submit, and you also have to give this a type. So this is going to be of type submit. So once that's done, we see this button and we can submit it. So if you go and submit, you'll see please fill out this field because it's a required field. And that's all that is there, the forms. So that's how you create a form in HTML. You can also create tables in HTML. So let me show you how to do that. Let's reload and make this blank. Save it. Yeah. So our tables are created with table tags. Your table, and tables have table datas. Okay, so we can also create tables in HTML. For that, we need table tag. Now, table comes with the table header, first of all. So this will contain all your table headers. So suppose you are creating a table for dogs and the breeds. So th dog, and you can say the dog also has a name and breed. So this has created a table header now. So let me just show you what that looks like. So now we have the dog name and breed. Now we can just simply go in and put in some table rows. So for the row, you say tr, and in every row you will have to put in some table data. So for that, you use a table data tag, so td. So let's say our dog is called, so let's make this rather dog owner name, right? So I had a dog and my dog's name was Stoner. Let's call him Stoner. And Stoner was a street dog. So let's just keep the breed as street. Okay, so that was one table data row. Save it. Now we'll be needing multiple table rows. So let's just copy that, paste it multiple times. So let's say my friend Shubham, he has a dog called Goldie, and it's a retriever. And then I also have this friend called Ayushman. He has a dog called Duke, and it's husky. And then there's this guy called Ishan. He has a dog called Monster, but it's a pug. Yeah, so now we have successfully created a table, and you guys can see dog owners are Arya, Shubham, Ayushman, and Ishan. Their name of their respective dogs is Stoner, Goldie, Duke, and Monster, and the breeds are street, retriever, husky, and pug. So that's how you create a table. Now with CSS, you can add a border to this table. So let me show you how that's done with a little bit of CSS. So let's say style. Let's say text/CSS. Now out here, you could just do some little styling. Let's say, let's give our table a border of 1px solid black. Now our table will have a border, and we can also give TDs a border, and they're gonna have 1px solid black too. So now everything has a border, and our table looks much neater. Yep, so that's how you create a table in HTML. Okay guys, so now it's time I actually show you how HTML can be really polished sometimes. So let's go ahead and create a blog. So for this blog, I've already created the CSS out here. So I'm not really going to be explaining the styling part, but we are going to be creating our blog. So let's go ahead and see how that looks like. So first of all, let's delete everything. Let's create a page now. So let's call this blog. Now we'll be linking our style sheet out here. So for linking our style sheet, all you have to say is something like this, and then we go ahead and copy my style sheets. The desktop, we're doing our stuff in HTML demo. Let's copy this here. Right. Now our blog.css is going to be here. Now let's go and start creating our blog. So firstly, let's put everything inside a div. Now this is going to have a class called post because I've used the class to actually style some stuff. Now that's done, so let's have another div. So this is going to have a class called date, and we're going to be putting in the date. So let's say our date is going to be October 24th, 2018. Now let's say we have a heading. So let's say Vancouver, my favorite city. Then let's put in some paragraphs because every article needs a paragraph. So for paragraphs, you're just going to be filling it with some lorem ipsum. Now a paragraph will have a class called quote. Okay, now let's reload and see what is being made. Okay, so if you guys can see, our blog post is coming up. Now we can also add some images to our blog post. So let's add a link first. So we link to https www.edureka.co. Now we are going to use an image for actually making it clickable. So we already have an image. It's called image1.jpg. So that's there. Let's also put an alt tag out here just in case this doesn't load up. So alt and say Vancouver image. Now let's put in some another paragraphs. So another lorem ipsum and some more paragraphs, I guess, because this is a blog. So let's make it look like a blog. Save that. And let's also give it a horizontal line to make it look neat. Save this. Let's load it. Okay, so we have this nice looking article and it has this image. If we click on this image, it'll take us to Edureka's site. So we go to Edureka if we click that image. Let's add another article into this just to make it a little longer. So let's copy down this div. So let's change the date first because let's say we posted on the next day. Let's change the title. So my second blog post. Save it. Let's remove the image from this one to make it a little different. Yeah. So now if you see, we have this nice looking blog post going on. It has this horizontal line. We have some quote out here. And that's how you can do stuff with HTML.
So guys, before we start creating the website, let's look at the prerequisites. Alright, so first of all, you'll need a code editor. I'll be using Visual Studio Code to type the entire code, but you can use any code editor you're comfortable with. I personally switch between Sublime Text and Visual Studio Code. Alright, now apart from that, you must have a good understanding about HTML and CSS. If you guys aren't familiar with these languages, I suggest you go and read about them. I'll also leave a link in the description so you can go and check out our content on HTML and CSS, and then you can come back and create this website. Okay, so guys, it's important for you all to have a basic understanding of HTML and CSS. So please do check out the link in our description in order to learn more about HTML and CSS. Guys, you don't have to be a master in CSS and HTML in order to build a website. You just require the basic functions and the basic concepts of HTML and CSS to create a simple website. Alright, so guys, I'll be creating a website for you dog lovers out there. Let's take a look at how the website looks. Alright, so guys, this is how the website is. There is a cute little dog in the background. It is basically a dog adoption website. And here you can see there are several buttons, and when you hover over these buttons, they have a background. Apart from that, there is an Adopt Now button, and there is a cute little tagline to our website. So we're going to do all of this from scratch in less than 15 minutes. Okay, so guys, without any further ado, let's get started. Alright, so guys, we're going to begin with creating a new folder. It's always a good practice to store your entire code in a single folder. So I'm just going to name this folder as website, and we have this image of a puppy which I'll be using as a background image for my website. So I'm just going to drag this image and put it into my folder. Now throughout this demo, I'm going to be using Visual Studio Code as my code editor. Alright, I find it very compatible, so it's a good choice for me. Now what I'm going to do is I'm just going to drag this folder that I created and I'll paste it into Visual Studio Code. Alright, so here you can see that there's a website folder with a puppy image. Okay, now let's start with coding HTML and CSS. So first of all, you'll need to create two files. Alright, so first is the HTML file, which I'm going to name index.html. And similarly, I'm going to open a CSS file and I'll name it style.css. So I'm going to begin with HTML tags, of course, and I'm going to add head tags. And within the head tags, I'm going to define a title for our website. Okay, let's name it website using HTML and CSS. Okay, so guys, you can name it whatever you like. This is just the title of the website. I'm also going to link my CSS file in my HTML file. So for that, let's just give the name of the file, which is style.css. Alright, and style sheet. So for those of you who know CSS and HTML, know what exactly I'm doing. Now, like I mentioned before, if you're not familiar with the basic concepts of HTML and CSS, please look up the courses that I'll leave in the description box below. Go through them and then come back to this video, because you only require the basics of HTML and CSS in this website. Alright. Okay, so I've created head tags over here, title tags, and I've also linked my CSS file. Okay, let me just save this and let's go to the style.css file. So I'm going to begin with adding a margin and a padding to the entire website. So that's what I'm doing here. Alright, margin and padding. Okay. Now let's define body tags over here. Within body tags, I'm going to define header tag. Okay. Let's just leave this empty for a while and let's style the header now. Sorry for the spelling mistake. So I've just selected the header. Now what I'm going to do is I'm going to add the puppy image as the background image over here. So background image, and you have to mention the URL. Alright. Now URL here is basically the path to the image. Now since my puppy image is in this folder itself, I'm just going to write puppy.jpg. So guys, if you had this image in any other folder, then you just mention the path of that folder. Okay. So I've set the background image. Now I'm just going to fix the height and background size of the image. Alright. And let's fix the background size. Similarly, I'm going to fix the background position as center. Alright, let's save this and now let's see how our website looks so far. Okay, so I'm going to reveal an explorer and open this file. So guys, this is how our website looks for now. Like, the image is quite clear, but what we want to do is we want to make it blurry because it's a background image, or we want to decrease the opacity of the image. So we'll be doing that later on. For now, let's add the navigation menus. So guys, when I showed you all the website, there was home button and there was about button and all of that. That is the navigation menu of the website. So let's add navigation menus now. Alright, so we're going back to the HTML file. I'm going to define a div and let's give it a class. Right, so I'm naming it top. Okay, this is basically for the navigation menu. Now I'm going to put the navigation menu in an unordered list. Okay, I'll give it a class name as well. Let's name it navigation menu. Okay. Now I'm going to add a list of links over here. So the first one would be, now these are just empty links because we're not coding the back end of this website, just the front end. So I'm just defining an empty link over here and I'll name this as home. Alright, so what I did here was I added an empty link over here called home. Okay. Now I'm just going to copy paste this because we have around 5 such links. Okay. Let's name this about. So usually in all the websites you see these navigation menus which have home, about, or which have contact, services, and so on. That's exactly what I'm doing here. Alright. Let's name this one as breeds. So basically the breeds of the dogs. Okay. Now this can be adoption, since this is a dog adoption website. Okay. And lastly, I'll add contact. Okay. So this is how it looks. So guys, what I've done here is I've added 5 empty links over here. Okay, now let's just save this file. Let's look at how our website looks. Okay. Alright, you can see all of these links are on the left hand side. Now what we want to do is we want to get these links on the top right corner. Okay, we want to align it horizontally as well. Okay, so let's start by doing that. Let's go back to the Visual Studio Code and I'm going to go into the style.css file. And what I'm going to do is I'll select the navigation menu class. Let me select that and I'm just going to float all of the elements to the right. This will just position all the list items to the right. Okay, and let's also set the list style to none and I'm just adding a margin on top. Okay, setting it to 30 pixels. Alright, let's save and let's see if there's any change. Alright, now you can see that all of them are aligned to the right hand of the page, but they're all aligned vertically. Okay, I want them to align horizontally over here. So let's change that. Now going back to the CSS file, what we're going to do is we're going to select the navigation menu. In that, we're going to select all the list items. Alright, what I'm going to do is I'm going to set the display as inline block. Let's see what happens when we do this. Okay, let's save the file. Let's open this up. So guys, I made a small mistake over here. I'm supposed to add dot because I'm selecting a class. In order to select a class, you add this dot notation. Okay, so now let's save this. This will basically align all of the links horizontally. Alright, let's save it and let's see if it works. Alright, refresh. And here now you can see that all of these links are aligned next to each other. Okay, this is exactly what I wanted. Let's add some padding. Let's change the font size, font color and all of that. Okay, so let's go back to our CSS file. Now what I'm going to do is I'm going to select navigation menu class. After that, I'll select the list items within which I'll select the anchor tags. Okay, so basically all the links. Now I'm going to change the color. I'll set it to turquoise. So guys, you can change this and you can do whatever you want. Like if you want to have a different color or if you want to have a formal business kind of a website, you can do that as well. Okay, I'm going to set this to none and let's add a padding. Alright, I'm going to add a padding of 5 pixels by 20 pixels. Okay, now I'm going to set the font. Okay, so I'm selecting the font family. I'm going to add Verdana. So guys, you don't have to do all of this. I'm just doing this so that the website looks more attractive. Alright, you can mix it up and add your own functions, own styling functions. And please do share your website picture with us. We'll be very happy to see your progress in this. So here we just styled all the links. Alright, now let me just open the website and let's see how it looks. Alright, I'm just going to refresh. Now there's enough space between the links and also the color has changed. Okay, but for some reason you cannot see the navigation menu because the background image is too opaque. So let's blur out the background image or let's make it a little bit transparent. Okay, go to your CSS file and scroll up. Alright, go here where you added your image and what I'm going to do is I'm going to add an opacity function to this. So I'm basically going to make it a little bit transparent. Okay, so RGBA where A is for opacity. Alright, alright, so I'm basically trying to set the opacity of the image. Okay, y'all can do this or y'all can set it according to your needs. Okay, so I'm just going to save this and now let's look at our website. Now you can see this entire navigation menu. Okay, so this is exactly what I wanted to do. Now let's go back to our HTML file. So guys, when we're on the website and when we are on the home page, I want this home link to get highlighted. Alright, so for that, let's go back to the HTML file and let's just add a class to this home link. Okay, I'm going to add a class. Let's call it home button. Okay, now that I've added a class to this home link, let's style it. Okay, so let's go to style.css. I'm going to select the home button class and let's add some border to it. Okay, so I'm going to add a border of 1 pixel solid gray and similarly I'm going to add a background color. I'll set it to white. Now let's save the file and let's see if these changes are visible. Okay, open up the website. Yeah. So this basically shows that I'm on the home button. Now I'm just going to add the hovering effect on all of these buttons so that they get highlighted every time I'm hovering around them. Okay, and let's try and do that. So for that, go back to your CSS file and select the navigation menu. All right, and within that, select all the links and add the hover function on them. Okay, and let's give it some properties. Okay, so the border, I'll again set it to 1 pixel, solid gray. Similarly, I'll add a background color. All right, I'll set this to white. Now let's save and let's see if this works. So you see that when I'm hovering around the buttons get highlighted. This is exactly what I wanted. Okay. Now what I want to do is I want to add a tagline to my website. Since it's a dog adoption website, I want to add a cute tagline. So I'm going back to my HTML file. I'm creating a div and let's give it a class. Let's say tagline. All right. And let me define my tagline now. So my tagline is share your home with a cute dog. All right. So let's just save and let's see how this looks. All right. So this tagline has come on top. What I want to do is, because this is a tagline, I want it at the center. Okay. And I want to change the color and the font of this. So let's go back to the CSS file and let's start styling. Okay. So I'm going to select the tagline class and let's add some parameters to this. So first of all, the position, I'll set the position to absolute. All right, I'll also adjust the width. Okay, 1200 pixels, and I'll set the margin on the left and margin top. Now I also want to style this text. All right, now this text is within h1 tags. So let's select the h1 tags first and let's style it. Okay, h1, and let's set the color to white. And I also want to change the font size. I'll set this to 50 pixels, and similarly font family, set it to Verdana. Alright, and I'll also align the text at the center because this is a tagline and I want it at the center. Okay. I also want to set the margin. Okay. So we'll select 275 pixels. Okay. So let me save this and let's see if it brings changes to the website. Okay, so refresh and yes. Okay, this is exactly how I want it. Okay, so you can reduce the size of the font or you can play with it, change the tagline, or have it somewhere else. Okay, so just play with the website, make it look interactive. I'll leave all of that to y'all. I'm sure all of you are creative enough to do that. Okay, and next what I'm going to do is I want a small button over here which says adopt now. Okay, immediately after this tagline, I want a button which says adopt now. Okay, or anything which says adopt or something like that. So for that, I'm going to go back to my HTML file and I'll define another div over here. Okay, I'll give it a class, let's say adopt. Okay, now what I'm going to do is I'll add a link which will say adopt now. Okay, it's an empty link because we're just coding the front end. I'll give it a class. It's always a good idea to give class or identifiers to your HTML tags. Okay, that way you can select them easily and then you can manipulate them. Okay, so I'll name it adopt now. All right, let's save this. Let's see how the website looks. Okay, you can see that this link has come on the left side of the page. Now I want it exactly at the center below this line. Okay, let's style that. So go back to your CSS file and select the adopt class. Okay, adopt, and let's add some margin to this. Okay, so I'm adding a 30 pixel margin, also adding margin to the left. Okay, all right, now I want to style this link adopt now, so I'm going to select this bttn class and I'll style that class now. Okay, so dot button, and what I'm going to do is I'm going to set a border for this. Okay, so 1 pixel solid white. Okay, I'll also add padding. Okay, we'll set this to 10 pixels by 30. Okay, apart from this, I'll make the text as yellow. Okay, so I'm setting the color of the text to yellow, and I'll also change the font. It's always good to know different functions in CSS. There are hundreds of styling functions. Okay, the more you know, the better it is, because that way your website, it'll look more interactive because it'll have a lot more styling. So guys, don't add too much of style. It might look too congested, but it's totally up to you. I mean, y'all can do whatever you like. Okay, so I'm setting the font size, and let's also set the text decoration to none. Okay, so I'm going to save the file and let's refresh this. Alright, so now you can see that there is a button called adopt now. I want to add the hover function over here as well, so let's go and do that. This is going to be the last step of our demo today. We're almost done. So first of all, select the div, and then I'm going to select the link, and I'll add the hover function. Alright, so I'm just going to set the background color. I've already given it good border, so I'm just going to change the background color. I'll set it to burly wood. Okay, save the file, and let's open up our website. So when I hover around this link, this background color changes. Okay, it's just like what we did over here. So guys, this is exactly how the website looks. Alright, so you can go ahead and change anything you want. You can change the font. You can have a website of cars, or you can have a website about cats. It's up to you. But this is how you create a simple website. I hope all of you enjoyed coding with me. And also, if you want to make your website more interactive, for that we use JavaScript. So if you want to add any motion in your website, then you'd use JavaScript. You can check out our content on JavaScript and jQuery. Now, jQuery is basically a JavaScript library which makes it very easy to use JavaScript functions. Okay, so I'm going to leave a link in the description about jQuery, JavaScript, HTML, and CSS. Okay, so you can go ahead and add motions in your website and make it more interactive.
So what exactly is CSS? Well, CSS stands for Cascading Style Sheets and is generally used to control how HTML tags and elements are displayed on your screen. So this means basic styling of your web page is controlled by CSS. Now, CSS was actually made to solve problems that were introduced in HTML 3.2. Now, HTML 3.2 got in some new attributes like font color, background color, which generally was pertaining to styling of an element on a web page. Now, while this did add some very needed functionality into HTML 3.2, it cluttered up your code as a developer and made your life pretty miserable. So to keep the structure of your web page, which is the HTML, and to make the styling a different aspect, CSS was made by W3C. So W3C stands for the World Wide Web Consortium, and CSS till date is still being maintained by the W3C developers. Okay, so that was a general introduction to CSS. Now let's move ahead. So this is the basic syntax of CSS. You basically have selectors, which selects or targets the place that you want to attach your styling to. Then you have basic properties and value pairs. Now you can include your CSS into your HTML with a link tag while putting the href attribute as the file name. Or you can do some inline CSS, but that's not actually recommended because that's the problem that we are actually trying to mitigate by putting CSS as a different file. Also, if you don't want to create another CSS file, you can do some internal CSS by putting in some style tags in your head tag and just writing some normal CSS to it. Okay, so now let's see the different types of CSS selectors. So these are all the different types of CSS selectors, and basically a selector is a way of targeting an element on a web page. So the star selector selects all the elements and applies the CSS that you would apply to it. And then if you would say div, then it would apply your CSS to all the divs. Now div comma p will apply to all the divs and paragraphs. Div space p will put your styling to all the paragraphs inside divs. Now going through all the CSS selectors is a pretty cumbersome job, so I recommend that you go through this page on W3 Schools, which has all the different types of selectors and the different types of pseudo selectors all listed out. So this will very much help you when you're doing your own CSS, so always keep this page open. Now just for basic sake, let me just tell you about pseudo selectors. So we also have pseudo selectors, which is defined something like this. So pseudo selectors include stuff like hover, active, visited, and stuff like that. Now suppose you were hovering over an A tag, so you can say there is supposed to be some specific styling when you're hovering over it. So how would you do that? You would just say A:hover, and then you would actually specify the styling that you want. Now you can also find all these types of pseudo selectors out here, and it's all listed out here. So A visited, like select all visited links, something like that. Now I also want to make you all aware of the box model that is very much used in CSS. Now box model has 4 things: the content, padding, border, and margin. So content is the basic content of the web page that you want to show to your general audience. Then the padding is the space between your border and the content itself. The border is a line that can be of any size, color, and width. And then there's a margin, which is this distance from the edge of the screen to the border. Okay. And now the box model looks something like this. So the content comes in between, then comes the padding, which is between the border and the content, and then there's the margin, which is between the screen and the border itself, the screen edge and the border, right? So that's how the box model works. Now the last bit of basics is the CSS units. So there are 4 kinds of units. Firstly, we have the pixel. So pixel represents any pixel on a device. So you could say something like font size is equals to 25 pixels, so it'll make it actually 25 pixels. Then there's also points, which is mostly used in print media. And all you need to remember to use points correctly, that 72 points equals 1 inch. Now the last 2 types of units are relative units. Now these are relative to your current font size. So 1 EM or 100% is actually equals to your current font size. So if you want something to be double your font size, all you have to say is 2 EM. So these are how relative units work in CSS. Okay, so that was all the basics of CSS and how you select stuff and all the units. Now let's get ahead and code some of our own CSS. So for this time, I've actually created a bunch of HTML pages, and we're going to style these HTML pages by adding some CSS into them, and this will stand as good practice for CSS alone. Okay, so for the first page, we have this page called page1.html. And it's a pretty basic page. Let me just open it up and show it to you guys. So this is what it looks like without any sort of CSS being attached to it. Now we're going to create some CSS and we're going to try and practice, first of all, selecting stuff in different ways possible. Okay, so firstly, let's do some very random CSS. Okay, firstly, let's target all the divs in this HTML. So how would you actually do that? Well, you'd say div by going selectors, and let's actually save this as a CSS file first so that our syntax is colored properly. Okay, so that's a div. So that's how you select any element in CSS. Now suppose we were to say background color, or rather just background, it'll be purple. And the text or the color of the text will be white. So now everything inside a div will look like that. So now let's just save this as page 1. As it's saved as page1.css, let's reload our page. And everything that is inside the div now has a white text, and it also has a purple background. Okay, now let's see how we actually select IDs. So we select IDs with the hash. So we have an ID called quote out here if you go and see. So where is that thing gone? Okay, so this paragraph out here that you see has the ID called quote. So we're going to select that and put in some of our own CSS. So let's see. Now that we've selected our ID, we can say, suppose we want to change the font family. So we could say font family is Verdana, and you could also put in alternate font families just in case Verdana doesn't exist in your system, like Gill Sans. Fine. So that's how you set up your font family. Let's also set the color to be black. Let's see what changes now. So this is the code that I was talking about. So that font should change now. Let's reload. Oh yes, now the font has become Verdana, and that's what we exactly wanted. And the text is also black now. Okay, so how do we select classes now? So if you go here and see, we should have a class called movies. Right. So all these have a class called movie, all these A tags. So let's select them. First of all, to select a class, you say dot, and then you say the class name. Now we could put in some random CSS into this again. So let's make the color, let's keep it white, and let's make the background steel blue. Let's see. So where are our movies? Let's see where the movies actually exist. Oh yeah, Dota, Splinter Cell, and God of War. These are the movies, so these should now change. Let's save it. And now they have a background color of steel blue and they have a text color of white. And that's exactly what we defined out here. Fine. Now let's try out some other kinds of selectors. So suppose in the span out here, we have this ID called author. So what if we only want to target that? What would we say? So we could say span and hashtag author. Now you could put any type of CSS. So let's say text transform. So this is how you transform any sort of text, and you could say uppercase. Now the author will be changed to uppercase out here, and this is the author, the Pope Alexander part. Now watch that. Now it's just uppercase, and we have selected it with this selector called span and hashtag author. We can also do some other kinds of selecting. Let me just show it to you. So we could select the LIs of the unordered list or the ordered list. So our skills is the ID. This is the ID of skills. So let's select them now. So we have skills, and we could go the ordered list and then the LI. And what we want to say out here is the color will be purple. We can do the same thing for the unordered list too. Let me just copy that down, put this here, say unordered list, and let's say we change the text color to white. Save that. Let's reload our page. So wait, first of all, let me uncomment this. Now let's save it again, reload our page and see the differences. Now since we had given it a purple color, it's now all purple, and let me just put a background of white so that you can see it. Yeah, now these are purple and these are background white. We can do the same for the unordered list too. Let me just uncomment that. Let me also give it a background of purple. Or actually, let it be like that. Let's just make it blue. Now SAS and Hamel have turned into blue, as you see out here. This is the blue thing. Fine. Now that was selectors. Okay, now let's go ahead and select some other stuff. So what if we want to select all the paragraphs that are after the h3 tag? So if you remember, we can do that by saying h3 plus p, and let's say we want a background of black and some text color that is white. So color white. Not being very creative with my CSS at this moment because this is just about selecting. So let's see how that reloads. Yep, now we have a color of white and a background of black. And that only selected the paragraph just after the h3, which is my favorite video games. Okay, we can also select every paragraph that has a class by just saying something like p and class. We don't even need to specify the color, or I mean the class name. So you go background, let's say we want to give a gray background. Let's see all the paragraphs of the class. So this is the only paragraph with the class. Now you can do the same thing for IDs, just say ID out here, and let's see all the paragraphs with an ID. So this is the only paragraph with an ID. Okay, so now that we're done with selecting stuff, let's go and actually see how text can be transformed with the use of CSS. Fine. So first of all, I already have a page created for that. So this is going to be our page that we are going to use to see how text is transformed. If you see, I have an ordered list with all the types of text transformations or the text stylings that I want to show. And we also have a paragraph out here which will show the basics box elements like the borders, margins, and padding. So I'm going to demonstrate that through this PID out here. Right, so let's get started. First of all, let's create our CSS file, and in the CSS file we're going to save it and we're going to call it page2.css. Right, then yeah, it's connected as page2. So let's get started. So first of all, let's target this ID with lorem. So lorem ipsum is just some Latin paragraph that is normally used in web development to fill in spaces with text, where you can always come back and delete that text and fill it with something more meaningful. So for now, we are going to be using this lorem ipsum thing. So it's in a paragraph tag with an ID of lorem. So let's go ahead and select it. So we're going to select it with the help of the ID, call it lorem. Now, first of all, let me just show you what the page looks like without any CSS attached to it. So this is what the page looks like, right? So this is the part that we are going to target right now. First of all, let's give it a background of black. Let's make the color of the text white. Let me show you what that looks like. Okay, right? Now let's give it some borders and padding. So first of all, to give a border, we could say we use the border property, then we give 3 parameters: the type of the border, the size of the border, and then the color. And you do it something like this: 3px solid red. Now, apart from solid, there are a lot of types of borders, and those include dashed, dotted, rigged, and many more. These are the ones that are just from the top of my head. So you can try them out, and you can find other types of CSS border just by going to Google and saying CSS border types. So these are all the types of borders that you get, and you can definitely check them out. It's impossible to show everything in one video like that, so let me just show you the solid type. So let's save it and let's see what kind of border we actually get. Let's close this down. Yeah, now we have this neat little border of 3 pixels in size and red in color. Now let me just show you how dotted would look like. So this is what dotted looks like, and this is what dashed looks like. Fine. And this is what dashed is. Okay. Now let's also give this thing some padding. Now padding exists between the content and the border. So I just explained the box model when we were discussing the basics of CSS, so I hope you remember that. So for padding, there are 4 parameters actually: the right, top, left, and bottom. So you can define your padding something like this. You could go 13 pixels, 13 pixels, 13 pixels, and 20 pixels. Now these are just very arbitrary numbers, but what I want to explain is that this first part will mean that there's 13 pixels of padding from the top, and then we move in a clockwise fashion. So this is on the right, this is in the bottom, so 13 pixels of padding in the bottom and 20 pixels of padding on the left. Now you could also say this really easily if you want to give equal amounts of padding, suppose. Now this means that there will be 13 pixels of padding on the top and bottom, and this second part would mean that there's 13 pixels of padding on the left and the right. And if you just put 1 digit, that means there's 13 pixels of padding all around it. Now let's go and put these different paddings around lorem ipsum. Now it looks much neater. We can also put a margin, so let's put a margin, and the margin also works in the same way. So suppose you were to say 5 pixels, that means it would give a 5 pixel margin all around your content. If you were to put, say, 10 pixels and 20 pixels, this means that 10 pixels of margin on the top and bottom and 20 pixels of margin on the left and right. And there's also another keyword that I want to make you aware of, and that is auto. So what auto does is it gives equal amounts of margin however you specify it. So out here it'll give 10 pixels of margin on the top and bottom and equal amounts of margin on the left and right. So let's see how that works. Yep, so that's how it changed it. Now that was all about the box modeling. So let me just remove this part from the HTML, and let's remove this part from the CSS. Now as you guys can see, I have this ordered list out here. First of all, let me reload the page. Now I have this ordered list out here, which shows us all the types of styles and weights and sizes that I'm going to be showing right now. And this will include a lot of the units that we discussed, like ems, points, pixels, and percentages. So let's move ahead. So to select these, I'll be using these IDs. So let me just remember the first 4 IDs is normal, italic, oblique, and small cap. So let's go ahead and create them. So firstly, let's select our normal ID and say what are we going to try and show here is font style. So all you have to say is font style is normal. So normal basically means that the font style will be normal instead of something bolded. Then I think we had italic, so you go font style italic. Then we also had oblique, so we go font style oblique. And we also had small caps. So let me just see that again. Yep, it's small cap. So you go small cap, and what are we trying to show in small cap is the font variant. So font variant small caps. So let me just reload and see how that changed stuff. Okay, so font style normal just stays normal, while italic and oblique are almost similar. Then in font variant small caps, this is how it would look like, where the first letter has a bigger font size and the rest have a smaller font size, but everything is in capital. And next is the font weight. So let's see the IDs. It's normal, bold, bolder. So let's go with that now. So firstly we have normal. So font size is the size, or weight? It's weight. So font weight will be normal. Next part is bold, bolder, lighter. Okay, so we select bolder like that. We go font weight is bolder, and we can say again, let's what's after bolder, it's bold. Okay, so W bold, and you go font weight is bold. Let's see how that changes stuff. So yeah, bold is bold, and font weight bolder is slightly more bolder, while font weight normal is absolutely normal. Right, time for some more. So the next is the font size, which goes from extra large, large, medium, small, extra, extra small. So let's do that. So first is extra, extra large, and this is the font size that we're talking about. So it's extra, extra large. There's also extra large. So extra, extra large looks something like this, while only extra large looks something like this. Fine. Then we also have large. So font size will be large. So that's font size large. Next we have medium, small, and extra, extra small. So medium, small, and extra, extra small. So this is going to be font size medium, this is going to be font size small, and this is going to be font size extra, extra small. So let's see how that changes stuff. So this is extra, extra small, this is small, and this is medium. Now the next thing that we're going to see is how points work. So our size is going to be 25 points. So instead of just doing that, let me just change extra, extra small, and let's say it's 25 points. You should remember that 1 point is around 2 inches. So that's how font size extra, extra small would look like if it was 25 points. Then we could also say the font size is 150%. So that shows us how percentages works, where 100% means the current font size. Look at the change, and that's how 150% means. The next thing that we want to show is line height. So let's say, what is the ID? Let me just check the ID. So the line height IDs are line normal, height 25 points. So let's just select one, line normal, and this is going to have a line height of normal. Let's put a semicolon, save it up, and that's how line height normal is. That is the normal line height. Now you could say your line height is 25 points, and that's how it would change. Also, you could say your line height is around 25 EM, or just 5 EM, let's say that. And that's how it would change even more with EM, with 1 EM being the constant font size that we are using. Or you could say line height is 200%. That is basically twice of what our line height or font is. So that's how it would change, right? So that was all about text styling. Now let's move ahead and see how positioning and stuff takes place in CSS. So for positioning, I have again gone ahead and created this page3.html. So in here we will be including a CSS page called page3.css. So let's go ahead and create that. First of all, we have to set this to CSS, save it as page3. And let's get started. So first of all, we have 3 types of positioning in CSS: absolute, fixed, and relative. So first of all, I'm going to show absolute positioning to you guys. Now before I show absolute positioning, let me just show you guys how text and stuff can be centered first of all. So let's start doing some random CSS. So first of all, we are going to target this ID called container. So let's go hashtag container. And let's go to background, some random color. So for color picker, we just go color picker. Let's give us this background, go OK. That's the background we chose. Let's also give it some borders. Border will be 2 pixels, solid and black. We can also set up a border radius. So border radius gives you a curved border. So you could say border radius is around 5 pixels, let's say. Now let me just open up the HTML file that is concerned at this moment. So this is page 3. Okay, so this is with some CSS. Now let me just uncomment that CSS first. So this is what our page would look like without any sort of CSS. Now this is what it looks like with the CSS that we just included. Now to make you aware of how box radius works, let me just uncomment that first. Let's comment it out. So box radius should not work, and we should get, yeah, now if you see, let's zoom in out here. You see that this border is pointed. Suppose we don't want that to happen. Let's remove that first, and let's uncomment this. Save it. Let's reload, and now we have this slight little curved border which looks much neater. Okay. Now we can also center stuff. So a neat way to do that is, let me just show it to you. Let's take this part called centered. Now to center it, let me just give it a first background to make it look different. So this background will be, let's say, 89 CFF0. So that's our color. Let's see what our color looks like. So that is the color that we are gonna center. Now let's say our width is gonna be, we can set the width of elements like this. So you say width is 50%, and then you go margin is going to be auto. So what does auto do? It'll put an equal margin on all sides. Let's reload our page. Yep, and now it's centered. We can also center without actually centering the element. We can just center the text by just saying text, align, and center. Fine. Now that will remove the background and just keep the text out here. So that's exactly what we wanted, and that's how you align your text. Okay, now let's move ahead with absolute positioning. Now absolute positioning means positioning based on the document itself, which means this whole web browser. So a browser is basically the document that you are actually manipulating. So it's called document object manipulation, if you've heard of that term. So let's go ahead and let me just show you how absolute positioning works. So first of all, we have this element called top left, and we're going to try and put it on the top left. So let's select that first. So you go top left. Now let's give it a background. Okay, that'll going to be the background. Let's also give it a border. So let the border be 1 pixel, solid and black. Let's say now to position something with absolute positioning, all you have to say is position is absolute. Now let's also keep the width around 200 pixels and the height also around 200 pixels. Let's save it. Let's see how stuff changes. Let me just zoom out. Yeah, so that is our element. So this is what top left and bottom right is going to look like. Now we are going to try and select this element and put it in the bottom right of this parent. So let me just show you how that is done. So to select that, I've already created an ID for it, and it's called bottom right. Let me give it a background of white, and you say the position is absolute. Now we want to change the position to actually inside the element. So we have to say it's going to be 0 pixels from the bottom and also 0 pixels from the right. So since it has absolute positioning, it's going to position this inside of this. So first of all, let's give it a background of white and also make the color black. Right. And now we have this right where we want it. Now there's also something called the z-index. So z-index is what comes first on your screen basically. So if you have multiple things that are stacked on top of each other with absolute positioning, the one with the most z-index will be the one that is shown on top. So you could set a z-index like this and say the z-index is 5. So anything with a z-index of 4 will actually come underneath this thing, right? So that was all about absolute positioning. Now let's go ahead and do some fixed positioning. So for fixed positioning, we have this ID called fixed, which contains a paragraph saying I'm staying right here. So let's select that first. Let me just remove all this stuff so that it's not cluttered anymore. Let me reload the page, save it, reload it, and that's how. So I'm staying here. First of all, this is what is going to change. Fixed positioning, right? Is that what we called it? Fixed position, okay. Now first of all you have to say is position is going to be fixed. Now let's make it more prominent by giving it a background of black and a text color of white. So let's see, this has become black and position is fixed. Whatever I do, if I'm scrolling, it just stays there. It doesn't really matter what I do to this thing. Okay, so that was all about fixed positioning. Now the next thing that we're going to see is relative positioning. So for that I already have two elements created. So let's say these are the divs, which says this is going to be relative. So relative positioning, as I was just saying, is positioning based on the relative position of the element. So let me just show you. So relative 1. Now let's go to background first. So let's just select some color. Let's make this green out here. Okay, that's gonna be our color. Let's give it a border of 1 pixel solid black, and let's say the height is going to be around 100 pixels. Now we're going to select another element and position it relative to this element. Okay, so that is this element right out here is going to be relative to. So to set something with the position of relative, all we have to say that the position is relative, and the rest of the CSS is just arbitrary. So let's say left, not padding left. So you want to position it somewhere left of it, and the positioning is going to be relative. So 20 pixels from the original positions, 20 pixels to the left from the original position, I mean. And you could say from the top it would be around 30 pixels. You could also say negative 30 pixels to move it the other way around. Let's give it a background. I'm already given it the background. Okay, let's give it a background of yellow. So you say background equals yellow, and you could also give it a border and say 1px solid blue. Let's get a blue background. Okay, so this relative layout is going to be positioned relative to this thing. Fine, let's just reload and see. Yep, and that's how relative positioning works. Now this might just not look neat at this moment, but I'm trying to drive a point home. Fine. Okay, now let me just see if I have dog.jpg. Okay, there's a PNG file called Edureka. So let me just show you something cool. First of all, let me just remove everything from here. Okay, so now that our things are less cluttered, and let's me just rename this now to the image that is already there. So edureka.png and edureka.png. Fine, let's save this. Let's see what our page looks like now. So this is what it looks like. Now you can float stuff like images to the left and right. So let's just select the image tag, and suppose you say float them to the right. These will float everything to the right. Now that's how you position stuff or images, with the float tag. So I guess that was all about positioning of stuff. Now let's move ahead. Okay, so in this part we are going to be learning about overflows. So for overflows, what we can do, let's go back to page2.html, and we have this text out here, or this unordered list, and this list is pretty big. Right, first of all, let's open up a new page, or rather let's open up okay, wait, let me just close these out. So let's save this as page2.css, or rather let's just call it something new. First of all, let's set this to CSS. Right, let's save it, and let's call it overflow. Now what I want to show you guys is something really cool. So let's select the ordered list. So that's what we're going to select. Let's say it has width of around 100 pixels. It has some padding from the top and right. So let's get some padding of 10 pixels and 10 pixels all around rather. Let's give it a margin of 100 pixels and auto. So I'll bring it right to the center. Let's see. So it was page 2 that we're fiddling around with. So this is page2.html. Now let me just replace this with overflow.css. Let's see now. Yeah, so this is what it looks like. Now if you see, to scroll through this list is quite cumbersome because you have to actually scroll like this. Let's give it a background also. Background is going to be black, as I just love black, and the color of our font is going to be white. See how that changed? Yep, so this is what it looks like. Now what if you do and say max height is equals to 500, or rather only 200 pixels. Yeah, so that doesn't really do much. So if you say overflow is auto, you get a scrolling bar. or you could say overflow is scroll. Let's remove this max height. Now you see we have these little scroll bars out here, and that's what exactly overflow does. It's basically shows us the items and you can scroll through them. Yeah, basically like that. So if you were to say that the width is only suppose 50 pixels, let's say, make this even smaller. Yeah, so that's how now you have this little scroll bar that lets you scroll through stuff. So that's how overflow works. Okay, now let's look at some pseudo selectors or some pseudo classes that we can select and style. So first of all, let me open up the page that is going to be responsible for that. So we have this page out here that I've created. Now it also has some new tags that you might be seeing. These are some HTML5 tags. So header tag, nav tags, and then the main tag. These are just some new tags that you see in HTML5, and you can also target them through CSS3. So targeting them is pretty easy, but what I want to show is something pretty cool. Let's save it first. Let's create a new page. Let's call it CSS. Right, so let's save this first as page5.css. Okay, so now it's time to practice some more CSS, and we'll be doing it on this page that I've created. So this page is kind of a big page, to be honest. It has quite a lot of paragraphs, quite a lot of links, a few images also, I guess. And they use a lot of the HTML5 tags that have been newly introduced, like the header tag, the nav ID, or the nav tag, the main tag. We have section tags, and a lot of other tags like these. Now these tags can also be selected with the help of, let's say, CSS3. That's what we are learning. Okay, now let me just remove this part because we won't be needing that. Now let's go ahead and save our content, and let me just show you what this actually looks like on the web page. So let's go ahead and open up page 5, and this is what it looks like on a web browser rather, without any CSS attached to it. So let's transform this thing with the help of some CSS. So firstly, we've created this page called page5.css, and we've already attached it to this page out here with the link tag and the href attribute. Now let's get started. So first of all, let me just actually make use of some pseudo selectors. So we have already discussed pseudo selectors while going over the basics. Now let me just show you how they work. So a hover is going to target all the a links while we are hovering over them. Now when we are hovering over them, we want the background to become black and text to become white. Right, so let's save it, let's reload. Now if we hover over these, the background becomes black and the text becomes white. Right, now the same thing can be done with a lot of other selectors, like this is active. So when you click on a link, that means it's going to turn like that. So let's save it. Let's see. Let's reload our page first of all. Now you see when we hover, nothing happens, but once we click it, it becomes that black and white kind of thing. Right, we can also do this for visited, and that will actually change the link once it's been visited. So if we go and do this, open link in new tab. Well, it's not working out here, but if there was actually a database connected, you would actually see this to them. Now suppose we want to select our body. Let's give it a background first of all. Get out the color picker. Let's give it a nice green background. Okay, now that's going to be our background for the body. Now we also have a div with the ID of wrapper. So let's go ahead and select that first. So we say wrapper. Now let's give it some CSS. So we're going to say margin is going to be 0 and auto. Now whenever you say 0, you do not need to actually specify the units, so we can just do that. We'll give it a background color of white. Then we'll give it a width of around 800 pixels. We'll give it a height of around 1000 pixels. Okay, now let's save that and let's see what it looks like now. So this is what it has turned to. Now we can also do some more stuff. So let's select some HTML5 elements like the header tag, and let me just show you that CSS still works as we want it to. So let's give it some simple padding around 0 pixels on the top, 0 pixels on the right, and we want to give some 10 pixels on the bottom and 0 pixels on the left too. See what changes. Now we got that little change. We can also select stuff like with the IDs as I just showed you. Now let's select the navigation, which has the ID of horse nav. Let me just check if I'm right. Yep, it's called horse nav with the N being capital. Now we can say stuff like So there's also the display attribute. This shows how elements will be displayed. Now they can be blocked or inline block, which means it'll be converted into an inline element. Now we could say display is blocked, and you could just give it some background just to make it more apparent. So let's give it a background color of black and make the color white. Let's see. Yep, that's how it's selected. Now you can also give pseudo tags like this one out here, like visited, to IDs too. So let's say once we're hovering over the nav bar, we want this to happen. So let's save it. Now if we only hover over it, will the change happen? So that's how that works. Now let's go over and see some word spacing. Now word spacing is used for mostly specifying the words. So let me just remove some stuff from here. First of all, let's remove all this. Right, let's remove the header tags, and we just need this part where we have all these paragraphs. So I'll be targeting the first paragraph to show you all word spacing. So it's going to be this one out here, right here. Fine, let's save it. Go ahead here, reload the page. Now this is what it looks like. Let's remove everything that we have already created, and let's just select para 1. I hope that's what it was called out here. So it is called para 1 indeed. Now we could go word spacing and just say, let's give it 10 pixels between the words. Right, so the spacing between these words in this paragraph should change now. Now that we've saved it, let's go ahead and reload. So yeah, now you can see that the word spacing for this out here is much more different. Now we can also do letter spacing the same way. So let's select paragraph 2 for that. So for letter spacing, all we have to say is letter spacing, and then we could say something like 10 pixels. Now this will specify the letters and how they're spaced. Now you can see it looks, this horrible thing is having 10 pixels of letter spacing. It also put some word spacing into this, so let's see how that looks like. Let's put word spacing of 20 pixels and make this even more ugly. Yep, so that's what it would look like with word spacing and letter spacing. So that was just for experimentation purposes, and you can use that whenever you feel free to. Okay, so another property that I want to make you all aware of that is in CSS is a clear property. So the clear property makes sure that nothing actually appears before it. So in this case, the footer tag, which is right about here, which says only the copyright part. Now it is shown here. This is the footer tag that we are talking about. So we want to say something like, let's say, so you can say clear and both. So that's how you specify clears. Okay, so let's give it a background color of black. Let's also say the color of the text will be white, just to make it a bit more prominent. Yeah, so nothing actually appears before that. So that's how you use clear now. So there's also style types, also list style types. So let me just see. We have these lists out here, first of all, which says random 1, 2, 3, random 1, 2, 3. Now let's say, first of all, let's convert this into an unordered list. So find all, let's gonna replace that with unordered list. Right, I just want to show it with unordered list first. So let's say, let's select all the ULs and let's say list style is gonna be none. Now if you see out here, we have these bullet points, and now we don't. Okay, so you can also do these with ordered lists. So let's go back and let's do control and UL, find all. Let's select them, let's make them OLs, ordered lists. Let's see. Now OL doesn't work with list type none, if you just realized. Now we can do something like alpha, lower alpha. So let's see that, how that works. Okay, so for lower alpha, we have to say list style type. Please remember that, that was my mistake right now. Okay, if you have to select the OLs again. Now you see that we have these list types that is saying with small caps. Now there are other stuff like lower Latin, there's also lower Latin. So let me just show you what that looks like. Save it. Okay, that doesn't really change because I don't think I have Latin installed, but we can also go Greek. There's a bunch of stuff that you can do. It's pretty fun. So I have Greek installed. Now it goes alpha, beta, gamma instead of ABC. And that's how you can change stuff. You can also change the position of the list style. So list style position, you could say outside. So let's see what that means. And doesn't really change much out here, but that's one of the properties that I just wanted to show. Okay, now you can also place contents before an element. So let me just show you how to do that. let's clear all of these things now. So let's say we want to select par1 and say, so this is going to be a pseudo selector again. So you say after, you say content, and your content is going to be, let's say, at the rate. So all these at the rates are going to be before this little thing out here. So let me just show you the change. Yep, so since we said after, it has all these at the rates after, but if we say before, this is how it'll change. So now it's all before them. Right. Okay, now let's go ahead and see how we can use the nth child element. So for that, we're going to select our UL again. Actually, let me go ahead and delete everything first of all. Okay, so let me create another HTML boilerplate, and this is going to be called list. First of all, let's say we have an unordered list with a bunch of list items. So LIs all around. Let me just copy that down and paste it a few times. Right, so now we have all these list items here. Let's just fill them up with some random text. Okay, so let's just say something random like cats. So let's save this, let's go out here. Now we have these things called cats. Okay, so what if we want them to have alternate paragraphs? I mean alternate background colors. So first of all, let's go ahead and select the LIs and give them a background. Let's say this gray color that I have selected, F7, F7, F7. Now you see we have, okay, this doesn't seem to be working. LIs. Looks like I've deleted my link tag, that's why the CSS was not working. So let's see. Now we have that. Okay, so first of all, let's go back and change this to F7, 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 right? This will give it this gray color that you see out here. Let's also give it the width of around 360 pixels, so that'll bring it there. Let's also give it a margin of 100 pixels from the top and equal on the side. Let's bring it to the center. Right, now suppose you want to say li nth child, and you could say something like 2n. So this will select all the even childs, and you could say they have a background color of white. So let's see how that changes things for us. Now you see that all these things out here have an alternating background color where it's gray, white, gray, white, gray, white, and that's how you select all the even childs. Now you can also select the first child by saying first child. For that we do not really need this 2n counter, and now only the first is black. You could also say last child, and now the last will be white. And that's how stuff changes with CSS. Okay. Now you can also change the first line, so let's go ahead and change our HTML up a bit. So let's create a paragraph, and it's gonna have some lorem ipsum in it. So let me just show you something really cool. Let's delete all of this stuff. Let's select our paragraph, and we're gonna say the pseudo selector called first line, and let's say text transform uppercase. So let's reload that. First of all, let me just comment this out just to show you what the page looks like without any CSS. So this is our page without any CSS, and let me uncomment this now, save it, and there you go. The first line has been completely made uppercase. Now instead of first line, you could also say last line, and that will transform the last line to uppercase. You could also say something like first letter. And okay, so just to show you that it does indeed work, let me just reload this without any CSS first. Okay, now you see that the lorem ipsum begins with a lowercase l. Now let me just uncomment this out, save it, and now you see that the first thing is a capital. You could also change it to say stuff like text size, or rather font size, and say around 100 pixels. Now the first letter will be 100 pixel big, and that's how you can do stuff like that. Okay, so another thing is you can also change the pointer or the cursor. So let's see, when you're hovering over a paragraph, let's say P and hover, first of all we want the background to become black, we also want the color to become white, and we want the cursor to become pointer. So let's see, so when you're hovering over it, it becomes this hand-like thing, and when you go out, it comes back to normal. So that's how you can change the cursor also. Now let me show you all something called a box shadow first of all. So let's remove this cursor part. So without the cursor it looks something like this. Let's remove the hover tag so that's always there. Right. Okay, now let's also change this to that gray color that I really like, and let's also change this to black. So this is what it looks like now. Let's give it a width of around 400 pixels. So this is what it looks like. Now let's also center it so that I can show you some cool stuff. So margin, let's say 0 and auto. So this is going to center it from the top of the screen. Now that it's centered, okay, so this is what our thing looks like. Now suppose we were to give it a border. So borders are really neat. So 2px solid black. So this is what a border looks like. But there are other stuff also, like a box shadow. So this is how box shadow works. Takes 3 parameters, so one is z, x and y axis, and not really in that order, it's x, y and z axis, and then it also takes a color. So let me just show you how that happens. So suppose we say 0x, 0y, and let's say 3 pixels on the z axis, rather 5 pixels to make it more prominent, and then it takes an RGBA of 0. We want to make it really invisible, so 0.5. So that gives it a half opacity. Now you can see this really neat little shadow going all across our content. So that is what box shadow does. It's a neat little trick for when you don't want to use a border or something like that. Now other than borders, there's also outline. Let's say an outline is black in color. So outline completely negates our box shadow. And you could also say outline equals none. So let's remove that now because box shadow looks really neat. Yep. Okay, so now let's talk about text decorations. So since we have some text already going up, let's decorate it. Now there are a few kinds of text decoration that I want to show. So the text decoration, let's say, so first say is line through. Just put a line through all of the content. So now it's all strike through. You could also say something like overline or underline. So let's see that. Underline will underline our text. Yep. And overline, as you might have guessed, will overline our text. Now everything has a line on top of it. Fine. Now we can also set the visibility of our text or any other tag, to be honest. Visibility. So let's check out all the other visibilities that are there. So to do that, always go on Google and type visibility and CSS. And let's see the visibility property and how it goes. So you must understand that knowing everything in CSS is kind of impossible. So you should always have a go-to or a backup. So my backup is normally W3 School, and they have everything regarding CSS and its properties. These are all the properties that you want to go through, and I'm mostly going through the most important ones in this tutorial that you may use in your day-to-day projects and topics. But sometimes you might need the rare ones like counter reset, empty cells, flex spaces, and all these stuff. And you can always go back to W3 Schools and go through them. Now you can say visibility is visible or something like that, and it should make it visible. Yeah. Right. So that was all about the miscellaneous types of CSS that we were handling. Now let's go ahead and see some gradients and how we can create some beautiful gradients using CSS. Okay. Now before we move on to gradients, let me just show you some white spaces or some more text transformations. Right. So I already showed you all these text transformations. There's capitalize, there's lowercase, there's overline, line through, uppercase and underline. Now capitalize will just capitalize it. So I don't think I'm going to show that to you guys. Now let's close these two pages out here. Let's create our new CSS file, and first of all let's set this to CSS. Let's save it, and let's say it's going to be page6.css. Now out here, if you see, we have a bunch of white spaces, right? Now let's see how you can handle white spaces using CSS. So there is this thing called the ID called whitespace pre. I think that's exactly what it's called, whitespace pre. Yep. Let's select that, and you could say whitespace is pre. Let's see how that changes stuff. So first of all, let me load up page 6 for you guys. Right, let's remove the CSS, save it, let's reload it again, and what we are actually targeting is this part. White space will be preserved. Right, so white space will be preserved. Now go ahead, uncomment that, save it, and let's reload. Now see, the white spaces that are in the HTML is preserved. Now, white spaces can also be handled in other ways. So there are two things that I want to show. So let's select this thing called never wrap, right? And we say that the white space is going to be no wrap. So let's see how that works. So first of all, this is what we are actually targeting, this lorem ipsum part out here. And it's somewhat like this, and let's see how it changes now. And now you see that it goes completely out to here, so no wrap. It doesn't wrap it around. So you also have pre-wrap. So let me just show you how that works. So I'm going to be targeting this part out here with these weird kind of white spacing. So let's see. Preserve wrap. So with preserve wrap, we go pre-wrap out here. And that's the property. So let's see. Yep. Lorem ipsum and the wrap has been preserved. Okay. Now you can also set up the direction. So let me just show you how that's done. So we're going to select these two things out here, left, right, and right, left. So hash left, right, and also Control C, and let's make this right, left. Fine. Let's remove all this stuff for now, and let's remove everything before right, left too. Now that we've removed that, let's remove this. Let's save it. Let's see. Okay, so this is what it looks like right now, and all you have to say is direction is L2R, so that means left to right. Now here you say direction is RTL. Let's see how that changes stuff. So I prefer right to left, and I prefer left to right, so that's how it's working. Fine. So that was all about white spacing and directions. Now let's move on to gradients and animations. So this is going to be the last part and the most interesting part in my opinion. So gradients are those beautiful backgrounds you see on most websites, and to generate your gradient you can always use this thing called a gradient generator. So this gradient generator out here is a really nice gradient generator. You have to select the direction and you select the ending colors. So I've already selected a gradient out here. It's going to create this gradient. Now let's see. Go to page 7. Right. Now let's select the body tag. Let's close this off. Let's close this off. I want to save this. And let's create a new page first of all. And this is going to be our CSS. So we have to save it and say page 7. Right. Now we select our body and just paste in. So let me just explain how this happens. So there's a linear gradient and there's also another thing called radial gradient. So I'll just show you that. Now this takes in a few parameters. The first is to the right, that's the direction, and this is how the colors will change. So let's just see how that works. So first of all, let me comment this out. Let me just open page 7 for you. Now if you see, it's going to be a blank page. Okay, this is the gradient. I'm sorry. Let me save that. Right, so this is what it looks without a gradient, and you already saw what it looks with a gradient, but let me just show it to you again. This is what it looks with a gradient. Now you can also set the background with other stuff like image. So for that you go URL and you can paste in the URL. So let's go and search for a beautiful image. I really like Dragon Ball Z, so Goku Super Saiyan 3. So that should be a good image to save as a background. So let's see, this looks like a really nice image. So you go here. Let me just save this image as. So this is going to be Goku, and it's going to be saved in desktop and in CSS tutorial. It's going to be goku.jpeg. Right, so you could say goku.jpeg. Right, now that's saved, let's go back to our page and it should have a picture of Goku. Okay, so that didn't work. I think I got something wrong. Let's go and analyze that. So open up our CSS tutorial. Okay, so it's a JPG file and not JPEG, so that was our mistake. Small mistake, nonetheless. And now we have this picture of Goku. Now you can also set the background repeat. Let's close this off. Say background repeat, and you could say no repeat, and it will not repeat the background anymore. Or you could say background repeat is gonna be. Let's check out all the background repeats that are actually available. Now background and repeat. So if you go into background repeat and see the properties, you can just try it yourself. So you can repeat it according to the y-axis, you can repeat it according to the x-axis. So let's see how that works. So repeat x, So if we say that, I think it should repeat it on the x-axis like it was, or you could repeat it on the y-axis. I don't think that'll show up out here, but let's see. Yep, it's now repeating on the y-axis. So that's how background repeat also works, so we've covered that too. Now we've also covered the gradients. Now it's time we do some radial gradient. Now if you remember, let me just go back to the gradient part. So if you have a radial gradient, all you have to say is that it's a radial gradient out here. And a radial gradient doesn't really need direction because it's going to be radial. Save it, page, and let's reload it. Okay, now we have a radial gradient. Now you see all these lines going in, but if I just zoom out, you can see that it starts from the center and it spreads out, where it's white on the sides and white on the sides. So that's how radial gradients work. Okay, so now that we've covered the gradients, let's go into animation. So I think animation is the most interesting thing that you can do with CSS. So we have selected the div. So first of all, let's give the div a border. So this border is going to be 2 pixels, solid and black. Now let's give it a background to begin with. Let's say it's going to be of red. Now this is how you do animations in CSS. Okay, so before animations, actually, let me show you how you can move this thing around. Fine, so there's some stuff that I want to show you guys. So let me just show you what this looks like. So let me give this a width. First, it's going to be around 100 pixels, or rather 200 pixels. And the height will also be 200 pixels. Now let's see. Okay, we have this div out here. Let's make it a little bigger. Give it 500 and 500. Save it. Yep. Let's also make this much more prominent. Let's give it a 10 pixel background. I mean a 10 pixel border. And now you see we have a really prominent square out there. Now let's try some really interesting stuff. So let's say div, and when we hover over the div, you want to scale this. So scale, and let's say we want to scale. Okay, so that's not how you scale. First you say transform, and how do you want to transform? You want to scale it, and you want to scale it twice. So when we hover over it, it should scale twice. Let's reload, and as you see, it's scaling twice. Now we can also transform some other stuff like this. So we can rotate. So we can say rotate 45 degrees. Let's see. When I hover, it's rotating 45 degrees. You can also skew it. So skewing is how it works. Let's see. You can skew it 20 degrees to the x-axis and 10 degrees to the y-axis. Save it. And this is how it gets skewed. This is how skewing works. You can also translate stuff. So let me show you how translation works. So translate, and let's see, you want to translate at 20 pixels and 20 pixels. So let's see. Hover over it and it translates a little. Let's translate it around 120 pixels just to make it more clear. 120 and 120. Let's save that. Let's reload this, and you see that now it's translating so much, right? So that's how translate works. Okay, now that I've showed you scale, rotation, skewing, and translate, let's see, we can also set up the transitions. So with transitions, you can set up a lot of stuff. So now that we're done with transitions, let's go ahead and see some animation. So for animation, I'm going to be actually targeting this div out here. So let's actually style this div. I've given it the width of 100 pixels and a height of 100 pixels, and a background of red, and a border of 3 pixels, solid and black, let's say, right? Let's see what that looks like. Now that's what it looks like. Fine. Let's zoom in a bit. Now all we need to do is actually set up some keyframes. So we do that by saying keyframes. Now we name our keyframes. Let's call it anime. And we have to set up actually what it will look like at different points in time. So we do that by saying 0%, and it'll have, let's say, a background color of red, and then it'll move. So we want to move it in the square. So let's say it'll be not padding, rather there'll be 0 pixels from the left, and from the top it's going to be 0 pixels. Let's save that, copy that down. Let's paste that a bunch of times. Now all we want to say is this is going to be 25, it's going to be 50, It's going to be 75 and this is going to be 100. Let's save that. Let's change their colors. So this is going to be yellow first, then changes to green, some pretty basic colors, blue then, and in the end we'll change it to red. So that brings us back to the original position. Let's first also move it by 300 pixels. Then let's move it 300 pixels both ways. Now it's only going to move 300 pixels this way, and in the end it comes back to the original position. Now to use this keyframes animation, we have to give this animation name. It's going to be using the animation with the keyframes name anime. Now we can say the animation delay is going to be 2 seconds. You can also say how many times it's going to be iterating. So you can say that by 100. Let's save that. Okay, so our animation is not working because we haven't set the positioning. So now let us just save this, and let's say our position is going to be relative. Let's save that. Let's uncomment our animation. Now you see that our animation will work as we intended it to. So after 2 seconds, our animation starts working, and this will just keep going on and on. Now if you want to actually repeat that animation, there's a way you can do that, and that is with the animation iteration count. Let's say you want to iterate it 100 times. Let's reload. Let's wait for 2 seconds, and voila, our animation will keep going on and on and on. So that's how you animate stuff with CSS, guys.
So what is JavaScript? Now JavaScript is basically a high-level interpreted programming language which is used to make web pages more interactive. Now it all started in the year 1995 when Brent and I created JavaScript in a span of 10 days. Since then, it has seen multiple versions, updates, and has grown to the next level. Now JavaScript is basically the language of the web. So it is used to make the web look alive by adding motion to it. Now to be more precise, it is a programming language that lets you implement complex and beautiful things or design on web pages. Now let's move on and see what can JavaScript do. So basically there are a lot of queries about why do we need JavaScript and what it can do when we have HTML and CSS already. But JavaScript as a language helps you build a website that will do a lot more than just gawk at you. Now currently we have hundreds of programming languages, and every day new languages are being created. Now among these are few powerful languages that bring about big changes in the market, and JavaScript is definitely one of them. Now JavaScript has always been on the list of popular programming languages. According to Stack Overflow, for the 6th year in a row, JavaScript has remained the most popular and commonly used programming language. Now moving on to what this programming language can actually do, we see that JavaScript is mainly known for creating beautiful web pages and applications. Now an example of this is also the Google Maps. So if you want to explore a specific map, all you have to do is click and drag with the mouse. And what sort of language could do that? Of course, is JavaScript. Now this language is also used in smartwatches. Now the popular smartwatch maker Pebble created Pebble.js, which is a small JavaScript framework that allows a developer to create an application for the Pebble line of watches in JavaScript. Not just that, the most popular websites like Google, Facebook, Netflix, Amazon, etc. make use of JavaScript to build their websites. Now, among things like mobile applications, digital art, web servers, and server applications, JavaScript is also used to make games. A lot of developers are building small-scale games and apps using JavaScript. Now, a lot of people ask about where to run the JavaScript code. Now, when it comes to running the JavaScript code, you can use the console, which is pretty simple because you can just type whatever you want to do with your code and you will see the output here itself. Or you can use any text editor. For example, I will be using the Visual Studio Code and show you how you can write your code here and then how you can run it in your website and see how it works. So you can work it both ways. You can enter any data or input here and then you can go back to your console and check your output. Also, if you have to check anything for your code, you can check it inside the console itself. Now, JavaScript was originally designed to run only in browsers, so every browser has what we call a JavaScript engine, that can execute JavaScript code. For example, the JavaScript engines in Firefox and Chrome are SpiderMonkey and V8. So it's pretty easy for you when it comes to running JavaScript code online. Now, JavaScript can build the backend for our web and mobile applications. So, in a nutshell, JavaScript code can be run inside of a browser or in Node browsers, and Node provide a runtime environment for our JavaScript code. So now that you know where the code runs, let's move on and have a look at the different benefits of JavaScript. Now, there has to be a reason why so many developers love working on JavaScript. Well, there are several benefits of using this language, such as it's easy to learn and simple to implement. Now, it is a weak type programming language, unlike the strong type programming languages like Java and C++, which have strict rules for coding. Now, it's all about being fast in today's world, and since JavaScript is mainly a client-side programming language, it is very fast because any code can run immediately instead of having to contact the server and wait for an answer. Not just that, it has a rich set of frameworks like AngularJS, React.js, which are used to build web applications and perform different tasks. Lastly, it also builds interactive websites. Now, we all get attracted to beautifully designed websites, and JavaScript is the reason behind such attractive websites and applications. Now, finally, we will have a look at the setting up of the development environment or the IDE. Now, there are different editors that you can use for writing your JavaScript code. So there's Visual Studio Code, and then we have Sublime Text, and then we have Atom as well. Now, these are pretty famous and popular when it comes to working on any programming language. But when it comes to choosing the favorite one, I would definitely opt for Visual Studio Code. So today I will be using the Visual Studio Code in order to show you all the examples and also explain the fundamentals of JavaScript. Now, out of these, my favorite is the Visual Studio Code. It's simple and easy to run your codes here. Now, to download Visual Studio Code, you just have to type download Visual Studio Code and just go to the website code.visualstudio.com and get your version that is suitable for your system. Now, it's a very simple, lightweight, cross-platform and powerful editor. So if you don't have Visual Studio Code on your machine, go ahead and download it right away. Now, in order to become a front-end developer, you should also be aware with HTML codes. So here we are going to use our HTML code as our host for the JavaScript. Now, first thing first, you must get this live server extension installed here before you try to run your JavaScript or HTML code here. So all you have to do is just go to the extensions and then search for live server. Now, I have already installed this, so you just have to install this before running any of these codes. So now that you are ready to learn how to code in JavaScript, let's begin with the fundamentals. Now, talking about the fundamentals, the first thing is the variables in JavaScript. Now, this particular programming language includes variables, which basically holds the data value and it can be changed anytime. So it uses a reserved keyword var to declare a variable. Now, all your variables must have a unique name. So now let's get back to our Visual Studio Code. So this is my basic HTML file here. So here I have the HTML head and title, and after that I have the script tag as well. So inside my body, I have a head tag that says welcome to Edureka, which means when I go to my website, it will show me this particular head tag that is welcome to Edureka. Now, it's always a good practice to keep your script tag at the end because the browser parses this file from top to bottom. So if you put the script element here in the head section, you might have a lot of JavaScript code there. So your browser may get busy parsing and executing that JavaScript code, and it won't be able to render the content of the page. Now, almost always the code that we have in between the script elements needs to talk to the elements on this web page. For example, if we want to show or hide some elements, so by adding the code here at the end of the body section, we will be confident that all these elements are rendered by the browser. So here we use a variable to store data temporarily in a computer's memory. So we store our data somewhere and give that memory location and name, and with this name we can read the data at the given location in the future. For example, think of the boxes that you use to organize your stuff. You put your stuff in various boxes and put a label on each of them so that you can find your stuff easily. Now a variable is basically like a box. So what we put inside the box is the value that we assign to a variable. Now that's the data, and the label that we put on the box is the name of our variable. So let's see what's the code for declaring our variable here. Now in the old days we used to use the var keyword to declare a variable, but there are certain issues with that. So now we have started using the let keyword to declare a variable. So first we will use the let keyword here, and then we have to declare a name for our variable. And your name should be something that is understandable, or by looking at the code you can see that what you are trying to write. So here I have a code with the variable name. So I have given the name as Edureka, and then I'll just write console.log name. So now once I save this code, and finally we will save this code with the extension .js. So this is our JavaScript file. Now in order to run this in your web browser, you need an HTML file. So now this is where this file will come into existence. So here I have added one source which points to my JavaScript file. So here I have just given an extension as src equals to index1.js, which basically takes me to my JavaScript file. So now when I run this HTML file, it will take me to the browser, and you can see the heading here that is welcome to Edureka. Now how do I get this console? So you just have to right click on your website and go to inspect. And once this window has come up, you can just go to console. Now inside console you can see that you have Edureka mentioned here. Why? Because we have declared a variable with the name Edureka. So our output was console.log name. So as soon as we run this code and go to our console, you can see Edureka. Now in case I change the name, for example, I'm just changing the name to Learn JavaScript. Now make sure you give something unique, because you cannot use the keywords that are there in JavaScript as your variable names or any sort of value. So here I have given the value for my variable as Learn JavaScript. Now once I just save this and go back to my browser, and once I refresh this, you can see that it has been changed to Learn JavaScript. Now previously it was Edureka, and now you can see that the name has changed to Learn JavaScript because the value also has changed here. So now that you have seen how this variable works here, let me tell you about certain rules that you need to follow while writing the name of your variable. Now the first rule is that it cannot be a keyword. That is, it cannot be a reserved keyword in JavaScript. For example, let, var, these are all reserved keywords for JavaScript, so you cannot use them as your variable name. Next up is you should always have a meaningful name. So you must keep in mind that when you are giving a name to your variable, it must be meaningful and understandable while just seeing the name itself. Also, your name must not start with any number. So how odd would that be to just have a name that begins with a number like 1 Edureka or 2 Edureka? So it does not look good that way. So you must not have a variable name that starts with a number. Next up, you must keep in mind that there should not be spaces or hyphen when it comes to the name of your JavaScript. For example, I have written Learn JavaScript here. I can also just write it like this in order to separate the two things, but there should not be a hyphen or a space in between the two words. So you just have to write it together. Also, the names here are definitely case sensitive. That means if I write Learn JavaScript like this and then I change it to Learn JavaScript with a capital L, these two will be considered as different names because it is case sensitive. So now this was all about variables. Now let's move on and take a look at constants. Now by declaring a constant, you basically assign a meaningful name to a value.
So once a constant is declared, it cannot be modified or assigned any other value. So now let's see how we can define a constant in JavaScript. So for example, you want to describe your name in two different parts such as the first name and the last name. So suppose you have let first name is equals to Edureka, and then you have last name as JavaScript. So here you would need a semicolon to separate the two things and declare it separately in such a manner. But rather than doing this, you can just use constants that makes your work easier. So now let's see how you can use the constant in your JavaScript code. So now let me just take the variable name as age. So for age, we have a specific value. Suppose I'm giving the age as 23. Now when I type console.log age, and then let me just save this one again. And now once I go back to my website and refresh it, you can see that it gives me the value 23. So here what I'm doing is I'm declaring a variable, but also I'm giving it a constant value. So now I cannot change the value of my age here. Now sometimes we don't want the value for a variable to change because otherwise it's going to create all kinds of bugs in our application. Now in those situations, instead of a variable, we use a constant so that the value of a variable, that is the name implies, can change. But then the value will remain constant. Now in the next line, I give age is equals to 21. And then now let me save this one and see what output do I get when I run this one. So let me just refresh it. So you can see that I get an error here because we have already declared a constant value for age, which is 23. And again, we are changing the value to 21. So this will definitely give you an error, that is the uncaught type error, assignment to constant variable. So here your variable age is a constant. You cannot assign any other value to this variable anywhere. So thus it will show you an error. So basically we cannot reassign a constant. So once you have used constant, you cannot change the value. So the best practice is to use var whenever you're planning to change the value next. So now that you know what are variables and what are constants, you must be wondering what are the kind of values that we can assign to these variables. So now let's move ahead and have a look at the different data types that you can use. So now here we have two different types. So first we have the primitive or the value types, and then we have the reference types. First we will have a look at the different primitive types. Now the data types are basically the type of data that can be used and manipulated in a program. So the different data types include the numbers, strings, boolean, undefined, and null. So now talking about these data types, let's go back to our code and see what are string literals, what are numbers, what are booleans. So let's just type let name equals to Edureka. Then we have another variable as age, which is equals to suppose 23. Now for checking boolean, let's just give another variable as is approved is equals to true. So true and false are the ones that represent our boolean values. So this one is basically our string literal, and this one is our number literal. This one we are using for boolean. Next up, if we just write let first name and put a semicolon, it automatically gives an undefined value to this one. But we can also write it as first name is equals to undefined. So there's basically no value assigned to this particular variable. Now the final one is the null value. So let me just give it as let date equals to null. So now let me just save this and then let me go back to my console again. Now once I refresh it, so basically I have not given any console here, so there's no output in my console, but then you can always check the type of your literals here. So what I have to do is just type of, and then if I want to check the type of my variable name, so I can just give name and it shows me string. So here I have my name as Edureka, which is a string literal.
So this is exactly the value that it is showing me here. That is, the type of my name is string. Now let's check the type of age. So you can see that it shows number. So my age declares my number literal here. In the same way, when we type of is approved, suppose I write type of is approved, it'll show me boolean. So you can see that inside the console itself, you can find out the types of all of these variables. Now, if I just want to check the type of my date, so I'll just write type of date, and it shows an object. Because we do not have any value here, we have a null value, which is also considered to be an object in JavaScript. Now, this is exactly where the reference type comes in. So these were the different primitive types. Now we will have a look at objects. So now that you have seen the primitive types in JavaScript, we will have a look at the reference types. In the reference type category, we have the object array functions. So now we will talk about these three different types. So first, let's talk about the object. Now, object in JavaScript and other programming languages is like an object in real life. So think of a person who has a name, age, address, and so on. So here I have given three attributes to my particular object. Suppose the girl is my object, so I have three different attributes for this object, that is name, age, and eye color. Now, when we are dealing with multiple related variables, we can put this inside our object. For example, we have two variables, name and age here. So what we can do is we can declare it as a property for our object. So we can refer these two as elements or properties for our object. This basically makes the code clear. So now let's see how we can declare an object in JavaScript. So let me just declare my variable as girl, and inside girl I'll add properties for the girl. So we have to begin with the curly braces. So now inside the curly braces I will add the properties. Now the first property was name. So let me just give the name as Emily, and then we have the age as 23, and then we also have another property as eye color. So it's brown. Now we separate these properties with the help of a comma. Now finally we close this curly brace along with a semicolon. Now I will just use the console.log and find the output for my object, which is the girl. So now let me just save this one, and let's go back to the console and see how it works. Now inside this I will add the properties for my object, which is the girl. So here you have to give the name of your first property and then use colon, and then I'll just write the name as Emily, and we separate the properties with the help of a comma. So the next property is age. So I'll write it as 23, and then we need to close the curly braces along with a semicolon. Now I'll just type console.log and the name of my object, that is girl, and close it with a semicolon. So here I have declared this variable or my object, which is the girl, and inside girl I have declared certain properties for the girl, which is the name and the age. Now let me just save this one and go back to the console and see. So you can see that once I run this code, I'll get to see the properties for my object. So it shows the name, that is Emily, and age as 23. Now suppose we want to change the name of this particular object. What do we do? So this is exactly where we use the dot notation. So what we will do here is we will just give the name of our object, which is girl.name. Suppose I want to change the name here. So I'll just give the name is equals to, and I'll give another name here. Suppose I want to give the name as John, and then add the semicolon. Now let me just save this one and see what happens to the output. So now once we go to the console, you can see that the name has been changed to John here. Now this is one approach. There's another approach that you can change in order to change the name. So what you can do is use the bracket notation. Now what is this bracket notation? So we can just type girl and use the square brackets. So inside the square brackets, I'll give the name, that is for the variable that I'm planning to change.
So my name now will be equal to, suppose I want to give the name as Sam. So I just type Sam and close it with a semicolon. And then now let me save this one. Now once I go back to my console and see, you can see that the name is changed from John to Sam again. So these were two different approaches, that is the dot notation and the bracket notation, through which you can also get into the property of your object and make any particular changes. So now that you have learned how to declare an object, let's move on and see what are arrays and how you can declare arrays in JavaScript. Now the JavaScript array object is basically a global object that is used in the construction of arrays, which are high-level list-like objects. So now in case you have a list of products in a shopping cart or list of colors or list of items that are used in order to make a painting, you will need to declare them with the help of arrays. Now declaring them just using variables would be hectic because you have to define all of them separately, which might be a tedious task when your list is pretty longer. So now here comes arrays to your rescue. So let's see how the arrays work in JavaScript. So I'm just going to give the name as items, and inside this I will declare my array here. For example, I have certain items inside my list. For example, I have color, then I have paintbrush, and then I have a plate. So suppose these are the items that are present in my list. So what I can do is close it with a semicolon, and then now I'll just use the console.log and I'll put items here. Now let me just save this and go back to the console. And now once I refresh this, you can see that it gives me the value and also what are the items in my list. So you can see that I have added 3 different items in my list, that is colors, paintbrush and plate. So it gives me the value of the number of items inside my list and also what are those different items. So now once I click here, you can see that it also gives me the index value for each one of these items. So in array, the index value always starts from 0 and not from 1. So you can see that the index value for color is 0, and then for paintbrush it is 1, and then finally for plate we have 2. So basically the index value goes from 0. So here we have 0, 1, 2, which means that the total length of the array is 3. So now if you want to display any particular item, you can just use this index value. So suppose I want to display the paintbrush. So what I can do is use the square bracket, give the value as 1 because the index is 0, 1, 2. So the index value for paintbrush is 1. So let me just save this one. And now let's go back to the console. So you can see that the output it gives me is just paintbrush because I have just given the console log item value as 1. That means I only want to see the value that is there in the place of 1. That is, the index value should be 1. Not just that, you can also add something else in your list with the help of the index value. For example, I can just give the name and specify the index value where I want to add something. Suppose I want to add another item, so the index value will now be 3. Because I want to add it at the end of my list, so I've just given the value as 3. And suppose I just want to add sprays, so I'll just type sprays, semicolon, and then I'll just save this code. So I'll add the item sprays here. Now let me just change this so that it shows me the value of all the items. And let me save this one. Now once I go back to my console and reload this, now you can see that the value of the items have changed from 3 to 4, and also another item has been added to my list. And also you can see the index value. So sprays come at the index value 3. That's exactly what I have added, and that is exactly where the value has been added to. Now here you don't need to have a similar type of data. That is, if I want any number to be added here, suppose I just want to add 100. So I can just add this number here and then save the code. So you can see that in the output it will give the value as color, paintbrush, plate and 100. So it need not be a similar data type. you can add different data types and also put it in the array itself. Now, if I go back to my console and just type of the name of my list, that is, I've given it as items, you can see that it shows object. So you can see that array is basically a type of object. We can also use the dot notation here and find out various properties. So you can see that you already have different properties that you can find out. So let's just find out the length of my list. So we can just type length and let me just save this one. Now once we go back and refresh this, you can see that it gives me the length as 4. So basically with the help of dot notation, you can also find out the values or different properties for your array. Now this was all about arrays. So we have seen what are objects and what are arrays. Now it's time to move on and have a look at functions in JavaScript. So functions in JavaScript are divided into two different types. First, we have the predefined functions, and then we have certain user-defined functions. So basically, a function is a subprogram designed to perform a particular task. Now, functions are executed when they are called, and values can be passed into functions and used within them. So now let's see how we can declare a function in JavaScript. So here I'll use the keyword as function for declaring any sort of function or the name that I'm going to provide to my function. So now let's see how we can declare a function. So I just want to view welcome to Edureka. So what I do is take the function keyword and suppose let me just type view, and inside this I'll have to add the curly braces inside which I will have my console.log. So I want to print welcome to Edureka. So now once I close this, now after the curly braces, we have to call the function now. So my function name is view. So what I'll do is just call my function here. And now let me just save this one. So now once I go to my console and then I run this code, you can see that it shows me welcome to Edureka. So what actually happened is I have used a function view and I have inserted whatever I want to display. And after that, I have called my function here. So what happens is, so inside console log, whatever I have written is displayed in my output with the help of this particular function that has been called here. Now we can also add a parameter. So let me just add a parameter inside my function. So suppose I've added a parameter as name. And here I'll concatenate that particular parameter. So let me just type name here. And then inside my function, I will be typing whatever parameter I'm going to pass through it. So inside my function, I'll just write learn JavaScript. So here I'm just passing a parameter inside my function. So here I'm giving the name as learn JavaScript. So let me just save this one and go back to the console. So once we run the code, you can see that it shows welcome to Edureka, learn JavaScript. So the value has been concatenated here. So you can see that there's a missing space here because in my code I haven't added the space. So in order to add a space, so you just have to leave it blank and then add it again. And now once I save this code and go back to my console and run it again, now you can see that there's a space after Edureka because here I have added a space and then concatenated the name. So now let's check for the value square. So now let's see how the function works in JavaScript. So here we have taken the keyword as function and we have given a name to our function. Suppose I want to find the square of a number. So I have taken the function name as square. So now inside the square, I've given the parameter as number and then you have to open the curly braces inside which I'll return the value that I want as my output. So here I want the square of the number. So I've given the return value as number into number, which will give me the square. Now you have to close the curly braces. Next up, you will define the number now. So here, suppose I want to find the square for number 2. So I have defined the number here as let number equals to square of 2. So I want to find out the square of the number 2. And then finally console.log number. Now once we go to our console, you can see that it has given me the output as 4. Because the square of 2 is 4 and I have asked for the square of the number 2. So this is what the output is. So now that you know how functions work in JavaScript, let's move on and have a look at some conditional statements in JavaScript. Now, what are conditional statements? When we use the word as if, else, or we put certain conditions, that is when the conditional statement comes in JavaScript. So let's see how that works. So first, let's have a look at the if statement. So suppose I'm declaring a variable here as number. So let number equals to, let it be an undefined array here. Next up, I will define the array, or I will provide a set of numbers inside this particular array. So let me just define this and provide certain values. So let my array be 1, 4, 1, 2, 5, 2. So these are the set of values that I have provided inside my variable. Next up, here I will be using the if conditional statement. So now inside if, we are basically supposed to provide any particular condition. So I have to find a condition here. Suppose I want to check if the number in position 0 is equal to the number in position 2. So this is the condition that I have provided here. So now after the condition, I will just try to get the output. So I'll just give console.log. So let me just say the answer would be yes. So in case the condition is satisfied, it will give me an output as yes. So now let me just close this with a semicolon. So now this is where and how we are using our if conditional statement. So inside if, we have just provided a condition for our variable that we are using. So our condition is that to check whether the number in the position 0 is equal to the number in position 2. And in array, as you remember, the index always starts from 0. So we see that this is 0, 1, 2. So you can see that the numbers in position 0 and 2 are same. So basically the output should be yes. So now let me just save this one and go back to our console and see what it shows. So I get the output as yes because the condition has been satisfied here. My if condition is satisfied, and that is exactly where I've got the output as. So now let's see what is the if-else condition. So it is pretty similar to the if condition. So it's pretty similar to the if condition, just that there's one more condition that gets added here. Now in this case, if both the numbers were not equal, what we would have got. Suppose let me just change this value to 3, and now let me save and see what my output is. So you can see that we do not have any output because I haven't given any value for the next condition. That is, what if these two numbers are not equal? So now this is where the else condition comes in. So I'll show you how you can add the else condition. So you just have to write else, and then I will give another output here. So I will just type console.log and then let it be no. So when the condition is not satisfied, it comes out from this loop and goes inside the else condition, where if the condition is not satisfied, it will give me the output as no. So now let me just save this and go back to the console and see. Now you can see that the output is shown as no, because here the condition is not satisfied. So it has come out of this particular condition, and now it's checking the next condition. So here, if this condition is not satisfied, the output would be no. So you can use this if-else condition a number of times, and you can provide different conditions and also provide different outputs for different conditions that you are going to imply here. So now let's move on and have a look at loops. So in JavaScript, we have the for loop, the while loop, and the do while loop. So first, let's see how the while loop works. So for that, first I have to declare a variable. Suppose I'm taking I equals to 0. I have to initialize the value of I and then give a condition. So here I'll use the loop. So I'll take while and give the condition as while I is less than 5. That is, the value of I is less than 5. And then I'll give the output here. So it will be console.log number is. Now I'll concatenate the value of I here. And then finally it's I++. So now what happens here exactly is, so I have initialized the value of I as 0. And then I have given a loop which says that while I less than 5, we will be printing the number, that is number is and the particular number. and I++. That is, the value will be incremented after each loop. So what happens here is the loop will start from 0 and it will go on till 4. So 0, 1, 2, 3, 4. As soon as the value of I reaches 5, it will come out of this particular loop. And the output will be only from 0 to 4 because, so now in order to check the while condition, first I will initialize the value of I. So let me just take the initial value of I as 0. And then here I'll use my loop. So suppose I'm giving a condition here, that is I is less than 5. And for the value of I less than 5, I will give an output which will be console.log number is, and then I'll concatenate the value of I here. And then finally increment the value of I here. So now what exactly happens here is that, so first I have initialized the value of I to be 0. And then I have considered a condition, that is I must be less than 5. So I had to put it inside a loop. So I have taken the while loop here. So what we consider is while the I value is less than 5, our output will be number is, and it will take the particular number. So it will count from the number 0 and go on till 4. Now as soon as the number reaches 5, it will come out of this particular loop. The I++ is for the increment, that is from 0 to 4. And as soon as it reaches 5, it will come out of this particular loop, and then only the number 0 to 4 will be visible in our output. So now let me just save this and see what happens. So let's go back to the console. So now you can see that the number is printed as 0, 1, 2, 3, 4. So as soon as the number reached 5, it has come out of this particular loop. So this is exactly how the while loop works. Now in a similar manner, you can also use the for or the do while in order to insert loops in your JavaScript code. So in do while, what happens is, first you make the task happen, that is, you use the do keyword and put your output or whatever value you want, and then later on you put the condition. So the condition is checked later, whereas in while, first you check the condition and based on that you provide the output. Okay, so this was about the while loop in JavaScript. Now let's move ahead and see that how does the do while loop works in JavaScript, and also how the do while is different from the while loop. So in case of do while loop, what happens is the condition comes a little later. So first we declare the variable, and here we take our do loop, and inside the curly braces we give our output. So we have our output as number is, and we concatenate the value of I, and then we increment it as I++. Now once we're out of this loop, here we will be adding our while loop. So here we will be giving our condition. So suppose I'm giving the condition as I less than 6. So what happens is now it will take the values till 5 only. And what happens here is it will keep printing the value and come out of the loop and check for the value or the condition that I have provided inside the while loop. So now let me just save this one and go back to my console and refresh this and see. So here you can see that it's printing the value from 0 to 5. So previously we had given the condition as I should be less than 5. So it printed till the value 4. Now in my do while loop, I have checked till I value less than 6. So here it has printed the value from 0 to 5. And as soon as the value is more than 5 or the value goes to 6, it comes out of the loop. So now let's move on to the for loop and see how the for loop works. So while using for loop, you don't have to initialize the value here. So here we will begin with our for loop, and inside the for loop, there are 3 sections. In the first section, you initialize the value for I. So here we are giving I equals to 0. And then the next section is the condition for the I value. So here I am giving the condition as I value should be less than 7. And finally, we will give the increment or decrement value. So I'm giving I++ here. And finally, we give our output, that is console.log number is, and we concatenate the value of I here. Now, instead of declaring your variable here, you can do one more thing. So what you can do is inside your for loop itself, you can just type let and then initialize the value in this manner as well. So now let me just save this one. And now let's go back to our console and see what is the output. So you can see that I have given my condition that I value should be less than 7. So what it prints here is the value from number 0 to number 6. So you can see that using the for loop is pretty easier compared to the other loops. You do not have much to worry, or you do not have too many sections to be divided in this. You just have to use the for loop, inside which you can initialize the value of your variable and also provide the condition and then give the increment or decrement value all together. And finally, you just have to add the output, that is whatever you want to print. So this was all about for loop, and with this we come to the end of loops. So we have learnt about the while loop, do while loop and the for loop, and how these three loops work in JavaScript and how easily you can define any variable and insert it into the loops. So for any sort of condition, rather than writing the same thing twice or thrice or number of times, what you can do is you can just put them inside the loops and let it just take place all at once. Now the final thing that we can discuss in JavaScript is the switch statement. So what is this switch statement? So if you have a number of cases that you are supposed to check inside any particular program, so you can use the switch statement. So what happens is, inside your switch statement you can add various cases and then go for the value that you want to execute. So let's see how the switch statement works in JavaScript. So for example, let me just take a variable as let game equal to, let me just take any particular game such as cricket. It's World Cup season anyway. So let's take the value of my game as cricket. Now you just have to use the switch statement, inside which I will just declare my variable game. So first we take the switch condition, inside which I'll take the variable as game, and inside the curly braces I will have my first case. So my first case, I'm adding the game as football. So whenever the game football appears, I will just give the output as console.log. I don't want to watch football. Now this is our output, and then we give the break statement so that we can switch into our next case. So now if we consider another case, and suppose here we have hockey, and then we will give another output for hockey, that is console.log, and then we put console.log as I don't play hockey, and then break the statement again. Now the next case would be cricket. So suppose I have cricket here. So I will just give the output here as console.log. I love cricket. Now in case I hadn't initialized any particular game here, so we always need a default value when it comes to switch statement. So here what we do is we take another default value, and for our default value we give another console.log. So we just give match not found. So this is how we write a switch statement in JavaScript. Now let me just save this one and go back to my console and refresh this. Okay, so there's some error. Let's see. So yeah, we just had to put colons instead of semicolons. Now let me just save this one. And now let's go back to our console and see. So you can see that the output is I love cricket. Because here I have already initialized the game to be cricket. So what I want to see is whenever the switch statement comes in and inside switch we have various cases, it will only take the output where I have the value for game as cricket. Now in case I change this value to football, and now let me just save this one. Now let's go back to our console and refresh it and see. And it says I don't want to watch football, because for my football case I have given the output as I don't want to watch football. So this is exactly what is getting printed, or this is what we get as the output. Now let me see, let me just give foosball, and we do not have foosball in any of these cases, so it should go to the default value. But let's see what is the output here. So let me just save this one now and go back to the console and refresh it. Yes, so exactly we get the output as match not found, because it goes to the default value. So in case any of these are not found or matched with the initialized value, it provides us with the default value here. So this was all about the switch statement in JavaScript. Now with this, you know a lot more about the loops and switch statement. And before that, you have also learnt about all the fundamentals such as the object, arrays, strings, and how you can take the syntax and include everything inside your JavaScript code, and also how you can get it inside your console and see what is the output with the help of your HTML file as well. So now with all of these, you have learnt about the variables, objects, functions, arrays, loops, and conditional statements in JavaScript. Now this will help you create your own website. Now you can beautifully design your website with the help of JavaScript and also by playing around with these fundamentals of JavaScript. Now what are these JavaScript loops? So JavaScript loops actually provide a quick and easy method of doing something repeatedly. So they are used to repeat an action any number of times without having to repeat the same line of code again and again. Now there are mainly two types of loops. First we have the entry controlled loops and then the exit controlled loops. Now in the entry controlled loops, the test condition is tested before entering the loop body. So here for loop and while loop are the entry controlled loops. And for the exit controlled loops, the test condition is evaluated at the end of the loop body. Therefore, the loop body will execute at least once, irrespective of whether the test condition is true or false. Now do while loop is an exit controlled loop. So now let's move on and see what is for loop and how do we work with for loop in JavaScript. Now this method is actually a concise way of writing the loop structure. So a for loop repeats until a specified condition evaluates to false. So you can see that first we have a start point and then we have the item from our sequence and then we execute that statement. And if there are no more items left, we go to the end. But this loop will continue until there are items present in your sequence. So let's have a look at the syntax of our for loop. So in order to define your for loop, what you have to do is take the for keyword and then inside it you have to pass different parameters. So first parameter is our initialization condition. So here we will be initializing the value of our variable or what should be the condition. So this is basically our first parameter. Then next up we have our testing condition. Now what happens here is that we enter the testing condition that we are going to put for our for loop. For example, in the initialization parameter, we are giving the starting value for our variable. So here we can write x is equals to 0 or x is equals to 1. And here in the testing condition, we will provide the value or the condition till which this loop should go on. For example, you want the loop to go on till the value turns to 5 for x. So here your testing condition should be x less than or equal to 5. And finally, we have the increment or the decrement value here. Now what happens here is that this is our increment or decrement value for our variable. So we will check whether we are incrementing our variable or decrementing it. For example, either we can add +1 to our variable and go on with our loop, or we can go backwards and keep decrementing the value of our variable. Now once you have initialized all these three parameters, then you just have to write the statement inside that and you are done. So this is the syntax for your for loop. Now we will move on and see how this for loop can be implemented in a code and how it actually works. So here let's take an example and see how the for loop will work. So first let me just initialize a variable. Suppose let me take the variable to be x. And now I have to start with the for loop here. So let's see what are the values that I'm going to put inside these parameters. So the first one was my initialization condition. So here suppose I'm initializing the value of x to be 0. So this is my initialization. You can also put the value to be 1 or anything else. But here I'm initializing the value of my x to be 0. So basically the loop will start from the value 0. Now next up was the testing condition. So suppose I want this loop to go on until the value of x is less than or equal to 5. So this loop will stop, or it will come out of the loop as soon as the value exceeds the value 5. So here I have given the testing condition to be x less than equals to 5. And finally I have the increment or decrement value. So here from 0, that is the initial value, my value needs to increment and go until 5. That's why I have to give the increment value, which is written as x plus plus. If you want to decrement, you would be writing it to be x minus minus. So now I'm done with the initialization of my x variable, and also I have inserted the testing condition and also the increment as well. So now I just have to get the output for this one. So for that I have console.log, and I'm going to take the variable x because I want the output for this one and see that how the output comes out to be. Now let's save this one. And here I have my HTML file where I have linked the JavaScript file, that is the example.js. So as soon as I run this HTML file, I will be redirected to this website. So for this I had given a head tag which says welcome to Edureka. Now to go to the output, all I have to do is right click, go to inspect, and then I will get my console here. Now once I open the console, you can see that the output is 1, 2, 3, 4 and 5. So what happens here is that I had initialized the value to be 0, and then I've given increment value here. So what happens inside the for loop is that the value of my x is incremented from 0 to 1, and then to 2, then 3, 4, and finally it goes till 5. The next moment, as soon as the value reaches 6, which does not satisfy my condition, that is x should be less than or equal to 5, it comes out of the loop and prints the variable. That's why it prints these particular 5 values, that is from 1 to 5. So this was about for loop and the syntax of for loop, and also how you can implement this loop in your code in JavaScript. Now next up we will talk about the while loop. So a while loop is basically a control flow statement which allows the code to be executed repeatedly based on a particular Boolean condition. Now this loop is similar to that of a repeating if statement. So what happens here is that you have a starting point and then you get to go to the condition, and if the condition is true, you go to the conditional code and then back to the condition itself. In case it's false, it goes to the end. So until you finish with that condition, your conditional code will keep looping here. Now to understand the while loop in a simpler way, let's see how this works. Now talking about the syntax, let's see what is the syntax for our while loop. So we just have the keyword as while, and inside this we will pass our Boolean condition. So here we do not have different parameters. Here we just have one condition, that is we either check for true or for false. This is how while loop is different from for loop. So you just insert the Boolean condition here, and then inside this you add your loop statements. So this is the syntax for your while loop. You just have to insert your Boolean condition and then continue with your loop statements, and then you will get to see how it works. So now that you know the syntax, let's move on and have a look at an example of while loop. So now here I'm taking another variable, that is variable x equals to 1. So here I'll be initializing the value because inside while loop we do not have different parameters to pass the values. So I'm initializing the value as 1 here. Now next up is my while and Boolean condition. So what I have to do is take the while keyword, and inside this I have to put my Boolean condition. Same, let me check for this one as well. Suppose I want the x value to be less than equal to 5. So the loop should come out as soon as the x value crosses 5. So now here is the difference between the for loop and the while loop. So here we just have the Boolean condition, and then we have to put it inside the curly braces. So what happens here is that the increment or the decrement value comes later on. So what we will do here is that we will insert the increment value here as x plus plus, and then I'm closing this. So now you can see that first we have initialized the variable value here, that is x equals to 1, and then we have given the Boolean condition here, that is x less than equals to 5. And finally, I have taken the output of x, and after that I have taken the increment value. So what happens here is that it increments from 1 and goes till 5. As soon as the value reaches 6, it comes out of that particular loop. So now let's save this and go back to the console. So now you can see that here we have the output as 1, 2, 3, 4, 5. Because in while loop, what happens is that we are starting from the initial point, that is 1, and we go on until the value crosses this condition. So here we have given the condition as less than equal to 5. So the loop goes on until the value of x is till 5. And finally, we have printed the values from 1 to 5 for x. So this is how the while loop works in JavaScript. Now next up, we have another different kind of loop, that is the do while loop. It is almost similar to the while loop, but let's see how this one works. Now, as I said, this loop is similar to the while loop, but the only difference is that it checks for condition after executing the statements. In the while loop, we gave the condition beforehand itself, but in the do while loop, what happens is that first we will execute the statement and then we will check for the condition. That's exactly why it is also an example of the exit controlled loop. So now let's have a look at the syntax for do while loop. So here we have the do keyword, and inside that we have our statements. And finally we put up with the while keyword and insert our condition here. So as I said before, what happens here is that we first execute these statements, only then we go for checking the condition here. So this was the syntax for the do while loop. Now let's see how this loop actually works. So we will take an example here and see how the do while works. Now going by the syntax, so first I have to initialize the value for x. So for example, I'm taking the value of x to be 20 here. Then next up, I have to use the keyword as do. Now after this, I will be executing my statements and then I will insert my condition. So what happens here is that to execute the statement, I have console.log x and then I'm giving the increment value, that is x plus plus. Now once I'm done with this, finally I will insert my condition here. So for that I have the while keyword, and now inside this, suppose I'm giving the condition to be x less than 10. So what happens here is that it will only take the values if the value is less than 10. So here I have initialized the x value to be 20. So what happens here is that I have taken the condition later on. Now what happens, it will check if the condition is true or false. Now you can see that once I have executed this particular statement, my x value is 20. But according to the condition, my x should be less than 10, which is false. So it will go back and print the value to be 20 here, because here the execution of statement comes first and the condition comes later on. So now let me save this. And when I go to the console, you can see that the output here is 20 because it has first executed the statement and then checked the condition. So if the condition is false, we will go with the initial value of our variable. Now what happens if I change the value for my variable x? So suppose my variable value is now 5. So what happens here is that first it will execute the statement. So it will keep incrementing the value of 5. And then it will check the condition. Now you can see that here the condition is x must be less than 10. So now this satisfies the variable value as well. So the condition here is true. So now what will happen is the value of my variable x will be incremented and it will go on until the value is less than 10. So I should have the values to be 5, 6, 7, 8 and 9. Now let's see what do I get it as the output. So let's save this. Now when I go to the console, you can see that my output is 5, 6, 7, 8 and 9. So here what happened is it has executed the statement, and also when finally we have checked with the condition, it's satisfied with the condition as well. So we have printed the loop to be 5, 6, 7, 8 and 9. Now next up is the for in loop. Now this loop iterates a specified variable over all the enumerable properties of an object. For each distinct property, the JavaScript will execute the specified statements. So now let's see how this for in loop works, but first let's have a look at the syntax of the for in loop. So what happens is first we have our for keyword, and inside this we have our variable name. And then we use the in keyword here, and then we have objects. So what happens here is that it will take the variable name in your object. And this is how the for in loop actually works. And after that, we have these statements. And this is exactly the syntax for your for in loop. So now let's see how this for in loop works in JavaScript. So let's take the example here. So for that, first we have to declare our object. So let me take the object to be characteristic. And here let me add certain characteristics. So suppose I'm taking the characteristic of a person. So for that, the first parameter is name. And then let me take a second parameter. So the second parameter would be age. Then we have a third one to be eye color. And finally, we have another characteristic as the height. So these are some of the characteristics of a person that I have defined here. Now, according to the syntax for the for in loop, we have the for keyword, and inside this we have our variable name. Suppose we're taking the iteration here, so we have the ITR in characteristic. Now before that, we also have to initialize the variable here. So let's take the variable as ITR for iteration. And finally, we have the for loop inside which we have our variable name in object. And this is our object, which is the characteristic. Now we will just take the output for this. So for that, we have console.log. And here we have our object name, that is the characteristic, along with the variable name, that is the ITR. So now let's save this and go back to the console. So now you can see that we have got the output as name, age, eye color, and height. So what happens in this for in loop is that it takes the enumerable properties of our object, which is the characteristic, and for each of these distinct property, we execute the specified statements. So this was about the for in loop in JavaScript. Now we will move on and have a look at the break statement. Now talking about the break statement, here is a very simple syntax for this one. So we just have the break keyword, and here we have our label name. Now what is this break statement? So the break statement is used for jumping out of a loop. So it will help you in breaking the loop and also continue executing the code after the loop. So now let's see how this break statement works here. So first I have taken a variable I here. Now here I will have my for loop. So inside the for loop I will have my initial condition. So suppose I'm giving the initial value to be 0 for I. And then we have the testing condition. So for example, I should be less than equals to 5. And then finally, let's increment this value. Now in this break statement, we have another condition, that is the if condition. So here, let me take another condition as if I equal. So here we have the triple equals that will stop the loop as soon as it reaches that particular value. So I'm taking the condition to be I equals to 3. So as soon as the value of I reaches 3, we have the break statement here. So what happens is that the break statement will break the loop as soon as the second condition is reached, that is the value of I becomes 3. So now once you're out of this loop, now let's finally take the output for this one. So for that we have console.log as I. So now let's save this and go back to the console. So you can see that we have got the output as 0, 1, 2 because as soon as the value reached 3, there is a break statement here which broke the for loop. So we came out of this particular loop and only the 3 values have been printed. Now let me just change this value to 10 and this condition to be 5. Now let me save this code again and let's go back to the console. So now you can see that the values have changed from 0, 1, 2 to 0, 1, 2, 3, 4 because the condition has changed to 5. So as soon as the value reached 5, the break statement came out of this for loop and then we only got the value still 4. So now you understood how the break statement helps you come out of a particular loop, and also it provides you another condition so that you can come out of the loop apart from the testing condition itself. So this is how the break statement works in JavaScript. Now we will move on and have a look at how the continue statement works. Now the syntax for continue is also similar to break, just here we will have the keyword as continue and then we will have a label name here. Now the continue statement breaks one iteration in the loop if a specified condition occurs. We saw in the last one that when we use the break condition, as soon as the condition was reached, we came out of the entire loop. But with the help of the continue statement, the loop will continue. It will just break at that one point when it reaches the specified condition. Now the difference between continue and the break statement is that the continue statement jumps over one iteration in the loop instead of jumping out of the entire loop. So I'll show you the example of how the continue statement works here. So let's have a look at the same example here. This is the example we used for our break statement. So just in place of break, we will be using the keyword as continue. So here we have a loop which goes on until the value reaches 10. And here we have a condition which says I value is 5. So let's see how this works. So let me save this and go back to the console. Now you can see that we have all the values in the loop printed here except for the value 5. So after 4, the loop came out or skipped one iteration where the value or the condition was if I was equals to 5. And then it went back to the loop and continued with the rest of the iterations. So this is exactly how the continue statement works. So suppose I change this value to 5 and then change the condition, that is the if condition, to 2. And now let's save this. And now when I go back to the console, you can see that I have the values as 0, 1, 3, 4 and 5. Only the iteration where the value of I was 2 is missing here. And otherwise it continues with the rest of the loop. So this was about the continue statement in JavaScript. Now what are the JavaScript arrays? The arrays are basically used to store multiple values in a single variable itself. So the array is a special variable which can hold more than one value at a time. Now, for example, if you have a list of items in your shopping cart, you would want to store it in one place. For example, you would create a list of all the items that you want to buy. Now, the array represents those elements in your list. So you can have a look at the syntax of array here. You just have to define your array name and then you can put up the item names from your list inside the array itself. It can hold more than one item inside the list. So this will help you have one particular sorted list for all your items that you want to keep a track on. Now there are a lot of confusion between the arrays and the objects. So while working on JavaScript and using the console, if you're using the type of operator and checking the lists in your array, it will show as objects. So there's a lot of confusion between these two. Now arrays are special type of objects. So the type of operator in JavaScript returns objects for arrays as well. So you can have objects in an array and you can have functions in an array. Now we have already seen the syntax of how you can write an array in JavaScript, but there are two different methods as well. Either you can define one array with no values inside it, or you can use the let keyword, give the array name, and also write new array that will create an undefined array. And for object, all you have to do is take the let keyword and define the name of your object, and inside the curly braces you have to define the parameters that you have taken for your object. For example, here you have a girl and the girl is your object with parameters as name, age and eye color. So all you have to do is put all these parameters inside your object. So now that you know what are JavaScript arrays and how you can define them and also the difference between array and object, let's move ahead and have a look at the different JavaScript array methods. And also let's have a look what and all we can do with the help of arrays while writing a code in JavaScript. So first, let's see how this array works. So we have to use the let keyword and I have to give a name to my array. So for example, I want to put items in a list and for my shopping cart. So let's see what we can do. So we can give the name as list items equal to, and we can provide our items to create the list. So suppose I'm just putting elements like bag, shoes, dress. Suppose these are the items that I would want to put inside my list. Now to get the output, we just have to write console.log and inside that my array name, that is list items. Now let me just save this one. So here I've created an HTML file and I have linked it to my example.js, which consists of my JavaScript code. So what I'll do is I've saved this one. So now we will just go to the console. So once I run my HTML file, I will come to this particular web page, which has the head tag as welcome to Edureka. Now in order to get into the console, you have to just go to inspect and here you have the console option. So you can see the output here, and also you can see that it will give you the index number for each of these items present inside your array. So now in arrays, always the index number starts from 0 and not from 1. So you can see that the index value for bag is 0, for shoes it is 1, and for dress it is 2. It also provides you the entire length of your array, that is 3, because you have 3 items here. Now you can also define a particular item from your list with the help of its index value. For example, I want to get the element or the item from my list as shoes. So what I can do is I can take that particular element with the help of the index number as well. So here the index number for shoes would be 1. So all I can do is in my console.log, I will mention the index number or the index value as well. So I've provided the index value as 1, that is list items 1. So now I'll just save this one and go back to my console. Now you can see that it has changed. The output has changed to shoes. Initially it was showing me the entire array list items, that is it was showing me bag, shoes and dress, all 3 of them. But right now when I have already mentioned that I only want to get the item that is present in the index number 1, the output has changed to shoes only. Now you can also change the value of the variables, or you can insert items in your list, or also you can remove items from your list. Now if you want to add another particular item in this array, what you have to do is just take the name of your array, that is list items, and then add the index number where you're going to add it. So suppose I'm adding it in index number 3. And I just have to provide whatever I want to insert. So suppose I'm just writing watch and then I'll close this with a semicolon. So now I just have to save this, and now when I go back to my console, you can see that the array items have changed from bag, shoes, dress to now there has been a watch that has been added into the list. Now you can also replace a particular item from your array in the same way. So for example, I want to replace the dress with the watch. So I just have to change the index value here. So I have given the index value for watch as 2 now. So now let me just save this one. Now when I go back to my console, you can see that you have 3 items again, but those are bag, shoes and watch, and the dress has been changed with watch now because we have replaced the value of dress with watch by giving the index number for watch as 2. So this is how you can insert another value in the list of items, or you can replace any particular item in your array as well. Now another method used in arrays in JavaScript is the length. Now what do we do with this length method? Basically this will provide you that how many items are present in your list, or what is the length of your list. So what you can do is just write list items dot length in console.log, and this will give you the total number of items present in your list. So I'll just save this one, and now I'll go back to my console and now you can see that it gives me the output as 3. So basically it says that how many number of items are present inside my array. So this gives you the length. Now there's another method called as the concat method. Now concat method is used to return a new array comprised of this array joined with other arrays. So basically what happens is if you have two different arrays and you want to join them together, then you use the concat method. So it will help you in joining or concatenating these two arrays or more arrays together. So here we have one array that is the list items, and we have a few items inside this particular array. So let's take another array here. So suppose I will name it as colors, and then I will provide the colors as blue, green, and red. So now with this we have created another array here. Now we have two different arrays, that is list items and colors. Now if I want to join both these arrays together, what I have to do is I have to go to console.log, and suppose I want to join colors and list items together. Now I first want the colors and then the items. So I have to write it as colors and then use the concat method. And inside this, I will add the array that I want to concatenate here. So my first array is list items. So now let's just save this one. So it should basically give me the elements inside the colors array and then give me the values from the list items array. So now let's go to our console. So now you can see that the arrays have been joined together. So you can see the values inside your array as blue, green, red, bag, shoes, and dress. And also the total number of elements have changed to 6. Now you can see that the index number is also given here. So the first 3 elements belong to my second array, that is the colors, and the next 3 items are from my first array, that is the list items. Now if I want to do the opposite, all I have to do is just change it to list items and then concatenate colors. Now when I save this one and go back to my console, now you can see that the order has changed from blue, green, red, bag, shoes, dress to bag, shoes, dress, and then blue, green, red. That is, the first array is there, which is my list items array, and then you have the next array, that is the colors, concatenated with the first one. Now next up we will have a look at the push and pop methods in array. So let's see how the pop method works here in array. Now this method is used to remove the last element from an array and also return that particular element. So what happens is, here I have the array as bag, shoes, and dress. Now when I use the pop method here, it will just remove the last element, that is the dress, from my array and return that particular value. So now let's see what is the output here. Let me just save this one. And now when we go to the console, you can see that the output is dress here, because pop method is used to remove that element and also return that particular element from your array. So basically it always removes the last element or the end of your list. In the same way, push method is used in order to add any particular element inside your list. So pop removes the element from the end, push inserts any element into the end of your list. So for example, here I will just add watch again inside my array. Now suppose here I'm pushing another element. So what does this push method does is, it will provide you the new length of your array. In the pop method, we just used to get the return value as the one that has been removed from the array, and with the help of push method, the return value is the length of your updated array now. So now that I have pushed another element inside my array, the value should be 4 now. So let's see what it shows. So let me save this one, and now let's go back to the console. So you can see that the output is 4 here. So basically it updates the length of your array and also updates another element inside it, and the return value with push is the value of your new or updated array. Now another commonly used method is the reverse method. Now this reverse method is used to change the position of your elements in the list. So what it does is it will reverse the entire array that you have created. So here I have bag, shoes and dress. Now the first element would become the last and the last element would become the first element here. So now I will just save this one and now we'll go to the console and see what is the output. So now you can see that the number of elements are still the same. The items inside your arrays are also the same. Only the order has been reversed here. So initially our array started with bag and ended with the element dress. But now that we have used the reverse method, the values have been changed. The last one has become the first element and the first element has become the last one. Now there's another method known as the shift method. Now the shift method is used to remove the first element from an array and return that particular element. Now we had the pop element for the end of your array, that is the last element, and here we have the shift method for removing the first element. So here we'll see how the shift method works. So all we have to do is just use the shift method along with my array name, and now I will save this one. And now let's go back to the console and see. So now you can see that the output is bag. So my array was bag, shoes and dress and in this order. So the first element was bag. So now as soon as I've used the shift method here, what it has done is removed the very first element from my array. Now the return value is also that particular element that has been removed from my array. So this is how the shift method works here. Now the next one is the slice method. So slice method usually extracts a section of an array and returns you a new array. So what you can do is you can use the slice method here and you can provide any particular beginning and ending value that you want to slice from your array. Now the return value would be the values that have been extracted from the array. So now here I have given the beginning value as 0 and the ending as 1. So the value or the element present in the index number 0 will be extracted from my array. So now if I save this one and go back to my console, you can see that the output is bag, that is the extracted value from the array, and the index here is 0. Now let's just change this. So if I change it to 2, you can see that from the position 0 and 1, the values must be extracted. So my output should be bag and shoes. So let me save this. Now you can see that the output has changed from bag to bag and shoes because it will take the value as 0 and 1. So you have to define the beginning and the ending value here, and it will take the -1 value. So as I've given 0 and 2, it will take the values as 0 and 1, that is 2 minus 1. So it will extract the values from the position 0 and 1. And also it will return those particular values itself. So that's why the output was bag and shoes. Next up, we will have a look at the sort method. So the sort method basically sorts all the elements of an array. So if you have numbers here, it will sort from the smallest number to the largest one, that is in the ascending order. Or if you have strings here, so it will arrange them in the alphabetical order. So now let's see, we have used the sort method here. And now let me save this one and see what is the output. So you can see that the order has been changed from bag, shoes, dress to bag, dress and shoes. So the elements in the list have been arranged according to their alphabets. So it's arranged alphabetically. So B comes first and then D and then S. And that's exactly how the elements in the list have been sorted. So with the help of a sort method, you can just arrange all your elements in any particular order that you want. If you do not mention anything, it will sort according to the alphabets or according to the values if there are numbers here. Now the next method is the toString method. So with the help of the toString method, what we can do is take the array elements inside our array and get the output in the form of a string. So what it does is it returns a string representing the source code of the specified array and all its elements. So here I have added these 3 items inside my list or the array. So now during the output, I'll just use the toString method. with my array, that is list items dot toString method. Now let's see, let me save this one and let's look at the output. So you can see that in the console you see bag, shoes and dress, but this time all three of them are in the string format. Now to show you the difference, let me just take the output as array only. Now let me save this one. And now let's go back to the console. Now you can see the difference. So initially with the help of toString, it was only defined as a string. Here you can see the array elements. So you can see the index value and it is also represented in the form of an array. But as soon as you add this toString method and save this one, and now go back to your console, you can see that all these three values here are shown in the string format. So this is what you can do with the help of your toString method. The array elements are represented in the form of a string here. Now we have already discussed about the shift method. So now let's have a look at the unshift method. So this unshift method is used to add one or more elements to the beginning of an array and also return the new length of the array. Now shift was used to remove the first element of your array and return that particular value itself that has been extracted. But with the help of unshift method, we will be adding elements in the beginning and also return the length. So here I will use the unshift method, and suppose I want to add two values inside my list. So let's just add watch and let me add glasses. So here basically I'm adding two more values inside my array. So the list of items will become 5 from 3 now. So now let me save this one, and also it returns me the value of the length of my array now. So how many values I've added and what is the new or the updated length of my array will be shown as the output. So now let's go to the console. Now you can see that the output here is 5, that is the updated length of my array. So here I had 3 values initially and I've inserted 2 more elements inside my array with the help of the unshift method. So now the value has changed from 3 to 5, that is the length of the array has changed to 5 now. So with the help of unshift method, it returns you the value of your new or updated length of your array. So here you can see that the value has changed to 5. Now there's another method called as the join that is also used to join all your elements in the form of a string. Now with the help of toString method, we have seen that how we can convert the array values into a string. The join also does the same thing, that is it converts all the array elements and joins them together in the form of a string. So suppose you have 2 or more arrays here and you want to join the values and form a string, or you want to give any particular string output and then join the items from your array inside it, you can do with the help of join. So now with the help of this join method, you can see that all your array elements have been converted into a string here. So to explain you a little more about the join method, so suppose I want to add this particular string, that is string name, with all my elements in the array itself. So it will take the list of items and add this string name in between all of these elements. So basically it will join the elements from the array with the help of this particular string. So here I have bag, then shoes, so it will be bag, string name, shoes, string name, dress. This is just a name that I have given. Suppose you want to add them with a plus sign or anything, you can add it with the help of that as well. So let me save this. Now when I go back to my console, you can see the output here. So the array elements have been changed into a string and they have been joined together with the help of this string name. So when I left it blank, it was just bag, shoes and dress itself. Now I've joined these elements with this particular value. You can just also write a plus sign here in order to show that how it is joined. Now save it, and then once we go back to the console, you can see that it shows the output as bag plus shoes plus dress. So basically it is joining all the elements from your array and then converting it into a string and giving you the output in the form of a string. So these were some of the most commonly used methods when it comes to using the arrays in JavaScript. Now there are various other methods that you can use to perform different actions. For example, if you want to call any particular value, or if you want to return the last index, you can use the last index of, and you can also filter out the elements with the help of your filter method. So there are various methods in array that can be used here, but these were some of the most commonly used and also the most important ones that you would need while writing any particular code in JavaScript or while working with arrays in JavaScript. Now this was all about how we use the array methods and also how arrays help you in working in JavaScript, and also the various definitions or the different ways that you must know while working with this particular method.
Now, before you learn any language, you should always know why you're learning the language. Every language serves a special purpose, and the very same goes for Golang. So, why exactly should someone learn Golang? Well, Golang was built by Google to solve problems they face at Google. Now, at Google, lots of big programs are built for big server software that run on massive clusters. Now, before Go, Google was using languages like C++ and Java to solve problems, but these languages didn't really have the fluidity and ease of construction that was needed for problems of such scale. Keeping these things in mind, a few years ago, Ken Thompson and Robert Creaser thought about building a new language that would be good for these kinds of problems, and hence Golang was born. Basically, if you're trying to solve a problem of enormous scale or just need an efficient and scalable code, Go should be your go-to language. Now, Go isn't the first to address the need for a scalable and highly efficient program for large-scale programming. So what exactly makes it stand out? Well, the existing languages have been good enough until recent years, but there's been big changes in the computing environment in the last decade, which has included a lot of networking, a lot of cluster computing, or the cloud as you common folks might know it by. Now, the languages that were being used to implement services until now are at least 10 to 20 years old, so there are a lot of properties of modern computing environment that these languages don't address directly. Therefore, having a modern language that works really well in modern computing environment is actually important. But you also want it to be efficient, because you're going to be running these on hundreds or maybe even thousands of machines. You also don't want to waste resources by having an inefficient interpreter or some of the problems that generally come up with virtual machine implementations. Golang ticks all these boxes and hence has garnered the much deserved fame in the developers community. Okay, so that was all about Go. It's time we move forward and dive into programming. Now, throughout this tutorial, I'll be explaining various concepts that are general to most programming languages and some concepts which are specific to Go. I'll be showing a small piece of code on the presentation, and I'll explain the code and the purpose it serves, and then we will also build a simple program on a text editor using those concepts and then go run them on the terminal. Now, before we start programming, we must also install Go, which is a pretty simple task. Just head over to golang.org, click the download Go button, and install the binaries for your respective operating system. Okay, so now that we are done with the installation bit, let's head over to our first program, which is a very generic Hello World program written in Go. I'll go over the lines of code line by line. So firstly, we have the package main, which means that every Golang program belongs to a package. This actually helps in code readability and code reusability. So after we've defined the package, next we're going to import some general libraries that are going to be used throughout the program. Over here, I've imported the format package, which is used for formatting text on the screen. And as you guys can see, I've also created a main function. And inside the main function, I've used the printline method from the format package to print hello world. Okay, so let's see how this program would actually run when actually written on a text editor. So let's head over to our text editor. For me, I'll be using Sublime Text. You all could use anything that you feel comfortable with. So let's start typing. So package main, and then we want to import the format package. Then we have to create the main function, because the main function is what runs when the program is actually executed. It's the first function that runs. And then we have to print hello world. This is my first Go program. Let's save it and let's run it. So to run Go programs, you'll need to open up your terminal from the place you've actually saved your Go program. So now that you've done that, go ahead and type Go run and the name of your program, which is first.go. Okay, so as you guys can see, we've successfully compiled our program and the output is already on the screen. It says, hello world, this is my first Go program, and that's exactly what we had expected. Okay, so that was a very simple program and we have a lot to learn, so let's move on. Okay, so now let's head over to variables and constants. So what exactly is a variable? Well, a variable is nothing but a name given to a storage area that programs can manipulate. Each variable in Go has a specific type, which determines the size and layout of the variable's memory, the range of values that can be stored within the memory, and the set of operations that can be applied to the variable. On the other hand, constants refer to fixed values that the program may not alter during its execution. These fixed values are also called literals. Constants can be of any of the basic data types like integers, floating constants, a character constant, or even a string literal. And there are also enumeration constants as well, and constants are generally treated like regular variables except that their values cannot be modified after their definition. So that was it about variables and constants. Now let's move ahead with data types. I'll show you guys how to actually define and use variables and constants later on while we are programming, so just hold on. So Golang has 4 different types of data types. As you guys can see, they're numeric, derived, boolean, and string. So numeric data types are any data types that hold numeric value. For example, we have 2 types of numeric data types, that is int and float. Now ints are also of 2 types, that is ints and unsigned ints or uints, and they have a space of 8, 16, 32, and 64. Then there's also floating point values which have decimal precision, and these can be of float 32 type or float 64 type. Then comes derived data types. So derived data types include things like pointers, which is the memory location of any variable, arrays, which is a data structure that contains similar types of data types. Then we have structures, which is another data type in itself for actually creating custom data types. We'll see how we can use them later on. Then we have maps, which are like dictionaries in Python or hash maps in Java. And then we also have interfaces for abstracting our methods. Then we have Boolean data types, which are basically either true or false and are used for decision making and binary decisions. Then we also have string literals, which is just a series of characters, like your name would be a string literal in Go. Okay, so let's also cover operators before we move on to a little more programming, because we've already covered the data types. So Golang has 3 major types of operators that are prevalent in every programming language. That is arithmetic operators, relational operators, and logical operators. So arithmetic operators allow us to perform arithmetic in Go, and we have this 5 operators, which is basically addition, subtraction, multiplication, division, and modulus. Modulus, if you guys don't know, gives us a remainder after division. Then we have relational operators, which is basically used for comparing two values. Now we have the greater than operator, the lesser than, the greater than or equal to, then we have equivalence and not equals to. We also have logical operators, which include and, or, and negation, and these are normally used to implement Boolean logic in our codes. We'll see how these are actually used as we go on with programming. Okay, so let's head over to our text editor and try some of these stuff. So first of all, what we learned is that we have variables. So how exactly is a variable defined in Go? So first of all, we go var a and then the data type, that is int, and we say the value. So var a int equals 5. Now this will actually declare integer variable of value 5. We can also have floating type variables like var b equals float 32 equals 4.32. We also discussed that we have constants, which is const, suppose something like pi, and this could be a float 64, and it's going to be something like 3.141. Now, if you want to declare two variables together, there are a few methods that you could use. First of all, you could say var and open close brackets, and in this bracket, you could say c equals 8 and d equals 7. So there's also the shorthand notation that is very popularly used in Go for actually declaring multiple variables. So that is x comma y could be declared as colon equals to 14 comma 15. So this would declare two variables of integer type, like Go is smart enough to understand that x is an integer and y is an integer too. And it'll declare x equals 14 and y equals 15. So let's actually go and test all these out. So let's print everything. So fmt.println. So a should be 5. Copy this out. So we want to print b then. Then we want to print pi. Then we'll also print x and y. Let's save it and let's run it. Okay. Okay, as you guys can see, we have successfully printed out all the values that we have declared. Now, we also learned that we have operators. So in Go, you have arithmetic operators, Boolean operators, and relational operators. So let's go and test out the arithmetic operators. So let's declare two values, x comma y equals, that's 5 comma 6. And let's do some basic arithmetic operations with these guys. So we can also do the arithmetic operations in the println statement. This is very well supported by Go. So x plus y, let's do it a bit better, equals, comma, x plus y. So we have subtraction, multiplication, division, and modulus. X minus y, x multiplied by y, x divided by y, and x modulo y. So let's see if this produces results, which it should. Okay, so we have to go run and first program. So as you guys can see, we have the perfect results. 6 by 5 is 0 because it just doesn't go, it's too big, and it's not floating point numbers, so it will not give us precision. Then x 5 multiplied by 6 is 30, 5 minus 6 is minus 1, 5 plus 6 is 11, and we have performed arithmetic. Similarly, we also have booleans. So something like is bool is true. So we could also do this, or we could even declare it like this. So you could go var is boolean and true. So that's the longer way. I'm just going to be using the shorthand. Now for booleans, let's also create another boolean because I want to test something. So let's call hate. Hate is false. Now let's try and print some boolean stuff out. So fmt.println. We can also perform boolean operations here. So is bool and hate. Okay, so this should print false and this should print true, and this will also print false because the negation of true is false. So let's test that out. As you guys can see, it's false, true, and false, and that's how Boolean operators work and Boolean logic works. Then we'll also have relational operators, but we'll get to that later when we're actually going through decision making. Okay, so it's time we move ahead. Okay, so now let's see how pointers actually work in Go. Now, pointers in Go are easy and fun to learn. Some programming tasks are performed more easily with pointers, and other tasks, such as call by reference, cannot be performed without using pointers. So it becomes necessary to learn pointers to become a perfect Go programmer. So as you guys know, every variable is a memory location, and every memory location has its own address, which is defined. And this can be accessed by using the ampersand sign, and this denotes an address. So as you guys can see in the piece of code, we have a variable called x with the value 5. Now printing x will output 5, while printing the pointer to x, which is ampersand x, will print the memory location. So let's try that out in our programs. So let's delete all this. Now suppose we have a variable x, which is equal to 10, and we want to print the value of x, and we also want to see pointer to x, which is basically ampersand x. Okay, so let's see what that outputs. Okay, as you guys can see, this is the value of x, and this is the address where x is stored. Now you guys might be asking, where exactly would I use pointers in a program? So let me just give you a basic example. Now suppose you wanted to change the value of x by passing it into a function. So what you do is you create a function called change value and you pass in x. Now let's create that function here first. So change value and you pass in x as an argument and you say x equals 7, right? So now we want to print x. So fmt.println x. And what we are expecting is that 10 will be passed into this function, it gets changed to 7, and 7 will be printed here. But that's not exactly what's going to happen. So let's see. So as you guys see, x is still 10. So why exactly is that? Well, because the x out here doesn't have a scope out here. So it doesn't really mean that we're changing the same x. But if we were to actually send the pointer to x, then this would have a different effect. Now x is 7, as you guys can see, because we changed the value at the memory location. So this is where pointers are extremely helpful. You want to change something at the memory location, you basically use the pointer. Okay, so that was all about pointers. Now let's move ahead. So Golang also gives us an option to custom print using the printf function, which is in the format library. Now I've demonstrated a few of the implementations of the function as below. So as you guys can see, we have the format.printf function in this piece of code out here. So firstly, the %f lets us format print a float number. %t lets us show the type of anything. Then small t with percentage shows us a boolean. %d is used for showing integers. Now, instead of me showing you through the PowerPoint presentation, let's go and actually code a little. Okay, let's remove all this first. Before we get into format printing, let me show you all a bit of strings. Now, we had discussed that we have this data type called string, and it's basically a character literal. Now, to define a string, you could go var name and type, which is string, and then you define the value, which is aria Paul. Now, if you wanted the length of this name, you could just go format.println length of name. Let's go and run that once and see. Okay, so my name is 10 characters long, including the space. So we got that right. Now, we can also join sentences with the plus sign. So let me just show that once. So format println, you can go name plus probably is a chill dude. So you could do something like that. And this will now print out that I'm a very chill dude. Yeah, so Paul is a chill dude. Now that we have seen how strings and stuff work, let's go through the printf functions. So printf is basically formatted printing. So let's try out all the ones that I can think of from the top of my head. If you all want to go through all of them, I suppose you could go through the documentation. So format printf. So suppose we wanted to print out a float. So we'd go %f, and we also have to specify that we need a new line, and then we'll just print out any floating point number. For that, we also have to kind of define it too. So constant pi, which is a float 64, equals 3.1412345, whatever. Now that we have actually defined our float, we can print it out. Okay, now we've printed out the entire float. You could also specify the precision you want by saying something like this, that 0.3f. Now it'll show us for 3 precision. Let's try that out. Yeah, as you guys can see, it's just 3.141 now. Now, if it was a 5 out here instead of a 2, it would have probably rounded it off to the next value. Now, we can also print the type as I had discussed. So we can go format printf, and %t should give us the type. So %T will give us the type, new line, and let's check out the type of name. So it should print string. Let's comment these out for once. Yep, so it showed us the type that name is, and that is a string. Now we can also print booleans with the printf function, as I had shown in that piece of code, and that is by saying %t. So for that, we need a Boolean first. So let's go and do that. Win true. Now we can just print a win and it'll print true. Okay, so that's that. Now %d is used for integers. So let's see that. First, let's define an integer and let's print out x. So that's going to be d and this is going to be x. Okay, so that worked. Now we can also print binaries using the printf function. So for binary, we go %b, new line. Suppose we wanted the binary of the number 25. So this would print the binary of 25. So 110001 is the binary of 25, and you guys can check it in your binary calculators, and I'm sure it's right. Okay, we can also print the characters associated with a key code, if I remember correctly. So that is given by printf and %c. So let's try 33. What exactly is 33? Let's check that out. Okay, I forgot my comma out here. Okay, so that's an exclamation mark. So we come to know that. So 34 is probably a question mark. Let's check that out. Okay, it's that thing. So we can also print the characters that are related to the ASCII codes. Then we can also print hex codes. So let's try that out too. So you can print hex codes with the %x sign. So this will print out the hex code for whatever value you input into it. So suppose we want the hex code for 15. As we all know, as hex in F is 15. Now we can also print scientific notations. So let's see that. So fmt.printf, the scientific notation is given by %e. You want a new line, and let's print pi. As you guys can see, that prints it out in a scientific notation. Okay, so that was all about formatted printing. And this taught us how we can print different objects and different data types with different escape characters. It's time we move on to loops now. So if you're new to programming, a loop is basically an iterating mechanism in computer science, and it's used mostly when you need to perform a repetitive pattern in programming. Now, in most programming languages, there are 3 types of loops, namely for, while, and do while. But Golang has only one type of loop, and that is a for loop. The syntax of Go, though, allows while loops to be implemented with the syntax of a for loop. Now, before we get to coding loops, let's take a look at the general structure that is followed in Go for looping. So the code that you guys see on the slide, for loop with 3 different parts. So firstly is the declaration of the iterator I, which has been set to 1. Then we have the limit of the iterator, which has been set to less than 5. And then we have to set the incrementation of the iterator, which has been set by I++, which is basically a shorthand for I equals to I plus 1. Okay, so now that we know the structure of a loop, let's try and practically implement them in our very own Go program. So let's head over to our text editor. Now let's remove all of this first. Okay, so first of all, we will try to print the first 10 numbers using a normal loop. So let's say for I equals 1 and I less than equals 10, because we want to go up till 10. And I++. Okay, these have to be semicolons. Please remember that. Then we just open up our loop bracket. Now what we want to do is print out I. So we can go format.println, and we just want to print I. Okay, so that should print all the numbers from 1 through 10. And that's exactly what happens. Now we can also define a loop like this, which is basically making it into a while loop. So we can go I equals 1, and we could just say for I less than equals 10, then format.println I, and we have to also increment I. So this will also do the same thing, but in a while loop sort of fashion, because this is kind of an exit control loop now. And as you guys can see, we implemented the same logic in 2 different ways. Now we can also have a loop inside a loop, just like every other programming language, and we can use that to build patterns and whatnot. So let's try it out once. So for I equals 1, I less than 5, I++. Now inside this, we're going to have another loop for j equals 1, j less than I, and j plus plus. All we want to do is go format, print, and we want to print a new line here. Okay, I forgot the quotes. And if you use printf, you get a really cool pattern, something like this. So that's how you use nested for loops also, and nested loops in general in Golang. So now that we're done with implementing loops in our very own Go program, it's time we moved on to decision making. Now, decision making is used in computer programming whenever we need to make a decision based on logical steps. So let's take a look at this code for an example. So we have a variable called age, and it's set to 18. Now, we have to decide whether this person of age 18 can vote or not. So if age is greater than 18, you got to print you can vote, else you print you can't vote. So this is how proper decision-making control flow actually works. So first, when you meet the if statement, the computer decides whether it's true or false. So if it is true, the conditional statement is executed and the program moves on. And if it's false, the control flow of the program just moves on after the conditional statement. Okay, so let's implement decision making in our very own Go program now. So there are two ways you can actually implement decision making in Go programming. So one is through the if and else if, and the second one is through switch statements. So let's try our very own decision making program in Go. So first we define an age, and now we're going to decide if this person can vote. So if age is greater than 18, then this guy can vote. So format print line, yes, you can vote. Else, be very careful of the syntax, so I'll give you a syntax error. Else has to be on the line that we ended here. Now else, we have to say format print line that no, you can't vote. Let's save that, let's run that. So as you guys can see, since 18 is definitely not greater than 18, so the program prints out, no, you can't vote. Now decision making, as I said, can also be done with switch statements. So let's say something like this. So we want to switch the age, and we'll set different cases. So suppose our guy is 16 years old, so we say format print line prepare for college. If he's 18 years old, probably he's trying to get a girlfriend. So we could say something like, don't run after girls. Or you say case 20, and we could be like, get yourself a job. Or the default case, in which case we're going to print, are you even alive? So at this moment, you're going to see don't run after girls, but this is when you have specific operations for specific cases. Like for case 16, we'll have a specific operation. Case 18, we'll have a specific operation. And then we also have a default operation. So let's run this and see. So as it says, don't run after girls. If we change this to 16, we'll see whatever's in case 16. Let's prepare for college. And if we make this something like 78, then the default case will run, and it'll just say, are you even alive? So that's how switch statements work. Okay, so that was all about decision making. So now it's time we move to arrays. Now in Go programming language, we are given a data structure called an array, which can store same types of data in one variable basically. So suppose we have student count, and it's going to store 10 different student counts, and it's of int type. So that's how you define an array. So basically an array is used to store a collection of data, which is often more useful to think of an array as a collection of variables of the same type. Now let's go and implement them in our Go program. You'll have a better understanding through that. So first of all, let's delete everything that we had created. Now let's define our first array. So let's call it even numbers, even num, and we're gonna store the first 5 even numbers, suppose, so 5, and they're gonna be of int type. Now we can also initialize all these even numbers like this. So at index 0, we're gonna have 0, And let's copy this out now. Okay, so let's say, so 1, 2, 3, and 4. 2, it's going to be 4, it's going to be 6, and it's going to be 8. Now that's how you initialize the members of an array. Now suppose you want to print third element. So you'd go 0, 1, 2. So that is, second one is the third element. So you'll say even num and the second one. So that should print out 4 for us. So let's see if we are right. And we are exactly right. So it prints out 4, and that's how arrays work. Now you can also initialize arrays in multiple ways. So first of all, let's delete this, rather comment it out. Now you could have gone something like even num, and then using the shorthand notation, you say you're gonna have 5 of them, you say they're all gonna be ints, and then you just initialize them in curly braces. So 0, 2, 4, 6, 8. Now that would also give us the same thing. Let's uncomment this, and it should print 4 again. So that's how you can also initialize an array. Now we can also iterate through the array through all the members using a for loop. Now that's very important. So we don't really need the index for the for loop, so we can do something like this. Now there's also the range value. So value equals range of even num, and we are going to print the value. T.println value. So this will iterate through all the members of the array. So as you can see, it's 0, 2, 4, 6, 8. Now this underscore means that we are not actually using the iterator, and the value is still the range of even numbers. Now if you would also like the iterator to be there, you could just simply put this as I, and then say I out here, and that would also print out the values along with their indexes. So 0 is at 0, 2 is at 1, 4 is at 2, 6 is at 3, and 8 is at 4. Now, there's also something called slicing. Now, every array can be sliced in every programming language that is there, and Golang is no different. So how exactly do we slice arrays? So what exactly is slicing? Well, slicing means that you are taking some subpart of the array. So suppose we want to slice this array from the third element, so we would only get these. So that would be our slice. Now let's see how we can actually slice arrays. So mostly sliced arrays are just like arrays, but you just leave out the slice of the array. So suppose we go num slice, and you can go something like int, and you can just initialize it like 5, 4, 3, 2, 1. Now we're going to try and slice this array. So our sliced array will be stored in a different array. So we are going to call it sliced, and we're going to slice our num slice array, and we're going to slice it from the third value to the fifth value. So that is from 3 up till 5, not including 5. So you go 3, colon 5. Now let's just print out sliced, fmt.println sliced. Okay, I made a mistake here. So as you guys can see, it gave us 2 and 1, which is from the third to the fifth. That is third and fourth, basically. Now we can also slice an array backwards. So that can be done like this, which is you do not give the first value and it'll be just assumed to be 0. So it can give you everything, or you can do something like this, 0 up till whatever there is. So this will also give us the same output, 5, 4, 3, 2, 1. So you can also create an empty slice and define the data type. So we do it something like this. We go slice2, and we use the make keyword, and open close brackets, and 5, 10. And you can copy the contents of one slice to another slice. So you could be like copy slice2 into num slice. Now let's print out stuff. So println, and we print out slice2. Let's see what happens. Okay, so this was like this. And as you guys can see, that was it. Now we can also come and num slice out here and see that has also been copied into, and it's the same, it's been copied into and it's the same thing. Amazing. We can also append values to a slice, and that is done with the append function. So we go slice3 equals, so we want to append something like num slice, and we're going to put 3 with 0 and -1. Okay, so as you guys can see, we have successfully appended 3, 0, and -1 to our already sliced array. Okay guys, so that was all about slicing and arrays. The next thing that we're going to study is maps. So maps is basically like a dictionary. It provides us a key value pair kind of data structure, and it's used for hash maps. So if you have a value to a word, something like Theodore Roosevelt out here, he's matched to the value of his age. So we can create a map for such stuff. Now this is how you exactly declare a map. You go for the name of the map and then use the make keyword, and then the map keyword, and then the type of the value, and then the type of the key. So int is the string is the key, and the int is the value. So it's better that we go and just implement it because it gives us a better understanding. Okay, so let's create our map first. So let's call it a student age, and it's gonna have the name of the student as the key and his age as the value. So we go make map. So inside is going to be a string and it's going to be an int. So something like this. So student age area equals 23, or student age something like Saurabh equals 27. That's how you initialize your maps. Then you could also put a lot of stuff. Let me just copy this and make a definite map. Now let's call this person Prerna. Let's call this person Akriti. Let's call this person Sahiti. And let's call this person Kirti. So Prerna is 21. Akriti is 19. Sahiti is 42. And Kirti is 22. So this is basically a map of all the student names and their ages. Now, if we were to go and print something like this, fmt.println, so let's say student age, let's see what happens when we just print student age, actually. It prints out the entire map for us, and we can also print a particular value by giving it the key. So suppose we want Kirti's age. So Kirti is 22 years old, and that's what it should output. Okay, so as you guys can see, it's output 0 because I've put a small k out here. So it has to be exactly case specific. So if I were to make it capital now, output 22. Okay, so that's how maps work. Now we can also have maps inside of maps. Now, before we move ahead, let me show that you can also find out the length of a map. So we could go something like, let's print out length. So length of student age. So this should give us 1, 2, 3, 4, 5, 6. Let's see. So that was 6. That's amazing. Now we can also have maps inside of maps. And this is mostly used when you have a mapping to a mapping. You'll get to that when you actually code for the industry or something like that. But let me show you an example in a simplistic way. So let's say this is what we do. So for a map inside a map, suppose we have a map for superhero. And that is basically a map of a string, which is again mapped to a string, and it's also a string. So we would initialize something like this, so Superman, and you're going to map Superman to a string again, and you're going to say real name is Clark Kent, and he lives in a city called Metropolis. Then you could also specify another map, give it a comma, and just, so we could go something like Batman will be mapped to a string, and the value will also be a string. Now a real name will be Bruce Wayne, and city will be Gotham. Okay, so that was that. Let's close out our map. And we can output the data where the key matches Superman. So let's see. So we can do something like if temp, comma, hero equals superhero. Okay, now that we've actually created our maps inside a map for superheroes, we can actually print out the data. So how exactly do we do that? We do that by going if temp and hero equals a superhero, where superhero is Superman. So we can say hero. Now we just have to print. So we go temp, real name, and city. Okay, so that's how we actually make maps inside of a map. Now let's go and run it. Unexpected new line. Okay, expecting a comma. Okay, we need a comma out here, and a comma out here. 12. I forgot my commas. String map but not used. Okay, that should clear out all the errors. Now it's compiled, and we should see our output, which is Clark Kent and Metropolis. So despite all the errors, we have solved our program. We should put commas after every event. It's not an event, rather, it's a part of the map. So after every part of the map, we should put a comma. That's what we learned, and we have forgot an equal to out here. Now, that was all about maps. Okay, so let's move forward. So next up, we have functions. Now, Golang also allows us to make our custom functions, which will be used for our custom uses. So like in this piece of code you see out here, we have a function called add, and it takes in two arguments, which are a, b, and they're of type int, and they'll also return an int. So this is the return type that we have specified out here, and then we are returning a plus b. So adding custom functions to your program will make it in a more modular fashion and make your code much more reusable. So let's see how we can use functions in a Go program. So let's delete all this first. Now let's create two variables. So x comma y equals 5 comma 6. So suppose we want to add these. So let's send x and y. Now we can just directly print it out here. Now that we've actually called a function, we need to go and create it. So func add. Now this is where you set the arguments. So we are sending two numbers. So you could either go num1 comma num2, and they're both ints. Then we also have to specify the return type. So that is an integer too. Now we're returning num1 plus num2, and that's about it. So it should output 11 now. Okay, we have an undefined num2. Okay, so we forgot to say num2 here. My bad. And now this should say 11. Yep, just as we had expected. Now you could do this for other stuff, like you could make this subtraction, you can make this into a division function, or any other function that you would like to create. Okay, so that was how we could create a custom function. Now we can also do something called recursion with functions. So recursion is when you call a function from inside of itself. So let me show you the slide for that one. So yeah. So suppose you were calling factorial from inside of factorial. That means you're setting up a chain of calls to the function until this value is actually satisfied. Now let's see what that actually means. So suppose we want to print the factorial of a number. So we have a num, and let's say it is 5, and we want to print the factorial of 5. So we say factorial and 5. Right? Now, what we need to do is create the factorial function. So func factorial takes in one number, num, and it's an int, and also will return an int. So int, and there you go. So first of all, we need to say that if num equals to 0, then we return 1. Else, what we do is we just say, else we're going to return num into factorial of number minus 1. So this will basically call here first. So first 5 will come here, then 5 minus 1, 4 will be called, then 4 minus 1, 3 will be called. and we'll get the factorial. So let's see if that works out for us. So num is not declared, but not used. Okay, yeah, we had to pass in num instead of 5. So this should output 120 for us because that is the factorial of 5, and voila, we have 120. So that's how you use recursion in Golang. It's a very optimizable way of actually implementing a function where you're calling itself, and you should always use recursion when possible. Okay, now moving on, we have some Go-specific languages called control structures. Now these are basically 3 functions, that is defer, recover, and panic. Now let me just theoretically tell you all, because this is a very Go-specific thing. So defer statement defers the execution of a function until the surrounding function returns. So then multiple defers are pushed into a stack and executes in the last in first out order. Now defer is generally used to clean up resources like files, database, and connections. So suppose you have opened a file using Go, and if you all open a file, you'll always have to close it, but some people might just forget. So you could put a defer saying that you'll close the file after all these functions are done, and defer will do that automatically for you. Then we have the recover function. Now recover is another built-in function in Go, and it helps regain the normal flow of execution after a panic situation. Generally, it is used with the defer statement to recover panic in a Go routine. Thirdly, we have the panic function, which is similar to throwing an exception in any other language like Java or C. And generally, when a panic is called, then the normal execution flow is stopped immediately, and the deferred function are executed normally. It is a built-in function in Golang. Now let's see how these are actually used. So suppose we have 2 functions basically. So first run and second run. Now since we're calling first run first, that's what should run first, right? So let's create these 2. Func first run, and it'll just print out I executed first, and we'll also have a second run. Now let's see, I executed second and second run. Okay, so if we run this, we should see first I executed first and then I executed second. Yeah, so that's how it's worked. Now what if we put a defer out here? So we say defer, and this would make second run first because defer runs after all the surrounding functions have already finished. So we'll see how this actually works. So as you guys can see, I executed second, which is second run runs first, and then I executed first runs after this one. So that is how defer works. Okay, now that we have seen how defer works, let's see how we can use recover and panic to actually handle our errors. So suppose we want to divide 2 numbers safely. So let's say we're trying to print 2 numbers, print line, and we go something like div, say 3, 0. So whenever we're dividing by 0, it should throw an error basically. And we can also do fmt.println div 3, 5. Right. So now let's make the div function. Func div, first of all, is going to return an int. And wait, it's going to take in 2 numbers, num1 and num2. And both of them are going to be ints. And it's going to return an int. Now we want to defer a function first so that it runs last. And we're going to recover from this. So this is how you use recover with defer. So basically after everything is done, you want to recover from the situation that you probably created for. So you use recover with defers because you want to recover from the situation you created from yourself. And you want this program, this function to run after all the errors have been created. Now you want to say solution equals to num1 by num2. And you're going to return the solution, right? Now you have a sum called dem_panic, and this is a demonstration of panic, and you defer a function where you're again going to recover. Let's print our recover statement here. And in the end, we can go and say panic. Okay, so we also have to call dem_panic here, and that's about it. Let's save this and run. So this should throw an error, basically. Yep, so you see, We threw the error was like nil and then panic. So that's how you use defer with recover and panic. Now, you can also pass an unlimited number of arguments to a function. I forgot to cover that. So let's go through that quickly. Suppose you have an array. Suppose a list of numbers. So let's say list equals to its list of 5 numbers. They're all ints. And it's basically 10, 20, 30, 40, and 50. Right. Now, we don't really know the number of arguments that are going to be passed. Or let's not do it like this. That's actually a list. We can easily pass a list. So suppose we're going to add them all up. So println add them up is a function, and we're sending 10, 20, 30, 40, 50. Now we're going to add all these up. So make a function called func add them up, and you say args dot 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 and int, because that's the type. And you also want to return an int, and then you want to cycle through all the arguments. So value equals range args, and you just want to add them up. So value, okay, or rather we need a sum now. Sum equals 0, and then we say sum plus equals value, which is basically sum equals to sum plus value. Then we also need to return the sum, and that should do it for us. So this will just add up 10, 20, 30, 40. Okay, non-declaration statement outside function body, unexpected range and expecting expression. I think I made a few mistakes. Let's go through them. So first of all, this shouldn't be a semicolon, it's a comma. See if that fixes it. Okay, non-declaration statement outside function body. So then, okay, we put a stupid bracket there. Undefined value. Okay, so this has to be like this. Okay, so that seems to have compiled our program, and now it's going to give us the addition, which is basically 150. Okay guys, so that was how you pass unlimited number of arguments into a function. And I think that ties up functions and all the special types of functions that we had. So let's move on with our tutorial today. Okay, so now that we've covered the Go specific function, let's move on to structures. So Go allows you to define variables that can hold several data items of the same kind. So this is called a structure. Now a structure is another user-defined data type available in Go programming, which allows you to combine data items of different kinds. Now structures are used to represent a record. So suppose you want to keep track of the books in a library, you might want to track the following attributes of each book, like the title, the author, the subject of the book ID. And in such a scenario, structures are highly useful. So to define a structure, you must use the type and struct statements, and the struct statement defines a new data type with multiple members for your program. The type statement binds a name with the type, which is the struct in our case. So in this example, we have created a structure and named it rectangle. It has the left position, the top Y position, the height, the width, and then we are passing in a rectangle type into an area function, and we are going to actually calculate the area. So let's see how this works in a normal Go program. Okay, so first let's delete all these things. So first of all, let's define our structure first. So let's see, type rectangle, and it's going to be struct.